Hey folks, let's try to build a Groundwork. So what is the Groundwork is all about? It's a simple self-hostable managed agent service for long-running infrastructure and backend work. And I want to be clear right up front, it's not UI heavy. We will have a UI kind of like to sanity check the backend logic and infra that we'll be adding. And this will be built on a durable replayable event log, completely orchestrated with Temporal, which means a run can survive a crash and it can pause in the middle to ask a human for approval before it does something dangerous or something like that. So that's the groundwork that we'll be trying to build. Let's have a look at how does at a high level the architecture of it is going to look like. And the first the callers, you can see the React web client, an external service, a webhook caller, custom UI or SDK. So all of them talk to Groundwork the same way, the public API over HTTPS. So that web client is just one caller, and others are something that anything that they wanted to talk to our system should go through our public contract API that we'll be trying to expose. So yep, and then the temporal, this is the brain that basically orchestration, it's what it does, and plus signals, so it decides what runs and when. And the worker that we have, so it runs the agent, the OpenAI agents SDK harness, and reaches out to the sandbox to actually do the work. So the sandbox backend, basically where the actual work happens, isolated and pluggable. So we can use Docker on our laptop or Modal in the cloud or local for tests and all. And the data related parts, the Postgres, the actual memory. So every session, every event, all the state, whichever is durable, we'll try to store here. And this NATS core, that's the nervous system, whatever we can call. So the live fan of that makes the UI stream in the real time. So these are all the components that are involved in overall architecture of this groundwork, and we'll try to build each component and try to see how to wire it up. And this should give you a rough intuition of what this groundwork is all about. And let's try to see a couple of runs, how like if we trigger a session, how does it look like. So the session run, let's see. So first is basically the client to API communication. So we'll try to hit endpoint like maybe v1 sessions ID events. So everything a user does, like he sends a message, approve, signal or interrupt and all, it's just an event that is posted to this API. And then nothing ever calls the agent directly. It's all events. Then now this step 2 that we have, this API writes it down. So what it does, it appends to our Postgres and publishes to our NATS. So this is what this API is doing in one shot, appending to our Postgres durable storage, so that we doesn't get lost later. If you wanted to replay, we can use this as a single source of references. And then it publishes to NATS, so it's live. So one write, both is what it is handling. And once we do that, the step 3, this API now wakes this temporal workflow. So that's a signal. So that API doesn't run any agent itself, it just signals the sessions temporal workflow. Hey, there's a new work, just go on and work on it, something like that. And the step 4 is the workflow should now claim the work. So the claim next queue turn. So this claimed next queue turn to run turn, it pulls the next queue turn off the queue and starts running. Here worker is nothing but agents SDK, and the step 5 is basically the run agent segment, and then activity. The workflow handles this actual agent run, basically hands this actual agent run to the worker as temporal activity. That activity is the durable boundary like between the brain and the ends. And the step 6 is something that agent works in the sandbox, the executive, like whatever it needs to execute those tools in a loop or something. So that runs the agent which executes the tools inside this isolated sandbox. It will have shell, git, the database database, and whatever it needs we'll try to install in the sandbox, and it does the job. And after it's done, the results go back to the log, which is like, we try to append the events to Postgres and publish it to our NATS as well. So whatever everything the agent produces, reasoning, tools calls, output, all gets appended right back to Postgres and will be published to NATS simultaneously. And then that's what we'll be trying to see in the UI. So that's how, like, a rough session run it looks like whenever user starts triggering a prompt in our rough simple UI. And let's have a look at the rough UI, how it's going to look like, though it's not UI heavily focused build, but I'll just give you a brief about that. So this is how it's going to look like. Just the way to start asking the session run whatever we wanted to do with the things, and here just the model selector and the repos that the option to connect our GitHub app and then pull in all the repositories that we have, and then we can select that repo and start working on that. And here we have like a document section, so whatever the context that we wanted to give, attach all the docs, and then standard drag flow and all those things, embedding, indexing, and all those things. Again, that happens through Temporal, and we will have, like, if you wanted to attach as a context, you can just toggle this one. And this is Groundwork MCP, just wrapping our DB calls and all the important things in our as a tools things and all. So this is how just the brief that we'll have as a starting thing. And here the documents here, that's where, like, we try to create a new document base and upload all the documents, and this will start indexing and all that stuff. And here we can just search, and here basically the results will start showing here whenever like this, whatever the document that you have just adopted. That's so 2020 just I'm because everything is now these days agentic harness. And if you run the specific session, so how does it look? I'll just open one session and give you just a high level walkthrough. So once we ask some query to do, and it goes in the background and spins up the sandbox and does its job whatever we asked, and make sure in the sandbox whatever it needs it configures and does the work and all those things. And every tool call, reasoning, and all the standard things that we see in Cloud Code or Codex or whatever we're using. That's and here basically all the NATS events, just the overall count that we wanted to do. Here you'll see events and the timeline, and even if there are things that you wanted to, you can just copy it. So that's the at a high level is what we'll be trying to build. The thing here is not the UI, but more or less the infra and the backend stuff. How do we handle all of these things? And even the temporal workflows, we can have a look at it, and how do we handle approve or reject signals, and then durable workflows and retries, and so that it doesn't crash in between also, and how does it survive and all those things and all. So let's that's what we'll try to build. And schedule tasks. So how can we schedule it once or interval daily, and then attach basically the repository and any other tools that we wanted to for that schedule, and then so that it can pick up this whatever the task that it wants to do, and that also will be handle everything to through temporal schedules and all. So because here one of the best use cases can be, let's say, like we are running the product feedback calls with our real customers and all, and there are a lot of frequent meetings as happening or something like that, and they report that issue or this bug and all those things. So running through some transcript and giving the access to all those tools, meeting tools, and then any Slack channels or whatever it's being used, and then it understands that, and then after that, and it tries to create linear tickets and pick one ticket at a time and then go and do the job and all. So that meeting analysis maybe can be every day or a couple of days once run through, and then create tickets and then start picking one at a time, something on those lines. So that those kind of situations, this loop, this is what called like looping feature in Cloud Code, or that's like loop engineering is what it's going viral these days. So that's kind of one of the use case out of many that we could find on to day-to-day basis based on our domain and the work that we are dealing every day. So let's try to see how the sandbox is going to work, and is it going to help us do the real task or not. So okay, so I'm selecting this GitHub, and that's what one repo is selected. And let's try to do the first simple thing, and in the second thing we'll try to do the harder like destructive actions and all. So I'm just trying to see, just ask it to create simple getting started section in readme, and then create a new branch and all those things, and asking it to drive, and hoping it does the thing what I expect it to. Let's wait and see. That's the intention. And yeah, so it started working, and it's just reasoning. So you can just see the reasoning summaries, and also you can see the NATS events getting published here as well. Debug and all, you can just see here opening this event sections, and I'm just not so keen on that. You can see or what is all happening. So it will reason and make a call, tool calls. So just trying to inspect repository instructions, and then now basically the sandbox, it is checking if it has RG installed or not, and all those things, tools, and checking that CLI is authenticated, and working trees on main and all. So the sandbox, since we are using local thing, I'll just show that in Docker. You can use Docker PS command in your terminal and check. You should see that sandbox, or else in Docker desktop and all. Yeah, so you can see the tool calls and all that stuff, it's happening. And in a while I'll just showcase you that it'll summarize and let us know after patching and all those things. Okay, so it is reapplying that, and then branch is pushed, you can see. So and now it's creating the PR with the concise title and summary, and then PR was created, and it is now capturing the final branch. And then yeah, okay, let's try to see how the approval condition works in Temporal, and let's see how it persists even if we try to restart worker and all. So I'm just trying to ask it simple destructive action to drop the legacy nodes column in the users table or so. And ideally it should ask, since it's a destructive, it should ask for my approval, and that tool call should happen. And then there should be condition that should park that workflow till we give the signal. And I'm going to show you that in a while. Let's see. I'm hoping at least that's what it is supposed to do. Okay, it's trying to create new SQLite file in workspace that it has by default, it will have in our sandbox. And SQLite 3 CLI is not installed, and it has created using Python's thing. And now you see we got the UI approval asking for that. And now if I switch to this thing, and here we have this one workflow running, and if I see this thing, it is basically now should have the result with the status as requires action. So till I approve that, it will be in the running state itself. So if I go back to this, so even now basically if you restart your worker or something goes down, and if you come back, it will be in the same thing, trying to say that it doesn't erase itself, or so how durable temporal it is and how it works and all those things. So now if I just try to click on this approve, and if I go to this here now, you should have seen that approval decision. So this is the signal. Approval decision is what we have sent, and then it now it knows that that has been approved, and now it is continuing the run agent segment. This the same the turn ID and all. And if I just go back here, so now you can see that it is running with the drop command, and it has just confirm that that is a drop down. So that is how like it works, like signal sending and condition based workflow, parking and all those things. Hope you get what I was trying to showcase. All right, let's start building Groundwork from scratch then. All right, let's start building Groundwork. So first we'll try to scaffold and then lay foundation packages that we need, and then we'll start evolving from there. So we can start creating package.json by running this npm init and all those things, or else we can just manually create as well. For example, package JSON. Okay, and in this I'm just going to add the simple thing, name, version, and a description of it, and we'll try to keep this as a monorepo. So we'll have this apps and packages, so that's why it's a workspace, and then simple commands to do type checks and testing, and then dev dependencies, bun and TypeScript. Fine. So that's the simple package .json, and also I need the TypeScript config, just a pretty standard. And so for that also what we do, I'll just take a reference from the, so for that what we'll do, we'll just create ts config .base.json. okay, and here I'm just adding simple things, compiler options, and then module, and this you can just take it from the initial commit and all. That's not much to talk about, pretty standard that we see in all of the TypeScript projects. And once we have, you can just try to run this. Okay, we don't have this any packages, that's fine. The next thing we'll try to add that. So now what we will do, we'll try to create a packages called contracts, kind of like the types that will be reusing across packages and apps, so as an initial skeleton that we need and all. So what we'll do is basically we need to create a new folder called packages. So I'm just creating in here this packages, and inside this let's create or name this as a contracts. Sorry guys, this also needs to be folder, not file. So contracts, and inside this let's have the package.json, and this basically simple things that we normally see in turbo repo or any workspace that we normally see. So I'll just add here this Groundwork contracts and version, private, and type its module, and main file will create source folder now, and index.ts, and just type checks and dependencies zord and dev dependency TypeScript. okay, fine. And in this contracts, let's create a source folder, and inside this I'm just going to add index.ts. Let's try to close the sidebar so that it will be more spacious for us. Okay, so here what I'll do, we'll try to create a simple the jar types and the enums and all those things that we need. So first what I'm going to do, let's try to import the so importing, we need the jar thing, and of course we need to run one install, so that now we'll have this job installed, and yeah, that error basically. Okay, fine. So first we'll try to define basically the lifecycle status that we need, basically how session moves through. And let's I think this is should be simple, so I'll not talk much about this. So session status, so this is going to be enum. Okay, so fine. So in this enum we'll have the queued and running, and this can be idle, session can be idle, and also we need let's say requires action, that is an approval or denial or something like that, and is it failed, and then finally is it like maybe cancelled. Oh fine. And now let's create this type called session status, and pretty much standard. So just the session status helping with the lifecycle states of that session. And now we'll add kind of maybe other two types of enums that we need, like where the agent's sandbox runs. So I'll just define the same thing in the same lines, like sandbox backend also. So this is going to be enum again. So this basically our sandbox will try to spin it up in our local or Docker, or provide the option for conferring Modal VMs or the Daytona VMs and all those things, or else we can just keep it none also, just to be safer side. So these are the things. Later we can add more, and same again, we'll try to create a type, and also we'll have the constants for reasoning effort whenever we are trying to converse with the agent. That will, so reasoning effort, so this also it's going to be an enum. And yeah, so let's keep this one low, medium, high, and also maybe none like we have, and extra high, yeah. And like this we can also keep maybe quite opposite of that, minimal. That should be fine, and later we can just add in and reasoning effort. We have this, yep, pretty much. And after this we'll try to create a constant, again the object for repositories, kind of like we can attach our Git repository to a session. Later you will see that in UI, just the simple UI to test our core backend and infra functionality. So that's a URI, ref, optional mount path, subpath, and optional GitHub linkages and all those things. So this basically I'll just name this as a repository resource reference. And this one, let's like I said, it will have this kind, so I'll just keep this as, yeah, kind as repository. And then this URI, which is going to be a string, and let's be very strict, we need this URI, so I'll just say minimum 1. And this reference, this also I'll just keep this as a string. Mount path, let's again this one we can keep this as an optional. Then the subpath, yep. And then GitHub installation ID, so this one is going to be a number. And let's keep it very strict, like it should be positive, and also the optional, fine. And then GitHub repository ID, okay. So this again positive and optional, pretty much the same. And I'm just going to create a type, pretty much standard to infer. And yeah, like this we have the repository ref, we'll have the other attachable resources as well, like for example an uploaded file referenced like by id. Again, we need to have the kind and all those things. So yeah, okay, fine. So file, this one kind will be file, and here let's change this a bit, so it will be, instead of URI, it is going to be file ID, this one string, and let's keep this to be unique ID, and mount path and subpath I don't think we need, so I'll just get rid of this, and file resource ref, and that should be fine. And now we need to combine those file resource ref and this git resource this repository resource ref into one thing. So I'll just try to here we have this resource ref. So yep, discrimination, yeah, it's already auto generated, that should be it. Okay, fine. And here we just need to yeah, so resource ref, and we have this and this. Let me just delete other things. Okay, so that's the thing. And then now related to MCP. So MCP, when we talk about MCP, first thing is basically the tool reference. So initially what and here this kind will be basically, I'll just group it under parent, like the MCP, and then this is going to be an ID. Let's just make it this as a string, and minimum I'll just set this to 1. Okay, fine. And now this tool ref and all those things. So yeah, and fine. And now for any conflicts whenever we are trying to refer to resources, so we'll just extend the base class error. I'll just define let's say resource ref conflict error, and this let's so this needs to be class, my bad. Okay, fine. And we'll just extend this error, and in this all we need to do is just in the constructor take in this message string and inherit that, and give this name resource ref conflict error. Fine. Yeah, mostly this is it. And we need some of the helpers, like to merge multiple tool references, and also same to merge resource references, and all those few things. So what, like for example, let's say so let's create one, then you'll understand what I mean by that. So for example, I'll name this as merge tool or reflect. We can add all of this later as well, but I just want to lay the foundation and just have this so that we can refer in all the apps and the actual packages that we'll be needing. Those are the core things. So these are like getting things started. So here let's say like existing is this, and so basically what I wanted to achieve using this helper function is whenever we append new tools to existing ones, make sure that it is deduplicating by kind ID. So attaching the same MCP or tool twice is kind of like harmless. So like that. So this is going to be a list of the tool references and additions, and at the end yeah, tool ref array. So here first let's see simple logic. So we'll have the set things, scene things, and also let's create here this out empty array, and we'll just try to now iterate. So for const tool of this combination of this existing and additions. So inside this now let's try to create this unique ID, yeah, combined with kind and ID. And if now we'll just check if this has been seen before. So So what we do, I'll just continue. That should be, yeah, instead of throwing, we'll just continue, and if not, we'll add it to our scene set, and then we'll push it to out, and at the end we just return out. So this is the simple helper. You get the intent. It's straightforward logic, just deduplicating existing and new additions and all. And same thing we'll try to do for the merge in the resources thing. So I'll just name the same thing. So merge resource refs. So existing so this also will have the existing tool refs, and then the addition, which is again, this is going to be a list of the resource ref array, and then the options. So here this, let's say we'll have this reject conflicts as the additional options that we wanted to take in. Yeah, and here, okay, and we'll just return list of this resource ref. Okay, fine, same thing. So I'll just try to be quick here. So this one, let's have this existing by default into out, and this mount to paths, I'll create this new map. So here existing, we'll just convert this into flat map, and so this, let's say, okay, so this what we'll do, this resources, we'll just try to check if, okay, I need to close this. Okay, let me just close this. Fine. So now this resource dot mount path, if we have this, so all I'm going to do is basically add this mount path to this thing, and also now we need to convert this one to JSON. So for that we'll be trying to use just JSON.stringify in multiple places. So I'll try to create a simple helper. So first to to sort the JSON. So I'll just be vague here. So value will just take in unknown, and also I'll just return on this unknown as well. So first we'll just check this array, if it's array or not. So if it's array, well, we are just going to return this value.mop thing, and we'll again check if we have this value is not null, and this type of value is the object, pretty much the standard thing. So object dot from entries, and we'll just sort it, compare this, and then we'll just try to map this key value and use this nested things that we have, and finally return this. And this sort JSON, so I'll just now use this inside a new function called something like and this will be trying to use across the packages. So we can just export this, or else later you can just come back and export this. So stable JSON, so again this will take value unknown, and now we'll just use this sort JSON, and yeah, pretty much this is it. And here now I'll just use this the function, this stable JSON that we have, and yeah, and we can just, or else this empty array will just create. So we're just trying to get the list of all the mount paths and those things. And now this the identities, this also pretty much the same. So we will just here will not do a check in here for anything. We'll just, it's a straightforward this thing. So this for this also, instead of doing the check here kind and all, we can do the chat check in this function. Let's say resource identity key. Okay, and in this of course we'll receive the resource as the input param, and now we'll just check if this resource dot kind is equals to file. Then I'll just return this key in the with the prefix as the file attached. So yeah, resource dot kind and then file id, else URI is what we are going to use. So now here instead of directly using this URI, so I can just use this helper function that we just created, and yeah, and we can just get rid of this thing, and pretty much. So now we have this mount paths and identities, and let's create one more const for exact. So here this will be a new set, so we'll just existing, I'll just pass in here this table JSON or the helper function that we have below. And now all we need to do is, now we need to iterate through this each of the resources in the new addition that we are receiving. And here first we need to serialize this, and we need to again check if this exact as this serialized. If so, we'll just continue, so we already have it. If not, again before we need to again check the options patterns that we have. So does this has to reject the conflicts? If that is true, then let's say create existing at mount variable. So this basically will just check if this resources dot mount path, if that is so, I'll just try to get that, or else it's undefined. Okay, yeah. So and again we need to do a check. So if existing at mount and also this is not serialized, then I'm just going to throw this error, this resource reflect it's not serialized, something you can just throw an error of something of that kind. And this the identity, so we need this identity key, so pass in this identity resource, and let's see if this existing identity or not. So we'll just get from the identities list that we have. And also here same check again, we'll do serializes check, and if it's not serialized, again we'll just throw this error, it's not matching. And after all this check, all we need to do is try to push the resource into out, and then exact we'll need to add this serialized thing that we have. And identities, I need to set this resource, and now we need to, this pretty much the thing. I think we should be almost there. Okay, so this is pretty much helper. I know it's simple helper to make sure that we don't have the duplicates. So basically what it does is, we're trying to merge this resource list. We're trying to skip like an exact duplicates, and also we have these options called reject conflicts. So when it's on, we are throwing if the same mount path or resource identity is reused with different settings, then then that's the kind of safety net for attaching resources mid session. So that's just the helper thing, this thing that we have. And also we need some of the like for reasoning effort, metadata or something like that. This basically I already tried testing and everything, so these are like helpers that I need, so I'm just adding it upfront instead of adding it when we need, or like where to place it or where to grip. So I think you get the point, right? So here I'll just define that quickly. So I'm just reasoning effort, just metadata, and here we will just it's going to be record type, and also we'll have this fallback param, which is again going to be of type reasoning effort. And now inside this let's we'll just try to get this value. So we'll just so it is going to be a reasoning effort, so I'll just be fine. And all we are going to do is basically now if this value is none, this check minimal basically with the types that we have defined in our reasoning effort. So minimal, medium, high, extra high, we'll just return that, or else the fallback. Just the pretty simple function that we have. And we're almost there, what and all we need in our contracts. And the main things now for our the per turn lifecycle states and all for our session important. That's the thing, core thing that we'll be trying to deal with. So I'll just define them as well here, called the session turn status. So this is going to be pretty much the enum. So first is queued, and is it running, and then does it need any action, and also did it complete, did it fail or cancelled, and so now I'll just this is like, I think should be understandable that we have. And then the session turn source, basically was that user triggered, or was it a scheduled task, or was it like API triggered, and all those things. So that so I'll just create in here session turn source. So this also we'll just keep it 3, the one that I just mentioned. So here user I'll just define this as a scheduled task, and then this API that should be and here session turn source, and session turn will come back to this now. Here this is basically the ultimate the prompted segment of work, basically the one which carries the details whatever our worker needs to run the actual agent, so that the prompt resources and all tools and all those things. So I'll just try defining, of course we need ID, and then this session ID, which is again going to be a string, and this trigger event ID, this also I'll just keep this one to string. Okay, and then we have this temporal workflow. So temporal workflow ID, so this also I'll just keep this one to be a string, and status, So we'll just attach in the above what we have, session turn status, and the source. So this also I'll just create this session turn source that we have, and after that of course this auto completion, let me just get rid of that. Then this position, this, yeah, we'll just keep this as positive, and then the actual prompt, this is going to be a string, and this resources, which is going to be an array of resource references, and then this tools that will be attached, again this is going to be an array of the tool ref, and this model name, this again going to be a string. Then this reasoning effort, and the sandbox backend important, so this is going to be of this type, and this any metadata, this is going to be a record of string and unknown, and then this when did it start, so this I'll just keep this string, and like make this as a nullable, that should be fine. We can keep that as a date time and also, but that's fine. And finish that also I'll just keep that as a string, and then the standard things created at, let's keep it, and updated at, and I'll just be keep this also as a string. Fine. And this is the actual session turn and all, that's the main thing that we'll be using across the apps and all, and the session turn type and all. Yeah, fine. So that was the session turn, and now we need its parent, basically that owns that each of this session turns. Basically the accumulated resources are tools like points at the active turn, and tracks like the last sequence and all those things, right? So I'll just, yeah, this is the thing. So in here, of course it will have the ID and the status, session status, and this initial message, this is going to be a string, so fine. And this it will have this resources that is attached, and also this tools in model, and I'll just reasoning effort, I don't think we need. And after this I need meta data, so this is going to be a standard record string of unknown, and sandbox backend. And then we'll need to okay, already we had this, I added, that's my bad, okay, fine. Then this temporal workflow ID, so this one, it's going to be a string, and I'll just make this as nullable. And then this active turn ID, this is going to be unique ID. And then this last sequence, this is going to be yep, and created at, and I think this is enough for this session, and I'll just create this type that we want. Fine. So this is the parent, and that session turn for each of the things. And now the and what and all can happen in a session, basically the life cycle, like user turn, like user input, turn transitions, agent streaming, sandbox operations, artifacts. So every logged event, we need to have kind of like better if we try to maintain each of the event type that can happen in a session. So that is this for, so like session event type, so this is going to be an enum. So here first is we'll have this session is created, and then this status change, so, and then does session require the action. So these are all the events that can happen. So like user message, user has sent a message and user has interrupted, and user this approval decision whether is rejecting or approving, and then this each turn. So is that queued or is that updated and all those things. So is it updated, and yeah, and like did it start, and did it complete, did it fail, did it cancel, and let's just keep that for that turn. And now for our the agent, so agent message, so we need to stream the delta chunks, and so message, did it complete, and the same thing for our reasoning as well, we need to stream that. So this reasoning, and then this tool calls that we'll be making, which is it created, and then this output that we'll have for that tool call, and then if that agent updated, and finally the sandbox related stuff. So this operation in that sandbox, did it start, and did it complete that operation, and did that fail, and then the commands that we'll be trying to run those outputs. So command output delta, and finally artifact if it is created or not. So for time being, I'll just keep this to this list. So this is all events that can happen from sandbox perspective, agents perspective, turn and user sessions and all those things. And here now all I need to do is just create a type. Okay, fine. So those are the event type, and now that we need to just attach it to our session event. So yeah, exactly. So here this will have the id, session id, and the type, session event type, and we need to attach in the other things like sequence. This is going to be a positive, and then this payload which is going to be unknown. So default I'll just set it to empty dictionary, and yeah, so id, session id, type, sequence, payload, and also maybe instead of timestamp we can be maybe, let's say, occurred at, and also the client event id and turn id. I think that should be it. Client event id, so this minimum, let's set this not optional. Okay, it can be nullable, and also make this optional, that's fine. And this turn id, yeah, pretty much I'll just keep that as same. Fine. So this is the session event. So these are all the basically the types and all that we need as well defined, so that it will help us catch any issues during runtime and all. So good to have all of these types in a single package, so that as a contract that can be used across packages that we will eventually add. So, and also now we added this, and to be used like for example, let's say in new package I just want to import directly from Groundwork contracts and all. Let's try to add that path here inside this and also we need to extend our base ts config. So I'll just define that first. So ts config, all we need to do is just basically extend that and include our source folder files. So it's going to be as simple as that. So extending our base thing and the compiler options that we have. Yeah, so ignore this the id issue that we have. And in this base, basically in the paths, now I'll just attach groundwork contracts, and I'm just attaching this thing. And now you can just try to run type check. It should run. Yeah, now it ran in our contracts that we have. So this is the like job entities that we need, and session event related types and all that we need. So we have this contracts and all those things ready. Next I wanted to add the package that will be same like this, will be using across all the main things. Other also like observability related stuff also I wanted to add a new package, and one and all just helping us to log those things cleanly, so that we'll know exactly what's happening. So let's try to create that package now. So inside this packages folder itself, let's create this new package called observability. Okay, and yeah, pretty much the same. We'll create the same thing, package.json, and then the source folder. Okay, I need to that's a folder. Okay, fine. So this same thing, I'll just add it in the same way that we added for contracts, the package.json thing. So observability, and then version, and then main file and scripts, and then dev dependency, TypeScript and all. So now in this, let's define this index.ts file, and this will also be pretty much the same things that we need everything. I'll just try to define quickly, and let's see what and all we need here. First I need like base attribute primitive values, and like just strongly typed thing. So I'll just name this as attribute value. So this is going to be just the standard either a string or number, boolean or undefined. Yeah, and then this I'll have this type as the attributes. So this is going to be pretty much a record of string mapped to this attribute value above that we have. And fine, so that's like a base thing that we need. And now the standard settings for our observability. So the type so observability settings. So this will have the service name, and this environment, and then this observability structured logs, and is metrics enabled or not. So and then the endpoint. So observability OTLP endpoint, let's keep this as an optional. So this can be either string or undefined. And then the headers. So this OpenTelemetry headers, so this is going to be of type string. So basically, yeah, the simple settings for observability. And now the type for the options per instance constructions. So this is for that. So observe options. So this will have this component which is of type string, and this yeah, the time that we want to attach the now callback function, and then this exporter. So this URL, and then this body, let's keep that to be unknown, and headers, yeah, pretty much this the options. Basically it helps us to control the clock and capture exports and all. That's the simple type that we have here, and then the span shape and all those things that we need. So I'll just add in this type, the span. So this will need the trace id, and the span id, which is going to be a string, and in the end, so input, this will have this attributes, and then this error. So let's keep this one to be an unknown. Fine. So this one basically this is the shape that will be written by start span and end and basically an end callback. This is the standard Prometheus latency buckets also will try to add here below this. So histogram buckets, yeah, pretty much I'll just keep it this thing. Yeah, the if you know the Prometheus, just this is the latency buckets shared by every histogram that we have, and fine. And now the actual factory entry point, so which is creating an observability. So that's where like we'll try to like just create a new instance of observability and passing in the settings and options and all that stuff. So for that we need to like even before let's what I'm talking about starting point is this. So I'll create something like create observability function, and this will have the settings, so and options passed in, and returning, I'll just return this observability which we don't have yet, but so, and here I'll just pass into this, and here now we need to work on this the class observability, and in this the constructor and all those things. So so basically this class is we'll try to kind of like private in-memory metrics registry, like we'll try to inject here itself the clock exporter with the constructor pre-computing this OpenTelemetry resource attributes, like basically that tags every span with service, environment, and component. That's what like just pretty standard that we see in our observability stuff. So here this metrics, so this one is going to be metrics registry. So that's a new object. So even to need this metric registry, we need to first create this class called this metrics registry. So this basically this is where we need to first define the counters, and then histograms and all that we normally see. So let's try to quickly add this. So this in-memory metric store, of course we need counters and histograms. So let's define them. So private read only counters. This is going to be simple map, and here let's just keep this as number. That should be fine. And then the histograms. So again this is going to be of type string mapper to. We will have buckets number, and the accounts number array, then the sum, which is going to be number, the count, labels, this is going to be just a record of type string. All right, yeah, this is pretty much okay. I think this, yep, now makes sense. Okay, fine. And now the functions to increment. So just we are going to bump the counters by 1. So this we're going to receive the name and this labels, which is again, and the value. I'll just maybe rename this to amount, and now inside this let's just define this key. So here I'll use this helper function called metric key. Again, that is going to be a simple wrapper to stringify this thing. So metric key, and here I'm passing in this name, and pretty much the same record, and try to return the string. And here now let's try to stringify this this name and this labels. So we need to just use from entries and then pass in this labels, and I'm just going to sort this and sort this, and yeah, pretty much the way that we want, and should be fine. So now this key is going to be, just will take this help of this metric key and pass in the name and labels, whatever we are receiving as the input params. And here all we need to do now, increment this, yeah, and then the function to observe. So now this function basically to record one histogram observation, basically we'll try to accumulate some count, and exactly as Prometheus histograms require. So this will need a name and this buckets, which is going to be a number array, and this value, which is going to be a number, and the labels. Yeah, okay, fine. And now inside this again, this key, I'm just going to get this, and then the histogram. So all we're going to do now, we're just first trying to get this. If not, I'm just going to pass in this buckets and counts and this labels, and after that we need to set in this histogram the sum basically accumulate this value whatever we are receiving, and this in the count we need to increment it by 1, and now we need to just iterate through these buckets that we have. And so iterate and check this, and all I'm just going to do is check this if we have this value, and we'll increment that by 1, or else by default we'll initialize it to 0, and I'm just going to set this key to yep. Yeah, so there was a typo issue. Fine. So that's the simple observe thing, and we'll need one helper function to convert it to Prometheus, just to so that we can get in the same format as the Prometheus does. So for that I'll just define a simple function called to Prometheus, and here we will pass in this resource labels. So this is and here it's just we need to add in some lines things. I'll just add quickly and just walk you through what it does and all. Simple this is how it's going to look like. So I'll just add it here, and we have a couple of helpers that I need to quickly define, so that also I'll just add it in because those are like not the major things. That's something that we need to discuss. So format labels and pass metric key. So pass metric key also, it is going to be simple passing the JSON that will be receiving. So I'll just add in here. So this parts metric key takes in the key and returns the name and the label. So just the vice versa of what we add for this thing. And then the format labels also just a simple helper. So all these helpers I'll just try to maybe add straight away, and anyhow I'll be adding sharing the repo, and we'll have the clean commits and all. You can just take a reference from there. So and escape metric label also okay, fine. Now there should not be any issue. Of course here we have an issue in here, that's why. Okay, we'll come to that once we complete this. It's the thing. So here what are we doing is basically we are trying to add help and type headers, and then one line per counter series, and you see, and the full bucket sum count set, like then including the plus like infinity yeah, here the bucket per histogram, then the closing brace, this just ends the class. So that's the simple to Prometheus, and here are the just helpers formatting the labels, taking in the record of a string, and then trying to format into the way so that we can just add it to by comma separated things and all. And here just the escaping metric label and just replacing this, all of this pretty straightforward. So I basics things. Okay, fine. Now we have this metric registry class thing, and now we need to use that inside our this observability stuff. So here now first thing I just need to define is basically create a constructor and define this private read-only variables, so that can be used in our whole this class. Okay, so this read-only metrics, new metrics registry, and then we need the time related stuff. So I'll just define this as now, and this is going to be callback function, and this the exporter. So again I think we know already the definition of this. This is how it's going to be. Yep, the exporter that we need, and also the resource attributes private variable. So this is going to be of type attributes. Okay, and now we just need to define this constructor, and again here I'll just get in these settings, which is observability settings and also the observability options. And once we get that, all we need to do is now set in the private variables that we have just defined above. So the options dot now, else I'm just going to set this one to date dot now. That should be fine. And this dot exporter, and yeah, and so this default exporter will just define this in a while. And then this resource attributes we need to add in the service name, so I'll just keep it in the consistent format. So settings.service name, and this one, so it's a deployment environment, and also this component. So what I'm going to do, this one, let's associate it with this groundwork.component. Yep, and yeah, I think there is a typo issue. Fine, now there should not be an issue. Okay, so that's the simple constructor initialization. And now we need standard things, basically info, warn, log, error, and all those things. And then okay, so I'll add this default exporter. It's not big deal, so it should be pretty simple. Okay, first this info, this message will take in, which is going to be of type string, and then attributes. By default, let's just set this one to empty dictionary, and let's not make this an optional. So I'll just yeah, and now inside this all we just need to call in this this dot log and pass an info, message, and attributes. And of course we need to have this log function, so or else it's going to complain us. So here I'll just define this function. So level, it's going to be a debug, info, warn, or error, and then we'll pass in the message, attributes, and all that stuff. And inside this let's just do a quick check. So if this settings observability structure logs any not enabled, then I'm just going to do it in the standard developer way, like trying to use console. So here const line where let's attributes dot error. So here we'll just yeah, maybe instead of adding a line, I'll just add colon, and string attributes dot error and message, and all that should be okay, fine. And now we'll just do a check. So if level is maybe let's start with warn. So if that is the case, I'll just use this console.warn, and same thing if it's error, and else will just default to line. And yes, so and then maybe just written, fine. And if it's a structured thing, then now we need to be little bit in the format that it is expected. So we'll attach the timestamp and then the level message, and along with that the instead of adding it in this attributes object, so I can say it is service. So this dot settings dot service name, environment, and then and attributes, maybe we can define a simple helper something, let's say clean attributes, or yeah, I'll just define that. That also pretty much so I'll just add in here. So takes in attributes and returns this record string, either string, number, or boolean, and just yeah, this is a simple helper, and here I'll just pass in to this attributes that we have, and also the default exporter that I mentioned. So it's basically we need a simple helper function now where it is complaining here, so that also I'm just going to add it here. Okay, so this default exporter takes in URL, body, and headers, and all we are doing is basically trying to make a post call to that URL and send in the body, and then that's what, like sending it to OpenTelemetry and all. That's the thing. Fine. So we have this log defined, and we just defined info, and now we need to add the other standard things like warn, error, and all those things. So let's add in here this warn, and here let's just try to log this thing, and the same thing for error, we'll just try to log that. So that's a pretty standard wherever we see and all. And then we need to work on the function which is going to help us the start span. So basically that's like, which helps us to create a lightweight span, like with random trees or span IDs and capture start time, something of that sort. So I'll just name that as well in the same way, start span. So here we'll take in this name and this attributes, and it's going to return this span. So the now first thing, I need to define some constant variables. One is the trace ID, and here also we need some random number or so, something, let's say x number or so. For that also, let's we can use crypto random values and all those things. And then since I will need it to be used across for trace ID, span ID, and all, so I'll just define same way one helper as well here. So this is going to be simple like this: take in bytes and get the give me the x number that I need for an ID. So yeah, I'll leave it to you, just check it out, and fine. So this is the thing, and now let's yeah, okay, so here I can just call this now, and I need 16th decimal thing, and none of the span ID, yeah, 8 should do it. And let's and now the start milliseconds, this dot now, and let ended, I'm just going to define a variable here, false. And here all we are now going to do is basically return now the trace ID, span ID, and the end is going to be, so input, let's take in the empty dictionary, and here if it's ended, if it's ended, I'm just going to return, and else I'm just going to set this to true. And now these the error attributes, so this input dot error, and here we need to convert this into error to attributes, so that simple, it will take error thing and attributes. We just need to convert it to attributes format, which will have like error dot type and error dot message and all those things. So that also, like we have this separate functions defined, I'm just going to add in here. And this error message also simple, will just take in error instance of, so this was all refactored. So that's why we use so many helper functions and all, but that's a clean way. That should be simple, and you can just check it out. So I'll not talk much about that here. And yeah, so here now I can just pass in the input dot error to our helper function that we just defined. And after that we need to call kind of like export this span. So for that let's define so this, we still don't have the export span function. So what I'll just try to add that thing here. So private uh, export span, and this one it'll take trace id, span id, which is going to be of type string, then this name start milliseconds, which is going to be of type number, and the same end milliseconds, attributes, and then the error. Okay, so this again, let's make this optional and then remove this type issues and all. Okay, so now inside this so here we need to check first if settings basically this exporting span, just an helper to create this open telemetry JSON body, like, and to fire it at the collectors like /v1/traces. So that's what this does, but you will get it eventually. So here we need to do first a few checks. So yeah, if settings it doesn't have endpoint, we don't have anything to do. So I'm just going to return else. We need to construct this endpoint first. So this is going to be this endpoint, and I'm just going to replace and here I'm just going to add in this endpoint. So I just need to so this is the endpoint. Okay, fine. And now we need to prepare this body. So this resource spans, this is going to be an array of this objects. So resource, and attach in this attributes, and here also we need to have some helper to give us this format that is needed for that body to be sent to that endpoint. So something on this line. So yeah, and so these are all minor things and basic things. So that's why I'm not just giving that emphasis, because it's not core logic and you should be able to refer it in commits. Okay, so this trying to convert these attributes into this format, and that's the only thing that we are doing. And this ODP ODLP value, we're just trying to check and then return in the format that we need. And now I just need to use this here. So pass in this dot resource attributes, and now the scope spans and the name scope spans. So here the name, I'll just be very specific. So it is going to be Groundwork Observability, and version let's be like 0.0, whatever we have in the package name and all. And then these spans will need to attach trace id, span id, and the name, and this kind, let's set this to 1. And now start times, and also milli is seconds to nanos is something that we need to convert. So that also, because we need it for our start, end time, and also couple of places, so it's redundant. So I'll just create some here, this millis to nanos and all. So now all this here, I just need to attach in here start time, and then end time in nano and attributes I'm just attaching here, and then the status. Yep, so here this code, let's set it to 2. Okay, fine. So this is the function to export the span, and once we have that, the body and endpoint, now what we need to do is basically now call this exporter endpoint body, and to this parse the headers as well. I'll just create a simple helper. So this one takes in the value string, tries to give us the string, and if it's an empty things, we'll just return, else we'll just try to create in this format and convert and then give it in this required thing. So that one here, now I'm just going to use this to parse headers and send it. And also, like, if we wanted to catch and then console this error, we can just console, or else like we have this one thing, so I can just call this function that we want, and this is the basically sending it to that endpoint. And once we have this and opening this start span, and I need to consume this one. So exactly after this, so all I'm going to do is pass in this trace ID span ID, name, and then pretty much what it expects, and attributes, input attributes, and also we can so this is what start span thing. And then we need to record now HTTP requests and all those things, and also the worker activities and all that stuff. So let's collapse this thing, and here I'm just going to call this as record HTTP request, and here this input will send in this method, and basically this route which is going to be a string, and the status and duration in seconds. This is going to be just the number. And now here again I'll just do the if it's enabled or not, that check. If it's not enabled, we'll just return. Now let's prepare this labels object, so method, and also the route, and the status, and this component which is, and after that all I'm just going to do is call this increment thing and pass in HTTP request totals labels, and then we need to call this histogram related thing. So duration seconds, pass in the histogram buckets and durations, and then attach in the labels which we have just created above. So that's the simple recording HTTP request. And also now worker side, we need to do the same recording worker activity. So input it's going to be then activity thing, and then the status, then duration in the seconds that will have, and pretty much here this input dot activity and status, and then we'll just call this increment and observe, and here it's going to be worker activity runs total, and worker activity duration seconds. So that's the thing. And now to render the whole registry as a Prometheus text, so I'm just going to call this as Prometheus metrics, and in here we'll just call in this dot metrics to Prometheus helper that we just defined, and attach in this service settings dot service name, environment, and component. Yeah, so that's the Prometheus metrics and all. Okay, fine. That's the pretty much we are getting there. And yeah, so overall this is the thing. And later if we need something else, like to log startup dependency retry and all those things, that also, like, we can straight away call this to log this thing as an helper. So what I'll do, so I'll just write that as well, so that will be helpful for us. So basically the shape of the startup retry event, like which dependency, the attempt counter, the backup delay, and the error, and all those things, you will, so that we can use it in our core logic to directly call this function, and then that will log for us. So here I'll just dependency retry event. So this will have this label which is of type string, and then this attempt, and then the attempts count that, and then this delay milliseconds, and then error. Okay, fine. And this function this so that now we can use this helper function in the API and worker thing later when we try to add those core logic. So I'll call this something like log startup dependency retry, and yeah, yep. And along with this event we'll add one more thing, which is observability, which is going to be of type this one. Okay, fine. And in this simple thing, it should be straightforward. So we'll just check if this instance of this error, if that is so, I'm just going to get this message, else we'll convert into a string. And after that this will, I'll just call this one function, and here I'll just say failed to start up dependency after this attempts, and pass in this label. No, let's name this one dependency, then attempts. Yeah, I think pretty much fine. So this is the like observability package that we need. I know we have a lot of things that we added, but this is like basic thing that is needed. And also to test everything and all, you can write separate test folder, test package, and then do it. I don't think that's needed. And this observability value you will know when we are trying to add actual logic. And post this, now we need to work on config related packages. So basically that's where like we'll try to configure all the environment variables that we need overall for all of our app or the core logic that we need, and make sure that environment variable check and all those things. So, and this config can be shared across packages or apps. So that's a better way of dealing with any missing environment variables. So let's try to add that config package now. So here okay, and also here we forgot to add this tsconfig thing. So we'll add this and then we'll move to so this is the tsconfig.json. okay, fine, that's the thing that we have. And now we'll try to create a new folder called this config, pretty much the same way that we have just created the other packages that we have. And here this package.json will just add it in the same way. So I'm just going to be way quicker now, and also I'll just walk through. So now I'll just not try to add every code snippet. So this config module will just define source folder, and then pretty much the same. And here now we are trying to add in this add this groundwork contracts, and because we'll need to use those contracts a bit in our this the config package, that's why we are installing this as a dependency. So here again the source file, and create index.ts, and also let's try to add this tsconfig.json pretty much the same way that we try to add for other packages. Okay, just extending base thing and all. And also now in overall base.json that we have, I need to extend this thing. So the config also I can just use this import directly. So now let's open this source index dot thing and collapse this thing. And here are we in the fortune? Yeah, fine. So fine, now in here I'll be quick as I just mentioned. So for example, I'll just first see, let's say if I wanted to use reasoning effort, this basically I just need to run this one install. Yeah, now you see I can directly use from this thing. And let's say I wanted to use other like sandbox backend and all. So like this, just using the packages across thing. Okay, and here quickly I'll just try to define some regex for registry ID, environment name, and all those things, and I'll just try to add quickly, so I'll not try to lag it behind. So the first thing is basically and let's try to import this jar. We can be, yeah, that should be fine. Okay, environment name, so regex it should be of this any of this caps alphabets or in this format and all, and registry ID as well, and environment boolean, just trying to check this one. I'll just be quick. Okay, fine. And now first thing we'll focus on so basically, yeah, I think by this you should be able to understand. So alphanumerics, dashes and underscores only is what this the registry ID meaning, and this one and I think that should be self-explanatory. And this n boolean function is basically it will try to convert this true, 1, yes, on, false, 0, no or off into like real booleans, like before George's boolean check, so that it's properly validated. So that's the thing. And now first thing is sandbox related preparation profiles. So that let's say we what and all we need. So for that I need the, let's say we are using Azure or GitHub or something, so just trying to add it in this way. So, and let's collapse this also a bit. Okay, so sandbox preparation profile, so it will be a string to env and then hooks. So here Azure for like this is more or less for our Terraform infra configuration. So Terraform Azure RM needs that, or Azure CLI needs this Azure CLI client ID and all those things. So that's the thing, and this hooks is for CLI login and all those things. And GitHub, we need this for our the creating an app and all those things inside the GitHub thing, so that we can connect to those things and all. So that's what. So basically this Azure, this is basically when it to conclude what this is, this is the registry mapping each the sandbox preparation profile to the env variables, like it injects and the lifecycle hooks it runs. So for example, here Azure brings in this cloud credentials plus the CLI login hook, and then GitHub brings this tokens and Git author identity details and all, and there's no hook and all. So that's the thing. And now the setting schema. So setting schema is going to be big, huge here. So that's like, properly typing it and all the cache. So I'll just not add it one by one, but I'll just add it and walk you through what this does exact, what and all we need. So okay, so we need a lot of stuff. So that's the thing. So here this is the full setting schema. So first is the service identity, so that's like groundwork and all, and then the infra endpoints that we have, NATS, Temporal and those things, and then the startup retry stuff that we have, and then the observability related structure logs enabled and all those things. After that, auth related is auth required, and those things like an access key, auths and all. Then the API records like API host and API port and groundwork MCP URL and origin regex and all. After that, it's like OpenAI or Azure model related details. We're using exclusively here OpenAI, just the only reason it's cheaper than Anthropic, though at work and everywhere Anthropic SDK and all is used. But anyhow, it's just swappable. But the intent is to understand the architecture and the way that we can come up with the infra system of this kind. So here OpenAI provider details and all those things, and if you are using that, or else Azure OpenAI related details and all those things. And then the sandbox related stuff, if it's a Docker, then Docker image exposed and Docker network. If it's a model that we're using, so model have name, image, ref and all details related to that. And if it's none, so yeah, and then object storage across all four backends, like document indexing, this. So S3 compatible, S3 Azure Blob GCS and all, so that is related to that. So everything, if it's depending upon the each backend, we need the specific Azure or GCS or the other things. And then the document parser related stuff, chunk size, and then embedding provider, in the model dimensions and all those things, and get related details, author name, email, committer name and all those things. GitHub app that will be trying to make commits and all those things. And the MCP servers, the validated ones, it's going to be an array of this object. So name, URL, allow tools, timeouts and cache tools list. So this is the the settings to get this whole of this self-hosted agent service needed. And okay, so that was like setting schema that you need. I hope you get the intent, right? So once we have this thing, then just type settings. I'm just trying to export that thing, and also some helper functions to compose or construct the Azure deployment base URL and all those things if you are using Azure and all. Though in this case, I'll just try to straight away use the OpenAI's API keys and then try to run this. But if you have used Azure OpenAI models, basically like Aux, they prefer to use Azure cloud and models within that instead of directly using OpenAI because of that some compliance issues and all. So that's, if that is the case, you can just define some helper function like this, which can give you the endpoint. So basically I'll just add in the function that is, this just trying to construct this OpenAI deployment settings or Azure OpenAI deployment and all those things. Okay, and then the helper function to get the settings. So basically it should return the settings object type, all the things that we need. So for that I'm going to create one function called get settings, and it should return all the settings object. So this is going to look like this. I know we need to add stuff, but I'm just, so get settings, so optional groundwork service name, environment, NATS URL, and all those things that I just gave you walkthrough and all those things. So here we have an errors and all, we'll just fix that. It's just the helper functions that I need to add in here, parsing and ensure built-in MCP server, some validate settings and all, which I'll just add in. So for optional helper, this is the simple function. So here we'll just take a name and then take that and try to see if it's greater than 0, and then we take that actual value, or else undefined. So that's the optional helper function, and that we need. And other things that we need is basically parsing the MCP servers and built-in stuff and all. So let me add them as an, so to parse MCP servers, this is going to look like this. Okay, so simple, we take in raw, and if it's not, we'll just return that, or else we'll just pass that and return that. So just a simple wrapper to check the proper errors and all, and then return after passing the JSON that whatever we are receiving. Okay, and then the function to ensure built-in MCP server, so we'll just check if it's existing, and then we'll try to get the first party MCP URL. And this also, like, couple of helpers I'll just try to add in here. So these are all basically extra checks to make sure that nothing is we are missing and all those things. So for example, so this first party MCP server URL, so this is going to be, if we have this settings.groundwork MCP URL, that right away we'll use that. Else the server settings API port and v1/mcp something, when we try to create Hono API endpoints, you will get this is what we'll try to expose our MCP in. And this documents MCP server URL will have this /docs thing. That's a difference, and this is what we are doing, whether it has files, docs and all, you're just trying to check. And this is what we written, groundwork and URL and cache tools list. And if it has files, we'll just add in these additional details. If it has docs, we'll just add in it can do search documents, fetch documents and all those things. You get the intent. So that's the parse MCP servers and all. And now for validating settings, so it's I'll also, let me add that also the validate settings. So that's also like so here, and this also needs, okay. So this validate settings, we try to see that if it's auth required, and if it doesn't has access key, then we know that it should be needed. So that, like, which are like interdependent, and if that is set, this also is needed, something, all those kinds of check is something that we do. And this is something you can just check it out. And I'm just walking you at a brief. And now we need to have this helpers to pass this GCS credentials and other sandbox environment variables, lifecycle hook IDs, and all those things. So let's do one thing at a time. For parsing GCS credentials JSON, so I'm just defining here just simple parsing. If it's error, we'll just catch that and throw that, so nothing else. We can just directly throw that, but just to capture this error, that's why we have this separate function. And then the parsing the exposed ports that we need to add, so that also basically we need to add this. So this helper to split CSV as well, I just need to basically comma separated value, so just trying to split that by commas. So split by comma, get the value, trim it, and then return that. So here that's what we are doing. So get the port number. If it's not number, we'll throw that exposed docker exposed ports must contain this actual TCP port numbers. And so that's the thing. And now we need to also have this helper function to get the all environment variables that is needed exclusively for sandbox. Just trying to isolate these things needed for specific components in our old system. So I'll just add in quickly those 3 helper functions that we need. Okay, so here we go. So this is the environment variables, and we just get these profiles and check that, and also we need to make sure that it's a unique environment names, not like duplicated things and all. It's just we're trying to filter through set. That's just the wrapper for that unique name. So here unique values, and same thing for unique env names as well. So I'll just add that, create a one set, and try to store this env into this, and then iterate through that raw strings list that we have, and make sure that we capture this unique value. So this is sandbox environment variables and getting this, and this lifecycle hook IDs is also going through this sandbox preparation profile names, and trying to push those hooks whatever we have and trying to get that. So mostly we got it covered what we need. Yeah, and that's the I think do we have any issue? I don't think so. Okay, this is pretty lot of checks and all, but that's fine. This is just being extra cautious and safer, because this is what needed to at least have our infra running. So that's why the strict check way before we start the critical components is expected. And if we need something else, and if we have missed something other than this, we can just come back and add it. But that should be about this config thing. And one, now we are done with basic stuffs: config package, contracts package, and then the observability package. Now the real thing starts, the DB stuffs. Okay, so actual tables that is needed to handle our the basic infra architecture and all those things. This is where we'll try to create the initial tables that we need, and try to migrate and create those tables in our we'll try to spin up our Docker Compose and have our Postgres and all, and let's see from here at least we'll start the core work. So the DB package now, before that let's try to run the type check and all. Okay, contracts is working fine with no issues. Config observability, we have an issue at 377. Okay, here. Okay, this one, let's make this is not null. I mean strict check, and now everything should be fine. Okay, fine. All right, so let's create a new folder called DB, and inside this I'm just going to create source folder, and also let's create package dot JSON file. So basically this one will also be pretty much similar what we have. It's just we'll have the DizzleKit related dependencies that we'll try to add in. So db and then source index, we'll have this generate command, DizzleKit generate, although we will write schemas as well as a SQL because we need some pgvector and other just control for ourselves in migration. And I'll just showcase it. It's a simple and how it generates in the same way we'll try to add it manually. That's the difference. That's nothing but. And once we have everything, we'll just try to run migrate and spin up our Postgres Docker container and then migrate, and it should create 4 tables, whatever we are trying to, or whatever tables that we'll be trying to add in this DB package for time being. Okay, and then we need contracts and then Dizzle ORM and then Postgres that we need, and then dev dependency, DizzleKit and those things. Okay, and also we need to add in this tsconfig. Pretty much the same. We just need to extend our base schema that we have, and also now in the base I can just add this path so that we can import in the directly as db in the other packages. Okay, so let's try to first create a schemas thing, because that's the important stuff. And so there also I'll just try to first let's try to install this thing so that we will get the result related dependencies and all that we need. Okay, so in here first thing I would focus on creating tables. One is the sessions. So this is going to be, I'm just going to close this and import this from the Drizzle ORM PG core, and also we need to import the other types and all those things. So let's import this thing, but I'll try to not add it one at a time, but I'll just add in, because already we know the types that we have defined in contracts and all. By that you should at least have the decent idea what and all we are going to have. So I'll just add all and then walk you through a bit, and should be fine. Okay, so and let's just import what and all we need. Okay, this sessions table, so all we need timestamp, text and all, you can just import from this Dizzle or MPC core. And let me just, anyhow we need the terminal to run the migrate command once we are done with all of this. So status, initial message, resources, tools, metadata, and model, sandbox, backend, temporal workflow ID, active turn ID, last sequence, created at and updated. So that's the first table, sessions related things. So and after that we need a table for session turns. So if you remember, so now I'll just add that session turns. So here also I'll just import this index from PG core. So this is session turns, and we'll have this ID, session ID, trigger event ID, same thing that while we added job contracts, in the same way status, source, position, prompt, resources, tools, and you can just check this definition. No, that should be fine. Reasoning effort, metadata, started at and all. Then we have this index on session ID, status and position. That's the thing. Okay, that's the second table. And then third table we need for session events. So here again the imports we need to this SQL is from drizzle ORM directly, so I need to, yeah, then okay, so this is the third table, session events, same, linking it to session ID, turn ID, sequence, type, payload, client event ID, producer ID we have, and producer sequence, so basically who produced this, and occurred at, created at, and we have the indexes on session ID and sequence, and that is the session sequence, and client event we are trying to, and also on the session created. So these are the indexes which helps us to retrieve way faster depending on the use cases that we'll be trying to use on. So that's the third table, session events, and then the other table that I'll try to add now for and is basically agent run states. So this agent run states, the just the table mirror here. So session ID, turn ID in state version, and serialized run state pending approvals and created at. And yeah, I think I'll not walk through much. Basically these are the tables by job contracts, whatever we added there, I walk you through a bit, and that should reflect here why do we need these tables and all those things. So okay, so that's the schema.ts, and I need to add drizzle config. So config.ts. So here I'm saying again I'm trying to add it manually so that we'll have better control, and also we need pgvector and other dependencies. So by default drizzle kit generate doesn't help us with that. So and now here simple, we need to just configure the config for drizzle kit and all, so that migrate and all those commands work. Simple, we need to attach in the schema, and also output where it should be into .drizzle. Dialect is PostgreSQL. DB credentials will just take it from the groundwork database URL. I'll just add this .env, which we have not yet added, or else by default fall back to this thing which will anyhow whenever we run this Docker Compose Postgres container, it will be this one, so it will fall back to that. So this is the config, and now I'll just define the drizzle folder. So inside this drizzle folder, and here we can just be as simple like, let's say, initial .sql. It's just the whatever the schema dot that we added, it's just the SQL code of that. So I'll also add it and just give you brief walkthrough. That should be self-explanatory. Yeah, okay. So here we're trying to create an extension pgcrypto and table sessions ID, status, initial messages, tools, JSON B, and all those things. Same session turns, and then session events, and then agent run states, and we are creating unique index, all these things that we added in our schema.ts. So that's the thing. So I'm just leaving it to you, and it should be pretty much the thing. And yeah, and also like to be very identical to what db generate command does, the maintaining the journal, how drizzle kit does, we can just add it in the same way. So meta, and create in here. Okay, and now inside this you can just add in the entries and version any of 0, 1 or 2 and all, depending upon how many times you ran. So I'll just add it any default things. So add timestamp just whenever you need, that should be fine. And now we're almost there, and I just need an helper to run this migration. And so for that I'll just create an helper function for me called this migrate.ts, and here Also, I'll just walk you through what this does, and should be simple. So here the function, again getting the database URL as the input, and then trying to get the migration path. Here in our case, this is this first SQL, and SQL trying to read that, and then SQL calling this Postgres, trying to run this, and that's what we are calling here in this thing, the migrate function that we have. Okay, pretty much the thing that we have, and I just need to add in the env file as well, and let's so I'll just maybe add in here env, and in this I'll just try to add initially what and all we at least need by default. So Groundwork service name, and your database URL, startup, retry items, and all those things that I need, and also the ports and all. You can add host port and all. So I'll just add in this something like this. Okay, fine. See, the main reason that I'm trying to just walk you through at high level of the code is basically these days most of the code is just generated using an example, using Cloud Code or Cursor or Codex or whatever it is. So the intent is to just understand the overall flow and the high level architecture, and the way that we can drive the application, and try to reason up the problem and come up with the approach and all. So that's the reason. So then there's nothing much. I can untype or narrate, try to walk you through each and every code snippet, but that should be fine. I think you must have got the point by now. Okay, fine. And now we need the Docker Compose YAML file to set up our Postgres container. So here this stuff, yeah, I think this also should be simple, because we have created many file, many products and all. So this also I'll just name Groundwork services, and Postgres pgvector, like I said, we need that, and Postgres DB, everything I'm setting it to Groundwork by default. And ports, I'm just attaching the environment variable that we have, 5432, and volumes you can just attach so that it will be persistent across restarts, and the health check just is ready, Groundwork and all those things. Yeah, volumes attaching, yeah, Postgres data, fine. That's the thing. And also, like, now in the main package.json to run for me, like burn db migrate in my terminal, I just need to add these commands here inside this script. So basically db migrate and db generate, and to run overall dev stack and all, I'll just add here a few commands under the scripts. And also we need to add few things. So here basically I'll add devstack.sh, and I'll walk you through what's the content of it's going to be, and high level how it's. So db migrate is basically trying to load the .env from this source, and after that trying to cd into db package and run migrate and generate, depending upon it's a migrate or generate command. And the script that I need to add is basically it's a simple script. Basically later we'll have many services and all, so I'll need an help of like just calling one script, so it figures out what and all services we need, bring it up and see if the port that is required for that is available. If not, can we check the next port automatically, and then bring up the dev stack no matter what, something of that sort. So here I'll just create a scripts folder, and inside this let's add this file devstack as thing. And here also I'll just walk you through, and I'm not going to talk much about every line or every code part, but the high level flow is something that I can just give you walk through. walk through basically. So the first few things what it does is just a bash, strict mode bash, that like what it does, it's trying to move to the repo root, and then it is bootstrapping the .env from the example. If we have not created .env, that's a good way. So anyhow, I have created .env, that should be fine by default, because when we push it to GitHub repo, then we'll have this .env.example, and even if the user has not created .env, we'll just try to create from that. So that's just like better add-on for whoever is trying to run this. Okay, and yeah, and after that we are just trying to close this bootstrap branch and then export every .env into the environment, so the steps below, like whatever we have, can read them. That's what we are doing, this thing. And here port available, basically it's the checking like is the TCP port free, and we'll try to check the fallback through like ls, OF, ss and netstat and all those things. And finally the raw dev TCP probe, if it works across, like basically it works across like Linux and Mac OS and all that stuff. So that's the thing. So and here the port, like I mentioned, it's like we'll try to pick a host, a port first, and trying to check if that port is available. If not, we'll see which is free, and then accordingly do a scan of like 100 port window, like 1000 above the default. So the stack still comes up like even when 543 is taken or some other port is taken. So that's this thing. Like I said, this is a whole like the intent, and then took the help of the cursor cloud code and then try to come up with this, and it works, and you can just try to iteratively test. And that's what I'll be committing as well, so you can just take an help of that. And here we're just trying to choose the port here. So basically is still the default, and rewrites at the point of this chosen port. And then after everything is done, we just run everything bun install, so that in dependencies across packages is installed. And then we come up with this Postgres container, and then we migrate and create the tables. So that's the thing. So now we can basically try to run this, and it should work pretty much the thing. So what, let's try to. So all I'm just going to run is the bun run. So if you are lazy to even to start the Docker compose container and all, you can just run bun run dev and basically see. So it's okay. Okay. That is related to other thing. So let's do one thing first. We'll only focus on checking the Postgres stuff. So it's running, okay, and I can just go to this thing and yeah, I think this command, it's something. Okay, that's just migrate. Okay, fine. Yeah, so you see now it's applied result SQL migration. That's, I think, the other we don't have the temporal NATS and all those things running, so we'll worry about that dev stack script. But at least now it has created this thing. Checked pgvector already exists, and relation exists, triggers exist, and all those things. So you can even clean up, because I've been testing it this one, so I already have in the volume that we have. That's why it's saying it's created, and at least we have applied this tables that we need. So at least now the tables that we need has been up, and now we'll try to create the database client factory and like CRUD functions for session on the tables, and then to read the session events, run state persistence and all that stuff, like normally now trying to, so that these functions can be used in our core domain logic and the core logic and all that stuff. Okay, one correction before moving to DB client factory and all. Bun run dev is working fine because it was waiting for the Postgres container to come up, and I was trying to, like, it was like race issue. So now it's up, so it's able to run cleanly. So I was wrong, like temporal and all those things, my bad. Sorry for that. Okay, fine. And also, like, in the base section, we can extend paths like we had it for DB. If we want, we can extend the schema and migrate as well. So for example, and so this migrate, yeah. So now this also we can directly use it in this way. Okay, fine. This is shortcut paths, alias things. So all right, so we have the foundation. Those tables are created in DB. You can see by connecting to your GUI, pgadmin or table plus or whatever it is, or else you can directly see using psql command if the tables are created and all. That's fine. Okay, all right, now the actual client factory. So that goes into our source index.ts file inside this thing. So I'll just create a new file called index.ts, and these are the core things. Then we will try to work on this at a time, one at a time. Okay, so first is let's try to create this database type, and this one, yep. So it's going to be of this, and I'm just going to import this one from Schema, and this one from Postgres.js that we have. And here I'll just try to create this type called DB client, and this will have this database and also the close function, callback function. So first thing, let's create a function called create DB. So I'm just creating this and pass in this database URL, which is going to be of type string, and this is going to return this DB client. Okay, so here first thing we'll do is like try to pass in this database URL to Postgres, and max, let's say 10, and this one I need to import this one from the Postgres dependency that we had it. So yeah, that's the dependency that we have, and after this all we are going to do is try to return in the format that we have for DB client. So drizzle, pass in this client along with that schema, and close. All we need to do call is client.n, and this drizzle you need to import this from the same thing. So here as well you can just import this and remove that. So single line. Yeah, okay, that's the like create DB thing. And now let's try to create a CRUD thing for our session thing. So that should be simple now. So I'm just going to call this as create session and pass in here this DB, which is going to be of type database that we defined above, and input this will have initial message, and so let's try to, this is going to return promise of type session, and these things now we can try to import this from the contracts that we have defined. So yep, and so now there should not be an issue. Of course the code we need to add, we'll add that, but this I will just try to import now. And so here the resources, it's going to be resources ref array, and the tool as well, tool ref. So let's try to import this from contracts. Yeah, So tools refs and also the okay, then after this the tools, maybe we can just keep this as an optional, and then this meta data. So then model, we have sandbox backend, and this temporal workflow id. No, I'm just going to, so this is the input, and now we just need to make a call db dot call this insert and pass in this schema dot sessions table that we have, and I just need to pass in for initial message, resources, tools. If we don't have, maybe we can just be way safer and create this empty array, metadata, input model, and this status. I can say it's a skewed and written, and if there's no row created, then we'll say the failed to create, or else we'll just try to return this map session. And for that, I'll just have the converter. So map session. So here we are just going to receive schema session, and in here all we need to do is just try to attach row.id, status, session status, initial message, and yeah, I'll just try to extend this resources, tools, metadata, model, sandbox, backend. What's the issue? Temporal workflow ID. I don't think, yeah. Active turn ID, and yeah, pretty much this thing. And here we'll just pass in this thing. Okay. Sessions, we do have this. Okay, did I? That's fine, we'll see if, but that's the thing, to create a session, and now the function to get this session. So async will pass in the same db, pretty standard, and this session id, which is the string, and then promise of session or null. So let me close this one, and here all we need to do is call this and import this from the drizzle equal from drizzle orm. So here select from the schema.sessions and match the session id with this thing, and also we can be very strict here, like maybe limit 1, and then if it's not a row, we'll just return null, or else we'll just return the session thing. Okay, fine. And also, like maybe let's say if it's required function and all, just the like let's say require session, and here session id, and then all we can just use that. If yeah, pretty simple straightforward thing. So this is the simple db client factory and the CRUD for session related string stuff. And now we can just maybe run this type check. Yeah, there is an issue with this. Let me see what is this. Okay, the issue was in our this sessions in our contracts. Uh, we had a sandbox backend defined with capital S, so I just changed that to a small s, and then if you run this, it should be now fine. All right, so that's the related to session CRUD and all. Now we need to same thing we need to do for our session event things and all. So so I'm just going to do the same for, let's say, a list session events, pass in here this database, session ID. Along with this, I'll just pass in here after, and this limit so yeah, so this is promise of session event array, so I just need to import session event. Now inside this, so simple, I just need to call the session events and pass in where matching that one to and let's first see this logic. Okay, so I'm just trying to, yeah, mostly okay, fine. Doing the check that session ID should match and also greater than, I think GT should be fine, and then ordering by ascending order we're trying to limit, and after that we are just trying to map this one to map event, and that one same way that I just created, I need to, yeah, so this is the thing, map event, so row session events thing, and here I need to attach in sequence and then type, then the payload occurred at pretty much the same, and yeah, okay, that's the thing. And this greater than and ascending, I just need to import that, and that should remove this any errors. Okay, fine, that's the listing the session events, pretty straightforward. And same thing we need to do for getting the session event, and here again I'll just pass in this database, and then here we need to pass in this event ID, and yeah, pretty much trying to get this from session events where matching this ID to event ID, limiting one, and doing the same thing. And then the one more helper function to get the latest run state. So so here also we'll pass in the database session ID, and this here I'll try to return this promise of this object. Let's say this ID, and then serialized run state, which is going to be a string, and pending approvals, which is the okay. Okay, let's first try to db selecting from this agent run states and trying to match with session id. That's fine. And ordering by descending created at yep, and limiting by 1. And here I'll just if it's a row, we'll just return, else this null, and I'm just going to remove this check. And here the issue is basically I need to add in this null. Yeah, and then I need to import this descending, and then we should see that error go. Okay, yep. So that's the thing, getting the latest run state that we have, and also now the function to save the run state. So here database, and this input is going to be an object passing in the session id, and then this turn id, which is again going to be string or null, and let's say serialized run state again going to be a string pending approvals. And yeah, and here what I'll do, basically first let's try to get this max version. So we can try to query max version. Okay, so I'm just trying to get the max version, and here, yeah, from this agent run states, and then matching with the session id and version, we are incrementing it to 1 by 1, and then we are trying to insert values, session id, input turn id, and version, that thing that we have, and same thing. Yeah, fine. And then this just the helper function for session subject. I'm just going to add in here session events. Okay, this is something related to session events, and then saving run state, and getting the latest run state, and all just the all wrappers around the tables queries that we have just created, so that we can use it in our core logic. That's the thing. So session event reads and run state persistence and all, and now basically now appending session events, and with the logged sequence update and all that stuff is something we need to add. So they are nothing but like a durable event append with the sequence log and all. So let's see, and for that let me first define the type called append event input. So in this, the type will have session event type, and payload, it's going to be an optional unknown, and client event id, which is going to be a string, turn id, the string or null. Okay, and then producer id and producer sequence, and also the occurred. Okay, fine. This is like append event input, and now let's create this function. I know I'm just creating all the things that we needed and all, rather than coming back and then adding it up front. Either way works, anything works fine, just up to you. Fine. And append, I'll just call this thing as session events, and in this first thing, as always, the db, and then the session id, which is the string, yep, and the inputs, it's going to be an array, and the return type, it's going to be promise of session event array. Okay, fine. And here, first thing what we do, we check if its inputs length is 0. We're not doing anything, we'll just try to return empty array. If not, then we need to do some transactions here. So let's try to close this first. Okay, so here let's try to get this logged. So transaction, try to execute. So here I'm just trying to get this last sequence, and I'm just trying to query, yeah, the update, this is exactly. So okay, and after that we will, so if it's no row, then we'll say that session is not found. Else, let's so this get this now row dot loss sequence, and then now these values, which now I need to iterate through this inputs list that we have, and okay, let's see. Okay, now here session id, and then the sequence, anyhow we can do it, any order should be fine, and type is input type, turn id, and the payload, client event id, producer id, and this new date. Okay, so that's the and let's, okay, now we have this values. So let's try to insert this now. Try to call this insert, pass in this values thing. Okay, session id, what's the issue here? Okay, I think we are missing sequence is fine, type, payload, disarity. Okay, fine, that's the time thing. Oh, all right, so after that we're just now await, we need to update these sessions now. So, and update here last sequence to the sequence that we have, and also update here updated at and yeah, I think this is the thing. Okay, this is how we try to update session events, pretty like updating in transaction, first updating session events and then updating sessions, pretty much the way, and also now appending session events like with logged session update and all. So this basically the function let's name, looks like some issue. Okay, okay, I'll just try. Okay, export async function append session events with log the session update, and here we'll pass in this db and also the session id, which is string, and then this build function. So this input is going to be session type, and here this thing, the events append event input, and update resource ref. So this is what will be returning from this function, and this tools tool ref array model, let's give string and metadata. This is going to be record of string of unknown, and the status, which is session status, and then this active turn id, it's a string or null. Okay, fine. And that's the this function, and okay, so this, it's going to be returning this promise of session event array. So, and now inside this, okay, so again this is also same thing, we need to perform in the transaction. So first thing, let's try to get the session row, and here we'll try to get that from our sessions table, and if it's not found, we'll just throw in session is not found, and after that we need to call this function and pass in the session row that we have, and then if events length is 0, we are just going to return from here, else we will try to now prepare this values list. So here let's trying to build this thing, sessions input id, pretty much the same way that we did. Once we have that, insert into session events whatever the values that we get, and then update, I'm just going to build.update or else empty dictionary. Then we are going to update the sessions, and here we need to set a lot of things here. So what I'm going to do is basically last sequence to sequence that we have, and now if this update dot resources is not undefined, then we are going to set that or else to empty dictionary. So like this, we'll try to set everything: tools, model, metadata, status, active turn id, and Okay, I think the formatting is messing it up. Let's just undo this. Okay, this is at least something better. And now let's do one at a time. So if update is undefined, so I'm going to set this. So same thing. Now it's okay, fine. Tools, model, metadata, and active turn ID updated now. Just matching with session ID, and then we are trying to return that thing. Fine. So these are like appending session events with logged session update and all those things. That thing that we need, basically these are all the things that we need to make an entries into our database tables that we have. And now it's related to creating a turn, and how do we enqueue session turns, and how do we claim next turn, and then setting temporal workflow ID, and all those things help us that we normally need to cover other things and all. We need to create functions similar way in this file. You can even create separate files and all. Idea is anyhow the same, the logic wise. So I'm just keeping it in under the same file, and let's try to add these things related to turn as well. Queuing, enqueuing, claiming, reordering, and canceling and all. Okay, now turn related queue and enqueue and all those things. So before we try to create that, let's create these helpers like mapping and all those things, and then trying to get prompt resources from triggering things and all those things. So function, yeah, map session turn. So here okay, so ID, session ID, trigger event ID, then workflow ID, status, source, position, prompt, resources, tools, model, reasoning effort, sandbox backend, metadata, started at. Okay, this one, what I'm going to do is basically, yeah, okay, uncreated, and I think here same thing for the session turn, sandbox, yeah, fine. That's the helper, and now function to get the next turn position. Yep, so this thing, so I'll just try to get this max position, and then add the one is, yeah. So this is the simple trying to get this from the session turns, matching session ID, and then accessing max position plus 1 if it is present, or else by default 1 is what we'll try to give. And few things, other things that I need is basically getting a turn status for finish. Okay, so I'll name the same thing in this like turn status for finish. So here I'll pass in here the status, which is the session status or session turn status, and in here we'll just do if status is let's say idle, then I'll return completed, and if status is queued, we'll return it as queued. Okay, and if status is running, I'll just return it as running, else we'll just return whatever the default status is. Okay, and now from trigger thing, if I wanted to get the prompt, or if I wanted to get resources and tools and reasoning effort and all, just the helper to get directly from that payload. So here prompt from this trigger, so payload, so this can be a string or null. Okay, and here I'm just if payload and this type of payload is equals to object, and we have this text in payload, and also this type of payload text is string, then I'm just going to return that else null. Okay, yeah, just check. And same thing, resources from trigger, and here as well. So it's a payload, and type of payload is object, and resources in payload, and it's an array. Then we will try to return that resources or else null. So yeah, now same thing for tools, pretty much the same, and reasoning effort from session. So this will have session as an input, and we will try to get the value from the metadata that we have, and yeah, this is what I'll, if it's non-minimal, low, medium, xi or high, will just return that value, else by default medium. Okay, these things we need. Now these are the things that we need to use to create a turn and all those things. Okay, fine. So anyhow, that's fine. Anywhere we can just define wherever we want. Okay, so now let's create the function. Create a turn, and here we'll pass in this db, and input is going to be an object with session id, and then this trigger event id, which is going to be of type string, temporal workflow id, and we are going to return this promise of type string. Okay, so now in here, first let's check if session is available or that for that or not, and after that this trigger, so we'll try to get the session event, and then this position, so next turn position by passing in this session id, and now we will try to insert these two session turns and values, session id, trigger event id, workflow id, and status. I need to set this to running, and source is user position, and prompt from the trigger that I just mentioned. Or else what we are going to do is basically pass in the initial message, seam resources as well. So and tools in the same way, then model and reasoning effort that we have, and the sandbox backend metadata. I'll just pass in this empty dictionary and started at as a new date, and yeah, okay. And returning, we will just return here session stance id. Yep. And now if there's no row, we just say that we were not able to create a turn. And if yes, we need to first update sessions. So here we need to set that active turn id, and also we need to set the status as running and update it at to new date, and then return this thing. So this is the way to create a turn, the simple way. And now we need to enqueue the session turn. That's one the helper, the function that we need. So enqueue session turn. So here again db, and input, this will have some, let me just define the type here. Let's say, yeah, enqueue session turn input. So this will have session id, and same thing, so trigger event id, temporal workflow id, and source, it will have the prompt or resources, tools ref, model, reasoning effort. Yeah, okay, fine. And now this basically I'll just use this here. So input, and return, I'm going to return here the session turn, and let's do this in transaction. So return a Vite, and let me close this. Okay, first is let's get this position, call this next turn position that we have, and then try to insert into session turns values, session id, same predicate, source, position, prompt, resources, tools, model, reasoning effort, backend metadata. Returning will just not return anything, and yeah, and I'm just going to use this map session to turn, so basically trying to return old row. So that's the enqueue session turn that we have. And now the function to help us claim next queued turn. Okay, so how do we do that is basically claim next queued turn, and database and session id a string, and this workflow id, and so yeah, we'll try to wrap this in transaction. So first I'll get rid of this auto completion that I have. Okay, so here let's try to get the rows from transaction execute, SQL, yeah, id. Okay, fine. So here now I'm trying to select id from session turns and matching it with the session id, and status is queued, and let's remove this. in order by position in ascending order, and also created at, and then I'm okay, and we'll limit this one. Okay, all right, so this is the rows, and now here what we will do is we will first check if we have this id or not. If not, I'm just going to straight away return null, and if we have an id, so what I'm going to do is basically update session turns and set a status as running, and updated at and started at, and also temporal workflow id, will just set that, and then if it's not able to claim, we'll just say that session not found, or like failed to claim to, or whatever it is. And if it was successful, then again we need to update sessions now and set that status to running, active turn id to row.id, and update that to thing, and finally return this. So this is how we take care of how do we claim that next queue turn that we have, and this should be pretty much fine. That's the thing. And now we need some helpers, like to set the session status, setting the temporal workflow id, like finishing turn and getting session turn, and all those things. Simple straightforward CRUD wrappers and all. So let's function here will pass in this database session id and status, and along with that active turn id, which is string or null, and here we're just updating sessions, directly setting the status, updated at, and the active turn id, and here we can be maybe if active turn id is basically undefined, I'm going to set this undefined, or else pass in this active turn id, and that's the simple function to setting the session status. So same way we need to have the function to set the temporal workflow id. So so this also should be pretty much the straightforward setting this. Maybe you can keep this as temporal workflow id or workflow id, whatever it is. Okay, fine. And then function to finish the status, finish turn. So database, and then this turn id, which is a string, then the session status, okay. And now in here we will just db.update the session turns table, status, we'll set that, finish that. This one, maybe what we can do is we'll check the status. So if it requires action, then I'll set this to undefined, else we'll set this to the current value. Okay, fine. And now to get the details, so get session turn. Yeah, so simple from session turns, trying to get this limit one, and yep. And next is just trying to list session turns. So this and all, I'm trying to write all the wrappers and the backend functions and all, so that directly later we can consume in our client's consumptions and all. So that's the only point, because better if we get the backend and all the stuff and all way upfront than to anyhow it works like incrementally trying to do vertical in backend and front end and all. But still, this is not like UI focused, it's more or less in front backend stuff focused. That's why I'm focusing on this stuff. So list session turns, so database and session ID, and then this limit, maybe let's say 100, and here we need to return this, and simple select from the session turns, match with session ID, order by position, ascending, and also created at, and I'm just going to remove this. Okay, and fine. Yeah, that's the thing. And now we still need a lot of functions like updating queued session turn, like canceling queued session turn, reordering queued session turns, and I think those are the three functions we need still. Let's try to add update queued session turn db database turn id and input. So it's going to be update queued session turn input, and we are going to return promise of session turn. Okay, and I think this update thing also I need to define this type. Okay, yeah. So this will have this prompt, resources, tools, model, reasoning efforts, sandbox backend, and then yeah, and we can just remove this optional things, make it, yeah. Okay, now the type we have defined, and now inside this basically we need to just update session turns and set whatever the values that we are receiving. So db dot update session turns. Okay, so as usual we'll just try to check in the same way, prompt, and yeah. So if it's prompt we have, we'll set that, and every field like that, if it is getting, we'll just update that, else we'll not do anything. And matching with the turn id, along with that status is queued. Yep. I think there is it should be here. Yeah, now the syntax is correct. Matching with the turn id and the status is queued, so that's the thing. And now canceling the queued session turn, so export session turn, and for this, of course, the database and the turn ID, and here I'm just going to return session turn. So I'm just querying session turns and set the status to cancel, updated at, and finished at, and we are just going to match the one with the turn ID and queue and return that, and then map session turn. All right, and then final thing is reorder queued session turns. So here this database and then the session ID, and then we'll have this turn IDs, and I'm just going to return this list of, and here let's try to wrap everything inside this transaction. So let me just close this. So let's first try to get from the session turns matching with session ID, and then the status is queued, and also in array, and this will import that. Okay, and okay, once we get those values, so here I'm going to check if this is not equals to the turn IDs that we are trying to request. We'll just say that failed to reorder turns or whatever it is, and then let index set it to 0, and now we'll need to iterate through the turn IDs that we have, and in here let's first try to increment this index, and I need to now update session turns, set that position, and matching that with the turn ID, and after that is done, we need to select the updated things from the session turns, matching the session ID along with the status queued, and then we need to order by the position, and then the created at, and then we need to map this updated to session turn. And here basically it needs to be, and yeah, okay, fine. So this in array I need to import this, and then we should be sorted. Okay, yeah, so that's the reordering thing, and pretty much now whatever we needed for our turns, queuing, unqueuing, claim, reorder, cancel, and all the queries that we need, we have pretty much added it. And next is basically we need to shift our focus to adding our events package. That's where we'll try to initialize our NATS, which really helps us with real-time event subscribing and streaming to our UI and all that stuff. So we will add that events package same way that we added the other packages. Okay, so let's add new package inside this packages folder. So I'm just naming that as events, and inside this we need to add in package.json, and also the source folder, and index.ts file, and also tsconfig json file. Okay, and in each of that package.json, pretty straightforward. It's a name, its dependencies, and those should do it. Okay, so events and then main types and type check, and dependencies db package and contracts and nats thing, and other pretty standard thing. And also the ts config, it's just we need to extend the base and include the main source folder. So here's the thing. And now let's try to install this dependencies, and also now in the we need to add nats in docker compose, but we'll add that. But before that, I just need to try to work on this part. The main thing, it'll be just small and quick. First thing, let's try to create this codec. So from this nats, and this one will be of type session. It will be burst message and a session event. So that one we need to update inside the contracts package. So if I go in here, and let me just add it quickly, export const the session burst message. So this basically will have the session id and this events array. Okay, so it will be of type array, and minimum it has to have one, and then the type simple. So this is the like envelope published on nats, like a session id along with that a non-empty batch of events, which will be of course validated by Jord and exported as both schema and type. And now let's go back to or this package in this source thing, and on this we just need to import now from this contracts that we have just defined, and this can be or of session event. Yep, so this is the simple codec. And now the let's create a type of called event bus. So this will have a function to publish, subscribe, and close. So here publish, we'll need to pass in the session id, and then the events, which is session event array, and this will be like return promise void, and this is the subscribe session id, which is going to be of type string, and on events let's have this events session event as the input, and this is the simple callback function. And here we can have promise of void or void, and same in here I'll just yep, fine. So that's the simple event bus, and let's now create the actual function to create NATS event bus, and then couple of functions to append and publish events and subscribe to that session and all. So here this function, I'll name this as create NATS event bus. So here we need to pass in actual NATS URL, the one which we will try to spin up using our Docker compose, and this it's going to return promise of type event bus. So here we will import this connect from this NATS and pass in here the server's NATS URL. So it can be, if like let's say if we have multiple things, it can be a list of this URLs or else single string, both anyhow works. And now we need to return in this format, publish thing first, session ID, events, and here if events length is 0, I'm just going to return, and then we are going to publish the session subject that will be importing it from the DB package, and pass in here the session ID along with that encoding events along with the session ID. And after that we are just going to flush that. Yeah, that's the thing. And subscribe also, let's so subscribe, I'll just call in this function called subscribe session, which we will just define now below. Okay, let's define that anyhow. So this is called subscribe session. So here this will be NATS connection, and the session ID, and on events callback thing. Okay, and this yeah, and now inside this let's create this subscription which from the NATS, and here I'm just going to call this subscribe and pass in here this session subject and pass in the session ID. Okay, and now all we need to do is basically trying to keep listening to this. So for await that message whatever we have in subscription, and then we need to first decode, and that one as session bus message or the event. And now we need to get that events. So basically just double checking if events and decoded, we get that decoded dot events, or else we try to frame it in the array, and then we'll just emit that events to callback function. And yeah, and in cleanup we'll just try to unsubscribe. So that is the simple subscribe session function that we need. And now here I'm just going to call this subscribe session, pass in this nc NATS connector and session ID and all events, and after that it's the close. So here all we should do is basically just try to call this await nc dot drain function. Yeah, and yeah, I think we did not add here this close, and that should be this simple creates NATS event bus and subscribe session. And also I need a function to append and publish events. Later I'll be using it, so I'll just try to create right now itself. So async function append and publish events, and here we need a database and the bus, which is the event bus, and the session ID and events. So here the events type, it's going to be append event input array, and this is going to be returning promise of type session event array. Okay, and also we need to import this database. Fine. And now here appended, so append and publish instead of, so here we need to call this append session events. So in the DB that we define, pass in this DB session ID and events, and call this publish, and yeah, okay, fine. So that's the simple function. And also maybe an helper function, like to format into SEC and or lol, we can just for our testing purpose. So for example, if I pass in session event, and here we might maybe return this. So instead of this data, like ID, yeah, event dot sequence and event dot type, and then data we just stringify, and yeah, we can maybe join by new line. I'm just helpers like this we can just add in. So I'm just coding as an example and all, but yeah, so this is the simple the publishing and creating NATS event bus is something that's needed, pretty much that we want. And now I need to update our the Docker Compose stuff to include the NATS. So here yeah, we can be specific to latest or to Alpine lighter one, and then this command, this is going to be, yep, and NATS host post is this, and also the monitor host post also we can add. It has 8222 and health check. What we can do is basically try to make wget call, yeah, to this health endpoint. This should be it, and yeah, this is the thing. And now we need to update our basically this is the simple NATS server that we can just bring it up, and we have this actual host port, and this is just a monitor just for a health check and all, and this is pretty much the standard stuff. Okay, and also now we need to update our script as well as the env thing, and here, yeah, so NATS URL, it's going to be 4222, yeah, that's the thing. And the dev script is basically I need to update that too. So here this dev stack, so need to add in two ports, NATS host port and NATS monitor host port, and here we need to try to do it in the same way. Default NATS URL. Yep. So this is the default NATS URL, and if this if it's the same, then we are going to export that thing, and then that same thing. And here now I need to just add in this thing, and if I just run the bun run dev, it should help us spin both of the Postgres. And so let's try to run this. So you can see now it's spinning up the okay. Okay, again this is the race condition, which we will fix it, but that's if you wait a bit and try to run, mostly it's going to work. Yeah, this is the thing. So it has now, you can see in Docker Compose desktop app that you have Docker desktop, and you should be able to see NATS and Postgres and all. That should be the thing. And yeah, and just that's a simple events thing, and we'll come back to this when we are like near to the streaming and all in UI and all those things, and how this is working fine or not. And you can even check using curl command with this health URL that I just added in the Docker Compose. It should give you status as okay or so. Okay, and all right, so we also now established the foundation for events package, and now we need to start extending the schema SQL schema to include some related to file assets and file uploads tables and upload lifecycle helpers and all those things, because we will be supporting the resources intake as well, right? So for that, let's go to contracts, and I'll just try to minimize this terminal, and let's open the contracts stuff. And here we need to start adding related to the file as well. So now the file status, so this is going to be of type enum as well. So here we'll have this as pending upload, and then is it ready, did it fail, and expired, and then deleted. Yeah, okay, fine. So and then we need to just export this type file status, and now the file upload status. This also, it's going to be an enum. Yep, pending, and I'll just keep it this simple: pending, completed, expired, and failed. Yep, and the type, fine. And now the file asset, so this is going to be an object, so it will have the ID, and then the status, file status, and also the file name. This is going to be just the optional string, and file name, which will be a string. Okay, and then this content type, this is again going to be of type string. Yeah, okay, then the size in bytes, so this is going to be number, and it's going to be positive, and then the SHA of that file, and this can be nullable, so I'll just set that. And also the bucket, this also going to be of type string, and then this object key, which is again string, and then created at and updated at should be fine. So that's the file asset. And yeah, I think these are the things that we need, the types and the enums and all those things. And now we need to add the schemas. So basically in the DB section, the table that we need, and also the SQL stuff and all, we'll first add the schemas, and then I'll just quickly add the sequels followed by that. So this also I'm just going to straight away add it and walk you through what and all we'll have for this. Okay, so here let's say import. Okay, now it's done. Okay, so here files table, it'll have ID, status, file name, same thing, the file asset that we just created, all the same related fields, and unique index on this object key and the status stuff. And then file uploads table, same file ID, status, expired at, created at, update, and index on file ID and status. So these are the simple couple of tables that we need for to handle this file assets and all that stuff. And also we need to add this query functions to create file upload, as well as get file, require file, just spread up so that on these tables that we are going to add. And also I need to add in the SQL. So here we can try to create multiple migrations using the and manage that using Drizzle and all. Since it's just the simple application, I'll try to keep it in the same file itself. So anyhow, but ideally it's not recommended. Try to generate a new migration for each of the new tables or new changes that we'll be adding in. So in here, that's why I'll just stick to one SQL itself. And here I'll add these two tables, files, ID, status, file name, save file name, content type, size bytes, and same thing. And creating unique index on files, object key, and status, same for file uploads and all that thing. All right, so and we have this, and we should be able to run db migrate and create this new two tables. We will do that. And here I'll just now add this functions that we need to create and all that stuff. So first thing, we need that helper we wanted, which is map file. Yep. And here let's import this one. And now I'm just going to okay, ID, status, file name, save file name, content type, size bytes, SHA, bucket, object key. Yeah, this is it. And now here let's try to define one function at a time. Let's try to create a simple function. First is getting the file. So we'll pass in the db file ID, and yeah, and here I'll just try to select from the files table, match with the ID that we'll be trying to get, and that's it. If it's not, we'll just return that. Okay. And now the function to require file. Yep, db file ID, promise of that, and get this. If it's not, and here I'm just going to return this file. So that's the thing. And then the function to get file upload, and in here we'll pass this database and also the upload ID, and the return thing will have this ID ID thing. Along with that, the status, file upload status, and also the expires at, which is going to be of type date, and finally the file asset. Okay, or else it's going to be of type null. Okay, now inside this we need to now query the file uploads thing, and here we need to get the exact things that we need: ID, status, expire set, and file thing. So here schema dot file should do, yeah, okay. And we need to do joining here, so inner join schema files by this file ID, and yep, yeah, this exactly. So we'll get that row, and along with that, if we have row, we'll just return the status, expire set, and file, or else null. So that's the simple function to get the file upload, and also now the another function to complete the file upload. So complete file upload, and here let's pass in this database and upload ID, which is of type string, and this is going to file asset. Okay, and in here now let's try to handle this one in transaction. Okay, so here first let's try to get the upload row. Okay, we are just querying the file uploads matching with this ID, and this for the update. Yep, okay. And after that we'll just do a check. If there's no row, we'll just say that file upload not found. And now we'll try to get this file row. So now we'll query this files table using this upload row file ID, and trying to check the same. And after that, again the same check. If file row is not found, we are just going to throw that error. And here now the new date, and now let's try to update this. All I'm going to do is set the status to ready. Yep, and updated at, and we are just going to and here let's use this file row dot ID, and after that let's set the status to completed, and also updated at also the same thing. And yeah, pretty much this is the thing. Okay, just complete file upload. So first we are trying to get the upload row from file uploads thing, and once we are just getting the file row from that using that file id. Once you find that, we are just updating that status as ready in files and also completed in file uploads. And this is the simple thing to just mark the specific status rows in our tables. That's pretty standard. Okay, and that was the updating to completion. And now we need similar function to mark it as failed. So mark file upload failed. So same database, and the upload id, and then file id. Okay, and I'm just going to okay, and here as well we'll just try to wrap it in transaction. So await. Okay, so I'm just going to update file.uploads, setting the status as failed, updated it as now, and just matching with the upload id. And the same thing in my files as well. I'm just going to do the same thing. Yeah, pretty standard file to mark them as thing. And yeah, almost we need whatever the functions we needed, we have created, except one thing. Now the creating file upload, so that alone is needed now. So function create file upload. Okay, so here the database and input. Now we'll attach file id, file name, then say file name, content type, size bytes, sha, and this one, let's make this one optional, or it can be null as well. And then the bucket, object key, and expires at the date. And yep, and this return type, it's going to be promise of okay, promise of the file asset that we'll have. And let's remove all of this upload id, and then the expires at, which is going to be a string. Okay, fine. And now inside this the transaction file row, we need to I don't know why this select, it should be insert into files, and the values id and everything whatever we're just getting, we need to just attach. Okay, file id, file name, save file name, content type, size bytes, sha, bucket, object key, and the status pending upload. And then we will just call the returning. Okay, and now if file row is not found, we'll say that failed to create file. Else we will now insert this into file uploads as well as pending. Like we'll pass in this file id, so id, just remove this, and status is pending, expires at. And here we will now try to return the id, schema.fileuploads.id, and expires at. And we'll do the same check again. If upload row is not found, and we'll just throw in error, or else we'll just return this. So upload id, upload road expire cert, exactly the same thing, and map file. Yep. Okay, so these are the functions that we need, and now pretty much for the files and all it's there, and we can just run run db migrate and all. Okay, okay, connection refused. Let me. Okay, it is 5432 is used, so it is running in 6432. Okay. So let's just wait to, yeah, I'll check the Docker compose. Okay, neither of them are up, so it's or else we can just try to run this Docker compose alone, and now try to run this migrate. Yeah. Okay, so file uploads status, and also the file uploads file id index, file uploads table, and then this indexes and files table. Okay, that's created. So that's the thing now of adding the file related tables and all. So now we have added files and all, so now we need to think about file storage packages, like trying to add a cloud agnostic, maybe local we will use MiniIO, or then we can also add support for AWS S3, GCP's cloud storage, and then Azure file storage and all those things. So that's the package now we should try to focus on and add for those files related stuff. So the storage package now, so I'll just add in new folder called storage, and inside this as usual let's create package.json, and let's just minimize this terminal, and here this is going to be pretty much ground storage and same, and dependencies since we'll be supporting all S3 compatible, so MiniIO local thing, and AWS S3 and Azure storage blob and global cloud storage, and then our internal packages config and contracts. So this is what is needed, and also in our base we can extend the for the events, and yeah, so the events, and now for the storage, which we will add this index.ts file. Okay, so here let's create a new source folder, and index.ts, and also tsconfig, just the extending the base thing normally that we did for other packages. Okay, so just the normal extension, and now inside this We will quickly add what and all we need. So I'll just import the settings, config thing that we need and all those things from our package. So let's import from our config. And yeah, I think let's just run this one install. Okay, okay, there's internet connectivity issue, that's why we are seeing this error. Okay, now I'm connected to my Wi-Fi. Let's try to install this. All right, there we go. Now we have this whatever we need. And okay, whatever the imports that I need, I'll just add. And but that's the core the settings that we need. And now some constants, the max single, like we'll try to limit the put size bytes. So yeah, 5 GB is something that we'll try to limit that. You can even add it in this way, or else add this way as well. So it should be pretty much in the same order. And then the another constants is basically upload URLs TTL seconds. So here we'll keep this one to 15 minutes. Okay, and then the download URL TTL seconds, this, let's keep this one to 5 minutes. Okay, fine. So those are the constants that we would need. And now yep, then the like type for our object head. So, and let's just collapse this terminal. Okay, so here let's define this as object head, and this will have this content length, and then the content type, this headers pretty standard, and then this metadata would be of record of type string unstring. Okay, fine, that's the thing. And now this object storage, this will have this bucket which is of type string, and then this backend. So yeah, we'll have S3 compatible, AWS S3, Azure Blob, and GCS. And then the max single put size bytes, that's going to be of type number. And then we'll have the function to create the put URL, and this is going to take the aux of type. Let's this is going to have the key string, and this content type string, and SHA 256. Let's keep this one to be an optional string, so I can set this one to either to be string or of type null. And then the expires in seconds, this also I'll just keep this one to be optional and number. And yep, so and this is going to return this promise of object having this URL, which is going to be a string. And then this required headers, which is going to be of type record of string. And then this expires at, which is going to be a of type date. So that's the create put URL. And similarly, we need to have create get URL, head file, and get file bytes. So like these are like a couple of more functions that will try to make this part of this object storage. So here create get URL, and again this will have this arguments key. It's going to be a string and expires in seconds number, and then I'm just going to return this having a promise of URL and expire at the thing. Okay, fine, and let's just remove this thing, and now this head file, this is going to take in this file asset from our contracts that we have, and I'm just going to return this object head, and then the other getting the file bytes. This also would be pretty much in this way. Okay, these are the things that will make as part of this object storage for time being. And now we need to create a function, kind of like, let's try to create one function at a time. Like I'll add like something like S3 compatible object storage thing. So here this should be pretty much standard, because any application so far dealing with the files and all, you would have used this blob storage and all those things. So create S3 compatible storage, and here the settings. So I'm just passing in this as an input, and in return we are going to return of type the object storage or null. So now we need to fulfill all the functions and properties that we define in above thing. So first thing we are going to do is we'll check if the backend is S3 compatible, and also now the settings dot object storage endpoint or the just the safer side checking here, nothing much. So, and object storage access key ID and secret access key. And yep, so if we don't have this required things, then okay, if we don't have this, we are just straight away going to return this. That's a simple, just checking, like, you know, making sure we have the endpoint and also the access key and access key ID. So here, yeah, and let's remove this. That was the, yep, fine. And now this client config, this is going to be of type S3 client config from this AWS SDK. So I'm just going to import that. So here we need to specify the region, which would be settings.object storage region, and also this force path style. I'm going to again use this object storage force path style. Request checksum calculation, and this one we are going to say when required. And now then settings dot this object storage endpoint, if we have, then I'm going to set that endpoint, and the same way for the access key ID. So object access key ID and the secret access key. Then we are going to set the credentials thing, passing in the access key ID and secret access key, and that's it. So that's the client config that we have. And once we have this client config, now we can just pass in that to our new S3 client from this AWS SDK, and passing in this thing, and we'll have the actual client. And here now I need to start returning the actual things that this object storage expects. So first is the bucket. So this is going to be straightforward, settings.object storage bucket, and this backend. So here we'll just try to check if the object storage backend is AWS S3, then I'm going to say it's AWS S3, or else it is going to be S3 compatible. And then maxing single put size bytes, we have that constant defined, so I'm just going to use that. And let's remove this. Okay, and now this create put URL. So here now this aux whatever we have, and here first expires in, let's use this expires in seconds, or else by default I'm just going to use this upload URL time constant that we define. And we required headers, which is going to be of type this record a string. So here content type, I'm just going to set this content type. And now we need to prepare this command. So we'll use this new put and import this from AWS S3 client, and here we need to attach now the bucket, which is going to be settings.object storage bucket, and keys, and the content type that we have. And so here let's this meta data, if we have this args SHA thing, I'm going to set here the SHA, or else I'm just going to pass in this define. And finally here what we are going to do is return this URL, that is the signed URL. So here we'll get signed URL, pass in this client command, and expires in required headers. And yep, and we need to just import this one. So this is the thing for our putting the URL, basically getting signed URL so that we can upload. That's this standard pattern that we have. So same way now we need to define for our so here now I need to do the same thing for create get URL. So expires in, again download URL things, and then here URL we are just going to use the get object command, pass in this bucket, expires in, and this should be straightforward. And this is the thing. And yeah, and after that it's a head file, and here we need to again so const head, I'm just going to use this client.send new head object command, pass in this bucket. So here bucket file.bucket and file.object key, and then so if this result so let's make this as the result so that it will be clear. So if we don't have a body, okay, I'm messing things up. Okay, let's do one thing. All right, let's keep this one as head itself. Okay, fine. And here straight away I'm just going to return this object head that we have, and pass in here this content length, content type, and metadata. Okay, and this thing basically I need to import this one from the utils, or else we can just create in here itself. So that will be simple function. So just the checking, and accordingly if it's not null we'll going to use that. So this is the simple thing, taking in input content length content meta type. So if it's not undefined, so we'll set that specific thing. So that's the simple thing, object head that we have. And yeah, so here again okay, that's the thing. And now get file bytes, and here let's say this one, the result. And here now I'll check if it doesn't have the body, so I'm just going to say cannot get the file bytes. And also again we'll do a check of if the type of the result dot body dot transforming to byte array is equals to function. Then we will try to return await result dot body transform to byte array. And then the chunks, I'm just going to now iterate through this body, and then we are going to push in here, of course. So for cost chunk of result dot body, and here we need to very carefully say this async iterable of u in array, or it's going to be of type buffer or string. Yep. So now here, while we are trying to push this chunk, if this equals to string, then I'm going to use this buffer thing, or else I'm just going to push that here. Yeah, I think now type of chunk, yeah, so this is the thing. And here finally I'm just going to concat this chunks whatever we have. Okay, so this is the simple thing to get the file bytes, and then to get the add file object add, and then creating get URL and put URL s3 signed URLs and all those things. So this is pretty like simple standard thing, at least to get started, like object storage interface, and then s3 compatible or AWS s3 backend that we have. And so like this, now basically we need to extend this one to support Azure Blob and GCS, that is Google Cloud Storage Backend, to support like multi-cloud coverage. And anyhow I'll be just using the mini-IO local, and if you want any cloud you can just configure and you should be able to set it up. But I'm going to now, we need to add a few environment variables, so the object storage related stuff. So let's first add that. And so in this .env I'm just going to add here, so object storage backend, here you can keep AWS S3 or Azure or GCS, and storage endpoint. And accordingly, if you as per the cloud, you can just set this up. I'll just keep it like add other variables that you need to add for Azure account name, Azure account key, Azure connection string, or like GCS project ID, GCS key, file name, GCS credentials, JSON and all that. I'll add it in env.example so that you will have clear idea. And also the other things I'll just add the cloud storage, and I'll give you a rough walkthrough, because I gave you the brief idea of how we need to add the S3 compatible. So Let's try to add now. Okay, now we need to add a support for our GCS, Google Cloud Storage, and Azure Blob Storage and all. And then depending upon the backend selection from the user, we need to call that respective function, which helps them create that client. So here, let's try to create the GCS object storage, and this is going to yeah, look similar to what we have for our S3 compatible. And here first thing is basically we'll need to create this client, and here I'll just try to import that storage as alias. So here let's say GCS client, and now I'll just use this here, this GCS client, and we need to here pass in the GCS client options, and I just need to create an helper of this kind which can help us to prepare all the objects that we need in that. So it's going to be simple. Just we need to attach the project ID, key file name, and API endpoint, and also the credentials JSON. So I just have here helper function, and I'm just going to add it here. So this we need to import from this Google Cloud Storage, and this as well. The helper, I just need a function here, so I'm going to add it here. Alright, so just the parsing thing, and then returning that as the record as a string of string. Okay, so this is the simple thing. It'll take the settings, and it'll check if it has this project ID. If so, it'll attach to project ID, and I think this should be simple. Alright, now we have this helper functions. Let's continue in our the main thing. So after that, the bucket. So let's try to get the bucket, and so this is the structure. First we need to return the bucket, and backend now it's going to be GCS, and max single put size bytes, same thing, and this create put URL. So this expires in pretty much the same standard that we will try to create how we did for our S3 compatible. Okay, and this URL, so instead of calling it here directly, what I'll do is basically I'll just try to prepare this config, which is get signed URL config, and import that type from the cloud storage. Okay, and now if we have this SHA, we are going to attach this one to extension headers, and this one, it's going to be so xgo meta sha256, that for that we'll try to attach. And now this URL, so just now we'll pass in this arguments key and config whatever we have just prepared, and then that's going to give us the URL. So, and at the end, so URL and the required headers, the content type is what we're going to attach, and then SHA is something that will try to attach in, and expire set. So that is the simple create put URL. Okay. Yeah. All right. Fine. So after that, we will need to add the get URL now. Similar way. So expires in, and the expire set, and then the URL, pretty much v4, and then we are going to return. This is going to be simple and straightforward. And the same thing we need to do for the head file. So here this metadata will call this using this object key and get this metadata, and all we are going to return this content length. This is going to be, we need to parse this a bit, so I'll just create an helper, something called parse content length, and content type metadata as well. We'll try to have an helper called string metadata. So this both the functions, I'll just try to create it. So this so basically those are just an helpers to double check the type of that and all, like we added the other helpers. So here parse content length takes in and checks if it's number, we are going to return that. If it's not string and length is 0 undefined, or else we are just going to parse it. Just simple helper. And same thing for string metadata. So here as well, so we are going to take this value, which is going to be string and any of this type, and if it's not value, we're just going to return, or else from entries we are just going to filter and return those string values alone. So that's this head file function. That's how we are going to handle. And now we have just one function, which is get the file bytes. So here I'm just going to directly call this file download function, and we are just going to return bytes. Yep. So this is the what is this issue? Okay, we'll check what this issue is about. Okay, here's the thing. Yeah, now I think, okay, got it. Here as well. Okay. Yeah, that was the mistake. Now those should be sorted. So this is the simple GCS handling. That's an helper to create an object storage in GCS. Now similar way, we need to create the for the Azure blob storage. So I'm going to create similar way, create Azure blob storage, and the settings, and inside this let's first try to get this shared key. So here we are going to call this Azure shared key credentials, which I'm going to create an helper. So same way like we just created for GCS. So similar way, I'm just going to create an helper for that as well. So this is how it's going to look like. So let's import this from blob storage. Okay, and this parse connection string as well. So let's create an helper. Okay, so first thing is basically here it has to be credential. Okay, so you see we just take in that and check Azure connection string. If so, we'll just parse that connection string, and then same for the account name and account key, and pass it to our storage shared key credentials from Azure Blob Storage dependency, and same thing, account name and account key, and create this thing. So here parsing this, it's nothing, simply we are just trying to, because the format that we get in our Azure cloud, we are just trying to split that by this colon, and then trim that and filter and just get that values what we need, and that's the just the simple helper. Okay, fine. That's how we first get the shared key, and once we have that, now we need to prepare the service client. So this is setting start object storage Azure connection string. If that is the case, then I need to blob service client dot from connection string, and pass in this connection string. Else we need to create the new blob service client, passing in here the settings. So this thing, what I'm going to do, just I'm going to pass directly the settings. So here this, so we will create this helper as well and pass in here this Azure blob service URL. So simple, we're just trying to create an helper function to give us that the URL needed. So it's going to just look like this. We're going to check for Azure endpoint if it is so, and we're just going to return, and if there is no account name, we'll just throw in error. Else, using that account name, we're just going to construct that URL. And pass on to this. Yeah, that's the service client. That's how we are going to get the thing that we need. And now this container client, so all we need to do is just now call this services client dot get container client function, and then that should be it. So now let's start here. Bucket, object storage bucket, Azure blob is going to be backend, and now the create put URL, of course it's going to the expires in expires at so yep. And now this blob client, let's try to, and also now the signed query parameters to generate that. So I'm just going to so in here first thing, the container name, and then the blob name, and the permission. So here we can be use this, yeah, and expires at and the content type, and we need to pass in here the shared key, and let's just convert into toString. And finally I'm just going to return here this URL, which is going to be so here we will use this blob client.url and attach in this signature along with that, and the required headers, content types, and this one it's going to be ms. Okay, and also the blob type, it's going to be blob. Fine, that's the pretty much thing that we needed for our okay, this thing. Yeah, I just imported that, and that's okay, fine. So that's the thing, to give us the signed URL, to generate as the signature, and then to upload that thing. And after that, now it's about creating the get URL. So it should be pretty much the same way. First expires in, and the expire set is something that we are going to prepare, and then this blob client that we have, and I'm just going to generate the same way and pass in this container and blob name, and also the permissions expires on, and same way that we have, and simply we are just going to return this thing, and let's just remove this. Okay, and from here we should be straightforward, and same thing for the head file. This is going to be straightforward, so I'm just going to return the Azure head. So here we'll create one helper to object head, and pass in here directly these properties that we have, and same for the so instead of this I can just right away return this Azure same instead of here. Here also we will create one helper, download to bytes, and I'm just going to call in this get blob client and pass in this object key and call this download function. So now this helpers we need to add them. They should be simple and straightforward. Okay, so here I'm just going to add it here. Let's try to import this. Okay, nothing, it's going to take this blob get properties response and return this object head, which is our format, content length, content type, and metadata. We can write there itself, but it's just too cluttery, so that's the separate thing. And here now this also same thing, download to bytes. We take this pass thing, and if we don't have readable string body, we're just going to throw an error, else we'll create chunks array, and then iterate through this stream body, and then append into chunks, and then we are going to return that. So that is the get file bytes. So now we have basically all three things, and now I need to have the common function which is going to help us create the object storage. So something like this. So let's name this as the create object storage, and in here basically now we are going to check if settings dot the object storage backend, it's let's say the Azure blob, then we need to call this create Azure blob storage and pass in the settings. And if it is GCS, we need to return that GCS object storage. Else by default I'm just going to return this S3 compatible thing. Yeah, that's the pretty much thing. And here we can just say it's null or null. Okay, yeah, so this is the overall, like, now it's cloud agnostic, so you can create any S3 compatible Azure blob storage, ECS object storage and all. I'm not showcasing how to get that specific key or and basically environment variables. I think it should be self explanatory if you go through the docs, and that's pretty simple thing. Okay, so now we have the storage and all those things, and now I need to add in the Docker Compose for the local S3 compatible min.io and min.io init for L checks and all those things. So after that I add, and we need to start exposing all of this or consuming these things in our API app. That's the first app that we need to start working on. Okay, let's add the min.io in our Docker Compose. So I'm just adding. So min.io, just take whichever the image release makes sense, and then command server data. So this is all you can just refer in official Docker hub, those things, and root user min.io admin, and password as well. I'm setting the same thing and attaching the volumes, and then health check min.io health ready, and then the initializing just to for health check and all. Yeah, okay, so now once we have this, we need to update our script as well. So here basically now I need to add these ports here. So this is going to be min.io host port, and then console host port, yeah, and then the of course exporting that thing like we have below thing. So I'm just going to quickly add those things. This should be it, and then now we need to call this min.io and init thing, and yeah, I think that should be it. So this is the simple thing, and now if I just call this run dev, okay, I have not defined volume, so here we need to attach in this volume, and now let's trigger this again. Yep, so it's pulling these two things, and then once it's done, you should be able to access min.io or UI like 9001 port and log in with the this username and password, whatever we have here, min.io admin, and then you should be able to see that. I think you can double check yourself, and that should be fine. And now we need to increase our pace a bit. Now let's start working on the apps. So as of now, we are working on all the packages. We are getting there, trying to lay the foundation, and still we have like runtime package, setting up the sandbox and OpenAI clients, Azure clients, and all those things. So eventually we'll get to main core functionalities. So here inside this, I'm going to create this API app, and let's as usual create this package.json, and this we need to have few dependencies. Main thing is Hono. If we can add any API, fast API or whatever it is, just the idea is simple. This is just a black box thing, and in here the API, same thing, module and source index.ts, which will create, and scripts dev to develop a watch thing, and start and then type check. And we are going to use all our packages, config, contracts, db, observability, storage, and then main thing is and that should be the thing, and then pretty much other like we need to add ts config like we did add in our packages and all, just the bare minimum setups and all. So here so here also all we are going to do is just extend our base ts config. So I'm just adding this and all. Okay, fine. And now we have this. We need to work on the routes and the main things that is going to be. So, and also let me just try to run one install, and now we should have this installed in our API thing. And let's create the new folder called source, and in that we will need to create main app and all those things. And so here we'll have the main file, which is the index.ts. So that is the starter, and also we are going to create the app not okay let's create a app.ts file, and also the other dependencies that we need for our whole app. So I'm just going to try to maintain in separate file. Maybe I'll just start with this, so how it is going to look like. Simple. So here I'm just going to create a type called app dependencies, and this basically will need the settings that we have, so very important from the config. So I'm just going to import that, and then this db is something that we need. So this also let's import it from the db package that we have, and then the observability. Okay, this also I need to import this one from observability package, and this one we can keep this one as an optional. And now the object storage dependencies. So object storage dependency, so this one it's going to be a written type of this is going to be the type of the function that we have, create object storage in the storage package. And finally I'm just going to export the type for our API routes. So this one will be combination of this app dependencies that we have plus the object storage dependency. So this is the like this we'll try to maintain at a common place, so that we can change in one place and refer wherever we need in our all of our API. Okay, so and then let's maybe start with one of the routes. So I'll inside this maybe a source folder, let's create a new folder called routes, and I'll start with simple, which is something to do with our files. So let's see what and all the endpoints that we need and all those things. Okay, so I'm just going to start creating a function called register file routes, and here we are going to be needing inputs app type, which is going to be main and depths which we just created now in our dependencies thing. And let's what are all the routes that we can register, let's see. And here let's try to destructure db and object storage, that is what we need mainly here. And the first endpoint always will try to version so that it's better. Okay, first is uploads, and inside this thing. Okay, so first straightforward check is we are going to see if we have the object storage or not. If not, we are going to straight away throw this http exception, and with the code, let's say 503, and message as object storage is not configured or whatever, something of the on those lines. Okay, and if it's configured, let's try to get this payload. And this one, we need an maybe a jored scheme object or something which can help us to parse way better than we trying to parse it here. So in the contracts, I will try to define a few things there so that I can use it instead of here defining here, so that can be used across the packages or apps. So in here, let me just call this as create file upload request. Okay, so the file name and this content type, size bytes and SHA, yeah, that should be pretty much it. And then let's try to export this type of that create file upload request. Same thing we need to create for create file upload response. And here it will have this file ID, then the upload ID, port URL, then the required headers, expires at, and the max size bytes. I think this should be it. Okay, yeah, and this type, exporting both of them. And now so a couple of other things for complete file upload response. So this should be simple object. Yeah, we are going to just see so okay, that was the small typo. Okay, and now the type thing, and then the final thing that I would need is basically file download URL response. Okay, that will have the, maybe just keep this as common URL, which is string and then the expire set and file download URL response. Okay, fine. This is what we need. And now let's go back in here. Now we can just use those the job types that we have just created and import it here and use it from those package. Okay, so here this payload first, let's this one I would need, yeah, file upload request, and I'm just going to parse the request JSON, whatever we are going to get that, and here we'll do the checks so that size bytes is within the limits that we have. Max put single size bytes. If it's greater than that, we are going to throw this 413 saying that file size exceeds maximum upload size, whatever we have it set in our limits. And if it is in limits, let's first try to prepare this random ID, file ID, and then the safe file name. So I'll try to sanitize this file name. So this the helper, basically we just need to create some just to sanitize that, just to replace and also I'll just straight away add that helper. So I'm not going to leave focus on that. So take in this file name, trim it, replace with all these things with underscore, and save, and make sure that other than this replace with the underscore, and then give me that and all. So that's the simple thing, sanitizing the file name whatever we are receiving, so that it's a proper format the way we are storing it. Okay, so once we have that file name, now this object key. So this is going to be something like, we are going to store in the files folder, file id, and then the then this original, and then the save file name is something that we'll try to store. And now we need to call this create put url, the function that we have, and pass in here the object key, which for the key, and then this content type, it's going to be payload dot content type. So and then this, so I'm just going to, so if we have sha, we are going to pass that, or else the empty dictionary. That's it. And now we have this signed url, and all we need to do is basically upload now. So here we are going to call in create file upload function that we have, and here we need to create an entry into our tables. So file id I'm attaching here, and file name, and save file name, content type, the helper functions, you remember the things that we just created in db packages. Now in our main apps is something we'll start to use one functions at a time. So content type and size bytes sha, same, we're just going to pass that, and bucket object key and expire set. Yeah. And then so here I'm just going to return create file upload response, and I'm just going to parse that and import the types that we just created. And here we are just going to attach file id, upload id, signed the url that we have after uploading it to the blob storage, required headers, expire set, and max size. Yeah. So this is the simple way to create that. Okay. So yep, and that was one endpoint to upload that. And now to get the endpoint for the progress, did it complete or not. So let's try to, so it's going to be upload id, and this complete. Okay, so same check as usual. So if there is no object storage, we are going to throw in that object storage is not found, pretty standard. And then this upload, so we are going to query now this get file upload function that we have in our db query, and pass in here the upload id that we have received. And we'll see now if we are not getting any upload value from our db, we'll say that this upload cannot be found in our db or something like that. And now this upload dot status is not equals to pending. Then we will throw an exception that upload is basically not pending or whatever, or you can throw in the status of exactly whatever it is. And then if basically all the checks that we can think of, we're just trying to do it here. And if expires at this get time is less than the date dot now, so here I'm just going to mark this file upload basically as failed in our db, so that and then we are going to throw that file upload as expired, something like that, so that it will be very like we maintain the consistency in our db, as well as we return the right thing for the end users. And now let's try to get the head. So object storage, call this head file that we have. And now we are just going to handle this error in the callback. So here all we are going to do is just throw this exception for like let's say 409. Here also I'm just going to throw this 409. Okay, and here I'm just going to say that something maybe message. So here I can say that uploaded object is not available, or something like that. So I'm not being very strict about here, because you can just add whatever you need. And now let's do the checks with the head content length. So if this is not equals to size bytes, then we need to again mark this upload as failed, and then say that uploaded object as wrong size. So this is not what we are looking for, and all these things. And same, now let's try to check for the content type. If this is and so this head dot content type, and this content type is not equals to this upload file content type, we can again mark this failed, and then say upload object as wrong content type. Same thing for SHA comparison too. So yeah, we are going to mark that as failed and all those things. And finally, I'm just going to call this function called complete file upload and mark that as status as completed in our DB. And then I'm going to return here complete file upload the response, and return the file thing. So here we can just, yeah, so this is the simple endpoint to mark that as a complete and all those things. And yeah, like this we need to still add a couple more endpoints. I think you get the intent, the flow, and the momentum what we are talking about. And now this endpoint to get that file ID. Okay, so in here first, let's first call our require file function and get this file ID. And again we can just handle this error. So on error, I'm just going to throw in this null. And here, if we don't have this file, then I'm just going to throw this exception for 404 not found, and else we are just going to return this file asset and parse that file and all. Yeah, that's just the endpoint to get the file. And now to get the download URL, which is again pretty, so file ID, and here you can keep it as download or download URL, whichever makes sense. Okay, and here as usual, the first check if we have this object storage or not. So that's not there, so I'm just going to return 503 object storage not configured. And if we have that, then I'm going to check the file is present. So same thing, and if it's not present, 404 not found. And again I'm just going to make sure that file status is basically, if it's not ready, then we'll say that file is still not ready, so you cannot download that. And then this signed, all we need to do now basically call this our the create get URL, which is going to give us the download the signed URL. And that is something now we need to just pass in to our file download URL response schema, and attach in this URL and expires at. Yeah, so this is the rough file endpoint. And now we have this route, and basically we need to register in our the main app and all those things, and we need to call. So this basically we need to wrap and use as a like core routes in the index.ts or app.ts, and then just call this straight away in here. So for this to be used, I need to basically create this like, let's try to call this thing inside this app.ts. So let's see, I'm just going to name this function create app So here app dependency, and here all at the end we are just going to return this Hono. And first thing we need to import this dependencies, and here I need to, let's do one thing. So first is basically we need to create an app. Yeah, I'm just going to and just try to return this way. And this dips dependency is something okay. This has an error because I need to attach file storage, I mean object storage related stuff. So here let's say yeah, API route, and here I need to attach in this object storage, and for that as well let's say okay, so object storage, let's call this create object storage, and here just need to import this thing. Yeah, okay, so here object storage, and now I just need to pass this thing, and now we should not have an issue. Okay, this is the thing, and then this main app, and of course we need to handle all these cores and all those things. We'll come back here, but this is the at least the bare minimum skeleton that we have. Just we have like tried to register our file routes, and now if I just go back to this index.ts, and this is where the main export function, just we are going to wrap the call. So let's say I'm just going to call the start API, and inside this we just need to now create an app. So here let's say, so for this we need settings and all those things. So let's call this get settings. Okay, okay, so we need settings, and then the observability and this, let's attach in here this component. I'm going to attach this as API. Okay, and then the DB client, so you're just going to pass in database URL, and now we have at least whatever we need. So attaching the settings, DB and observability, and now I just need to import this create app. So this, we have this app, and now we need to configure the server. So we need to use this one dot serve that we have, and attach in this first host name settings.api host that we have, and then this port, same thing. Here we need to use this API port, and then this idle timeout, let's say 255, and then the fetch call. Now I need to pass in here app dot fetch. So we have this server now, and this basically now we need to return this server. So and here we can just log that, API server started, and here like we can say something like Groundwork API server started, attaching the host. So settings dot like API host, and then port, yeah, and then we are going to return server, and then this closing function. So I'm just going to call here the server dot stop, and pass in this true, and we need to close this DB client. Okay, fine. and here all the way now if input.meta.main, and all we are going to do is call this start API, and this is how it's going to start. So yeah, I think this is a simple bare minimum thing, and the command for us to start this thing, and also like this index.ts helps us to start those things, and we need to update a lot of stuff. Basically, let's say if I wanted to run the API, let's main package.json that we have. So here API thing, and so pretty similar way we are just going to get into C apps API and call this bun run dev. So and I can just start this and check it, but we'll check anyhow eventually. We added files route, and also let's try to add the auth related thing that basically we need access key, and also like is it authorized, and then those checks, and then try to in the app.ts handle that course related stuff, and this the metrics endpoint, and then others like to config client and all those things. I'll try to expose the things that we need, and eventually we are getting started, and then we'll try to test just these endpoints are live or not. That's it. I'm not going to test exact endpoints and all those things eventually, because when we start on the UI, we'll anyhow try to call these things, and if it's not working, then mostly it's tested already, so it's going to work, and then we'll try to go from there. So let's add the auth related stuff and cores, and then the observability logging and all those things. What I'll do is basically inside this source folder, let's create this new folder called http, and inside this I'm just going to create this auth.ts. Alright, so here basically the standard thing that we normally see, bearer prefix, the bearer, and then we'll just try to have the function like require access key. So settings, and here middleware handler. So this middleware handler is something I need to import from Hono, and here so here first thing, so here what I'll do first, we need to check if settings dot is auth required, and also like few routes will try to exempt from the auth. For example, so let's just try to create here a simple function so that you will know. So is auth exempt, and pass in here this the context from the Hono, and the settings. Okay, so if the context request dot method is options, we are just going to return true, and then let's try to get this path. So and if this path is matching to v1 config client, so this is to configure ARL client and model names and all those things. We will add eventually right out of this. We don't have it, and then if settings dot auth hello health, and the endpoint is something, let's say health or whatever it is. Then we are going to return true, so this is exempted and all those things. So same thing for metrics, and we're going to exempt all of these routes, else or else we'll make others routes to go through auth check. Okay, so now I can just maybe here call this that function, and await next, and then I can just return here. Okay, fine. And now the authorized thing, so now we need to check if it's authorized or not. So for that also, like we have auth exempt, I'll just try to create an helper here. Is the authorized, pass in this the context, and this expected, let's have this string or undefined, and here first thing we'll check is basically if there's no expected, so I'll just right away say that it's not authorized. And now this authorization, we'll try to get the authorization header first. So and here, and let's try to get this bearer. If that starts with bearer prefix, then we are going to slice that, or else undefined, it's pretty standard thing. And the explicit, so we need this header groundwork access key, and also I'll just have the simple helper to check the bearer and expected. The simple thing that I wanted to add as an helper here, so I'll not, so you should be able to understand this, taking the actual and expected and checking the every byte of it and all. So that's the thing, this helper that we have. So bearer expected and explicit expected is something that I'm going to check, and this is the is authorized helper that we are just going to use in our this function. So now all I'm going to do is call this is authorized, and pass in this context and settings access key, and here we are going to say this is unauthorized, and also I'm just going to authenticate, we're going to say something groundwork. Okay, fine. And here this should be the simple require access key auth helper, and I'll attach now in our main index .ts, sorry, in app.ts. so let's open the stuff that we have. So now here, so basically here we need to configure the all this CORS check and observability logs before and after request and all those things. So let's try to add that those things here. So basically the observability here we are just going to call this settings, and pass in here this component which is API. Okay, and now this will try to add in this CORS thing from this Hono CORS. So here origin, so let's try to add this check. So if it's not origin, so we are going to straight away not allow that, else we will have this allowed CORS origin, just the like basically trying to match with a complete domain, simple regex check that will do. So for that I'll just add here just CORS check that I wanted to do. So that we are just going to call now this so return allowed CORS origin, and parse pass in this regex that we have in the settings, and yeah, pretty much this is the thing. And after that, now for logging that I mentioned, so now this try to, before making API request and after API request, we'll try to add logging so that we'll know what is happening and how long they are taking and all those things. So let's first try to construct this URL and then this route. This route label, basically we can also create an helper for that. Just the routes that we are going to have, and something like this, I'm just going to add those helpers as well. So here this route label patterns, health matching to this metrics, and on the config client, which I'll just add this, and file related stuffs which we added. And this route label, we just find this match, and then if it's match we return, or else if it's, yeah, just double checking these route labels way before so that it's properly taken care. Okay, so now what I'm going to do, so just call in here this route label and pass in this URL path name, and this start, I'm just going to now create this span. So start span, observability dot start span, and here yeah, method. So we can just be specific and it's something related to, let's say this is related to HTTP, we can add this prefix like this, or it will be clear for us later if you want to do something with that log start, whatever we have. And here first thing is HTTP dot request the method, and so let's attach in this here. And now this URL that we have, URL path name, and also this groundwork route, I'm just going to attach in here. And now let's try to wrap this in try catch block. So here now we are just going to make the request to actual endpoint call, whatever the logic that we have in specific thing. And so here the status here 200, so duration seconds. So now duration is just basically we need to detect current time with the start and those things. And here this now observability record HTTP request, and here this method I'm just going to attach the route status and duration seconds, same thing. And after that we need to just end the span, the one which we started the thing here. So I'm just going to here this span dot end. So and here let me yeah, and attributes, let's attach in here HTTP dot response dot status code, and let's pass in the status, and also groundwork dot duration. Let's just try to round this thing. Yeah, fine. That's the ending the span. And after that we'll just log this observability info, saying that HTTP request completed, something like that. And here again this method, let's log that, and the route status, so duration milliseconds, and I'm just going to round this again. And now this catch block, let's just try to, okay, in the catch block what I'm going to do, so let's just remove this, all the things that okay. So here status. So here let's try to get HTTP status for error. So simple, we'll just try to get the 500 by default, or else we'll just add in some helper here. So I'm just adding in here. Let's just import this HTTP exception, and here we just need to now try to get that exact status for error, and then duration seconds. Let's try to, and then the observability will just going to record that HTTP request, which one is something that failed, and I'm just going to throw in error. Okay, so just we are going to end that span, and I don't think we need this logging, and straight away throw this error. And also here I'm just going to attach in the error object for this. Yep, so this is the simple thing. So we are going to before every HTTP request, so we are going to start span here, and after every make this do actual endpoint logic call, and then we're going to record that and end that span call, and then again HTTP request completed. So just the proper logging before and after. So basically kind of middleware that you wanted to log on everything and all that stuff. Yeah, that's the thing. And now other routes that we need to quickly add. Yeah, we need require access key and for all the endpoints, and now the health endpoint. So here I don't think we need this to be async. So here let's just so this thing basically let's just first close this. Okay, so here this service, I'm just going to set this environment and okay, true. Just checking the health, make sure it's working fine. And now this metrics endpoint, so let's try to so here c.text Prometheus metrics, and pass in here this content type. Yeah, pretty much this is the metrics endpoint, and now the endpoint to configure this client. So here basically here we need to create the client config. So quickly I'll just try to add inside our the contract section. So let me just so index dot thing. So here let's try to add in this client config. Okay, so yep, and here we'll have basically I can just add it thing because it's not something, it's pretty standard config that we'll have for client. So let me just add this thing. So it'll have default model, allowed models, and then reasoning effort, and then MCP servers, file uploads, auth attached to that, and this is the thing. And now going just back to the API here, I can just now basically we need to import that and all I'm going to do is basically client config, and let's try to parse this. Okay, so here allowed default model, attaching this settings OpenAI model, and allowed models basically let's instead of here trying to split, maybe I can say that configure allowed models and pass in the settings. So this configured allowed models, we have it in our config we'll just create. So I'll just create that, just same thing, we're just trying to split by command, all those things. So what I'm going to do, let's go to this config package and open here, and quickly I'm just adding this couple of things that we need. So just trying to get that OpenAI model and others OpenAI models, allow models, I'm just splitting by comma, and then we'll have that, and same configured allow reasoning efforts as well, same thing, we are just trying to do the same stuff. Okay, so now going here, let's just try to import this from the config that we have, and I'm just now same for the default effort, this is going to be the thing, and here this is going to be the allowed reasoning efforts which we have just created. I'm just trying to take there, and this MCP servers, let's try to map the server that we have, and here I'm just going to attach in the server.id name, then the server.name or id, and after that this file uploads. So enabled by default, depending upon this object storage is present or not, so we will set that. So or else we can just be very less verbose, something like that. If this is not null, then by default it is enabled, and max size bytes we are going to attach in this whatever we have, or else I'm going to say that it's a 5 GB or something like that. Okay, fine. And what's the error? Server, yeah, it should be sorted. Okay, file uploads. Okay, now MCP servers, that's fine. And after this the author stuff, so it's a required whatever we have, and authorization and bearer, so that's the other name and scheme that will be attaching in. So this is the config client thing, and others basically the routes that we need and all we have just added, and it should be now and I need to add in the authorization stuff in the env section. So let's try to add in the env stuff. So here basically auth required for our testing, I'm saying it's false, and if it's enabled access key something, it should be in this some format, and auth health true, and metrics false, and those things and all. The regex, the origin is basically localhost, I'm just setting this one, and yeah, this is the simple stuff. And also now whenever we start our the dev script, we should be able to basically run our API as well. So for that I need to add the command in our dev stack. So here basically what I should do is this port, yeah, 8000 is something API port that I need to add in, and then I just have a way to just first clean up the any process IDs that we are running, and then starting this thing. So right after this we need to add that thing. So we're just cleaning any process IDs that are running, and in between and cleaning up and getting into APIs things and running our bun run dev command, and that should help us spin up the server that we need. So basically now we have this ground things set up, and also now in this thing you can just extend the API thing, so that we can just import later in our actual web and all those things whatever we need. So now just open the terminal and try to run this bun run dev thing. Mostly it should work. So So you can see now it's spinning up Minio, NATS and Postgres, and also it should start the our server, and you can just try to call this metrics or else endpoint and it should work fine. So you can see Groundwork API server started. That's the log that we added, and it's a like indication that it is up and we can start consuming our API endpoints. So yeah, I'm not testing it, and you can just check it out. And once we have this, now we need to lay the groundwork for our the runtime, basically the sandbox, the container. That's where like actual our groundwork agent will try to do the infrastructure work and all those things. So and we'll create that runtime package and have that sandbox Docker file and all those things, and eventually configure if it's a Docker selected, if it's local selected, if it's model selected, how do we connect and all those things. So let's add first the Docker image. So I'll just collapse this, all of this, and let's create a new folder called this Docker, and in that I'll just create this is related to a sandbox, so I'll just name in the same way as well. So sandbox Docker file, and now inside this I'm just going to add in straight away the base image from the Python. So okay, so it's simple. All we are doing is just a minimal Debian image with Python 3.12, and also we have this checkout version, and also this tools that we need: bash, curl, certificates, gpg, git, jq, OpenSSH client, Fuse, s3, rclone, unzip, and wget. So basically those are the at least foundation needed for our groundwork agent to execute the things that are related to our code bases, that the GitHub repos that we'll be trying to attach. So that's the thing. And also like after that we are just trying to set up the Terraform to help us with the infrastructure of Azure CLI and all those things. This is this unzipping Terraform and all those things, and deleting the zip once it's installed. And then we are trying to install the checkout and the Azure CLI, and then setting this workspace as the working directory. Okay, so yeah, that's the thing. And checkout is basically a security scanner for our infrastructure as code. Basically helps us in catching misconfigs in Terraform before we try to apply that. So that's the simple sandbox thing. And then I wanted to create one helper in our config section. So basically collecting sandbox environment. So I'm just going to create that, and you will see why we need that and why I added that, because I'll be using in our runtime package, which I'll be just adding now. So in this config index.ts, and I'm just going to add in here. So basically this is collecting all like sandbox environment given the settings, and then the source, which is the environment, and we're just going to get the sandbox environment variable names and collect all the environment variables that we need for that, and that is this helper function. Okay, so now let's create this new folder called, I'm just going to name this as a runtime. This is very important because this is what the runtime for our groundwork agent. And here, as usual, first we'll need to create this package.json and also this tsconfig.json. So I'll just straight away add this tsconfig.json, and here this package.json. So this should be straightforward. So here we'll just try to name our package and add some dependencies that we need for this package. So this is what it's going to look like. So runtime and main thing is going to be source folder index.ts, same the types, and dependencies, our packages, config and contracts, and we'll use the OpenAI agents and OpenAI agents extensions. Here you can swap with this Anthropic agents and all, any agents SDK, as long as you get the intent, you should be able to easily swap it using the help of like cursor or cloud code or whatever it is. And then the model for the sandbox and OpenAI for our client, and the TypeScript as usual.
So that's the simple thing. And ts config, so basically all we need to do is just extend the base that we have. So let me just quickly add that. So this is the thing, and now let's try to create the source folder, and inside that I'm going to add in index.ts. Okay, and here
I'll just stop this, and so that let's try to install the dependencies for our runtime package, and then we'll try to add what we need for our this thing. I'll just try to be quick because these days hardly everybody's typing code. As long as they know how to steer and how to navigate, that's what matters these days. Okay, so I'll try my level best to try to slow down and add manually wherever it's needed. Else I'll just try to be at this pace. Anyhow, I'll be committing, so it should be there for you. Okay, so first thing is basically I'm going to add here polyfill. So that's something that I'm just I'll try to add this, then you will understand what do I mean here. Let me just try adding that. Okay, so basically whenever we try to run this for Bun, we need these things. So here anyhow I need to import this MCP server from the OpenAI agents. So it's not agents extension. Yep. And then the session event type from the contracts, and then what else? Yeah, then iterable that. Okay, mostly okay, this alone I just need to import this. That's in an helper, just a generic thing, so I'll just create that quickly here below. Okay, so let's so this is simple normalized runtime event. It will have type which is of type session event type, which we added in our initial contracts thing. That's what we and the payload unknown. And here this ensure readable stream from, we are calling here basically on bun run itself. So what is this? Basically it is like, it's a polyfill. So this basically it adds the standard static method, which is a readable stream dot from to the global readable stream. So it's why do we need is basically Bun, whatever the thing that we are using, doesn't ship this readable stream dot from. So that's why, like like for example, if we are using model sandbox, that code path calls it like to turn an iterable into a stream. So without this shim, whatever you're trying to add, running an agent on the model backend would really crash with the readable stream dot from is not a function. So this is like basically targeted compatibility patch for the gap in the runtime, and like we are trying to bridge this missing method so that model code just works. So that's the only thing. And ensure readable stream, and so you can just take a reference from this, and this is the standard generic. So I'm not talking much about this because anyhow I have tested model before, but now we'll be using local or Docker. That's the thing. And now we have this. I need to add a function to configure OpenAI. So here what I'm going to do is basically I'll just try to add pieces of the stuff and then walk you through. So here basically yeah, let's first try to import the settings. So this is config or OpenAI settings, and we are just trying to set a response transport, whatever the transport that we have. So that again we need to import this from the so this from OpenAI. So set OpenAI transport. I need to import it from the OpenAI agents. So yep, so whatever I need, so OpenAI transport and then OpenAI client and set default OpenAI key. So what's wrong? Okay, fine. So here what we are doing, just setting the transport, and if say OpenAI provider is Azure, we are trying to get the base URL from the Azure thing and API key and the Azure directory token, and then setting that OpenAI default client API key, base URL, default query, default errors, and setting that. And if it's OpenAI key, we are just setting default OpenAI key, and base URL I'm just setting this. So this is pretty standard, the config that we normally see whenever we are trying to config. And here I'll need a few type helpers for me, just kind of like agent segment input. So basically it's a kind of message, or it's a kind of approval from the users and all. So there I'll just try to define a couple of types, so that we need to use that. And I know I'm not typing it, so but I think you understand so what I'm trying to so I'm just trying to convey the intent and the way to get the work done, rather than so I need to import this sandbox session state. Okay, so this is simple agent segment input of kind message. If it is message, we need string and serialized run state. If it's approval, we need approval ID. Decision, it's either rejected or approve. You will see this one and all, temporal signals and all. And here preparing agent input, so it's an input of this kind, and sandbox session state and serialized run state for sandbox. So this is the at least the simple thing to get started, the things that we need inside our just trying to add a polyfill for model to work, and as well as then trying to add an helper for our to initialize our OpenAI client. So now we have this, we need to basically and also add the environment variables related to sandbox and the Azure OpenAI and all that stuff. So let me just add and give you a brief walkthrough. And so here let's open the CNV, and let me just try to close this. Yeah. So here basically if it's OpenAI provider, add this OpenAI model, reasoning effort models and all those things, blah blah, you can just check this. And sandbox backend, it's very important here. You want a Docker model, local or none. So we are going with Docker, so we'll add the how to connect with Docker network and all those things, and use that to make it as an environment for our Groundwork agent and see how it's going to do and all. We'll see that eventually. And this image will create this Groundwork sandbox. Basically we'll try to whatever the sandbox Docker image that we have, we'll try to tag it with this and use it. Okay, and Docker network, and then the model, if it's selected, we need to add this, and also model image references once we push it to our GHCR or the Docker Hub, wherever you prefer. And then model token IDs, this and all you need to get it in the model portal. And then yeah, this simple things that we need for our ENV stuff. And once we have all of this, and also now we need to update our dev stack script that we have. So here I'm just going to open this,
And as usual, first thing is I wanted to set this Docker network. So here I'm going to expose set this Docker network as Groundwork default, that's the name. And then we need to build our Docker image for the sandbox. So that thing, let's do here. So I'm just going to add this, and we are going to tag this one sandbox local, and that's it. And that should be it. And also, like, we need to just give an alias inside our base. So let's give that for our runtime. And now if I open our terminal and let me try to run this run dev, so it should help us, like, build this sandbox thing and all. So let's wait for this NATS, Postgres, Minayo, and all those things to come up. And once they're up, okay, and now you can see it's building our Docker, the thing that we need for sandbox and all. So basically we'll have this local things that we can later use it for our agent. So this is, like, laying foundation for for a runtime package, and then adding an helper for our OpenAI Azure client config. And once we have this, basically now we need to create an helpers to for helping us to create an helper, like, for sandbox client factory, for example for Docker, Modal, or the local backends. So I can maybe add that. So this is built, and then API is started. So we will see this output and all later. So this is more or less backend and infra heavy. So a UI something at the end will have, like, minor tiny UI, and then we'll see how it works end to end when we are wiring it up. So here, runtime, let me just open this. Okay, let's try to close this. Okay, and now here, so I'm going to create a function called create sandbox client. And pass in the so this one, and along with that I'm going to attach in the environment. By default, this is going to be the helper which we just added, which is collect sandbox environment, and pass in the settings. And the return type, I'm just going to keep this as this unknown. So, and this we should import so it's imported from the config which we just added. Okay, and now we need to check if this is a Docker. So what are we supposed to do? So if it's a Docker, we need to wrap this inside our Docker network and all. So these are the helpers we need quickly to add. So I'll just basically it's like like spawning the Docker commands that we have. So I'll just add this so that you will get a brief idea of what I'm talking about. So this thing, so basically connecting Docker network, passing a network and container ID, and we run these simple commands inside the spawn Docker network, connect, pass in this network container ID, and then we're just going to pipe this. And so this is the simple thing, connecting a Docker network. And now I just need as a wrapper to use this connect Docker network. So that is something, the helper again I'll just try to add quickly. So this thing, so here this one, what this does is basically takes in sandbox client. So from this OpenAI's agent sandbox, and then sandbox session like. Okay, so here first we're trying to trim this network, and then we are going to get this container ID, and once we have this container ID, we are going to pass in this network and the container ID, and creating this wrap session, and afterwards we are just returning this backend ID and other details that we need. So basically this is the thing for creating, resuming, deleting, and then serialization state and all, just trying to adhere to the this sandbox session like that we have in this agents of OpenAI's dependency. So you can just check it out, and it should be just what need to do for all this parent class that we are inheriting. Okay, so okay, now once we have this this helper, now I'm going to, if it's a Docker, so let's try to grab this. Yep, and so with Docker network and call in here Docker sandbox client. So from the OpenAI agents, and inside this pass in this image and also this exposed ports. So this one we are going to use this parse exposed ports from the config, the helper that we have, and I'm going to attach in the settings.docker exposed ports. And along with that, now I need to pass in this Docker network. So that's the thing, if it's the Docker. Okay, now let's see about this model. So if this settings dot the sandbox backend is this model, here let's options, so constructor parameters, this is going to be yep, so constructor parameters, and this is going to be of type model sandbox client, and inside this we need to provide the app name, and then this so this timeout milliseconds settings dot model timeout seconds multiplied by 1000, and then the exposed ports, same thing, and then attaching this environment which is yep. And once we have this, again we are going to check now model image. So these are all the env values that we expect, and we have defined these jod strict things and all, that is why, so we need these things. And now we need to call this model image selector from this tag, and pass in this model image ref. And same thing, now if we have settings dot model or token ID, and here we need to attach the options token ID, and same thing for token secret, and the so token secret, I'm attaching this token secret environment as well. So let's try to attach in environment, so settings dot model environment, and after everything we have, I'm just going to return this yep, this new model sandbox client, and pass in this options. That's this that's a way to configure a model sandbox client. And if it's a local, we are just going to, it's going to be simple. So if settings sandbox backend is local, so I'm just going to call in Unix yeah, local sandbox client from this OpenAI agent sandbox local, and this should be it. Okay, so this is the way to configure the sandbox based upon the backend that user has set in his environment variables. I know I've just tried to be faster, and but these are all you can check in the documentation of OpenAI agents SDK and all, and this is how we are going to create a client factory for the sandbox things based on the backend. So yep, so now once we have this, it's now basically we need to add functions to prepare agent tools like MCP tool prep with the prefix, the server adapter, and all those things. So those are also all helpers, and it's going to be in the part of the same file. Let's try to add them.
Okay, now we need to quickly add some helpers and then the function related to MCP tool preps and all. So I'll just quickly try to add these things. So first thing is basically okay, fine. So I'm adding this simple normalized URL. You see, this is simple. It's just stripping the trailing slashes and then the hash, so two spellings of the same URL compare equal. That's the only thing, just the normalizing URL, and then I'm just going to add a function called first party MCP URLs. Okay, so here now we are using this normalized URL above helper function. So this basically the allowed first party URLs, the base the /v1/mcp endpoint, and its docs, the subpath, both normalized, and then this is first party MCP server will add the function which matches against this list. So adding this is first party MCP server. So basically this is the first parity check. So what it does is basically it gates on a known ID plus a normalized URL match against the first party URL list. So that's the simple helper function that we have. And now once we have all of these helpers, let's try to initialize first party MCP request thing. So the same way the name of the function also it's going to be in the same way. So here is the thing. So we are trying to now spread into the each server config by entry point here using this function. So it basically it injects our groundwork access key as the bearer header, and only when the server is verified first party. So basically we never leak credentials to third party MCP URL. So that's the simple thing. And now I just need some helper to prefix the MCP tool name and all. So just we'll try to add the registry ID and then the tool name. So it's going to look like this. So this is the prefixed MCP tool name, and it will have the registry ID and tool name as the input params. And once we have this, now let's try to create a prefixed MCP server which is going to implement MCP server. So that's that's where all the tool calls and then the initialization and all will try to do that. So let me just quickly add what I mean here. So this is what the core of the MCP server related part that we are trying to add. So yeah, so this is the thing. So prefixed MCP server, so this is simply stores the inner server and sets its prefix to this registry ID that we have, and we'll try to build a set of allowed tools for like big O of 1 checks, and kind of like mirrors the inner cache tools list. So we have this cache tools list, name, prefix, and allowed tools, and we are initializing in the constructor whatever we receive in here and all, and then functions to connect, close, and the listing the tools in a dot list tools, and we are just going to filter by allowed things and trying to showcase that, and the function to call tool name args meta and invalidate tools cache, listing the resources, and listing resource templates, and reading the resource and is allowed and unprefixed tool name. So these are the things that we need basically as part of the prefixed MCP server. And I think by now, if you know MCP tool calls and all, this is the simple thing, and I don't want to like now talk much about that. And after we have all of these things, the helpers and all, now we need to prepare agent tools. So for that, let me just define the type here. So the type, it's going to look like this. It'll have the MCP servers, list of MCP server, and the functions to close. And once we have that, now we need to create a function called prepare agent tools. So kind of that's like a tool prep entry point, and I'll try to add that. So that is where we'll try to consume this prefix MCP server class which we have just created. So in here I'm just going to so let's try to import this tool ref and also from this OpenAI agents, and from this OpenAI agents. Okay, fine. So here prepare agent tools, we have the input settings and tools refs, and just the normal check if tools length is 0, just written that, else trying to create the registry by using the MCP servers in the settings thing, and then the servers we are trying to iterate each of the tools list that we have and get the config. And once we have this config, we are just trying to create a new instance of the prefixed MCP server by using MCP server streamable HTTP from the OpenAI agents SDK, passing in this config URL, name, cache tools list, and the other first party request initialization and config and allow tools. Then once we have those things, we are just trying to connect the MCP servers, passing in the servers, and others optional things connect in parallel we are just setting true, and then finally we are just returning MCP servers and the function to close. So this is the simple function to prepare the agent tools, and I hope at least you're getting the gist and all, and the code wise and all that part you can just refer in the commit that I'll be attaching in. Fine. So this is the simple way to have the functions to create MCP tool prep with prefixed server adapter and all. And now we need to add an manifest builder, like with git repo and object storage, resource mounting and all that stuff. So that basically same here itself. So I'll also start here by adding the helper function that we need called normalize manifest path. So basically that name itself says it's just a simple helper to normalize the path string that will be passing as the input. So this is how the simple helper looks like. So this is like, again, we are just stripping leading or trailing slashes and rejects any double dots traversal, so resource can never escape the workspace root. The helpers and the others now will be adding, we'll just try to use this. So once we have this, and also other couple of helpers like to assert save sandbox file name, just to make sure that it doesn't deviate from the workspace navigation and all. So here again, this thing, we are just trying to block separators and dot name, so file name can't really escape its directory, it's what will be reused by the download normalizer and inline file builder and all that stuff. Okay, so and this is the asserting safe sandbox, just trying to strip and trying to be as clean so that navigation to directory and workspace and all will be not clashing and all. Yep. And so now we will try to use this one in normalizing sandbox file downloads. So here's the thing. So here what it does, it's basically trying to normalize each downloads mount path, and requires a content or a URL. Okay, so this is the thing, and then we are just throwing early if we don't have that, and then we are returning download amount path, and this will be used by build manifest to index downloads by file ID. So this is the thing. And also now we will try to add one more function called the sandbox download directory. So here let me just add this thing, and let's try to, okay. So here this is the simple, it tries to builds the manifest entry for pre-downloaded file. So here first, what we are just trying to check if the download mount path is not equals to mount path that we received in the input. We are just going to say that mismatch path and all, and then the asset saves sandbox file name, the double checking the file name and meeting the standards that we have using the above helper function we have. And after that, then if we have this content, then we are just trying to create a directory, passing in this the file name content along with that. So just trying to create download directory using the download file that we have. That's the thing if we have the content. If not, we are just returning the empty directory and all. So that's the thing. And also now I wanted a bit helper function to config the S3 related mount config. So that is where we'll try to use it to mount the files and all. So this is how, this simple thing, this basically gets the inputs settings, and we'll try to return the bucket, endpoint URL, all these things that we need basically as the S3 config related details. And simple check getting the endpoint URL, and checking other access key ID and secret access key, and then finally I'm just returning from the settings and all. So this basically simple. By that you should understand we are trying to gather and validate the S3 compatible credentials, and throwing early if you don't have these details, then later broken mount at runtime and all. So that's the simple thing. And if this is the S3 thing, but if you are using Azure stuff, so we need to properly pass the connection string. So for that we need an helper. So it's simple. We receive the value, and we are just splitting by key equals to value and Azure connection string into a record. So handling the inside values correctly and all, splitting by this, and then index of this, and then trying to get the values and all. If you know the structure of Azure connection string, you should understand this very straightforward. And then the Azure's blobs manifest endpoint that we need if you are using. So again this one, it's basically we are just trying to again take an endpoint and account name, and if there is no endpoint, we're just returning straight away. And after that we're just normalizing it, and standard account endpoint is going to look like this, and this is what we are trying to return. So this is the simple straightforward. And now we have connection string, and then endpoint and all. Now same way we used S3 to config and all, now we need to create a function to config for Azure blob and all, mount config. So for that it's going to be similar way like we have for S3 compatible And also here we are just trying to be generous and support multi-cloud and all. Okay, so here again, takes in settings, returns container, account name, account key, and endpoint URL, basically whatever is needed to mount the sandbox related files and all. So I'm just trying to parse this and use these helper functions that we have, get the account name, account key, and endpoint URL, construct, and then return this. So that's the simple the thing. And yeah, and now we have the S3, Azure, and all that stuff. So all we need to do now, decide which object storage to use, and for that again the parent the function that we need. So I'm just going to add that function. So this is how it's going to look like. So let's try to import this from the OpenAI agents SDK, and yeah. Okay, so here is a thing. So this is the basically the three backend mount selector. We know that thing, AWS, S3, GCS, Azure, and all. So simple. We are just trying to first check the if it's a backend is Azure Blob and sandbox is Modal. Then we are just going to throw that error, like it requires pre-signed download mutilation, because the current this SDK model client does not support Azure blob mount entries and all. So that's the known thing, and we are just going to throw in that. If it's not model, then we are just trying to get the config by using the above helper functions that we have just created, and then call this Azure blob mount from the OpenAI agents SDK thing, pass in this container prefix, account name, and other mount strategy in container mount strategy, and we're using pattern rclone mode fuse. So here basically this is mounting via rclone fuse, and that's the thing. And now for S3 and GCS, straight away throwing that it requires pre-signed stuff for the thing, and then S3 compatible, if which is the local SminIO via this model's native bucket. We are just trying to mount using S3, pass in all the details that it needs, mount strategy, and all those things. So this is the simple object storage file mounting and all. And now we have the major things to mount and all that stuff, and we need to try to add the main function called build manifest or so, something like that. Just before that, just try to add couple of helper functions to just remove this shell codes and all that stuff. So I'm just adding the simple thing. So we are just trying to safely single quotes and interpret value for the download shell script thing and all. And now we wanted to get the sandbox download target path. So that one, it's going to be here. Okay, this thing, so this is basically the in container path, basically where the download lands at. Like it's basically we're trying to root under workspace. So here I'm just trying to
So basically we need a path from the node path and all. Let's try to import that. Yeah, okay, so my bad. So this is, yep, so now I can just use this. And yeah, I think this should be simple thing, and all those things. And we need the function to, like, command for file download and all. So this is pretty that I need the exact function which gives the proper command set and all. So this is the thing. So here we'll get the sandbox file download and target path as the inputs, and we double check if download URL, if it do not have, we're just going to return through an error. And target directory, we're just going to construct that, and temporary path, it's going to be in this format, or downloaded. And after that, so these commands, what is does at a high level, basically it tries to emit an idempotent atomic call to basically to temporary, then move shell script for backends basically that can't like fuse mode. So this is the simple thing, the command which is doing that. And this one is what we'll be trying to use in our main function, where we are trying to build the manifest. So this is the main function that we need. So let's try to import this from the OpenAI SDK agents thing from this contracts. Okay, so here is the manifest writer. So inputs is settings, resources, environment, and file resource downloads. So what we are trying to do is it's trying to turn each resource ref into a manifest entry, sending git repos to the SDK's git repo, clone helper, and files like to either a download directory if it's a pre-materialized, or live, like object, the storage, the file mount, all rooted at the workspace. Okay, resource, that's fine. So ignore this type error because we have either or that, so that's the issue it's throwing at. And now basically this is the I'm just going to okay, fine. So that's the I know this is a bit not clear and all, but hope you can just take an help of ChatGPT and other stuff to understand. But this is how we try to build our manifest with git repo and object storage, resource mounting, and all that stuff. And after we have all of this, now we need to add this agent builder, and the all this run input preparations and SDK event normalization. So that's the next helper functions and all, everything we need to try to add in this runtime. We are getting there to wrap up the sandbox stuff and all, and let's try to add them. Okay, now the agent builder related stuff. The thing, basically the intention is we wanted to build the brain of the runtime harness.
So trying to turn the session into a runnable agent and translating the SDK's events, whatever we have, into our standardized vocabulary and all those things. So for that, again, we need quite a bit helpers and all those things. So I'll just try to quickly add one thing at a time and just give you brief what this is basically produces a stable string ID for an interruption or approval from whichever ID field the SDK provides. So approvals can be matched on resume on serialized consistently by the functions that we'll be using below and all. So that's the thing here, the approval identifier. And then we have a function to deserialize the sandbox session state envelope. So that I'll try to add in here. Okay, so basically what it is doing is it's trying to unpack the serialized session and hence the provider state manifest snapshot and exposed ports back to the sandbox clients, like deserialized session state that we have. So copying again the optional fields only when present, and it'll be called by our the other function called like restored sandbox session state, which you will just see. So that's the same thing, just here checking if we have that and all, and then trying to deserialize this and pass this to our session state, what and all it needs, manifest, workspace ready, and all those things. Yeah, fine. And now I just mentioned restored sandbox session state. So that is this function. So this one kind of what it does is it digs into a persisted sandbox session, the out of the saved run state. Run state is basically handling both the multi-agent map and the single sessions shape, kind of, which is the legacy one, and it verifies such that it matches the configured backend and reiterates. So a resumed run reattaches to the same sandbox. So that's the intention here. So sandbox state and entry based on the backend, we're just trying to prepare that, and if it's not matching, we're just throwing an error, and then finally trying to return this deserialized state envelope. This is what we'll be using to prepare the run input and all, which I'll try to add now. And also just I need one more helper called sandbox run as. So basically it just picks the user, the agent runs commands as, like it's like for example, if it's a Docker, it's just dedicated sandbox user inside Docker, and if it's a local and all, the current OS user and all, and nothing for otherwise. So undefined for other stuff. And yep, and now let's try to maintain a global agent file downloads map. So this is the module level weak map. Basically it's keyed on the agent instance that records like which file downloads must be materialized at runtime and all those things, and which files are read back by sandbox file downloads for agent. So this weak map is basically, it's just extra measure to not leak any memory and all. That's the thing. And now I need just the types for building agent options. So basically for that is where we need to pass in this model, reasoning options, and all those things. So let's try to import this thing. So model, reasoning efforts, sandbox environment, and file resource downloads, and MCP servers. These are the things that we need. And also the one more option for our preparing the run input, which is sandbox client, and just takes in live sandbox client, which is needed to rehydrate a resumed session. That's the only intention. And before we try to add actual the build agent, we need a kind of like common ground helper which can help us to normalize the SDK events and all to our standard vocabulary and all. This is what exactly does that. So here let's try to import this from the agents. Okay, this is normalizing the SDK event, kind of like universal translator is something you can just we can think of. So whatever it maps the streaming or metadata SDK events that we receive, like text deltas, reasoning summary deltas, agent updated, and the run item events and all, which are like basically tool call created, tool call output, completed message, and to basically our strictly typed vocabulary. So like this. So if it's a raw model stream event, and then we try to check if it's a text delta and all, we try to take this as agent on message delta and all. And if it's a OpenAI's streamable event and all, if it's of this type, again reasoning delta is what we try to collect. And if it's agent updated stream event, we try to push it to it as agent updated and all, so that it will be consistent and all. If it's a tool call item, tool call created, and tool call output item output, message output item, message completed. So this way, so that it really helps us whenever we are trying to construct the logic in our consumptions, client's consumption and all those things. So that's the simple the helper. And now I need a couple of helpers to serialize approvals and all those things. Here this basically what it does, it's trying to turn the SDK interruption objects into like simple JSON safe structures. So pending approvals can be persisted and shown to the user, and falls back to like approval identifier for the ID. So that's what we're just doing, nothing else. We are just trying to serialize the approvals and all. And then the one final helper function, which is the sandbox file downloads for agent. So it's a simple what we are trying to do. We're just trying to return a copy of the URL pieced downloads recorded for a given agent, so the run can materialize them. So that's the thing. And safety handling on the non object inputs and all. So that's the stuff. And now what should be the input for the agent run? So we need to prepare in the format that it's expecting, right? So this is the function for that, which here let's try to import from OpenAI agents SDK. Okay, so this is kind of like control panel. So for a fresh message, it returns basically the plain text, or reconstructs history plus the new turn, like restoring sandbox session state when resuming. Like for an approval, it loads the saved run state and finds the interruption by ID, approves or rejects it, and hands the mutated state back to SDK. So that's what exactly we are trying to do. So message and state, sandbox state, and constructing the history and appending this new message and all. And again interruptions finding by ID, and if it's an approve, we're just trying to approve that or reject and all. So this is what preparing the run input. And finally the once we have all of this, we need to build our groundwork agent. That is what is the main heart of runtime harness that we have. So here it's what it is. So let's first try to import this, then I'll talk about this sandbox agent and capabilities. Okay, this is the thing. So it tries to like assemble the instructions that we need to provide, and model config. For example, you see here base config, the name is Groundwork agent, and model we are just going to attach whatever we have in settings or in the options that we'll be trying to pass in. And the instructions, basically we are trying to be very detailed what it should do and what it should not do. For example, here it's a standalone infrastructure engineering agent, so it lives inside the sandbox workspace, and you can use file system and shell tools when useful. Repository stays under, and file resources are mounted under like this. And we are trying to say that attached files are read only, so asking them to like create a copy of it before modifying, and use checkout Terraform, Azure CLI, GitHub CLI, and repository tools like when relevant and all. And other info whatever you need, you can just add in. And then model settings, reasoning efforts, summary, and all those things. And yeah, and if settings sandbox backend is none, we are just now trying to create a new agent by passing in the base config that we have constructed above. And then we are trying to run as the sandbox agent if it's sandbox backend we have specified, and pass in this detailed sandbox environment, file resource downloads and all. And then we are just trying to set the file downloads config and all those things. So this is what so when there's no sandbox, we're just trying to return a plain agent or sandbox agent if it's a backend wide to build manifest the default capabilities, and then backend appropriate run as, and also it records the URL based downloads to materialize later and all. So this is the main thing and all. So that's what we needed for our building Groundwork agent. And all, so far it's all wrappers around OpenAI SDK and trying to respect its vocabularies, jargons, and all that stuff. And we need to add now on the lifecycle hooks of the sandbox, like manifest, refresh on resume, and running facet and all. So what we need to do now is basically try to wrap the sandbox in a decorator chain and expose the single run facet, the actual worker calls, basically the worker temporal worker, which we will try to focus on after this runtime stuff. So let's try to add those things as well, the lifecycle hooks and all that stuff. So after in here, first is the lifecycle hook phase. Okay, so here this the phase enum before agent start for now, and context every hook receives. Here we have the resolved environment, then the optional runtime event callback, and run as user. Okay, so that's the thing. And and if we want extensible hook contract, we can just add it in this way. So I'm just adding, so sandbox lifecycle hook, and this basically now it declares its ID, the phase, and optional should run, and then run body that operates on live sandbox session and context and all that stuff. Okay, and let's try to add simple helper which can help us to normalize the plain manifest stuff. So here ensure manifest, so basically it tries to normalize the plain manifest shaped object, that is, for example, from deserialized session state back into this real manifest instance thing. So apply missing manifest entries, can call its methods and all those things. So here this thing and all. And now that's what, like, now let me try to add apply missing manifest entries. That is the function which will be using this ensure manifest, which we just added. So let me just add this here, and I need to of course import a few things, but so what this does is basically at a high level, this thing tries to compute the delta between the restored manifest and the target, and applies only the new entries via the apply manifest or per entry materialized entry, and raises if an existing entry's content changed. So we cannot replace a directory that's already mounted, right? So here we are trying to first get the current manifest value, and then current manifest we are trying to convert into proper way, and then the target manifest, same thing. And if session not applied and not materialized entry, so we are just throwing this error. And if its current manifest is not matching to the target root, we are again throwing this error. And then the entries that we have, so let's try to import this stable JSON. Okay, and then trying to get the environment changed value, and then the delta manifest between both of them we're just trying to convert, and then trying to apply that thing. So that's what we are doing, and then finally return that thing. So that is what this apply missing manifest entries is doing. Simple, fine. So that's the thing that we have. And now we need to refresh manifest on resume. So for that also I just need an helper. So let me just try to create the helper function here. This is called with manifest refresh on resume. So basically what we are trying to do, we're trying to wrap the client's resume so that after a session is restored, it patches in any manifest entries that were added since the actual original run. So other methods are passed straight through. So for example, here if it doesn't have resume, right away we are returning client, or else we are returning backend ID, and then create thing and resume thing, and we are trying to apply here, and others delete serialization and all this we had. We're just trying to return like what actual session we had, returning those things. Fine. And yep, and then we need to have some helpers to normalize the exit code and output and all, sandbox output and all those stuff. So let me just try to add them. Okay, so here the sandbox exit code, just simple. If it's a type of string, I'm just trying to return in this way. So the idea is trying to normalize the exit code and pulls the output strings out of the differently like shaped exec results, the various SDK backends written. For example, string output, exit code, exit underscore code, code or status. So fail command can surface a meaningful message. That's the only thing. So trying to handle all of these types, and candidate, and for if it's exit code and all those things we are trying to return. And then the sandbox command output, same thing again, trying to normalize those things. So these are the just helpers to normalize those things based upon the sandbox backend and all those things. And then let's add one helper which is kind of like asserts us that sandbox command, whatever you're trying to run, succeeded or not. So basically this will be used by file download and Azure login paths and all, like turning a non-zero sandbox exit code into thrown error with commands output and all. So that's the thing, trying to use this exit code, and if it's not null and it's not zero, we are throwing exact like some error, like which really makes sense later to interpret and all. Yep, so that's the thing. And now we need to add a function now to materialize this file downloads and all. So let's add this the function called materialize sandbox file downloads. So what this does, it tries to per file download command inside the sandbox for backends like that can't fuse mount. So emitting started, completed, failed runtime events, and asserting the command's exit code. So failed download surfaces loudly is something that we're trying to do. So we're trying to normalize file downloads here. If its length is 0 written, and if it's not execute a command, so requires this execution support, so right away early exit. And now we're trying to iterate through this normalized downloads and get this target path, prepare this payload, and on runtime event we're just trying to emit events like started, and the payload is this file resource download, and pass this. And after that we're trying to run the executive commands on this is the command, working directory, and all the context one as, and all those things. So same thing, if it's an exec, or else executive command, and all those things, and just making sure it is succeeded or not. And same thing if it is completed, and if it's an error. So all those events is something we'll be trying to emit so that it's clear for us. Yep, that's the helper thing that we need. And now the with sandbox file downloads, another this helper that I need here. Okay, so this basically what we're trying to do. We are trying to create our resume, so file downloads run exactly once, like per session. Like they'll be tracked by our weak set, which is a global module variable that we have just created before the agent touches the workspaces and passes through all other client methods. So again, same thing, normalized downloads completed. We are local computer variable and wrapping the session, and if this, we're just trying to call the above function that we have, materialize sandbox file downloads, and add this to our completed set, and then returning this create, resume, delete, and serialize session state, can persist, reuse, and deserialize. Standard things that we need out of this. Okay, and now to log in to the Azure and all those things in sandbox, we need CLI command and all those things. So this is the command trying to return. So this is simple, trying to generate this shell script that authenticates the Azure CLI in the sandbox, like handling both Azure underscore variables or arm underscore variable names, and skipping login if Azure account show already succeeds, and all those things. So this is the standard way of trying to log in using Azure CLI and all those things. So I think I'll just briefly state this. Okay, fine. And then other helpers for Azure checking, and does it has the service principal or not. So here, this is trying to get the client ID, client secret, tenant ID, and does it have the service principal. But depending upon all of this present, we are just going to know that yes or no. And yeah, and now we need the actual hook to run those commands. We had this script and all, so now we need to tie that up. So this is what that does. So run a Azure CLI login hook, trying to prepare this payload. CLI login command is this service principal, and on runtime event operation started, so emitting started. And then now in the try cache things, we'll try to execute actual the login command that we have just prepared above, and all those things, and emit if it has succeeded or not. Same thing if it's exec command, do the same thing, and login hook, and if it has failed, we're just going to throw in error, and then mark this operation as completed. And even if starting command itself failed, operation failed. So this is the login Azure login hook that is needed. And now all these built-in hooks, we can try to maintain a list in this way. Like for example, right now built-in sandbox lifestyle hooks. So Azure CLI login is what we are trying to do. The phase is basically before agent start. and and it should run this handle service principal. Above that we have, and run command is run CLI login hook and all. This how we can try to maintain static list of what and all lifecycle hooks that we have in specific sandbox built in that stuff. Okay, and then I need an helper to get the hook IDs here, like this Azure CLI login and all those things. So here sandbox lifecycle hook IDs. So I'm just trying to iterate through this and get that ID and try to return each ID from that list we are going to prepare. Okay, and finally I need outermost wrapper. So let's try to add that. So here with sandbox lifecycle hooks, so this is basically the outermost decorator runs each eligible before agent start hook once per session, which is the weak set guard right after the sandbox session opens before agent start doing any work. So that's the thing, like sandbox opens and then what and all it needs to do so that agent can easily get the work done later and all. So that's the thing. I'm just trying to wrap all of these things as outermost decorator and then return this wrapped thing that we have. Okay, yep, so all now we need and all it's done. So now the main thing, run facet, is something we need. So this is the important stuff. So here let's first thing is run agent stream options. So this is going to need sandbox client, environment, and on runtime event, the callback thing. So this run agent stream, what it does, it helps us in building the decorator chain. So manifest refresh, then the file downloads, then lifecycle hooks. So that's the the sequence when sandbox needed, right? So first it needs to manifest refresh and then download those files, and then lifecycle hooks whatever we have before the agent should kick off is something. All of this around sandbox client and tries to restore any prior session state, and then calls this agent's actual SDKs run with like max stance like 40 or 120 or something that we can set in. So here prepared input agent, environment, raw client, refresh client, and all run as this file downloads, resource client, that stuff. And here now with sandbox lifecycle hooks, and here this yeah, from this config and pass in this thing, and in the session state if you have anything it's going to restore this, and parameters let's import this from the agents SDK and run options. So stream is true on max turn, you can update here 120 or something, but now I'm just limiting it to 40. And then this config, and we are just trying to return this run options, and finally call this run from OpenAI agents SDK and pass in this prepared input, run options, and agent and all. So this is the ultimate running agent stream thing. And now the public method that we need to expose is what we need to add. So this is the thing. Groundwork runtime configure, build agent, prepare tools, prepare input, run stream, and serialize approvals. So what and all this needs based upon the functions that we added. So settings is mandatory, then resources, options, tools, and yeah, I think you can just check in this. So this is the public contract that worker actually depends on instead of the concrete functions. So callers like never basically touch Docker or Modal or API details directly. That's the thing. And now the optional injection points, we can just define the types like this, like production runtime overrides like model override, and also like fake sandbox client. So tests, so whatever we wanted to test we can run without spinning a real container and all that stuff. Okay, and now the final thing, let's try to create the actual production agent runtime. This is where the default implementation that wires the concrete functions into the groundwork runtime interface that we have just defined above. The model, sandbox client, and all those things. So configure, build agent, prepare tools, prepare input, run stream, and all these things. So this is what mostly the runtime harness and the agent lifecycle hooks, and then all the stuff that needs to happen in the sandbox lifecycles hooks and all those things before we can actually kickstart our groundwork agent. Oh, I know I rushed a lot and things are not clear, but the intention is always so clear. It's to give you an eye level idea, not like every line or every line of code what it is doing exactly and all that stuff. So now we have this runtime setup. We will need to slowly start working on the worker stuff, and also trying to add some helpers wherever we need in other packages like config and all those things. So let's try to shift towards that. So now starting on the worker stuff, and for worker, before going to worker app, I need a few config related helpers for worker itself. Basically the primitives to make the worker boot reliably and to commit code as the right person and all those things and all stuff. So that's the like it'll be simple things that I wanted to add. So let's try to add in here the startup retry options. So it's just the type knobs for retry loop, like how many attempts, the back of the bounds, an optional on retry hook, so callers can emit like structure log line per attempt, like label attempt, attempts, delay, miss, an error and all that stuff. And then the simple helper to delay this thing. So just a tiny promise based sleep used between retry attempts, and basically it's kept private, so the retry loop like reads as plain, await, delay milliseconds or so. Okay, fine. And now this let's try to add this concrete type for our startup retry options. So here now we are trying to attach in the actual settings the config that we'll be trying to pass in retry attempts, and then initial delay seconds, retry delay seconds, and all those things. So that's the thing. And now that was the simple thing. And if we wanted to add exponential backoff tied up, so this is how it's going to look like. See, this is a simple exponential backoff retry loop. The worker uses to wait for like Postgres, temporal at boot, retries up to attempts times, doubling the delay, like capped at max delay milliseconds, rethrowing on the final failure. So the attempts, initial delay milliseconds, max delay milliseconds, and attempting like max cap on that, and yeah, then trying to exponentially increasing the delay after every attempt and all those things. So that's the simple retry startup dependencies. And on now helper related to collecting the git related info. So here basically git identity thing, just again trying to get it from the settings, author name, author email, committer name, and committer mail, and all those things that will be needing so that we can commit as a right user and all those things. So that's the simple type I mean the configs and all needed for a worker before we start the actual worker app and all those things. So let's try to see and add boilerplate stuff and all that we can for our worker. So here in this folder I'm just going to create this worker app, and as usual let's try to create this package.json, and then this tsconfig.json and all that stuff. Okay, so in this package.json, so let's try to add as usual the scripts and then dependencies and the name and all that stuff we need. So this is going to be just worker main source file folder will have dev script, will try to run that, and dev watch again. And we need here all our packages: config, contracts, db, events, observability, runtime, storage, and then mainly the temporal related dependencies, activity, worker, and workflow. They are like important pillars of a temporal, how it works and all. Fine. And now this ts config, it's simple. We just need to extend the base stuff. So let's just try to add them, and here in our terminal we can just run this bourne install, and it should install what and all we need in our worker and all that stuff. And let's just minimize this stuff. Okay, and now in the worker thing, let's create this source folder, and now I'll just try to focus on adding the helpers related for our activity stuff. So let's create this new folder called this activities, and inside this let's create the types that we need. So types dot ts file. Okay, so here let's see what and all we need for activity and all. So first thing, let's try to import all from the respective packages and all. So here the activity services, so this is the dependency bag every activity receives. Basically here what we are like everything that activity need is settings, db handle, the event bus, then runtime facet, groundwork runtime, and then the object storage and the observability and all those things. So that's the simple type that also we're just trying to start on. And then the other things that we need is basically related to run agent, segment input, and all those things. So here it needs session id, trigger event id, workflow id, turn id, and then claiming the next queued turn input, session id, and workflow id. Same marking the session idle input, session id, and run agent segment result. It can be either of these things. So that's the status what we are trying to add. Okay, I think those just the things that we need in the types, and later on we need, if anything, we'll just come back. And now what and all common that we can use commonly across the activities and all, let's try to add them. So here I'm just going to add, like for example, to help us prepare the payload for user message and all that stuff. So here let's try to import resource ref and tool ref. So here whenever user is trying to schedule user message, what should be the payload, the shape and all. So this is what we'll be trying to prepare in, so that any activity or anyone who is trying to use can be shared across. So format is going to be text prompt, schedule task id, scheduled task run id, and resources length, tools length, if any, we are just going to attach. And then the workflow id for session we are just going to return in this format with prefix session up and all. I think that should be a simple file for time being in the common. So basically this is where we'll try to add what and all we need commonly across activities and all. Okay, and let's try to add this environment stuff, environment file. So in here let me just try to add in the function which can help us prepare the sandbox environment for this run. So here I just need to import okay from config collect git identity environment, sandbox environment settings which we just added, and then the contracts and all. So here we are just trying to prepare the environment that is needed, and if it's a Docker or Modal, we're just going to return environment home as workspace, and then return all of that, so that all the details that we needed for run will be written by this helper function. So that's the intent. Okay, so same way like this, what and all we need, for example, for streaming. So let's create here this separate file, streaming dot stuff, and here to create, like, let's say runtime batcher and all those things. So I can add in function like this. So let's try to import agent input and all those things. Okay, so here simple what we are trying to do is basically the micro batcher. So it tries to accumulates events and flushes, like when like greater than or 50 or pending, and 33 milliseconds have elapsed or structural event arrives. So cheap streaming deltas are batched while important state changes go out immediately and all those things. So that's the simple thing. So last flush is when, and the structural all these things, important things, message delta, reasoning delta, tool calls, and turn completed a field, and then we are trying to push that, and just trying to flush them events and all. So that's the simple helper that we want in this the streamer. And also like, to get the current activity context, so we can add in the functions, like, let's say this just import this from the temporal activity. So this gives us the actual context of the current activity that we are running, and also starting activity heartbeat, maybe let's say every 10 seconds or so we wanted to send. So this is how we can do that. Here basically trying to send heartbeat every 10 seconds. So temporal knows the activity is alive during a long agent run and won't assume it's died. So the unref basically keeps the timer holding the process open. So this is the thing. So trying to send heartbeat every 10 seconds, so that for long run agents it knows that activity is still alive and it's not dead. So that's the standard way of letting the temporal know that activity is alive and it's not dead. Okay, and then the SDKs streams next stuff. So next stream event. So this we need to raise against SDK streams next against the temporal's context at cancel. So cancellation aborts the stream cleanly instead of blocking until the next event arrives. So that's the thing. So if it's not if there's no context, I'm just straight away calling this iterator next. If not, we need to raise this iterator next against our context cancelled whatever the temporal signal that we are trying to send. So these are the helpers and all that we need for our worker and all. I hope you are getting the big picture and all, why we need and all those things. And now let's create a new file called run input thing. And so this basically the file or resource types, the DB readers, and the runtime facet, who's like prepare input, turns a trigger into agent or input and all those things. So that's what we'll try to add in this run input stuff. So the first thing, basically the sandbox file path. So this is going to be here the sandbox file path. So let's try to import this resource ref and the file asset. So this sandbox file path is simply computing the in sandbox path for an attached file, like trying to honor the custom path, mount path, or else falling back to this file's ID and all those things. So that's the thing. And now like an helper that I'll try to add to look up for attachments in the user messages. So this is how it is going to look like. Okay, and let's try to import this from our db package. So user message with attachments, simple. All I'm just going to do is try to look for the attachments we have, and if we don't have an attachment, I'm just going to return then the text, or else we'll attached file separately. So this is how, depending upon these files that we have, by iterating through its resources, we can find that. All right, so yep, and now we need to bridge the gap between our segment input, basically this okay, so this is the actual bridge from a db trigger event to runtime input. So basically the user dot message builds the prompt with attachment paths and loads like prior run state and all. So this is what like we are trying to do, like segment input, trying to prepare the segment input, user message payload, and then user message with text with the attachments, and then the latest run state and all. And this user dot approval deletion resumes from save state with the approve or reject deletion later once we have user interruptions and all. So that's how, once we have that, and then we are trying to prepare this input and all. So that is this segment input function it's about. And yeah, and so that's what we'll try to have in this run input thing. And now let's add a new file related to session state. So in this, basically we'll try to add the lifecycle activities, basically the db writers, event publisher, and the activity input types, that from where 4 lifecycle activities are built from. Okay, so the first thing is creating a session state activities. So I'm just going to add in that function here. Let's try to import the types, require session, and then the finish turn session status. Okay, okay, so here's the thing. So first is the create session activities, all the activities that are related to that thing. So here we have this is basically kind of like factory thing. First thing we have is fail session. So this is the what like workflow calls when a segment throws like before reporting terminal state, like it publishes like turned out failed, and the session dot the status changed failed, and marks both turn and session failed in one consistent write. So that is this the thing, creating session state activities, first thing. And the second is basically trying to interrupt the active turn that we have. So here let's try to add this one. So this, what this does, so it's basically, this is called when a trigger arrives mid run, so basically cancels the active run, like turned out, cancelled stuff that we have, and flips the status back to queued, and finishes the turn, so the loop picks up the new work and all. So this is what this interrupt active turn thing is about. And then the claiming a next queue turn that we have. So that is the so let's try to import, and again from this db package, let's import next queue turn. So basically, yep, uh, here, so it is simple. What we are doing is it delegates to db automix claim, so two workers can't grab the same queue turn. That's what we are doing here. And then the other thing is trying to mark the session as idle. So let's try to, so this, let's try to import. I think this simple only drops to idle from queued or running, so it won't clobber a session that's already moved on. So that's the thing. And finally, we need to return these four things: fail session, interrupt active turn, and claim next queue turn, mark session idle. So this is what trying to deal with the session state, like, you know, activities and all those things, the life cycle, how it's going to look like. So that's the thing. And yeah, I think mostly now we at least got the foundation, like for the activity types, helpers, and session state, streaming, run, input activities, and all that stuff. So we can try to add now agent segment, the agent execution boundary, the that stuff. So same then this inside this activity, let's create this a new file called agent segment.ts. So, and inside this so basically here what we'll try to do, we'll try this activity is basically that actually runs the agent. So the boundary where like temporal hands off the hands off to our runtime RNS, which is what this run agent segment basically it claims or creates the turn, flips the session to running, builds the environment, signed file downloads, MCP tools, agent, and run input, then drives the SDK stream. Each event is again raised against temporal's cancellation and pushed through the batcher into the event log with monotonic ordering, and it branches on three outcomes. The agent might be passed for human approval, like persist, run state, publish, requires action, return, and or else it can run to run to completion, like saving state, publish the final message, and idle. Or else it can throw error like cancellation is rethrown for temporal, or any other error publishes, turn.failed, or all those things. So that's what this agent segment and all will try to add it in here. So first let's see what and all we can quickly add in here before we actually add that actual activities for the agent segment. Let's try to add in this the helper, like required signed file resource download. So this is the what we just a simple check that decides signed downloads versus like is it a fuse mounts and all. So true for backend or storage combos that can be basically mounted directly, which is Docker plus S3 compatible, AWS S3 GCS, or Modal plus Azure Blob, and all those things. So that is the combination that we are trying to check. So for which one we need file downloads and all those things. And then the other helper is basically let me add this. So let's try to import, create object storage. So this is object storage for sandbox downloads. So when a separate sandbox reachable endpoint is configured, then it basically tries to build a storage client that signs URLs against the endpoint. So the URL works from inside the sandbox network, not just the host. So that's what we are trying to do here: settings and object storage endpoint and all those things. And now the function to download files required for our run. So let me add that here. Okay, so and require file, and then the file resource ref and activity services. Okay, fine. So this it's only for runtime, only for backends basically, that needs signed URLs, like helping us to generate pre-signed get URL per file resource, so the sandbox can call it down. Okay, so that's what we are doing. We're receiving settings, db, object storage resources, and if you're checking if it's a sandbox backend is none or not required, then we don't need to generate signed URL. So we're just going to return straight away, or else then first we're trying to get the file resources. If file resource length is 0, again we don't need to generate, right? So we can just straight away return. And if there's no object storage, also all the pre-checks and all, and then download storage, and then we're trying to iterate through each resources and then try to get the URL and push it to our downloads and then trying to return that. So that's the thing. And now let's focus on the activities, that thing we have. So I'm just going to add it in one go. That's kind of like we are trying to add a lot of stuff in that. I'll try to convey exactly what it is doing. Let's okay, and of course we need to add imports and all. Let's try to import result. Okay, and this is from streaming, this also from streaming, and db, and also here let's try to import from db, same thing, and again this as well. This is from this db as well. This is from streaming. Yep. And then setting the session status. So this and all, now you understand why we added all initially in our contracts and all those things, these helpers and all. So let's try to, yeah, and this is the input, and next stream event from the, yeah, and also saving run state from the db. Okay, lot of stuff. Or else let's do one thing. So I'm just going to import all of this that I have instead of doing it once at a time. So all these imports that I have, yeah, I think yeah, yeah, I think all are sorted except these two things which needs to be from our contracts. Yeah, okay, those imports, you can just check this, because we are already having all things that we need in our db package and events package, runtime, config, and run input in the same package, and all things that we have. But the important thing is, let's see what it is doing and try to understand a bit the important stuff that we have. First thing is basically this is a factory. So create run agent segment activity. So this opens, what it does, opens this open telemetry span and declares, like, for example, if I just open this, so yeah, this is just opening that open telemetry span, session id, workflow id, trigger event id, and declares this mutable state, this try catch, finally in all share. Then we are trying to so all these things that we need: activity status, turn id, heartbeat timer, prepare tools, turn state, started, published and all. And now trying to run 3 ways. So I pass return id, and then the automatic db claim or freshly created turn. So exactly one worker owns this turn. So here what we are doing is trying to configure settings and session, making sure we have the session, and trigger getting the session event. And if there's no trigger, we can say it's not found. And if we have input turn id, we are getting session turn, or else we're just claiming the next queued turn db. And if it's no turn, and if it's not there's no turn id, we are creating a new one and then getting the session for that turn. And same thing, activity context, trying to get the current activity context, and starting this activity time wait, so every 10 seconds and all, so that and then producer sequence that we have. So just for ordering, then transitions this to transition the sessions to running, and then emits like basically this emit started, then turn, started, published, later gates whether failure event should be sent or not. So that's what we are doing here. Publish, and so running, and events published, and if it's immediate, we are just going to sleep, and then this turn started and all, and setting the session status to running, and we are just publishing this status changed, turn started, and published to true. And this run settings, now we are trying to now merge the session plus turn resources or tools, and building the environment and sign downloads, tools, and then the sign downloads and all those things, and preparing the mcp servers that we need, and trying to build the agent and run input, then kicking off the run stream here at the end. So the on runtime callback flushes the sandbox lifecycle events immediately, while the batcher handles ordinary stream events. So that's the thing that's this is doing. And here now we have this stream loop. Basically here the next stream event races each event against temporal's cancellation. Normalized events are like basically pushed through the batcher. The inner finally closes the iterator if he broke out early, and a final flush drains any pending batch. That's the thing. Okay, fine. And then if this interruptions length is greater than 0, so here now the approval gain path. So if the agent passed on like tool calls needing like let's say human approval, then it tries to serialize them and persist that run state with the pending approvals. And we are trying to publish that required actions thing, and returns so the workflow waits for the human decision and all. That's what here it's happening basically in the required section and all those things. The finish turn, and setting the status. And after that the API path here, the final output. So the agent ran to completion, so save run state with no pending approvals, publish the final message plus the turn dot completed plus idle, and return the terminal idle status. So that's what we are doing, and this is the simple error handling here. Basically the temporal cancelled failure is flushed, so marked the cancelled and rethrown, so temporal records it. So any other error, like once like turn dot started was published, the publishers turn dot failed and returns a clean failed status, so the workflow can reason about instead of an exception and all those things. So that is what we are trying to do it in here exactly, the status as failed and all. And in finally what we are doing, we are always trying to run the cleanup, so here we are trying to record the workers activity metric, and hence the OpenTelemetry span that we have. with the status and duration, and also the we are trying to close the MCP tool servers and clears the RB timer, so no matter how the activity exited and all. So I know this is all kind of paths and the API paths and all the scenarios that it can go, and everything is happening here at this thing, run agent segment thing. You can just check it out, and it should be straightforward. It's just the flow is so big, that might be confusing a bit, but that's the activity running agent segment and all. And now we have this. We need to actually now try to create a session workflow and add the durable loop and then bootstrapping worker and all those things, so that actually we can try to spin up a worker now. So in this worker now, let me just create activities.ts file, and inside this I wanted to create a kind of a singleton factory that boots the DB, NATS, bus, runtime and storage once and reuses them across all of our activities. So for that, this is what I mean. So basically, okay, and imports, I'm just going to strictly add all the imports that I need from the respective packages that we have, and config db events and other things. So here is the thing. It's a simple lazy singleton factory. That the first activity, what it does, it calls bootstraps the DB connection and the NATS bus, runtime, harness and the storage, and then the observability, and then reuses them across every later call. Dependencies can be overridden for tests and all those things. So that is this create activities, and we are returning this run agent segment, create run agent segment activity, and passing in this the services that we have. Same for our create session activities and all. Alright, so now okay, so once we have that, let's instantiate the default activity set and re-export each activity by name, so that we can use them. So this the default that I'm. So now default activities, which is here this create activities, and I'm going to attach in the run agent segment, fail session, interrupt active turn, claim execute turn, mark session idle and all. So this basically, this is the shape, this worker.create activities registers and workflow or proxy types against and all. So that's the that's the this activities thing. And now let's add the workflows folder. That's the thing mainly now. So, and inside this, let me add this activity.ts, and in this basically I'll try to just import the proxy activities from temporal workflow. That's the standard way thing. And then so this is the simple temporal proxy. Let's try to create that, and then you'll get an idea. Here you go. So this is basically the temporal proxy, which gives the workflow typed activity stubs, with a 4-hour call timeout that I have configured here. Sandbox runs are long, so you can increase 24 hours or whatever it is, and 30 seconds heartbeat idle deadline, and then the maximum attempts as 1, because retries are handled in the workflow, so not by temporal. So that's why I'm just setting this to 1. Okay, and then I'm just going to create a small helper here to handle workflow failure message. So to extract readable message from an unknown error, so the workflow can pass it to like fail session that we have and all those things. So that's the simple activity, proxy activity that we have just created here. This activities, this is the all of the things that we just exported, and we are just attaching here all the types to this. And now inside this itself, let's try to create the session dot ts, and in here we will try to have the first let's import add the imports that gives us the temporal workflow primitives, and then the activity types I'll just import from the activities, and also the activity and workflow failure message just from the activities we just added and all. So let's just add, you can add imports here or else add the code first, and then you should be able to use that. Fine. And I'm going to declare 4 signals. Basically that is what we'll be using to wake or steer the durable loop. So mainly the 4 signals are the user message, that the one that he'll be sending, and the queue changed, and also the approval decision, whether it was approved or rejected, and then the interrupt. So these are the things. So we are using here define signal from the temporal workflow, and this is user message, queue changed, and approval decision, and the interrupt. So those are the main things, the signal. And now let's try to define the input shape for our workflow. So this is how the input shape is going to look like for our workflow. So passing in the session ID and then initial event ID that will be passing on. Basically the session it drives plus an additional initial event ID. That's the thing that we'll be sending in. And now let's try to set up the workflow function. So let's try to break it down. Okay, and here let's okay, in here session workflow input, we are attaching in this session workflow input, and now we are adding in setting like this is like durable workflows local state, and we're trying to wire each signal, like message IQ signals bumps, hey, like the wake ups counter, and approvals NQ in event ID, and interrupt records the event ID that should cancel the long term. So that's what we are doing here. So set handler user message wake ups 1, and queue changed again wake ups, we are incrementing it. Approval decision we are pushing it to approval queue, and interrupt we are setting that event ID to interrupt event ID. Okay, so fine. And then now comes the major part that I need to add. So that's the core logic, which is very critical. So let's add here the infinite loop like while true. So and then I'll just walk you through what is this doing. Okay, so this is the actual durable loop, and it's a runtime helper which we are going to showcase here, this thing. Okay, let's see what this. So what this does, this loop, what it does basically, it claims next queue done. So you see here the activity, the one that we added the proxy activity, and it is just trying to claim this next queued turn that we have. And let's close this, and once it gets that turn, so if it's if there's no turn, so let's again we'll try to get the turn, and we'll need to check out the 2 directions whether did we get the turn or not. And if we don't have turn, we'll see the wake ups, whatever you have seen wake ups, and here we try to wait up to 5 seconds for a wake up or interrupt before a final claim, and clean idle exit. Like that lets the temporal close the workflow gracefully. Okay, so that's what we are doing. Await condition, so I'm just using here temporal's cancellation scope, condition define signal, set handler, and work flow info should be like, okay, so we are setting this condition, and if we have interrupt id, then we are going to set that to null, and then we are going to mark the session as idle and return straight away. And if we have this oak, we'll just continue, and here we're trying to claim the final turn, and if we still don't have the final turn, we are just marking the session idle and then returning that. So that's now this run turn, what it does is basically it tries to run each segment inside a cancellation scope raised against an interrupt condition. So an interrupt can basically now can abort the agent activity mid-flight, pending interrupt short circuits like before the segment even starts. So here this is what I mean. So runtime, it'll take in session id, turn id, trigger event id. So if interrupted id, we are just going to interrupt active turn, pass in this input params, and set this interrupt event id to null, and return true. And now create this new cancellation scope, get the workflow id, and then here we are just going to run the agent segment by calling this activity thing and passing in this all the input params that we need, and we are going to expect an outcome of this kind, result, interrupt, or failure. And then this segment, whatever we have, we are just going to so this is going to just look for the result and also the condition thing, whether it's an interrupt or the result or the failure or interrupt and all those things. So if output kind is interrupt, we are going to cancel this scope or cancellation that we have, and interrupt activity or call this active turn, and then we'll set this to null and return true. And if it's a failure, we call this fail session activity that we have, and if it's a failure cancelled, we are going to set the overall result status as cancelled. And if it's a require action, we are going to call this condition, and if we have this interrupted event id, we are going to pass on that to our interrupt active turn and set this to null, return true, and get this approval event id. If we have this approval event id, we are going to again start this runtime. So that's the overall flow. This is very important. Look, basically, when are we going to call the run agent segment, when are we going to call fail session activity, when are we going to call the interrupt active turn, and all those things activity based upon this output, and also the cancellation scopes and all those things. It's very important. So that's the thing. It's like basically that's a nested declaration. So the loop above can call this runtime before it appears in the source. So this is the simple thing, the session workflow that we're trying to have this durable stuff. And now the main thing in the source, the workflows dot ts, I'm just going to now export all of this that we have in our session. So let me just which is approval dation, interrupt, queue change, session workflow, and all those things from this thing that we have. So these are the things, approval dations and all those things, and that's basically needed. So just the parallel exports and all. So loads this file as the workflow path, so it must re-export the workflow and all signal definitions kind of in one place. All right, so now the final rule root index dot ts thing, and here in this file, basically this is where we need to start worker and create our groundwork worker and all those things. So let's try to import what and all we need in this thing. So basically, okay, So we need settings from the config and all, observability, native connection and worker from temporal worker, create activities and activity dependencies. Okay, first the type for our worker options. So here this will have this what and all we need: settings, activities and activity dependencies. That's what we need for constructing a worker. So that we can inject settings, a pre-built activity set and activity dependency like override sometimes for test and all. So the groundwork worker that I need to create in here, this function. So let's add in this function here. So this is the actual bootstrap. Okay, so you see here this take worker options and returns the worker and connection, native connection. So first we check the try to get the settings and observability thing for the worker and the connection here. Retry startup dependency. So we added those exponential retry and all those things. Retry and native connection dot connect, trying to connect with the temporal host that will now add in our env variables and all, and retry options for and then on retry again we're just going to try it again, so that we can establish a connection. And activities, whatever the options activities that we receive, and then once we receive them, we are just going to use this create activities from this activities that we just created here. This the initializer helper that we just created, pass in this activity dependencies, settings and observability, and finally this is where we start our we create our worker. So here we use worker.create, pass in the connection, namespace, temporal task queue and workflows path which we just created, workflows.ts, the path name and activities all associated with this workflow is something that we're going to pass in, and at the end we're returning this worker and connection. So simple. This is the what this does is basically it's just trying to bootstrap, retrying the temporal connection with the shared startup retry helper that we tried creating before, and then creates this the temporal worker pointed at the workflows barrel which we just created, and the activity set that are all associated with that. So once we have all of this thing, and now the entry point for this process, so let's create something called it is a start worker. So this is the thing. This is the one actually which builds the worker. So get settings, observability and worker. So here we are trying to get the worker and connection, and then once we get that, we are just calling run function on that, and that's what will runs it, and finally always closes the temporal connection on shutdown. And then this one, basically this start worker, we need to call it, right? So here I'm just going to add in this if import dot meta dot main. So await start worker. So it runs the worker when this file is executed directly. That's this thing. So and so basically why we add this separately, because start worker and create down worker now can be imported for test and all. So that's the thing. And this is the actual the code related to the starting our worker. And now we need to of course add our temporal worker and all that stuff in our Docker compose. So let's try to add them. So opening this Docker compose file, and here basically now I need to add temporal server and also the temporal UI, so that we can just see what workflows and what activities we are running, and that's where like retries, resetting and all we can perform. So I'm just going to add those images. So this is the image. So temporal auto setup gRPC server, it's going to help us, and it needs environment variables, HTTP proxy, all proxy. I'm just going to leave them as empty, and no proxy and all. This is by default, you can just refer that. And the db postgres is something that will attach port 5432 and postgres user password groundwork and postgres and bind on ip and this. Yep. And yeah, and then the depends on this postgres condition health and temporal ui. So this is the actual server and temporal ui will be on 8080, and it depends on this above things to spin up, and then we'll have this thing. Okay, so this is what will help us. And also now I need to add in a command to start our worker as well, and also update our script. Mm, so here let me just add in here same thing, dev worker. I'm just getting into worker location and run this run dev command. Okay, and this script. So here basically, and also I need to add the environment variables, which I will add, but also this port is something we need to export here in this script that we have. So let me maybe add here anywhere, you can just 7233 for our server. And also here I need to add in the host and the ui port for our the temporal stuff. Yep. So and now whenever we're trying to spin this thing, I need to now pass in temporal and temporal ui. And also after api I need to do the same thing for our worker and try to spin it up. Okay, fine. So we're almost there. We're trying to close the gaps, and in this base also we can just add the alias for our worker. And let's open this env stuff, and in this I just need to add in the variables that is needed for our temporal host. So let me add in here at the end. Okay, and also the temporal ui host port. So I'm just going to add this as 8080. Yeah, I think this should do it. And now if I just open this and try to run run dev, so it should now it's pulling the temporal ui, and also it should already I have temporal already pulled into local, so it's not pulling. So once it basically pulls all containers, and it's going to start our worker, start all other things that it's needed, api and all those stuffs. And I can just browse in localhost 8080, and we should see the temporal ui and all that stuff. So let's wait for it to start. Okay, api started. Yeah, now you see the worker registered, and this worker state changed, workflow bundle created, and it compiled successfully. And I can just now try to browse this. So basically I can try see, let's see if it let's see. I'm trying to open the browser and see temporal ui. Okay, I'm almost there. Yeah, I have it open. So let's try maybe showcase a bit here for you. Yeah, so this is how it's going to look like. Here we can see let's try to expand this. workflows and all, we have not triggered any stuff and all, but this is how we just try to monitor the UI stuff, any workflows and retries and all that stuff we needed. So now we are almost in a good place. We have almost there of laying the foundation and trying to have the worker and all those things. Now we need to like slowly shift towards the API layer and add there what and all domain logic and all that we can add, and then expose all of this triggering point through session related endpoints or something like those on those lines, and slowly eventually add streaming SSC support and all, then the simple UI section and all, and there where we can consume all of this. So let's try to add now basically contracts, definitions, job schemas and all, and then eventually towards the API app. So first let's define the contracts in the form of job schemas that we would need for our API endpoints. That is what we'll be actually talking to our workflow engine and all. Opening this contracts, and here inside this, and let's try to minimize this terminal now. Anyhow, those are all running fine. And here first thing, to create a session request, so let's add in this initial message, resources, tools, metadata, model, reasoning effort, and sandbox backend, and client event ID. So and then the type, that is what we are exporting, and that is for our the post that creates a session. Okay, and then the job schema for updating session turn request, so just for patching the stuff. So here is the thing, just it patches the queue turn with every field, like optional basically, so client can change just the model, just the resources, or just the prompt without resetting the whole turn. So that's the thing. So prompt, resources, tools, same whatever we have, sandbox backend and metadata and that stuff. Okay, and then reordering the session turns request, so let's add that schema as well. So here basically it carries the new queue ordering as non-empty array of like turn the IDs, so reorder request can never arrive empty. So that's the thing. And yeah, we're almost there, and now I need the client session event schema. So it's going to look like this. So basically this is going to be a discriminated union of three real-time signals a connected client can push mid-session, right? So basically a new chart done, which is the message, and then the interrupt, and then the approval deletion. So each carrying an optional client event ID here. So the API and any typed SDK will always try to agree on this shapes that we have. So type, client event ID, the payload, the standard stuff, and same thing here, reason for interrupt, and approval deletions, approval ID deletion, and message. So that's the simple the types that we need to add. And now let's add the like start adding maybe resource and tool validation as kind of as a domain layer in API. So let's open this API app that we have, and inside this source folder I'm going to create a new folder called domain. So here just a rough validation and all those things we'll try to create. So first maybe let's say resources.ts, and inside this the intention is basically purely API's validation domain that basically helps us to sanitize and verify every resource and tool before a session can use them. So that's the only thing, and this is going to be just simple stuff that we'll try to add in. And so first let me add a function which will help to normalize the mount path. And here we just need to import from the Hono HTTP exception, and I think self-explanatory, so it's just a stripping surrounding slashes that we have on blocks, so the mount path can never escape the sandbox via this path traversal. And yeah, so that's the thing. And now the another helpers, I'll just try to add one at a time and then walk you through about that. And this is parsing resource URL. It tries to convert unparsable URI into 422 rather than letting a raw URL constructor error bubble out. So that's the only thing here. And then the checking for the positive integer function, so making sure that we only accept only positive integers and returns null otherwise. That's this thing. And now let's try to normalize resource that whatever we try to attach for this session. So here let's try to import this resource ref, and then this stable JSON resource identity key and all those things. Okay, so here the idea is basically canonicalizing every resource ref. Okay, so file resources get a default, like, you know, files file ID. Okay, this error looks like there is some issue with the, let's see here. Okay, there you go, it is file. Now everywhere it should be sorted out. Okay, got it. All right, so yeah, let's see what this does. Okay, so here what we are doing, file resource get a default file / file ID mount. So repository resources are passed and forced to, like, you know, the HTTPS and lowercase thing, and then stripped of the .git references suffix, and given a like repos owner repo mount, then rejects the mount path collisions and same identity with different settings conflicts with 4 double twos that we have here, and just silently dropping exact duplicates, so the return list is always clean and stable. So that's what we are doing here, nothing else. So if it's a and we're just normalizing mount path and returning this file ID and exact path, else we're trying to process resource URL and make sure it's HTTPS, and then lowercase, and stripping of those things must include this owner and repo, and then yeah, and finally returning in the normalized way that it expects. And then here we're trying to convert have the stabilized version of the JSON, and this mounted that stuff, and duplicate resources, we're just taking care of it, and unique identity key. And then yeah, that's what this basically in the helper, making sure that we normalize the resources, whether it's a file or whether it's a Git repository and all those things. That's what we are trying to do. And now we need to just, you know, try to merge those resources properly. So that's one helper I'm just going to add in here. And this merge contract, it's basically I need to import. So let's just add all the imports that I need. So basically we have in contracts also those things, right? So I'll just try to add merge resources refs as merge contract resource refs, because we are trying to add the same name here. So that's the thing. And existing additions, and we are just calling that and passing in this existing addition, so that now we are reusing across the API and other layers and worker later whenever we need. And this is the standard error that we're trying to return. So that's this the simple merging existing and additions and that we get. And now we need to validate the basically we'll be trying to connect to GitHub repository. So there whatever the GitHub repository app is selected, we need to validate that selection properly. So this is for that. So we're trying to check the repository kind and installation raw, repository raw, and we are going to double check both of them are not undefined, and get the installation ID, repository ID, and then return that those things. If selected is 0, then by default I'm going to select the first one and return this. So this is just validating simple thing. So that's the thing. And similar way we need to validate the file resources. So let's me add in the same way. So these are all pure validations for our API layer and all. It's better, it's best always to have this kind of validation way before, so that we'll know where exactly things are failing or stuff. So what this does basically, it hits the DB for each file resource and rejects duplicates and unknown files and any file not yet in ready status, catching upload traces basically at 4:2 rather than at runtime. So that's what we are doing here, and exactly it's being done so in the loop. And yeah, that's the simple validating resources. And a similar way we need to validate the tool refs. So let's just add in here. So this also same thing, checks each requested tool is an MCP kind here, and whose ID matches a configured MCP server, and deduplicates first one wins and then throws 4:2 for anything unknown. So that's the thing, simple iterating through tools and then checking maintaining this unique tool refs selected set, and then trying to get the list that it's unique. So yeah, and mostly that's it. And I'm just going to export merge tool refs, and we'll be using this in a while. So that's why I'm just trying to add in. So this is simple resource and tool validation in the domain layer and all. And now let's try to create our session workflow client, and then NATS and temporal wiring and session domain and all that stuff. So first thing we need to add the dependencies inside our API layer. So in here I need to add event stuff. So it needs to be events package that we have, and also I just need to add this temporal client. Yep, so this is what we need. And also let's try to I'll just try to run this burn install so that it'll install this client that we have. Okay, so and let's again collapse this bit. So what are the dependencies that we need? Okay, and now in the API source dependencies, the global thing. So now additionally we need to add in here the bus, which is the NATS event bus, and also the workflow client. So here this is workflow client, and here again this I'll try to attach 4 signals that we have as a definition in here. So simple signal user message, wake session workflow, and signal approval addition, signal interrupt. So these are the basically 4 signal methods that is needed, and I'm just going to attach in here session workflow, and then this event bus. I just need to import this from the events package that we just added. So that's how now this app dependencies we're trying to wire in the NATS and temporal as well. So in the domains layer, now let's try to create the sessions related logic that we need, basically the calls to our DBs and all the queries. So here let's name this as sessions.ts. Okay, and in here first thing is the function to create and start session.
All right, and also let's try to just import all the dependencies. I'll just add in straight away, or else like auto suggestion should help you to add it automatically. Anyhow, both way works fine. And the thing now is those are the dependencies, and let's just create a few helpers like we normally had, workflow id for session and all those things, just prefixing session with the session id that we have. And then we need required queue turn id for api and all those things. So here basically I'm just this is a simple guard which routes like first check get the session turn, and if you don't have session turn, we just throw in 404 not found. And basically we know that this turn doesn't belong to this session. And 409 if the worker already picked it up, so it can no longer be changed and all. So that's the thing, if it's already queued. So that's the thing we are just trying to add. And now reasoning effort for the session. So same way, like first trying to add this atomic helpers that we need. So reasoning effort for session, passing the metadata and fallback, and returning this OpenAI reasoning effort. And here we're just taking help of this from the contracts that we have and using that. Okay, so now once we all have that, now let's add the core function to create and the start session. So that's basically the main thing for the in this domain of this session. So I'm just trying to add the function here. So this should be straightforward. So the input receiving as always the database, event burst, workflow client, initial message, resources, clients, and I think it should be fine. So first thing, we are trying to create a session in our db, call this and pass on this inputs that we got, and then try to prepare the initial payload. So the text, resources, length, and tools if we have. And then so if that's the case, so this now once we have that payload, we are just trying to now append and publish this events to our NATS thing. So passing in this db bus and session id. Session first, these are the events that we'll try to pass. Session is created and the user message, and along with this status changed. And so the idea is simple. First create the session row in a db with the model or effort baked into metadata, and like automatically append and publish. And then session created, the user message and status changed, and it records the deterministic workflow id via this workflow id for session that we have. And then we try to like enqueue now the first turn with every run parameter that we have, and we try to publish now turn.queued. So wake the temporal workflow now, and then return the fully iterated session. So that's the thing. So publishing session created, user message and status changed, and after that trying to find the events and workflow id for deterministic thing, setting that workflow id, and then now enqueuing that session, and again publishing, appending and publishing when it is queued, and now wake the session workflow, and then it will start the session. So that's the ideal ultimate flow, how we are trying to wire up NATS, db, and the temporal stuff that we have. Okay, so once we added that, now in the index.ts file, so let's go in here, this stuff you see already it's throwing an error. So basically we need to now update this stuff and all, because now we need to add this NATS bus and those stuff. Okay, in the start API, okay, first let's add the dependencies that I need. So I'll just import this. Okay, and I think duplicates we can just avoid.
Yeah, so you can just add in that anyhow, that should fine work fine. Okay. And I need to pass those okay, let me just add what and all I need before this app. So here let's add in this, and now all I need to do is basically pass in this bus and workflow client, and it should be fine. And of course I need to work on this creating temporal workflow client. We'll just add in, I'll just add this also and then walk you through what each part is doing actually. So that's the start API. Maybe I'll just add here. Okay, so this is the function to create the temporal workflow client. So taking in the settings and returning the client session workflow client and close. So session workflow client is from the dependencies the type, and here it is first trying to create a connection. So using this the connection from the temporal client that we have, taking in the temporal host, and once it has the connection, it is trying to create the temporal client, passing the connection and the namespace that we have. By default it's I think default namespace, and this client that we have, it's attaching the signal user message. So temporal workflow.get handle workflow id and signal user message is what we're trying to attach, and the wake session workflow, basically all four signals that we have. So now we need to attach the actual things. So signal with start session workflow, pass in the patterns that it needs, task queue, workflow id, reuse policy, and session id, and signal is basically queue changed. Same thing for the approval or decision, signal, interrupt, and then finally return this client and close. So this is the simple implementation of the interface that we have just created. Wake session workflow, user signal with start. So the first run lazily boots the workflow, while the rest forward signals to the running workflows handlers. So close test the connection. That's the thing. And once we have that, so here now I'm just trying to initialize this bus, which is of create NATS event bus and workflow client, trying to define these variables, and retry options we have this helpers, and on retry the callback things. And now inside this try catch block we need to initialize this bus. So wrap this inside the retry startup dependency and call this create NATS event bus, and same thing for a workflow client. Wrap this inside retry startup dependency and call this create temporal workflow client, so that now we'll get the both the NATS and the workflow client, and that just we need to pass on to our create app here. So okay, what is the issue? Yeah, it has to be workflow.client, so my bad. Fine, so that's the thing. And in the error we're just trying to close bus and workflow client and db connection and all those things. Pretty standard way to get things tied up and all. So this is basically what like now we have session workflow client, NATS and temporal wiring, and session domain and all those things wired up into the API layer. And now we need to create some SSE helpers, and then once we have those SSE helpers, then I can focus on adding HTTP routes for handling all the sessions related stuff. So quickly we'll try to create some helpers. Here I'll just create common.ts and sse.ts. So in common basically we'll try to add something like bounded limit, basically whenever we try to parse query string page size, and we'll always try to default it to 100 or something like that, so that we don't try to give unbounded list or something like that. So this is one simple helper. And also then I just need an helper to make sure that session is always existing. So just try to import so that whenever we're trying to load specific session, it's always there. So that's the thing, and we do proper handling of 404 throwing that session is not found and all. So that these are the just couple of helpers. And now let's open in the ssc.ts, and in here first we need an helper to replay the session events, so from our DB. So here let's try to import a session event. So this basically the supporting helper for our SSE session stream calls like during replay. So this is a pure paginator thing extracted, so it can be like what it does is basically it loads an history in 1000 event pages, so sends each in the sequence order and stops when a page comes back smaller than the page size. So that's what it is doing, just trying to replay that session events that we have. And now the SSE session stream, I need to add that's the thing that which is important for us. So here let's try to add in, and the imports that I need I'm just going to quickly add here. So yeah, I think this should be it. Fine, let's talk about this SSE session stream. So here of course the inputs for this is DB, bus, session ID, after, signal and all, and the encoder, controller, last sent, replaying, buffered and unscripted. This is a pretty common. And the here what is the thing that we're trying to play is subscribe first, replay second, and drain buffer protocol. So it like that's what we're trying to follow the order or so. And we are setting up the last sent here, cursor or replaying or flag or buffered array, and also the send helper that we have that skips already sent events and gap fills like missing sequences from the DB, and it subscribes to NATS immediately and buffer live events while paging DB history, then like flip replaying off, drain the buffer in order, and emit the connected thing. And this basically closes the race where a live event fires between the last DB page and the subscribe, and the abort signal or cancel like just try unsubscribes from NATS on disconnect. So this is the simple thing. And here in the stream, basically the starting controller we're just passing in this, and in the if event sequence is less than or equal to last send, we're just returning straight away. If not, we will first try to list session events from the DB, missing things, and try to iterate through all of the missing things, and check if the sequence is greater than last sent, and then enqueue into controller and keep updating last sent, and the same thing here. And that's what, like, now we are trying to subscribe to NATS, and if replaying, we are trying to buffer those events thing, and again trying to sort in the sequence order, and then send use this helper that we have. That's what we are trying to do here, the simple thing. And here we're trying to replace session events from the DB and all, and I think this is also like again sending it to the stream. So yeah, I think this should be. And in canceling, we're just trying to unsubscribe, and adding always event listener for abort, and just to call the unsubscribe whenever we are trying to interrupt or so. And this is the response stream. It's trying to send a stream and headers, content type, event stream, and all those things. So this is the straightforward SSE helper that we need. And now we will try to use this in the API eventually. And so now we have this helper and all. It's time to create routes for our session. So let's try going to this routes folder and create in here this sessions.ts file. And in here basically we will try to add the routes that we need for our the sessions and all that stuff. So basically now we have all the things that we need. It's just the importing and trying to wrap the queries, functions, and all those things that we have. under the API thing. And what and all I need here, I'm just going to import it straight away. So and I will try to use this thing. So from DB we need list session, get session, require session, and all those things, and append and publish events. So you will see now this all once I start adding one at a time. So first trying to register a session route, so let's try to quickly add it, because we already added it for the files, and it should be pretty straightforward as the skeleton. So trying to get from the dependencies, API route dips that we have, settings, DB, bus, workflow client, object storage. First thing is sessions. So this is the basically the endpoint where we'll try to create and start the session. So trying to get the payload, so we're trying to pass with the jot schema that we have. Same thing, trying to normalize resources, validate tool refs, and also validate GitHub repository selection, and all this pre-validation that we normally need. An object storage is configured or not. Same, trying to validate file resources, model, reasoning effort, and all. After we have done all these pre-valid checks, then we are just calling the create and start session function that we have, and pass in all it needs: DB, bus, workflow client, initial message, resources, tools, and all those things. And straight away after creating, we're just saying that it is 202, and the session is queued and not yet running. Yeah, so that's the thing. And that was the creating a session. And now what if I wanted to get the session by ID? So here this is the endpoint. So simple, we are just getting the session ID from the query param, and call this get session ID, get session DB function that we have, and then return that. That's the thing. And now to help us list the session events, so here I'm just going to add this route. So session ID events. So this basically gets the session ID from query params. Again, assert session exits, the common that we just added, the helper function, and trying to get the after and limit from the query params, and then just call list session events, which we have the function written in our DB package and all. That's to list session events. And now the important thing, opening the SSE stream. That's what we will be trying to subscribe from UI. So session ID event stream, get the session ID, again check that session exists, and get the query param after and or also last event ID. And then now this SSE session stream that we have just created here is what we are trying to call by passing in the params that we need. So this is what basically opens the SSE stream. So reading the resume cursor from the after query or the browser's last event ID, and reconnect header and passing the request, like basically the abort signal through. Yeah, this is what we have. Fine. And then the other endpoint is to list the session turns. So after this, I'm just adding here session turns, get the same session ID param, double check if session this exists or not, and then straight away return by calling list session turns, the functions that we have, and those things. And now patching a queue turn. So like, let's say if I wanted to update the turn prompt message or whatever it is, other stuff, details and all that we have. So that's this endpoint we need. Okay, so same, trying to get the session ID, turn ID, asserting, require queue turn for API, just double checking, and payload update session, trying to pass jar schemas, and resources validation, and tools, and then object storage is configured or not, and trying to validate that and see that a required session is there, and GitHub selection is validated or not. After having checked all this thing, we're trying to update that queue session turn, whatever. If it's a payload prompt is not defined, we're just going to update prompt. Same for model, reasoning effort, sandbox, backend, and any metadata. After that, we are just going to publish NATS event that turn is updated, and turn ID and payload. So that's the thing. That is this endpoint. And then reordering the queue turns, so that also we need one endpoint. So let's try to add in this endpoint. So this basically reorders the queue turns and then publish turn dot updated carrying the new ordering, then wake the workflow, so it picks up the right new next turn. So that's the thing. Reorder this turns, publish turn dot updated, and workflow client wake session workflow and pass in this session. So that's the thing. And to cancel the queued turn, also we need an endpoint. So I'm just calling here get the session id, turn id, and then here call this cancel queued session turn and update in db and publish turn dot cancelled. Yeah, that's it. I'm just going to return that turn whatever we have. Okay, I think we're almost done, except I think we need to add one more endpoint, which is for the events. So it's a quite big one. Okay, anyhow, let me just try to add and let's see. Okay, so here okay, this is the events endpoint. So basically the user dot trying to add different types of the events in the sessions that we can expect. So the user dot message branch, basically what it is doing, validating the resources and tools and model reasoning effort, and then validate file resources, and then we are trying to append session events with the logged session update, pass in this the all the things that this needs, like events, trying to structure in the payload format, event.type, payload text, and other things that we need to attach. And then it is, if it's a queue session, we're just going to say that status changed and then return this format, and then publish this events and all. And yeah, for this is kind of like trying to handle this merging resource tools and flipping an idle session to queued, and then automatically appending the message plus this optional status change here that we have. And then we are trying to publish it to NATS. Then we need to now enqueue new turn triggered by the accepted event. So falling back to sessions model or effort here, all these things, the turn, and then publish that turn dot queued. Then we need to wake up the workflow and return 202. So that's the thing for our user dot message events. If something that we are receiving for this endpoint, that's all we need to do. And now here if event type is approval deletion and requires action, so basically it's more or less interrupt and approval deletion branch. So here straightforward, if it's an trying to reject an approval when nothing is pending, so that's this thing we are trying to do. And then we are trying to append the event, then signal the runnings workflows approval deletion to basically take respective action. So on same, based on if it's approval deletion, we're trying to signal this approval deletion. If it's an interrupt, we're trying to signal this interrupt and return this 202. So that's the thing, trying to handle event type and all. And this is pretty much it that we needed in our sessions route and the endpoints and all those things. So now going to this app.ts, we need to first of all import the register session route sessions that we have. And once we have that, I need to basically register that same way we registered the file routes. And also in these patterns I need to add all the endpoints that for sessions it is. So we know already there's endpoint for sessions, so sessions to create and event stream, my events, reorder, turn id, turn, and then session id and all. So that's the thing. And yeah, I think we are almost done. So that's what yep. And also if we wanted to maybe export these things so that we can directly use it inside our whenever we are trying to use it in our front end. Eventually the next step is that so that it will be directly imported using the package name and all. So this is the session routes and exposing now all the way and tying it up through a HTTP API endpoints to our workflow engine and the DB queries and all that stuff as a wrapper. And once we have all of that, it's just now we need to start consuming all of these endpoints and try to somehow tie it up with a simple single page application in front end, and see if we are able to create a session, and if you're able to see the streams and see if the temporal workflow in UI and all those things are working fine or not. That's the next step. Let's try to create a simple web app, and then let's see. So the front end web app now. So let's try to create simple web app, single page application, Vite React thing. Let's see. Okay, so here in this web thing, let's create here this package.json and tsconfig.json, that stuff. I'll just try to be quick here because it's not okay, fine. So this is going to be simple Vite dev application. So I'm just going to add so module and then dev Vite dev on 3000 port, build, preview, and dependencies, font source variable, inter, and those things, and then standard radix UI sonar. You can just add it. Initially I'm just trying to spin up boilerplate and all that stuff, and tsconfig as well. Let's just try to include by default whatever is recommended for the React or type thing, React JSX and bundler and other things, just a standard default. So I've not touched anything in that. Okay, so we just need to run the one install so that it just adds those things, and then we'll configure actual index.html and then mounting root and all those things. But before that we need to have some API wrapper talking to our API endpoints that we have exposed, and then the strict types and all those things. So let's try to work on them. So here I'll just try to create a new folder, source, and inside that let's add this types.ts. I'll just try to be quick, and let's see. The first thing is we need about the session status. So like, is it queued, running, idle, request action? You know this more than me now by now. And then the resource references, so it's a file and repository, so that we need to attach in here. So repository URI, ref, mount path, subpath, and GitHub installation ID, repository ID, kind file, just file ID and mount path. So that's the thing. and then the tool reference, the kind, MCP, and the ID attached to that. So it is something is going to look like this, tool ref. And then the file asset, the one that we'll be trying to attach. So here status, what is it, and the file name. These are all the jar schemas that we have in the backend, so just for the it to be consumed in UI and updated it and all that stuff. And then the create file upload response. So here file ID, upload ID, put URL, required address, explicit, max size bytes, and all that stuff. And file download URL response, this is the type. And then the reasoning effort of the model that we'll be trying to use, that we have. And the turn submission, that basically the one that we'll try to submit in our composer, the text plus addition, optional resources, tools, and all those things that will be tied up to it. So those are the things. And then the client config that we will need. So basically default model, allowed models, and other MCP servers, file uploads, and auth, does it required, and all those things. Then comes with respect to session, so pretty standard, ID, status, initial message, tool refs, and all those things. Yeah, okay. And let me just add in session event, the sequence typed events the SSE stream delivers, and the inspector that we'll try to use to render and all. So this is the simple types that we need. Okay, and now once we have this types, and it's I need to create the API wrapper to all of our endpoints. So here let's try to first the types that I need from the dot types that we just created. I'm just going to import all of this. This is all I need, and a simple helper to resolve API based URL, the pretty standard things. Basically it's stripping, trailing slashes, and all those things, and default to same origin. That is the thing. And once we have that helper, now I just need to create a constant to get the API base URL. So here I'm just going to pass in Vite API base URL, which is going to be localhost or 127.0.0.1, that thing that we have, and access storage key to store local storage thing, Groundwork. I am just going to name this as dot access key. And now to read the local storage access key, this is a simple thing. We are just going to use this key to store the access key, and try to get in this way. And same way to set that, just the opposite of that, let's call the set item, and then clearing the stored access key. So let's all this CRUD ops on that local storage that we have. And now auth headers for access key, so this is how it's going to be. If we have value, we need to attach in the authorization bearer value whatever we receive for that access key. And yeah, and the internal helper, every request users, we need some helper here. So I'll try to attach this auth headers for access key and pass in this get stored access key, which will try to read it from the local storage. That's the thing. And let's try to add some generic request, so that we'll try to make calls to our APIs. So this is simple fetch thing, and we will try to use this the base URL path and init whatever we receive, request initialization, and then headers will try to attach auth headers and those things. If it's not okay, we'll just throw some API error. If not, we'll just try to return whatever the response that we have. So that's the thing. And now let's focus on the actual consumption of the endpoints. First is the creating a session. So here this is going to look like this, a post request. So the type here instead of T is going to be session, and the endpoint is v1/session, method is the post request init, and the body
what and all it needs. And I think by now we should know the definition of the API and body text specs and all those things. This is the create session endpoint consumption, and same thing now to fetch the client config. So this is to get that client config, and for fetching the session details by ID, so again the same thing, and fetching the events, I'm just going to add this same limiting and events, and while true we are just going to call this events that we have and try to push it to our events and thing. And that's the thing to fetch events, and trying to send a user message that's so to our the events thing. So here the type is user does message, and that branch how it's going to handle, and that's the thing that it's how it's going to handle. And now trying to upload a file asset. So for trying to upload the file asset, this is how it's going to look like. Making a request to files uploads, the initial route we have, and making a post, and then after that uploading it to the this signed URL that we get. And if it's completed, we just try to return this completed file. So yeah, that's this 3-step file upload. Like ask the API for pre-signed URL, put URL, upload the bytes right to the object storage without API server intervention, and then mark the upload complete, and then return the file asset ID. So that's the thing. And the other endpoint now to download the signed URL. So this is the thing. Yeah, simple method post, and we'll get that. And trying to get the files metadata. So this is the simple thing, make this thing. And now if we wanted to send interrupt to the events, like we send the user message, that's also one type. So that's the same thing, just trying to send a post request for that. And same way like this, the approval type decision for the events thing, approve or reject, that we can send to that. And then the stream URL is something we wanted to have an helper which helps us to build the SSE endpoint URL with the after cursor, so reconnects resume from the last scene sequence, instead of trying to see duplicate events. So here base URL, this is the event stream, and we are just trying to construct that URL and attach the after and return that stream URL. So now the stream connection state can be of this values, connecting live or error. And then the options the stream accepts. So basically for the stream endpoint, so this is what signal, reconnect delay milliseconds, max reconnect delay milliseconds, and on state is something. This is what we need. And now we should try to create specific error, just extending parent error class so that we can throw right error. So session stream HTTP error, just extending that and trying to log that thing. So, and also the simple helper to abort a signal. So if that is the like, should we abort signal, or is that signal aborted? So this is how just we are trying to check if we have an aborted in value, and on all those things. All right, and let's try to normalize stream options. So these are all the helpers for us to actually start listening to the stream before we actually try subscribing to that. So normalizing the stream options. If there are no signal options, try to return, and if it's about signal, just return this signal options. Else return this whatever the stream session event options that we have. Okay, fine. And a few errors, like some helpers quickly. Same thing, if is it about error, and the is retriable stream error. These are the all retriable stream errors that we can try and all.
and simple helper to calculate the back of exponential back of stuff. So I'm just trying to multiply it by 2 and take a minimum of these 3 values. Yep. And let's have an helper which is going to help us basically in abortable delay. So it resolves early if the signal fires, so unmounting doesn't hang. That's the thing. So setting timeout and abort and done. We're just trying to listen, remove event listener, resolve, and add initial abort event listeners and all. That's the thing. And then the parsing SSE event, it will be trying to come in the specific format. So we need to extract the data colon lines from one SSE block, and JSON parses them into like session event, the type that we have. So fine. So now we have all of these helpers. Then let's try to finally add a function to read that session event stream. So this is what it's going to look like. So here this is a single SSE connection. So instead of event source, which can't send basically auth headers, it uses here the fetch with the auth header, so that we have. So decodes this body stream, whatever we have, and splits on the like SSE /n/n this new line that we have, and block separator, that is a block separator, and emitting one the parsed event per block, and this finally like release lock, and finally guarantees that reader is cleaned up on every exit. So that's what we are doing. Simple, just trying to parse the body and split it by the /n/n, and then try to add it to this buffer that we have. So that's the thing. And parsing is this event, and then on event we are just emitting that. So fine. And that is basically reading session event stream, one thing. And to stream session events, so let's add this helper. So this is basically what it's the heart of the live feed. So this is a self-healing SSE loop. It reads the, basically you see the options based delay and all, just you can see that. So here while till is it aborted, so it reads the stream above helper function that we have just defined, stream, advancing a cursor and reporting like, is it connecting or live or error state on a like it just keeps listening and tries to emit, and on error it will just reports these errors and all those things. And on a clean close, it will just try to back off and reconnects them from the cursor and breaks the loop and rethrows. And that's the thing that we are trying to do, wait for reconnect and next reconnect delay. So this is the simple thing, and I think mostly whatever we need in our for SSE and the endpoints calling and all those things in API, it's all taken care. Okay, so that's the at least the API and the types that we have. And now some features. So let's create some features here, features folder. I'm just trying to group it by features folder and see if we can share among the multiple features that we are going to add, like for example session related, then document and RAG related, and all the stuff and all. So here just a simple helper to format the timestamp, and so that we can properly showcase in UI. So this is trying to convert, get the timestamp and get the time and showcase that into local string and all those things. Okay, so now the features, we are going to have few things. Right now I'll just try to create a stubs. So documents dot tsx, and inside this we'll just add some placeholder. So I'll just add it in the same way. So document search, we'll just enable its false and toggle and define. We'll just set that in that on those lines. Okay, that's the I'm just trying to be, because in anyhow next we are going to add all those things, so the document related stuff once we try to test this, at least the simple session related things, if it's working or not. And we'll have the documents workspace, and the documents search toggle should be enabled that or not, and all those things we'll try to add. And so for time being I'm just trying to keep this as the placeholder. Same way, like we'll have the option to connect to GitHub and all those things. So here as well, let's just add in a stub the basic things. For time being we can add. So I just had I have here, or else you can just ignore as well, but we'll know that at least which one to pick next. So that's the reason I'm adding this placeholders. Okay, and a similar thing for a scheduler, like what and all, or schedule and all those things, because we'll try to add schedule task related feature as well. So I'm just going to add it here, this thing. So yeah, and that is a schedule task panel, and here new schedule task form state that will try to take in the like which schedule to create. And this one is the form state from schedule task. And this is basically what and all functions we'll be trying to add: schedule from form state, and all those things, and agent config from form state, and all those things. You will know these things. I know I'm just trying to add it way in the UI, but just to get a overall picture. So that's the simple features. We will need to pick one at a time as we complete this UI skeleton, both from the backend and then front end and all that stuff. Okay, so now the source, let's create the components that we need. So components folder, and here I will add the atomic components from the shardcn directly. So you can just use the shardcn CLI and try to install, or else you can just refer from here the thing that I'll be trying to add in. So components will add the basics things. Okay, I need to add this live folder. So let's add that, or else we are going to see an issue. So in the source folder, so new folder called library, and inside this utils.ts, pretty standard thing we are trying to add in here. Yeah, now the error should be in the ts config. Yeah, this error. Okay, we'll check this types thing. And here the collapsible drop down input scroll area and things that we need. So besides this atomic components, the things that we need is the composer thing. So that's the text input that we will have. So here I'm just going to create this composer.tsx, and in this is basically I'll try to add this component. It's a simple one, and basically trying to add in a functions to I'll just add it straight away. I think it should be straightforward because we have dealt with this kind of components way longer before. So Okay, so here I'm just trying to add this complete component, and then maybe I'll just walk you through a bit. Simple. This the basic things. Imports, we need some icons, listed react and charts and buttons, text area and cn helper. That we need file upload, the API call, and the contract types that we have. Okay, fine. And then this composer handle, this is simple imperative handle the parent can call to focus or clear the composer. That's the thing. And these are all the props that we will be trying to send it to this component: placeholder, labels, disabled or pending state, examples, slot nodes, for extra controls, and then the submit callback. So that's the thing, all of these things. So, and this is for draft attachment, a local, the upload that is in flight, it's like ready or failed and all those things, that is for this. And this is the actual component now. So we are trying to just destructure all of the props that we are receiving with default, and setting up the values or attachments, states here, and text area, file input refs, use refs for text area, and file input refs as usual. Okay, and this use imperative handle basically exposes focus or clear to the parent, like why are this imperative handle. So that's the thing. And this, the trimmed, as uploading attachments, ready resources, and can submit, these are just the self-explanatory. So whether any upload is in flight, and ready file resources, and whether the form can submit or not. So that's the thing. Okay, and this submit, yeah, it just fires a callback with the text and on ready attachments, then resets the fields in this local state. That's the thing. And clearing attachments, yep, it revokes basically any object URLs and empties that attachment list that we have. So yeah, this is the thing. And remove attachments is basically, it will try to just drop one attachment, just revoking that specific preview URL. So that's the thing, and it's just trying to filter from that current list. Okay, and this enqueue files, what it is doing is basically it's trying to add each file as an uploading attachments, then uploads it and flips it to be ready or failed. So this is what we are trying to make an API call here, upload file asset, and then based upon that it is going to update the status to ready. If it has succeeded, if it's an error in the catch block, we are trying to set this as a failed thing. So that's the thing. Enqueuing files and handle file change is simple, funnels this file input selection into this enqueue files, and really and resets that input whatever we have. And handle paste is basically it'll try to capture the pasted images and enqueues them when uploads are enabled. So that's the thing. So yeah, it's just trying to enqueue them. And handle key down, enter, basically shift enter, it's a new line, and enter basically submits, and escape clears the field. That's the thing it's happening here. And the stylings, I'm least bothered. So it's just a wrapper, outer wrapper, and focus style, input shell, on all those things. And if we have an attachments, we'll just try to showcase here inside this block. And after that, it's all the text area component, just taking in all those things in the component, and then input for file stuff. And yeah, and here the right side will have the controls bar, like attach files button, submit button, and all those things here. So here we have this thing. So, and if we have any examples, like prompt chips and all those things, we'll just try to pre-fill that text area and just the close of that component. Okay, so that's the thing. And forward bytes is just trying to format it to KB, WB, GB, and all those things. Okay, fine. This is the simple composer component that we have. And now the main stuff, I know I'm just trying to construct it in the weird way, but that's fine. You can just spin up the boilerplate using the Vite command that helps you to bootstrap React application and all. or else you can just do it in this way, any how works. And in this, now let's try to create the main app.tsx. okay, so this is basically the main file. So this is the place where we'll try to consume that components that we have just created, kind of like adding the header icon and adding this files, documents, agents, and all that stuff. Let me add this, then I'll just give a walkthrough or part of it. So adding this, it's a big chunk of a file, the app.tsx. What's this error? Let's go all the way to the top. Okay, so first thing is basically trying to add the imports that we need. All this the icons, so lucid react icons and all those things, and then the toaster, sonar, those things that we need. And after that, just the main component, the composer, and then the button, the collapsible drop down menus and inputs. So these are all the basic things that I need, and all the so trying to keep in the single file, now trying to like organize into proper folder structure and all, since this is not UI priority or UI focus, more or less it's a backend and infra focus. So that's why like trying to keep all of this in the same file, so it looks big giant file. So these are the APIs that we added, trying to import the types. And here I need to add this vendor like to support the stream down cleanly. For that, what I'll do is basically try to add in the vendor folder, and inside that I'll just try to add. So basically inside this source folder, let me just create the new folder called vendor, and inside this let's create stream down runtime.js. so in this we are doing nothing, I'm just going to export the stream down, and that's what we will be trying to use it here. Yeah, okay, maybe let's try to okay, that's the thing. And also let's try to define these types. Creating this just the type, so that we don't receive this the TypeScript error. So d.ts. okay, so here I'm just going to add the types for our stream down, the type components and all those, just a small helper. So this is the simple thing, trying to import component type and React Node and stream down components, record of string of component of any or string, and this is going to have children, class name, components, media, mode, just the type definition that we'll need. So this basically now mostly this should, yeah, okay, fine. So that's the thing, importing this type definitions and all that stuff, and this exporting basically trying to re-export this scheduled task helper so other models can import them from the app. And here a couple of examples, prompts and empty state, like what and all they can do, just simple examples that we normally see. And the intelligent effort, that's basically this is the UI facing effort subset, like this live connection, state union, and the order efforts, basically trying to list them in. That's the thing that we have. and this conversation trace kind and conversation trace status. This I think should be self-explanatory. Kinds and status a single trace step can have. That's the thing. And here conversation trace item, this is one reasoning or tool sandbox or approval step inside an activity turn. So that's the thing. And the conversation user turn in a projected the conversation, and this is the assisted message turn with its streaming or terminal status and all that we'll try to have. And here conversation activity turn, same an activity turn, basically the collapsible trace of the agent's reasoning or tool or sandbox steps and all will try to have kind turn id status trace and occurred. And this is conversation turn is basically combination of all of that above which we just defined. And this is the main app now. Here so this will have, we need to track of the session id, active view, session, events, client config, model, reasoning effort, inspector is open or not, connection state, and OpenAI GenAI tool enabled, is it busy, or access key draft, access key version, last sequence, is auth required, auth ready, and trying to use the GitHub and then trying to use the document search. I know these are all the placeholder features that we have just now. And then trying to fetch all the client details on the mounting of this component, and trying to update our local config and update model, same set the reasoning efforts and all those things. And if it's again if there's no session id and all those things, we are trying to set in null and events and connection state as closed. And here we are trying to now call the fetch session if we have the session id and load those details, and same thing for the events and all. And here trying to open the session stream, trying to listen to the stream of events that will be emitted from the backend. So all the params that we need for that hook is something we are just trying to pass in. And here is the project conversation that we are trying to store in memory and load it into this. And same approvals goes here, and can send follow-up or not, depending upon whether session is idle only, we'll try to allow it to send, or else will not. Same thing if session is running or not, this thing. And submit initial, we first update the busy as true so that we can disable the input and all those things. And try to get the selected resources, selected tools, create session, and then we try to remember that session whatever we has created, and update the local session variable, session id. And then we are just trying to push the url with this created id. And if there is any error, we'll just say we cannot start the session, and then try and finally release the busy from true to false. Alright, and these are like couple of helpers, selecting the session, like setting the view of that agent and session id, and same thing. And going home is basically trying to set the view to agent, and deleting the path and the query params in the url browser. And this is the submitting follow-up function, just trying to send user message, call this, and follow, submit all of these things, and trying to set the session by fetching the session that we have. And and interrupt session, again calling that send interrupt, and saving access key, trying to save it into our local storage, the helpers that we have. Same for forget access key and all those things. And now comes the actual ui. So here at the like this is the main wrapper. So I'll stylings and all I'll just add now, the css and all those things and all. But ideally the layout is something like, we'll have the header button like a sparkle icon, and then we'll have like download agent, and after that we'll have this button to set active view, it's an agent or the other view, and that will have bot icon and agent, and the other button to set active view to documents and all, which we will try to add it later. That's the next feature that we'll try to pick on. And the same thing, so if session and active view is agent, so we'll try to see the arrow left icon and the initial messages kind of list of the sessions that we have. So this is what we'll try to see. And if auth is required, we'll have this lock icon to log out or something like that. And here connection pill, if active view is agent, and the same status badge, and this is like panel right icon to open the inspector to see the events that we are trying to collect and all, like from NATS and all the session events replay and all. And this is just the form if auth is required, and we don't have access key, trying to say that we would need this access key, enter deployment key for this instance, and then trying to take access key input, and then trying to continue and all those things. And if it's active view is documents, we'll try to showcase that documents workspace, which is a placeholder for time being. And if there's no session, what should the agent do, and trying to give the follow-up text like helper text, start a durable sandbox session and all those things. And here comes at the bottom the main thing, the composer, the input section, where we'll try to use this composer component and provide all the props that it needs. And then it will have this control start model picker, which one to choose, GPT models and all those things. And also we'll have the GitHub picker, docs toggle mode, should we enable doc search or not, and those are all placeholders. And here this groundwork toggle as well to enable our agent or not. And here below that composer input, we'll see the recent sessions, just to so that we can click on that and try to load what we have done before and all. And the other things is trying to schedule the tasks panel, that's also like placeholder for now. And then below this we are going to have sessions chat pane, and and then the sessions inspector, trying to, if once we open that, and roughly that's the thing. And these are all kind of like helpers to apply session status events, trying to get this list of sessions and trying to reduce and showcase that in the UI right hand side thing. And like is session status, and this groundwork tool toggle, basically the pill button that attaches or detaches our groundwork MCP tool for the next run. A simple control toggle, boost styling and check mark, reflect the enabled prop and all those things. And model picker, and just the drop down with all the list of the models from the OpenAI's stuff we'll try to showcase here. And status badge, and this is a session chart pane, the one that we were using. So here I think if these charts things are pretty common, so updating, trying to this is the actual the tool calling and all those panes that we'll try to see. This is what this component is, and we'll have this approve or reject the UI that comes up whenever it needs some exclusive permissions from us. And that's the thing, and this is very important session chart pane. And this is the composer that we're trying to wrap in, and this model picker, search tool toggle, ground tool toggle and all. And this conversations stream, basically helper, if it's a user, where it should which component, and assistant message and activity message. And these are the just tools we're trying to showcase. And message file attachment, okay. And here just a button to attach the files and all, opening file and those things, assistant message, avatar bubble, and then markdown text that we're trying to have, and streaming cursor, and then terminal notice, and those cancelled, failed or waiting and all. And the activity message, same thing. And trace panel, we have here button to open that stuff, and alert or circle, we'll see this in UI, then you'll try to understand what this is. So why I'm trying to paste it up here is because UI is not that important these days, because it's all, we are trying to rely more on agentic or infra or backend stuff, and that's the reason. And and then trace item view, which anyhow I'll be attaching in this commit, and you can just try to have a look at it. And this is the trace icon. Depending upon this, we'll try to use, if it's sandbox, terminal icon, it's complete check icon and all those things. And avatar bubble, and markdown text, we'll try to use this stream down component from stream down. And here markdown components, paragraph, h1, h2, h3, h4, and unordered list and ordered list, and block quote, and anchor inline code, pre table, t head, t body, th, table data, horizontal row, and pending bubble, just 3 dots, and pending dot, single dot, streaming cursor, and then this terminal notice will just have this icon and the message, and session inspector will just have this debug events that we'll try to see on the right hand side, and the tabs will have overview, events, timeline, just to switch the content for each of the things and try to showcase that things in that specific row the content will try to showcase. Yeah, and this is trying to wrap content in the scroll area so that they can scroll all the stuff. And this is the inspector section having title and children, info row, and the copyable button, and then the event debug row, just collapsible stuff, having this event type, event turn id, and timestamp, and all those things. And then the event sanitizing for display, just trying to display in the format, and then raw JSON pane. So instead of trying to showcase in formatted way, we'll try to show the raw as well so that they can see in the copy as stuff. And connection pill and recent sessions, just the buttons to view what and all they have viewed, and use session stream, that's the just the use effect, trying to hook to our calling the stream session events that we added in our API, and so that trying to listen depending upon the session ID and access key version, and trying to build out tools. This is the function, is resources ref array, and is tool ref array, and repository display name, project conversations that we already saw how we used in above thing, last message, start message, and last activity. And yeah, starting activity here, we are just trying to call the wrap around our API calls that we try to add in here. Okay, pretty much here, depending upon this tool output and all, which one to start and all, so which events, activities, trace to push, and this is all, and completing calling all of that, and run activity and all those things. And yeah, if its item status is running, we're trying to mark the status as complete, and finish trace and reasoning summary text, trace key, tool title, sandbox title, pretty JSON, stringify payload, and approval items here we'll try to showcase here using that, and merging, trying to merge current and incoming events, helper function, and status tone, tracing summary, all this, like, you know, just the coloring statuses thing, and events label, attaching like basically UI session created, and also that should be, it's better to showcase in this way, human readable way, than trying to show in this way. And is UI reasoning effort, and label effort, display model, remember session, those things, and recent sessions, just trying to get, and so that we can populate. I know this is very vague thing, but the idea is to just try to get the high level view and idea and all, and then exact code and all you can just refer in the commit. Okay, so now we have this app.tsx attached, and we need to create a main.tsx file. So that's where actually we'll try to call this app thing. So inside this source, I'll just create main.tsx. so let me just call this thing, and here we need to import our styling, stream down styling, and then try to, you know, wrap this root app inside this DOM ID. So you'll see now. So basically, yeah, just trying to import this app, and then the stylings and all I need to create. So anyhow, so let's try to create styles.css, and these all basically just the sample theme. Any theme should be fine. And anyhow, this is not a good UI and all. I'm saying it myself because this is just the temporary just simple UI, trying to add this theme, just some radius, coloring, and all those things, pretty much for so you can just see that yeah, it's just the black and white theme. Normally any theme Shanxian, you can just pick it up, and yep. And now that's this main.tsx that we have.
And yeah, and also now this in the once we have all of this, so inside this web, let's now try to create index dot html, and inside this all we need to just add the id root. That is where we are trying to add our main.tsx, so the script that we need to inject. So this is the thing. So I'm just trying to add the id div root and then attach the script module main.tsx, and I'm just attaching here. Yeah, that's the thing. And these are the like main things. And now the things that's pending is the Vite config, which is very important to build, and then update our package.json and the dev script. Then we should be good to see the UI. I know I'm just talking a lot and then not showing anything, but let's try to add now inside this. So why I'm trying to add it manually, it's way better that we understand how to tie things up rather than trying to use some boilerplate and all those things. That's also one reason, or else you can just follow whichever works for you. And this is the simple Vite config, trying to attach in the port and then resolving source directory to @alias, and then plugins, Vite, React and Tailwind CSS that we need, and just trying to attach these things. And now let's try to update our package.json. So basically there we need to add in the dev web command like we normally added for other things. So simple, straightforward, trying to get in web and trying to run this command. Yep. And now let's try to update the dev script, and then I'll try to spin this up and let's see how it's going to look like. And also we need to add the environment variable of API server, Vite API server URL, and here Vite API. So let's worry about this as Groundwork web port. Yep, that should do things. And also now I just need to run this web app here. So maybe after everything is up, yeah, below this worker, let's try to add bunx Vite dev port, whatever we have. And now let's open this thing, and here I'll just try to add in this Vite API base URL so that our UI can talk to our API. So that's the thing. Yeah, now mostly we are there. Let's see if it's going to work or not. So I'm just going to open our terminal, and let's collapse this. And yeah, and I'm just going to, let's now try to run this run dev, and it's just trying to spin up the containers that we want. And also, like, once these are all up, starting APIs, then starting worker, and then trying to start UI and all. Let's see. And mostly I'm hoping it should work. Yeah, we have this localhost that we have. Okay, should, okay, failed to start up. NATS is refusing to connect. Not sure why, but at least let's see if UI is up or not. So here I just need to check in localhost 3000.
Yeah, so this is the UI that I was talking about. So this is the, so from layout wise you should understand now. So that was the header with the Sparkle agent, the title, and then the tabs to switch the documents and all. Like you saw, it was disabled and nothing was there in document workspace and all. That's why we are not seeing anything. And here we have this the simple compose, and here this a model picker that we saw, and by default I have the ZBD 5.5, and then the reasoning thing, effort and all. And this is the just a toggle to enable, and these are the prompts examples that we added. And yeah, so now if I say at least okay, fail to start a session. Okay, so there is not able to start. Let's try to start it again, and let's see. Basically there's some issue with the starting the API server or so. That's why we are not able to see it as well. Let's see once again. If not, I'll just try to check what's the issue. Okay, UI at least started, and worker started, API started. Okay, looks like now all are up mostly, but let's try to see. Okay, so here let's see. Yep, so now everything is up at least, but we have an error, posting to endpoint. Okay, 404 not found. We'll check, but the UI you see here, this is the side thing that was we had overview, events, timeline and raw, just pretty much these vague UI. And trying to see here what we have on the timeline, the status, so that we'll be trying to see. And here basically so you see now this is the workflow which we just tried to trigger, the session workflow. So here you can see clearly the queue changed signal is what started this thing in the first place, the thing. And then it tried to claim the next queue turn, and this was the input, session ID and workflow ID, and this is the result, ID, session ID, trigger, workflow ID, event ID, and status, running, source is user, prompt, this is what I sent, and tools, MCP, model, all this the things that is needed will be sent to this claim next turn. And now the actual thing, run agent segment, is what we'll try to call, and here, and you can see here the status is failed. So now we need to check why it's failing and all. But this is how, like, trying to trigger like wire up the UI to the temporal engine and all, actual agents, ground time harness and all, through the API as a wrapper and all, like the thing. So now we need to inspect our terminal logs and see why it's not available. Okay, MCP server. Okay, so here let's do one thing. What I'm going to do, let's go back, and I'm just going to disable this and now try to ask. Okay, so now you can see that MCP server is not available, but we enabled it and it's trying to call that, and that's why we see the error. So now if I just go back to this, and you see here the session thing, so here basically same thing, it ran this agent segment now, and the status became the idle, and run agent segment, and trying to claim this. And here this is the timeout, and after that again came trying to claim, and finally this session is completed. So this couple of, that thing that I'm trying to show is a simple one, but we'll actually try to connect to GitHub and all, and then try to actually solve some simple like simple to medium problem, like try to simulate the database migration of like some, let's say like 500 rows or 100,000 rows or so, and see if it's actually doing the work or not with the actual agent and all. But the UI layout, at least by now you should be able to, this is the status connection panel, those status components that we had, and this is the debug section, trying to see. Now you can see overall this session, we can see all of this info, but this is not what we are trying to learn this from, but just the UI. We need to have something, that's the reason here. And now if you just keep on asking anything, you should be able to see this. So this is the at least the foundation for the UI that I wanted to at least wire up the things and showcase the connection end to end. And now we'll try to add more features. And here ignore this tracing, I'm not least bothered. So actual thing, it's actually request completed and all the things that we wanted. So the intention is basically on how do we create our runtime agent harness, and then create our the temporal engine, which is a very core of and understand the concept of the signals, interruptions, approvals, and the durable workflows and all those things, and how can we configure our own sandbox and all those things. And then just trying to wire it up to UI via our any API framework, in this case Hono, or you can use fast API or whatever it is. And also you by now you should understand the least importance is given to the UI as well, because everything we are just trying to dump into a single file called app.tsx that we have here, which is very big file, but if you just refer to this, it should be simple thing and should be able to understand. So now we have this at least basic UI tied up, and we can able to start the session and all. That's the thing, just able to are we able to create a session and start the session. You can check in your DB tables and all, you should see the entries into the sessions tables and all those things, and creating a turn and those events and all those things thing. I'm not just trying to show, because anyhow you can just query in the UI and have a look at it, and you should be able to see. And if I just go back and you see here, these are the recent sessions, just we are trying to pull it all the way from the DB itself, and we are trying to see that. Okay, so next I wanted to focus on the document section, so documents base, and trying to add a documents CRUD and all. So let's try to add them. All right, now let's start adding the contracts related to the life cycle of the document. So let me open our contracts package that we have, and basically inside this let's add the document status. So this is basically the lifecycle states of document, queued, indexing, ready, and failed, and just the exporting the type. So that's the thing. And now let's try to add the document base. That's the basically what the API returns and validates for top level collection and all. So the ID, name, description, created at and updated at. So that's the simple type for the document base. And now the actual document thing. So this will have the this is what is going to link a file to a base, and carries like this indexing status, parser used, chunk count, and any error and all those things like ID, base ID, file ID, status, title, parser, chunk count, error, and created at. And this is the type that we'll have. All right, so that's the document thing. And now whenever we are trying to search for document, the result of the document should have some schema, and this is that any retrieval query, it's going to return in this format. So it's going to give us the match chunk with its relevant score and source pointers, so I'm just defining right now because these are related to document search, so that we can directly use it later. So chunk ID, document ID, base ID, file ID, and title, text score, chunk index, or metadata. So that's the a simple thing. And now for CRUD operation stuff, like creating a document base request. So this will have the name and description as the input, and that's the simple the George schema for that. And And maybe a lighter version of that can be something like this, adding this document request, which is going to have the file id, just the id of an already uploaded file. So that's the thing. So these are the basic jot schemas that we need for the document. And now let's try to add our db schemas. Okay, so going to this db package, and in this source folder, let's open this db schema. And here first thing is basically I wanted to create a type for our pgvector type. Basically Drizzle has no native pgvector type, so we wanted to be strictly typed. So let's try to define that the type here, so that we can use while we are trying to define. So the custom type from Drizzle pg code, just import that. And this, so we are just trying to define custom column type that declares like vector 3072 and serializes a number array into a Postgres vector literal, that a comma b comma c on right and all those things. So that's this simple thing, just trying to define this vector. And now once we have, let's try to create tables that we need. So here let's go all the way to the bottom, and the first thing is we need the document basis table, which is the top level connection rows, like that create document base and list document bases. Will try to read and update from this table. So I think by the jot schemas you should know this skeleton and understand this. Okay, so this pretty standard thing. And now after documents basis is done, the documents table just to match with the schemas that we just added in jot. And here, so same thing here, each row what it does, it links a file to a base, so that we have here. And document basis.id, and deleting a base cascades all the way to its documents, but the file reference is restrict. So here you see here, so an indexed file can't be deleted out from under it. So, and the base file unique index enforces the idempotency. So add documents to base will try to rely on it. So that's the thing, and we are trying to add an index on base id and file id, status and all those things, and other fields. It's a pretty standard thing, so you can just check it out. Okay, fine. And now we have documents and document space table. So we need to add the documents chunks. That's where we'll try to store the chunks of each document. So this is that table. And here the embedded slices, basically that's what will power a retrieval. So this is the table, chunk index, text, metadata, embedding model, and created at. So it uses this the custom vector, the type here, column for our 3072 dimension embedding, and denormalizes the base or file IDs for fast filtering, and uniquely basically indexing on the document ID and chunk index. So reindexing is stable. So that's the only intent. Okay, so now we have these schemas, and these are the tables that we need. And also now the SQL, here again I'm saying it, usually it's auto generated using the Drizzle GB generate commands and all, but I just want to be this very simple and all, and single file SQL file, since this is just a prototype or something, the ideation that we are trying to understand. So I'm just trying to add manually in this SQL file. Okay, so that I think should be straightforward. First is basically we need to create an extension pgvector here at the top. So let's add it. So if creating extension if not exists, that's a vector. And after that we need to create a tables, which is the same thing, a document basis. And I think pretty much you should know the fields and all those things, id, name, description, created at and updated at we are going to have. And after that I'm just going to add in the documents table. So here it will have again same id base id, and it's pretty much the schema converted to SQL. This is what it is. So let's just quickly add other tables as well. I'm just adding the document chunks here. Let's same thing, and yeah, and also we wanted to add some helper here. So here basically we are trying to widen the embedding column to vector 3072 if an earlier dimension, basically let's say was applied, falling back to like clearing the table if the in place alter can't run, so then adds that chunk indexes and all. So here basically I've run already with other dimension index, so just to clear those things, if it's not 302 3072 dimension and all, that is the thing. And now we can just try to run the bundle dev, and everything, this creating of tables and then running this and all will be taken care, because we already sorted out how to do the db migrations and all that stuff. Okay, so I'll run that, and also now let's first start lay the foundation for documents package, so like we normally did, and then we'll try to run that. Okay, so here documents, as usual, let's try to create this package.json, and then the ts config thing that we usually need in our packages. So in this package.json, basically simple and straightforward, just trying to add the name and main entry point and then the dependencies. So here, yeah, just the standard documents, and we need dependencies here, all our packages, config, contracts, db, storage. And for parsing the documents, we'll use light parse, and these are all ORM and OpenAI for embedding and all those things. You can add Anthropic and all. The only reason I'm just using this because it's cheaper and not expensive like Anthropic. That's the only reason. But usually I use Anthropic Claude models. But yeah, okay, fine. So now we have this package.json and ts config. Let's try to again just extend the base, simple stuff. Okay, and extending the base, and now let's try to create a new folder called source, and in that let's define index.ts and all source. That's where we'll try to define. And here let me just now first run this one install, so that all the dependencies that we want in documents will be created. Okay, fine, and I'll come back to this running run dev and in a moments of time. Okay, so now here the parts that we need to add just to lay out the foundation. So just let's add in all the dependencies that I need. I'm just trying to import what and all I need. So from config, contracts, db, and all those things, you will see the usage of this as we keep using them. And let's define some constants, like what should be the embedding model default, and at least the default document parser, embedding dimensions, chunk size, and the chunk overlap and all. I think this rag and all, it's so 2020, but still I'm just trying to fit into this thing so that we can see the temporal workflows and durability and all. Only that's the intention. Okay, fine, and that's the simple constants. And now the I need to define the types for past document and document chunk. So let's add in this thing. So basically these are the in and out data shapes for the pipeline, that a past document basically is the text plus an additional metadata a parser will produce, and document chunk is basically is the one slice of that text carrying its own metadata. That's the thing. Okay, fine. And other few types that we need to lay a foundation. So here the document parser, these are just contracts kind of thing for our rack pipeline. The parser basically turns bytes into the text, and that's the thing. And this chunker basically slices the text into parts. And the document embedder, model dimensions, embed many, embed query. So this embedder just vectorizes it, and this document services basically bundles all three whatever we have just defined above. So that's the only thing. Okay. And now some other helpers to just try to convert into our document base the structure to insert into our tables and all those things. So just that's the API facing shape, which is document based, and so that's the thing just we're trying to serialize and convert into that format. That's the simple helper. And the same way like we have for mapping document base, similar way for mapping the document as well. I'm just adding this thing from this schema that we have. And yeah, these are all the stuffs that we need. And then after this I'll just try to add the actual queries to make it entries into our table rows and all those things. And other thing, basically the guards that we need, for example, require ready file. So basically it loads the file and refuses anything not fully uploaded or processed. So we never wanted to index a file that's off written, right? So that's this simple extra guard. And now let's focus on CRUD operations onto our document bases, document chunks tables that we just created, pretty standard. And first thing, creating a document base. So here simple, we take in the input, which is a create document base request with the things that we define in our Jot schemas. So all it does is basically it inserts a new document base, the top level connection value, taking a name and description with a trimmed of course a name and description, and returns the mapped row, the helper that we just created above. That's the thing. And now once we created that, we need some function to list them. So this is that. So listing document bases, the read side that backs the collection picker, which we will try to showcase in a while later. And now to get specific document base, so this is that function, taking in the base ID and just trying to query matching that document base ID with the base ID, and trying to return that row and map it to the format that UI or contract needs. Okay, fine. And yeah, and now trying to add the document to the base that we have just created above and link to that. So this is that function, adding document to base. So basically what it does, attaches an already uploaded file, because uploading file into blob and the files tables that we have separately, right? So attaching that already uploaded to the base is what this. So basically first we're trying to get the document base, and here assuming trying to do the guard check, this is a file ready, and then trying to prepare the now and then trying to check if it's existing. So if it's existing, we just return, else we just do a new entry and link the file ID and base ID and create a entry into our documents table. So that's the thing, the adding document to base and all, just trying to link the file ID with the base ID. That's the thing. And then trying to list the documents from the documents table. So let's add in here. So this basically, yeah, just for our UI to show in the upload order and all those things, just trying to query by ordered by created at in the ascending order, and then trying to fetch a single document. So here let's add in get document, same straightforward CRUD queries that we normally do. And pretty much these are the things that we need. So like to lay a foundation for our APIs and all those to be used. So now basically if I try to call this button run dev, usually it should create the migration for our documents table and all that things, and we should be able to see that migration getting completed and all. Yeah, you can see basically document chunks base and all those things. So it is saying that it's already exists because while I was trying to develop initially and trying to test and all, I created, and it has the same volume mounted and it's not erased and all. That's why you see, but you should see it's created and all those things and all. So we have these tables and all, migration is happening correctly and all those things and other things. So the creating and it should be able to start pretty much things. And do not worry about this fail to start and because I have other things running, but ideally migration is created and we are trying to lay the foundation for the documents. And yeah, and now let's once we have this thing, and now we need to start adding core functionalities in the documents package. Like for example, how do we handle this recursive text chunker and light parser, and basically trying to handle on those things, the core things that documents are supposed to handle, trying to handle embedding and document services, factories and all those things. Okay, so first recursive text chunker and light parser. So let's try to add again the helpers that we need in the same here. I'm just going to add usually I would need let's see first some helpers as usual. So trying to check if it's a text like so this is the helper. So basically the parser's fast path like checks that light parse document parser dot parse calls, this is that will be called by that, you'll see in a while. So it decides whether a file can skip OCR and be read as a plain text by inspecting just directly MIME type first, so that we don't need OCR, we need only for PDF and other documents types, right? Just normal files which is already text, we can just straight away read that. So that's the intention. So this is the thing that's we are trying to see, trying to first get the content type, file name, and if it's all text application JSON, markdown JSON or something, we can just straight away read the text and we skip the OCR. That's this helper for, you will see in a while. And now the entry point basically for our light parse document parser. So let's try to add that piece. So we have here the type defined, which is a document parser. So let's try to implement that part. So this is the first entry point, so I'm just trying to add. So light parse document parser implements documents parser, and here basically what the intention of this is basically turning the uploaded bytes into parse document. So we have this name which is trying to take it from the constant default document parser and parse queue, and just trying to implement this parse function that we have. So here basically text like files like decode straight as UTF-8. So that's the is text like is what we're using, and we are trying to do this. And this is basically trying to return that text straight away, and parser metadata, file name and content type and all. And okay, and then parsing with light parse, we just now use this light parse from this llama index light parse dependencies, and then try enabling the OCR to true. So you can see here basically I'm just setting OCR enable to true, number of workers 1, and result we're just trying to parse that and get the text out of it and return a thing. And so this is the simple things that we are trying to do. So everything besides that text is text like will go through this light parse through with OCR, and this enqueue parse basically serializes calls through a promise chain, because the native OCR worker can't run in parallel. So that's the thing, we are just trying to serialize this thing, just trying to create a simple entry point to parse the documents thing and all. So once we have that, that's the thing and all. And let's add a thin exported wrapper. So this basically parse document bytes. This is the simple wrapper that I am adding, so that later if we wanted to add test suite, and ingestion pipeline can turn bytes into parse document, like without actually constructing a parser themselves and all. This can be used and all. So that's the thing. And then now help us to split oversized text and all those things. Just normally we need usually in wherever we are trying to do chunking and all those things. So here what we are like trying to split the oversized text, taking in the text and the max characters. And what we are trying to do is basically if it's a single paragraph is longer than the max characters, we are trying to break at the best like sentence or the clause boundary, like period, question, exclamation, semicolon, comma, or then the space. So you see here, this is what we are trying to do. And falling back to like hard cut if no decent break exists, like past the like halfway point. So that's what we are trying to do. And this is the just a simple splitting oversized text, the helper. And in other helper, basically we need some overlap between the chunks. So this is the thing. So it should help us to build the start of the next chunk by gluing the last overlap characters from the previous chunk, right? So that's the thing. So that context isn't lost whenever we are trying to retrieve and all. Pretty 2020 when RAG started and all those things. So that's the overlap and all that stuff. And then the actual function to chunk the text we need now. So I'm just adding here and using the above helper functions that we have just defined above. So this is a pure chunking function that delegates to two helpers that we just defined above. So some simple. First, it's trying to normalize the white space and splits on a blank line into paragraphs, and then trying to pack the paragraphs into chunks up to maximum the characters and flushing and carrying an overlap tail when the like next part won't really fit into it. And then we are just trying to give the chunks from this helper function. So that's the only the functionality of this chunk text and all. And now let's try to create the recursive text chunker, basically just trying to respect the document chunker that we have created above, just trying to implement that it has the chunk function. So this the first phase, it's a parsing. After that the chunking. So this is the second phase. You will see this clearly in our temporal UI, while I'll try to show when we have all of this connected. So this recursive text chunker, of course, trying to in the initializer setting this max characters and overlaps with the default whatever we have, and just doing pre-check overlap characters cannot be greater than max characters, and chunking here just wrapper around the chunk text function that we have just defined, and then trying to convert into the way that we want. So this is the simple document slide parser and then recursive the text chunker that we need to lay a foundation for our documents related feature and all that stuff. Yeah, hope at least I think these are the basics pretty things and all, because these days all file systems, agentic memory and all this agentic hardness and multi agents
delegations to sub agents and all. That's what like skills and all that stuff, heavy stuff is something adopted, not this racks and all those things. Fine. And okay, so now we have the chunks. The next phase is it's something to do with embedding, right? So now we need the helpers and functions related to that. So let's try to add again. So here itself in the stuff, few helpers again before we try to lay out the actual core embedders and all. Validate embedding. So this simple, trying to take values, dimension and model, and if values length is not equals to dimensions, we know that it return the dimensions other than what I expected, and just the pure before guard. So that we are trying to reject the vectors with wrong dimension count or non-finite values, because it doesn't really work whenever we are trying to query or store later. So that's the thing. And now let's try to implement the OpenAI embedding provider, trying to respect our document embedder type that we have defined above. And let's try to close this. Okay, first I know because it's throwing error because we need to implement the other things that we have, which I will. So here just trying to we respect the document embedder. So the piece that vectorizes chunk text into embeddings in the index pipeline. So here the simple will need client OpenAI API key base URL, and constructor just trying to set all of this API key base URL, default headers, default query, model and dimensions, and that's what we're just trying to set these things. And then we need models, dimensions and default headers and all those things as a baseline to get started with. And now let's try to add the first function, trying to embed many at once. So this is the thing. And okay, fine. So here embed many, what it does is the core call that index pipeline will use to vectorize every chunk. So basically it batches the inputs 64 at a time per request. That's the maximum OpenAI's array limit. You can check its API docs and all, and runs every returned vector through the validate embedding, so that malformed response, if something failed for the API call that we are trying to get the embeddings, it will fail fast, like instead of corrupting our whole index and all. That's the thing. That's the simple embed many. And don't worry about this OpenAI. I'll just add this private function, just validating the API key and all, helping us constructing the client using the OpenAI dependency that we just added. And then embed query function. So here simple, this is the single text path used usually at our search time. So whatever user asks, it should be converted to embedding and then queried against our index and all those things. So it just trying to reuse the embed many and passing in the list of the one text and return that embedding for that query. Okay, fine. And then the initialization for our the OpenAI thing. So this is the thing. So just trying to check, making sure we have an API key, and then once we have that, constructing the client of OpenAI, and then just trying to return, and then this will be used now. Yeah, this is the simple, at least OpenAI embedding provider implementing this document embedder and all. And now let's try to have one helper which is going to help us configure the documents, OpenAI embedding stuff. So this is basically simple thing. We'll try to construct OpenAI connection config from settings with specific checks here. 3 branches usually we should see here. Yep. So here basically explicit document overrides here, and then Azure OpenAI API version, then this
query param and AD token bearer header, and then this plain OpenAI stuff. So the factory basically can build an OpenAI embedding provider without knowing the provider flavor in itself, like just trying to act this as a factory. Okay, so that's the intention. And now mostly we are there, and if we don't want to use any API key and not rely on the OpenAI embeddings and all, let's try to see if we can implement deterministic embedding provider. And for that, this is the first deterministic embedding. So this is just the pure FNV1A hash, basically, that powers the deterministic provider. What it does is basically it is just trying to tokenize on the unique code word boundaries and bumps one slot per token, and then trying to normalize this to one unit length, so cosine similarity stays well defined and tests can assert it independently. So this is what we'll try to use in our deterministic embedding provider and all. So you will see this now. So let's try to create this implementation. So simple. This is the just the simple strategy pattern factory that bundles. So this is a simple offline embedder used just to for our testing only. Okay, nothing much. That's the only reason. Ideally I'll use the OpenAI embeddings, but this is just, let's say, because we are not testing it as we keep developing, so we can just try to use it in our test suits, because code will be generated using the models that we are normally using on day-to-day basis. So this same document embedder interface that we're trying to respect, but instead it is just trying to delegate it to pure deterministic embedding, as so it needs no API key and network, or always returns the same vector for the same input. That's an idea. Given A, it's always going to give the same embedding. Given B, it's always going to give me B, so that it will be easier for me to test the functionality and all. Okay, and yeah, mostly we are done. And now only one thing, like I said, I need one factory for creating a document services. And here is the thing. So just bundling parser plus chunker plus embedder into document services, because these are all the three things that document services need. So that's what we are doing. So OpenAI, so parser, chunker and embedder, so that now it's like complete three phases pipeline: parsing first, chunking second, and embedding thing. That's the thing that will try to tie it up in our indexing workflow, which will be temporal workflow and all those things. So now we're almost there, trying to lay the foundation and all. And so getting there, and now we need to all wire it up in this index pipeline stuff. So let's try to add here it below itself. Here let me try to add index document now, the function, and let's try to close this thing. Okay, so yeah, so this basically, this is the pipeline's entry point. The temporal worker basically usually tries to call the index document now to index a document like end to end. Okay, and the old function like orchestrates like basically the parser to chunker, chunker to embedder, and embedder to db insert of like document chunks and all that stuff. So that's the thing we're trying to see. So first we are trying to get the document, given this document id in input, and if you don't have document, we just straight away throw it error. And after that, making sure that the file that we're trying to index, it's there, and then trying to update the status of documents to indexing, and that's the first step. Okay, as a thing. And now let's try to add bits and pieces as we try to go into the core stuff here. And here, first thing what we're trying to do, we're now trying to fetch the bytes from the object storage, which is our S3 compatible or AWS or GCP, whatever we are using. and then parse it, passing it to our parse function that we have, and then get the chunks out of that parsed file. And once we have the chunks, we are just trying to call the embedder embed many and get the embeddings, and we are trying to do a check, making sure that embeddings length is matching to the chunks length that we have, and we have not missed anything. And once we have, then we need to do atomic write into our DB tables. That's very important, so we need to wrap that inside our transaction. So here this transaction, all we are trying to do is basically first do deleting old chunks, like clean reindexing also supported stuff. And if chunks length is greater than 0, we're trying to do the bulk insert all the validated new chunk rows. And then once we do bulk insert, we're trying to mark the document ready with a new chunk count, all in one transaction, so we never get off index documents. That's the proper taking care, trying to do in the complete transaction. And that's the old sequence. And if we have any error and all, we'll try to handle now. So in this catch block, so here what we should do, basically we should need to update that status of the document as a failed, and then try to return that. And finally here we are just trying to reread the document on success and return that updated documents thing. So this is the proper wiring of all the phases that we have just defined above, and this is what ideally will be called by our temporal worker. Okay, that's the thing that we have. And yep. And so for indexing and all, and similarly now anyhow we are here of indexing. And now what if I wanted to, like, indexing is done, file is index, and we have it in our system. We need to now query for our document. Then that's the helper functions that we need to query that specific document thing. So let's like trying to like have search documents or search document or something like that. So let's try to add that piece also. Then we should be completely done what and all we need from the documents package, and then focus on using all of this what we are trying to use. So again, for this also I need some helper to basically serialize the number to pgvectors format and literal string, so which the basically raw SQL will try to cast with double colon vector. So because we know that pgvector won't accept a JS array as a bind parameter inside the expression. So that's the simple helper that we need. And now let's try to create a function which will help us to search the documents. So here let's try to add bits and pieces at a time here. So simple takes in the input query base IDs and limit. These are all optional, so the queries mandate. And services embedder create document services is something we'll try to inject dependency that we need. And the idea is simple. We are trying to just embed the query into the same vector space as the stored chunks, that is 3072 dimension. And then we are trying to build the PG vector cosine distance expression. And so that's the thing we are trying to do it here. And now once we have that, and we are just trying to query the document chunks table and trying to join with our documents, and then trying to check filtering by status ready, and then the embedding model and all those things. And if you have this optional input base IDs, try to filter and search on those base IDs itself and all, only scoping to that document search and all, instead of doing complete document search. That's the thing. And after we have all of these things, so we just need to get those rows and then return from this function. So that's the thing. Simple, straightforward stuff, nothing complicated in here. Searching documents and all, fine. And that's the basically searching the documents. And let's say if I wanted to get a specific document chunk. So that also I can just add in the simple helper. So this is the thing. So basically it just fetches the single chunk by id, same ready join whatever we had in the document chunk, and here, and we are just limiting it to 1 and returns it as like basically document search result with a fixed score of 1. So used basically when an agent wants to retrieve a specific chunk it found earlier. That's this helper just trying to add and all. And now basically all the things that we need in the documents part we have it covered. And now this basically we need to create a document indexing workflow and the activities and all those things, so that now we can try to tie up through APIs for the temporal engine and then try to consume in the UI. So now let's try to make this document indexing as the durable background job by wiring it to our temporal as a worker activity and workflow. So for that, let's go to our worker app that we have. So let's collapse all of this, and here first thing let's try to add this documents dependency that we have, and also let's try to just run one install so that the package would. Now let's try to again collapse this terminal, and let's try to add in the activity types for in the first place. So in here all we need to do is basically try to inject this document services into our activities thing. So here I'm just basically document services, and we need to just import from our groundwork documents and all. And then the activity input contract is something we need to define here. So I'm just going to add in here index document input. All we need to do is pass the document id in, and one document that's the thing. And now let's try to create a new file for the activities. So here I'm just creating it as documents.ts. okay. And in here basically the types that we just created, let's try to import it, and also the main function to index document now from our package thing. These are the core things that we need, and all we need is basically an activity called create document activities. So here we're just trying to inject return this index document, and trying to get that dependencies that we need from our services, db, object storage, and document service. These are the things that we need, and all these things needs to be passed to our index document. Now that's the core logic where we are trying to process the document and all. So and now once we have this, so let's go to our activities.ts, and inside this let's basically now import our create documents service and create document in thing which we just created. So I'm just going to here we can just add that and then clear this dependency. Okay, fine. So just trying to import this, and once we have, and now I need to add in here this initialization. So document service, so we need to attach in dependencies dot document services. If it don't have, we need to create this document services and pass in the settings. So that is the thing. And now along with this creating session related activities, we need to return create a document activities, so that now we will have this activities also present. And after that I need to initialize, export this index document, default activities dot index document and all. Okay, and then like we have now. Once we are done, so let's go to our workflows activity.ts file, and here let's try to create a document activity. So I'm just going to add it here, this index document activity, and add in start to close timeout 30 minutes and retry items max 1. So dedicated activity proxy, that basically big PDFs take a while to embed, right? So that's the thing. And a single attempt retries are handled at the workflow layer, so not here. So that's why I'm just trying to here. And now in the workflows, I need to create a new workflow for document indexing. So document index.ts, and here let's try to, we need document activity which we just created, so let's try to import that, and also the input that we need for our document index workflow. And here the workflow, basically it's going to be simple wrapper around our index document thing. So it just invokes the activity through the proxy, leaving durability and history to temporal. Okay, and just let's try to now in this workflow.ts what we have, let's just try to export this, so that we can directly use this thing in our API app and all. So that's the thing, just the gluing on trying to create new document index and activities, and trying to wire up the document dependencies, injections and all, so that activities and that they rely on, they can cleanly use it. So now we have this wired up, and now it's basically we need to use this all inside our API app, and try to create routes for our documents, base routes, rack search, and then MCP server and all those things. So let's try to first we in the contracts we need to update a bit, basically for our search request, something we have not added. So let's add what and all we missed, and here I'll just try to update here, and then we'll go back to our API. So first thing, simple thing, that just the search request will send in the query and the limit how many docs that we need as written, and this is the just a simple search request that should be self thing. And now let's go to our API app, and first thing is basically here the dependencies. Here basically now we need to import our and before that, let's go to this package.json, and here add in our documents thing, and also we need to add model context SDK dependency as well. Along with that, I'll just add the jod also, so I would need that. So here let's add in, and then this jod also I'm just going to add as a dependency for our API package, and then we'll try to install all of this, and then continue on our addition. Okay, so here let's open this terminal that we have, and let's try to run this burn install, and yeah, okay, fine, they are installed. So now let's open this dependencies. So inside this, first let's import our document type and document services from our that package, the documents, and from the contracts. Okay, and then I need for a document index client a thin abstraction. So here I'm just trying to create, so this is basically index document, and takes in the input document ID and returns this document that we have. And now we need to make this both injectable on app and dependencies. So here I need to add in the document indexer, which is document index client, which is the thin wrapper that I just created, and documents services which we imported from the package. Okay, so that's the first step, so that they are resolved by create app. So route handlers always receive concrete values and all those things. All right, so now let's start on the source folder. Let me just start with the MCP, and here for the documents stuff, documents.ts inside this. So here we'll try to I think building an MCP should be, this is pretty common. So anyhow, let's try to walk. So here just trying to, these are just the wrappers around the query store, DB layer, or any other storage layer that we have, and all those things. So trying to get this basic document related CRUD queries that we have, getting document chunk, listing those bases, search documents, document services, and then MCP server from our model context protocol SDK and all. So first thing, we're trying to build this documents MCP server. So the dependencies that we need is basically database and document services, and we're just trying to return MCP server. So we'll try to complete bits and pieces and try to finish it as a whole. So first, trying to initialize the MCP server and naming it as Groundwork documents and version as 1, and the first tool. So once we have that server, let's try to add in this first tool, and of course let me just close this thing. Okay, so first trying to register tool listing document bases, and it's just trying to call this and stringify this document bases call that we have. So let's collapse it's here. That's the first tool, and then the tool to do rack search stuff, and here again I'm just calling this search documents and input schema query base IDs limit, and then we are just trying to get those pass those input params to our things, and then trying to return in the format by stringifying those results whatever we get. That's the thing. And then the third tool basically to fetch the basically single chunk by ID. So here that's this thing, fetch document chunk. It needs chunk ID and get that document chunk, and then we are just trying to return that stuff. And then finally I'm just going to return the server. So for time being I'm just listing down these 3 tools as part of this our document MCP server that we are going to have. And now let's try to add in these routes inside this thing for our documents. So documents.ts stuff, and inside as usual let's try to import all the dependencies that we need first. All the types in contracts and documents, pretty CRUD queries wrappers, and then from this MCP context protocol we need this web standard streamable HTTP server transport. You will understand this, and basic and API route dependencies, and document parser we just created, and course. Okay, and let's try to create the helpers that we need for example HTTP exceptions and all those things. So this is the simple maps this documents package error messages to HTTP status codes, like 404 for not found, 422 for invalid state, 500 otherwise, and just so that every handler that we are going to create now will just try to use this document HTTP exception that we have. Okay, all right, so let's try to create a function to register document routes. Okay, so here let's first what and all the things that we need from these dependencies, we are just trying to get them, and once we have, let's try to add all the basic CRUD routes. I'm just going to add it straight away. So for getting the creating the document bases, just try to parse that and pass on that payload to create document base, and same thing for now listing here, and then trying to get that document base, and that's the pretty standard document base schemas that we have. And then trying to register the documents into the base endpoints. So these are those endpoints here, adding the document to base, and just pretty standard thing, and then trying to listing the documents thing of that base ID and all. Okay, fine. And then the endpoint to reindex stuff. So this is the endpoint to reindex. Don't worry about this, we'll figure out. I just need to add that API dependencies. So this basically only failed documents can be reindexed. That is the thing. Get document, and if it's not failed, we'll just throw 422. If it's failed, we'll just trying to index them again. So that's this reindex endpoint. And now for basic the endpoints to do the RAG search and then the MCP docs exposure. So here base ID search, just calling our document base and making sure that exists, and then calling search documents function that we have and returning that queries results. And here MCP docs, so trying to establish the transport, and now pass in this server build documents MCP server, the DB and document services that it needs, and then we're trying to connect this transport and then handle this request. So all this request will just try to so just we are trying to mount the fresh MCP server per request this over this stream bullet HTTP transport, and that's the thing. And yeah, that's the base we are trying to create the routes for our document stuff. And now in the in this app.ts, so I just need to import and export a few things. So first let's yeah, from documents we need these things, and then from routes we just need to register that. And I'm just trying to export this session workflow client and document index client from dependencies, so that we can directly import and use it in our web app, and we'll see that in a bit. So inside this basically okay, so in here in app dependencies, let's try to now basically add in the document services variable first, and try to basically we're trying to build document services and first use and provide a default document indexer that indexes inline and those things. So trying to get the document services and call this the create document services we have from this documents package, and returning that. And now this document indexer, if we don't have a document indexer in the dependencies, we have this index document now function from this indexer. And this thing basically now we should try to like add it here in the route dependencies, get document services, and yeah, okay, fine. And of course I need to update this dependencies thing, so that we don't get any that issue. So here, yep, so just going back now. So, and also app dependencies, we already updated that and those things. And now going back here, so we should see no issue. And also now in documents route you should not see any issues and all, because now we have this added into this API route dependencies and all. And once that is done, so let's try to register our document route. So basically all the way here, yep, so pass in this app and route dependencies, and now the document routes will be registered. And inside this pattern routes, now we need to try to handle this spacings and all those things. And here, so yeah, document bases and documents and search, and then the getting document base and reindexing all those endpoints. And yep, and finally let's open this index.ts, and uh, in here let's first import the dependencies, which is the document index client that we need from this. And now whenever you're trying to create this temporal workflow client and returning this, I need to now also return this document indexer. Okay, and after that I just need to add so yep. Alright, now in this client we need to wire up this document indexer. Yeah, let's try to collapse this signal user message. So basically I need to after this let's try to create a document indexer which is trying to start our index document workflow, and that thing now I just need to return from this thing. Okay, so this is the production indexer. So basically this is what will help us to start the document index workflow on a temporal task queue, with a unique workflow id and delegating this durability to temporal and all. Okay, fine. And yep, and now basically in our start api, while we are trying to create an app, here I need to attach in this document indexer, because this create app needs that now, the document indexer. So now on the API side, worker side and packages side, what and all we need, it's all wired up. And now let's try to add types in web and try to hook it up. Let's see. Okay, so here let's open the types that we have, and inside this just basic the document base and index document and document search result that we have. So I just need to add these things so that we can use it in our API calls. So just the client side mirrors of whatever we have in our Jot schemas and that API expects and all. So this is the types that we are trying to add. And now open this API .ts, and basically now let's try to import this thing, these three types which we just defined. And I need to now basically create a function, functions to help us talk to those document related routes. So I can just add in those routes here. So let's add it here, the creating document base, calling the document base as endpoint, post request and sending this input, naming description, fetching this documents, it's going to give us document base array, and the same fetching the documents, and it's going to give us this. And the same thing the other endpoints that we have, let's quickly try to add a callers to those endpoints, adding a document to base, so to this endpoint, and re-indexing a document and searching documents base and all. Okay, these are the endpoints. Now we have calls to our endpoint, documents endpoint, and now let's try to see if we can wire up this document stuff. Okay, so now let's try to import all things that I need in here. So let's add basically all API calls that we just added, and then few icons, and then you'll see this stuff and all. Okay, and this document search tool toggle, this is going to be simple button, so I just need to add that wrapper now. So let's extend this. Okay, so this basically that basically toggles the document search tool on and off, like we have for our Groundwork or MCP tool, like that. Okay, so fine, that's the thing. This addition is about that we have. So let's try to and now this document use document search, basically it should be wrapper around this component that we have. So let's try to update this one. So basically the result enabled toggle and toggle node, so I just moved it to the separate type instead of adding it here, and this is what we're trying to return, and just local state whether its search is enabled or not, and the toggle to turn it on or off, and then we are just trying to return that enable toggle and toggle node, which is this component document search toggle, and that's the thing. And yep, and once we have and let's try to add a few helpers that we need. Just for example, the status dot, just if it's ready it's going to be green color, if it's failed red color, and queued or indexing yellow color, and all those things. Okay, that's the stuff. And now the documents workspace, let's try to add the pieces at a time, what and all we need in this workspace. So here let's try to see the okay, first straight things, what and all we need: bases, selected base id, documents, results, and all this we'll try to see. So the intent is basically it tries to load bases on mount. We'll create this refresh bases function at the end, I'll just add, and then reload documents when the selected base changes, and we are just trying to poll the every maybe a second or so, like here 1200 milliseconds, while any document is queued or indexing. So status dots updates live and all. So that's the thing, this mounting we are trying to do, and other local state variables and all, those should be things. And now let's try to add all the queries we need, like for example refreshing bases and all the things that I was calling. So refreshing bases, just making our query calls, setting this bases local state variables, updating that, and this handling create base, which we will try to tie it up in our UI stuff just in a while. And same thing, handling files, trying to upload file asset, trying to add document to base, and all those things. So these are just mutations: refresh, auto select bases, create a base, and upload then index each chosen file, preparing that resulting document to the list. That's what that's the thing. And then other functions also, let me just try to add handling search and all those things. So now here yeah, this basically search plus like retry handlers, and this is handling just search thing, and retry document like tracks per id spinner state via this set that we have, and the wrappers basically retrying the document, like just adding a toast and a bulk retry all or failed documents and all. So those are just the functions that we have. And the UI part now, so let's try to add Okay, so here this pretty standard uh, title like workspace header, like we have this title, description, and then the a new base input plus, like, create document button that we are trying to add. And then let's try to add the left column. So left column, basically I wanted to add in so this the 3-column grid container, basically that we wanted to add. So the basis and the basis length that we wanted to have, and after that if base length is 0, and trying to showcase the text like create a document base to start, and if not, we're trying to showcase the bases that we have, and here that name of that, and the icon, whether we have selected that or not. So that's the thing per base. And then that was like left column, and this middle column, let's try to add so inside this now basically let's do one thing. I'll just add all the UI stuff that I need at once, and then maybe just walk you through what each part does, or else it's just confusing because the syntax and all that stuff. Okay, so what I'm going to do, let's just collapse this section part, just remove all of that stuff. Okay, and let's open this bracket. This is all auto generated, so let's just get rid of this. Okay, at least now it should be sorted out, but let's have a look. Yeah, still see an issue. Let's try to fix it. Just a minute, I'm just trying to. Okay, let's do one thing. So I'm just yep, fine. So it's all sorted out now, so let's try to walk you through. Yeah, so the first left side part is done, and here the middle column here basically for the selected base, whatever we have. And here we're just trying to showcase the files count summary plus the hidden file input, and then the upload the trigger, and then retry failed button. So that's what this the middle column does. And after that this the documents list. So here basically what we are trying to show is each row's title, then the status or chunk or parser, and error if it has failed, and all those things, and the status dot, and then per row retry button that we're trying to add. That's the thing, documents list stuff. And now this right the column here, the search input or button, and then the result cards. So this is the search input, and then the result cards with the title and the percentage this snippet that we have, and that's what we are trying to showcase. That's the overall the documents workspace that we are trying to add in. And now basically if we try to see the UI, we should see it's wide up. So let's try to run this thing. Mostly it should work, and let's see in UI and all that stuff. So let's wait for this containers to create them or recreate, start all of those, and then all we need then let's wait for migration to complete, API to start. Okay, and yeah, the UI is up. Let's try to view that. So this is the UI. Okay, the documents, if I try to view now, so now you see the 3 columns layout, like I said. So here this first, the second thing, and third stuff, and we don't have any thing now. So let's say test base 1 or something like that, and we have created now base, and we can just try to select some files. I don't know if I have any PDF. I'm not sure which PDF to attach or so. Okay, let's see this. Okay, we have an issue. Let's see, what is it? Okay, looks like let's see here. Okay, the error is in the input format, expected string, but received undefined. Okay, let's I think this thing, let's double check, and then we should be good to test. Mostly something to do with the job schema that we define in contracts. So let's try to see. So create file, upload request. Okay, this let's try to change this one to be an optional, and let's see. Okay, API has started, and I'm just trying to upload. Let's see. Okay, let's try to upload some vague document. I don't have anything in mind, so whatever the PDF, maybe let's take. Okay, I'll just take in. Okay, it's now 404 not found. The JORD validation one fixed, but now it's saying 404 not found. Mostly the endpoint should be post, because in UI we are calling it as post not put. Let's see. Okay, Groundwork API server started. Let's see at least if this works now. Okay, so uploading some PDF sample. I have some random PDF. Now this internal server, at least something different. Okay, let's see what is the error. Okay, it's just in logic and all. Let's fix this. So let's try to see 830 line. Okay, I think we are trying to check for wrong ID. mm, okay, let's collapse this. Okay, in here, get file upload, and yeah, I think here it should be upload.id instead of file.id. Yeah, mostly this should be the fix. Okay, I'm hoping that's thing that we messed up, but let's see. Okay, and let's try to clear everything, and here as well let's try to upload. Yeah, document, it's indexing now. Mostly if I see this, yeah, you see this temporal workflow, it's indexing. I think it's completed. Yeah, it has indexed, and let's try to close this, and this is what it's selected. And let's see, I'm just trying to ask the result. Okay, yeah, this is what we got. And yeah, okay, now at least indexing pipeline is working. And here we have this index document stuff, and it's receiving input as this, and result it's giving me id, base id, status, title, parser, how many chunks it has, and error, it's null. And then trying to run this. So basically this is the simple rag. And all right, now let's try to lay a foundation for our GitHub app, so that at least we can connect to GitHub app and then list down our repositories and select the one that we wanted to work on it and all those things. So for that, let's try to add the schemas that we need in our contracts package. So let's just open in here, and inside this I'm just collapsing. Let's just close this, and also let's try to minimize this terminal. Okay, fine. And we need kind of like shared GitHub repository, kind of the one which will help us to flow API to front end for every listed repository and all. So which is it's going to be having installation ID, full name, the name of it, is it private, HTML URL, clone URL, default branch, and account login, and account type, and all that type, and then exporting that type. And then the schema to create the GitHub manifest. So basically how do we create a manifest and what and all it needs. So the app name, organization, public, and include CI permissions, and this is the way. So here we'll try to help them to create a manifest and give it exactly the way it needs to be added, and that's this schema is all about. So these are the like couple of the schemas that we need. And now let's try to add this new package called GitHub. So I'm just naming that as a GitHub, and as usual let's try to add this package.json and tsconfig.json, and also the source folder, and inside that the index.ts. okay, so inside this pretty much simple. So let's try to add this first the package.json and the tsconfig. So it will have the same thing, and config and contracts, and we need for JWT we need this OSI dependency, and tsconfig we need to just extend the base one like we normally do for all the packages. So let's add it here. Yep, so this is the thing, and let's just try to run the one install command. So, okay, fine. And I'm just opening this index.ts. So let's collapse this sidebar, and here let's try to add what and all I need basically. So let's just add the imports that we need. So settings from config and GitHub repository, the from contracts which we just added, and just to create the signed keys and all those things we need from OSE, the signed JWT, and import pkcs8 and all those things. Fine. And then now few constant variables to basically hold the GitHub API's REST base URL, and the API version, like that will be sent on every call, and then the this PM header constants, like used to detect whether the key is already pkcs8 or pkcs1. So that's this helper. And now just the two types of error classes. Just we wanted to extend the base error class thing, GitHub app configuration error. So just so they can be mapped to write HTTP status codes. So this is missing env like 409, and this GitHub API error like GitHub is unreachable, something like 502 or something. So just to map it over HTTP code, and then just helper to convert into our int. So just the very strict defensive integer parser for GitHub loosely typed IDs, like accepting either real integer or a numeric string. So that's this helper. And yeah, and now let's try to create a function for our GitHub error message, so that I can use now in all of our API calls. It just tries to extract human readable error from this failed GitHub response, and trying to preferring it this one to JSON message field, and falling back to this raw text. So that's the thing here that we're trying to do. Okay, and now the headers that we need to send for all of our API requests of GitHub. Let's try to create this as a separate function so that everyone can use it. So we pass in the token, which is the optional param, and return this headers in it, and here accept these application stuff, and token pass in the authorization, and GitHub API version pass in from the constant variables that we have. And yeah, and we expect, so basically we need to add a lot of environment variables for this GitHub app connection and all. So this function will help return the what are all the missing from the settings, so that we can configure in .env, like a kind of like single source of truth that API's status route and front end setup panel both can use, and all those things and all. Okay, so now the helper to normalize the GitHub's private key. So here the idea is like it is to convert pkcs 1 pem GitHub the one GitHub answers into pkcs 8 that like web crypto or OSE ideally needs. So, and that's the thing. So trying to get this private key, and if it's starts with this RSA private key header, then we're just trying to convert it to pkcs 8 and all. Okay, fine. And now let's try to pull in the GitHub app bot identity, so that we can use that as a committer. So just trying to get this from the GitHub app ID settings, GitHub app slug, and trying to add this slug with the bot, and this is going to be name this, and email is going to be app ID plus this login what we have, and at the rate users. So that'll what we'll be using whenever we try to make commits from the sandbox and all those things. Okay, fine. And now let's start adding the actual API endpoints consumption. First, just the helper, this kind of like shared authenticated get helper that builds the query string, sends this standard GitHub headers and converts non-OK responses into this GitHub App API error which we just added above. Okay, so that is the simple thing. And also, like, some helpers to map the GitHub repository JSON object into strict the type that we have defined, which is a GitHub repository structure. So that's this simple helper, so you can just check it out. And yep, now let's try to add the core functions. First thing is try to create a GitHub app JWT. So what it does is basically it signs the short-lived JWT thing. So IAT is basically is backdated to backdated 60 seconds to tolerate the clock skew, and this expiration time is basically plus 9 minutes to stay inside GitHub's 10-minute cap. So that's just the keys normalized to this PKCS8 because I mentioned like USA or web crypto only accept that format. So that's how we're trying to create that JWT token for the GitHub app, and that's this function. And now let's try to add in a function to create an installation token. Okay, so here what we do now, we are trying to exchange the JWT for an installation access token. So the input app JWT string from this thing, and input installation ID repository IDs. So just trying to take the scoped, and if we have that, so we are making the call to app installations and pass the installation ID access tokens, and attach in GitHub headers the JSON token it needs, and if it's a scoped, we need to attach in this application slots JSON, or else nothing. And same thing, pass in this repository ID, so that will be giving access to that only. And then if it's not okay, we're just handling this error thing and try to get this payload and return that payload token. So that's the thing. And to basically create an installation token and return that token from this function. And now let's try to add a function to list all the installations. So here this function does that. So list installations input is going to take the token. And now all we are doing is basically trying to paginate the app slash installations endpoint with the JWT. So and we get like basically 100 per page, and trying to stop whenever the short page signals this last one, and we need like installation IDs before we can list repos and all. So that's the simple call to this installations endpoint to list them. And now we need to also add the second half of pagination, which is listing an installation repository. So here this basically, now what we do, we use the scoped the installation token to walk through this installation repositories, and then we are trying to just normalize each entry into typed shape here, repository from payload, and just trying to return that thing. So I think just the wrappers around the APIs that GitHub exposes. And now this public entry point to consume above functions that we have. So this is that what we'll be trying to expose. So create GitHub app installation token. So settings, input, and now we're just doing double check like if we have settings configured or not, and then first trying to create the token, that is what needed. Create GitHub app JSON web token, and then pass that to our create installation token. So that's the thing. And same thing for our listing GitHub app repository, the public function. So I need to expose as well, just consuming about functions that we just created. Same check missing things and get the first create the JSON web token installations, list them, and repositories. Now try to iterate through these installations, and now just use our helpers to convert strict as int, and collect this account thing and token we need to create by passing in this JWT again, and then push it to our repository array by again calling this list installation repositories and passing in installation ID, token, and account. And finally we're just going to sort out this repository and return them. Okay, so yeah, just sorting by the name and then returning that. So that's the basically the core functions that we need for our GitHub App solution, and listing all of those things and all. And so now we have at least package side and the contract side sorted. So we need to expose this to our web app. So let's try to define again the types and all in our web's types.ts thing that we have. So let's collapse this API, and in here this yep. So here I'm just going to add the same schema that we have for our GitHub repository. So and now let's open the features, and here we need to now replace all of this placeholder that we have for GitHub app. Again, this is UI related stuff. I'll not walk through much the UI stuff, but I'll give you just brief walkthrough. And here this share.ts, let's add some helpers to just group repositories by installation account, so that the picker, whenever we are trying to render in UI, can render it in proper group list. So let's add here so let's add at the top. Okay, fine. And so and then the simple helper to group things. So let's just collapse nothing. It's just taking the GitHub repository array and then trying to group it by the installation ID and all, and then trying to push into each group's repository thing. And then repo count label here, and other helpers that I need. So if it's a one, I'll need to show repo. If it's a more than one, it should be repos and all. And just the normalizing the repository URL as well. So this if just trying to check, like it should be always HTTPS. If it's not, throw that error. And then returning this normalized host, and then owner repo path, like which will be used to build the resource URI and mount path and all. That's why we are just trying to be extra careful here. And yep, now we have this helpers and all. So in the API section, let's add this GitHub repository in the imports which we just added. Okay, and once we have all I just need to do is just add the endpoints to for our first let's add the endpoint to fetch the GitHub status. So this, it reads the GitHub config status, like config flag missing in variables and the install URL from the API, and we're just making this to that GitHub app and all. Okay, and then to list the installed repositories, so I just need to make a call to this v1 GitHub repositories that and then to start the manifest workflow. we need to create this post endpoint app manifest. So this post, what it does, creates the options and returns the action URL and manifest for the browser form that we need. So this and all you can just check its GitHub API docs and all. These are all the endpoints. And now let's try to add the UI stuff here. I'll just maybe add all I need at once and then just give you a rough walkthrough of it, because it's just the UI placeholder just to way for us to consume all the backend related stuff we just added. So let's just add the stuff that are all I need, and then just I'll give you a brief walkthrough. Okay, so the imports and all, I think just the some drop down components collapsible, and the from API whatever we just added, and shared helpers and the types and all. Okay, fine. And this the helper function to build the resources, taking in this manual repos and just the raw that we have, mount paths, and then it's just trying to return in the format that we need, the resource format, the kind repository URI, and just for tool the references that we have, that is this helper. And that's what this build resources, it just turns the selected installed repos plus manual URLs into this resource ref array format, just trying to deduplicate this mount paths and like attaching GitHub repository ID, installation ID, and exactly the IDs the worker reads the next commit to scope a token and all those things. Okay, so that's the build resources thing. And now this submit GitHub manifest is basically it helps us to build and submit the hidden HTML form. So we are trying to HTML form that posts the manifest JSON straight to the GitHub's settings apps slash new endpoint. So that's the just this helper to just our workaround. Okay, and runs in the browser directly. And now this and fine. And now basically this types use GitHub result and all those things to for our as a props to return from this use GitHub hook that is will be trying to make a call to the just a function to refresh GitHub, and the start GitHub app manifest flow, and then just trying to select that specific GitHub repository and update that selected repositories, and adding manually a repository and trying to use that above helpers like build resources. And we have here the repository context picker. This is basically the presentational pickers full prop contract, like all state callbacks that comes from the hook plus the derived selection counts like used to label the trigger and all those things. So this we have configured install URL, repositories, groups, repos IDs, and reference and manual repos, app open, on all these things. I think you can just check in this the picker and that we have, and from this hook that's what we will be trying to return picker resources and all those things. And so this actual this is the component repository context picker and all. And I'll just not I think you just go through this. It's in the commit that I'll be attaching. It's just the simple jargon. And first the drop down this is the drop down trigger button. So what it does, it shows the selected repo count and like a status dot, whether it's configured or needs setup. So the composer surfaces GitHub state at a glance. So that is this thing, this drop down button that we have. And then this drop down menu content that we have. So it's a panel that the drop downs panel header, a title with the selection summary, and we have this refresh button. So it is basically disabled until configured, and that refetches the repository list. So that is this header. And after this we are going to have the scroll area. Basically we'll try to add in here 3 sections. First is basically the collapsible GitHub apps sections thing. Just trying to show ready or setup batch, like depending upon whether it's configured or not. So here GitHub app, and if it's configured we just showcase that, and it's a ready or setup is needed and all those things. And yeah, so that's this simple thing. And then the collapsible content, the extended setup body. So here we'll have this optional the organization input, and then the install link, and then the create app button that kicks off the actual manifest flow. That's the thing. And now the other section is the install repository section, just trying to show the available count or not configured things and all. And here we have now if it's not configured, we're just trying to show that it's not configured. And if the repo is busy, just trying to showcase the loading symbol and all those things. And if the repository's length is 0, we'll say that no repository is found, and try to install the app on repository, then refresh and all those things. Okay, so here now these groups, what this does is basically the populated branch opens, and we are trying to group repos by installation account with par account header. And that is what, like, trying to showcase this label repositories count. And yeah, now here each repository row, this is what we are trying to loop through this list. And we'll have this here, the checkbox toggle with the lock icon for private icon repos, and a default branch hint that we are just trying to show. And then other app or selected batch that visually basically enforces that single installation rule and all those things. So yeah, and here we have this the checked thing. So when repo is selected, we try to reveal a per repo reference input, so defaulting to that repo's default branch, so the user can just pin a branch or tag, then close the group list and section. So that's this thing we have. And pretty much the standard stuff. And here the other now manual repositories collapsible header with an add URL. So if you want to add manually the public GitHub repository or something like that, so that's this thing. So just trying to have this adding manual repositories and the button to add a URL, and this collapsible content. Basically each manual repo, what it now gets is a URL field, a branch or reference field, and remove button, just wired to the hooks or manual handlers that will do this. And this branch, and then the button to remove and all those things. Yeah, so that's the UI of this stuff. And we can actually see this, and I know I just walked you very roughly and vaguely, but that's the intent as well. So you can just double check in the commit. But let's see if this GitHub's app, now you see, this is what I mean. Yes, Now we didn't had this GitHub repos before. Now we have this, and this the UI repository context. This is the refresh app I was talking about, refresh GitHub, and this is the GitHub app to set up. So log in and all those things, and once we log in, do the setup, the manifest creation and all those things, we'll see the installed repositories and all, and the other collapsible section, the manual repositories. So we added this button, add URL. So this, like I said, it will have this input URL intake and the branch this selection and the option to delete and all. So this is just the UI side. And we need to add these env and all, but I'm just trying to showcase how it looks on the UI side. And now we need to add env variables and try to do this app manifest builder, and then sign the csrf state and pk cs8 key normalization, all the stuffs that we just need to establish the connection to our GitHub, and then we can load repositories. So now we need to add a way which can be way easier and quicker for users if we add one-click GitHub app setup flow, instead of the going to the add settings and then trying to get all the env variables that we need and all those things. So if we can help build the app manifest and securing the handshake with signed time-bounded CRSF state, so it gives provide by default we open pop-up and try to give some all env, and they can just copy paste into this .env of our for repository and all. So let's try to add that thing in our this package GitHub thing. So inside this let's okay, so these are the first. Let's add the constant just to add the 1 hour bound that will be trying to apply to our signed CSRF state. So I'll just add in here so basically that's like strict check so that an abandoned manifest flow can't be like replayed indefinitely and all. And now just a few helpers I'll just try to add. So and let's go all the way to the bottom. Okay, and here just the hmac sha256 signer for the state payload, and then this timing safe string comparison, just that is used to verify it and all those things. So all right, and now let's create the create signed state function. So this basically what it does, it mints the CSRF state and a random the nouns plus issued at and base URL encoded and appended with its hmac signature. So that's the thing. And now we need to have a function which can help us to verify the state on callback. And here, so this is this function. So what we're doing is basically a constant time signature check. So first trying to get this encoded and signature, and then sign state payload, and if it's not equal just return false, and then we are just trying to get that payload, parse that thing, and bound age window and all those things. So we're just trying to verify and all if it's properly valid details or not. And then the some helpers to detect if it's a HTTPS host or not. So this is just the thing, I mean rejecting local host and private IP ranges, so to decide whether the manifest should register webhooks or not. So that's the thing. And now the actual building the app manifest function. So let me just try to add it here. So yep, so this what it does basically, it helps us to first takes an app name base URL public and includes a permissions. Basically that's what the format it is. And here this JSON, so first the base permissions and events So permissions, metadata read, contents write, pull request write, and events, pull request and the push. So and then the optional CI permissions, so trying to construct this permission actions, read or write on the events, check run and workflow run. And after that we're just trying to construct this things for the manifest: name, URL, redirect URL, public, and request auto install and default permissions, and the redirect URI that we have, and then for only for HTTPS host, webhook attributes and all those things, and return this manifest. So that's the thing. And now this personal the app manifest URL. So this is where we need to actually go to this new and state. So basically that creates a personal app from this manifest carrying the signed state and all. And the same way, like, let's try to add for the organization. So github.com organizations and encode URI component organization settings app new. This is the thing. So for an organization, like URL encoding the organization login and all. And yep. And now let's try to create a function which will convert GitHub app manifest. So this redeems the one-time manifest code for the new app's credentials via this endpoint app manifest code conversions, and that's the thing. And we're just trying to get that stuff. And now render the credentials returned by the GitHub as .env lines, so that we can provide an option for the user to just straight away copy and paste into .env. So from this GitHub manifest conversion, trying to get that payload private key and payload ID and all those things, and trying to provide in this format and showcase it in UI. So that is the simple functions that we're trying to set up, at least for the to get the like app manifest builder automatically for us, and signing that CSR of state and this normalization and all those things. And now let's try to add the app manifest API routes and repo connect, and let's see in the UI stuff. So going to our route section in our API thing. So let me just open, and in here let's create let's collapse this thing, API stuff, and in here let's add in this github.ts. That's the thing. And now we need to actually add this stuff, and before even going to this the dependencies section, let's try to add the and app dependencies, the GitHub state secret, and so, and also the API routes dependencies. I'm just going to add this. We will need to set up that GitHub token. You need to get it from the settings developer stuff and the GitHub thing. You should be able to get that, just the developer token thing. And here now in the GitHub .ts, the actual route. So let's try to add the imports that and all we need here, just and of course I need to add this package thing. So let's add this thing, and also let's try to install this package so that we can use it and we should not see any issues. So let's open this thing, and let's collapse this sidebar. And now just trying to get that all helpers that we created in the GitHub package and contracts, and now the API endpoints and all that stuff. and just the few helpers I'll just try to add to escape HTML stuff and all. Just trying to characters, so the credential values and install URL can't really break out of the page markup and all those things, trying to handle. And then the important thing, GitHub sessions HTML, I'm just going to add it here. So this basically what this does, it renders a fully self-contained success page, like no external assets, with a pre of env values and the robust copy to clipboard button with the executive command fallback for non-secure context, and then the optional install link. So that's what I'm just trying to render it in the server side itself. You'll see in the UI and all, so I'm not going to show this here. And now let's try to add these routes registration. So let's here registering GitHub routes. So first is basically GitHub app endpoint. I know in our UI I just added way before adding it here, but that's fine because anyhow we have not tested it. So it returns this configured flag plus app metadata, and install URL, and then front end uses this to decide between the setup panel and the repo list and all. So that's this endpoint, and then the endpoint to list the repositories. So let's add this endpoint. So basically this simple, I think, calling this list GitHub app repositories that we have, and just trying to return them and handling the exceptions 409 and 502, or those things like recoverable and unreachable and all those things. And to sync repositories we need an endpoint. So here is the thing, trying to again call this list GitHub repositories, same thing that we have, and then to create a manifest. So this is the endpoint. So basically first trying to parse whatever the manifest, the payload that we are receiving, and create a signed state, and help build the GitHub manifest using the just helper we just created, and try to return that action URL if it's an organization or personal thing, and return that. So yeah, that's the thing. So for the browser it can directly post to GitHub. That's what we're doing. And then the callback to handle that manifest once we make that post request manifest thing. So here basically what this does, it tries to get the code and the state, and once we have those things, it tries to, that's what redeems that one-time code for credentials, formats them as like env lines, and tries to render that success page which we have just added that HTML and GitHub success HTML, and render it in the UI. So that's the thing. And these are the core the endpoints that we need as part of this GitHub app feature and all. And now in this main thing, so in this now we need to import this register GitHub repositories, and now we need to call this function. And also in the route dependencies, here I need to add in this GitHub state secret. So let's try to add, that's why we are seeing an error here. So basically the GitHub state secret will just try to randomly generate that, and after that let's try to register the routes. So here I'm just calling register GitHub app routes, and we need to add these endpoints in our patterns. So let's try to add them. Here I'll just add at the bottom. Yep. So those just the endpoints, GitHub app repositories, syncing an app manifest, and they call back for the app manifest and all those things. Yeah, pretty much this is the like trying to now we should be able to try to test it from UI, and let's see if we're able to get the create manifest and get the env variables and all those things now. So the app is already running, so let's open the browser, and let me just try to refresh this, and here the setup that we have, I'm not optional org login, no, so it's just a personal thing. So let's try to call this. Okay, because I'm not logged in here. Let's see our terminal. All right, let's see if we can set up this thing. So creating an app, I'll not add in the organization thing, it's a just personal connect. So let's try to see. Yep, and the app name, I'm just going to say Groundwork test 1 to 3 or something like that, and this should help us create an app for us. Yep, so it has created the app, and now I just need to copy these values, and then now we need to add this to our .env and then restart API and the worker. That's it, and then we should be able to see that now. Able to list repositories and all. Let's try to add, and let's see in UI. Okay, so I have added those env values that I just copied from the manifest UI, and now let's try to rerun this so that now it picks up our env values that we have, and let's see once this is up, and now in the GitHub's component we should see the change. I'll just wait for it to build. Yeah, okay, so it has built and NATS one, just it's going to okay. So now let's go back. Okay, there is an issue still. Let's inspect that. There was nothing, it just I had to wait for containers to come up, and then I restarted all the containers, and now let's see in UI. Basically we should see green dot, something connected, and let's yeah, I think yeah, so you see here now we have this GitHub app ready and all, and that's what we are seeing, these things. And before trying to wrap up this GitHub app connection and all, we have one thing, basically the sandbox should be able to authenticate to GitHub automatically using this run scoped installation token, so that it can clone private repos and all those things and all. So for that need to add a bit of the basically in our okay, the worker thing, I'll just show you in UI just in a while, how to install the app and then give an access to all repositories or specific repository, and then all. And one thing that's left is basically like the sandbox with the worker, so that it can clone and all. So let's try to add that, and also first the sandbox Docker file, I need to install GHCLI there. So for that let's try to just the trying to get from that official GPG, and then trying to install that GHCLI, and also we need to give the access, basically trying to change the mode to 755, for this docker git ask pass. Okay. Yeah, and now the worker, a few changes that I need to do. So let's open this worker source and activities, this environment that we have, and inside this and before that I need to add this package here, because I will be trying to use and let's try to install them. Okay, done. And now let's go to this environment, and in here we need to install create GitHub app installation token and app bot identity, the helpers that I have. So I'm just going to add it here, and that's the import. And then just quick a couple of helpers. I'll just try be quick here. um, just positive integer check, and I wanted a function to help us to select the GitHub repository. So this is the thing. So it just filters the resources to GitHub repository with valid IDs and returns null when there are none, and enforces that all selected repos share one installation, and token is scoped to a single installation. That's what we're just trying to do. And positive integer and all, just the helper and all those things. And yeah, and now the sandbox environment for run, let's try to add it here, and let's try to close this. Okay, my bad, I need to update here. Let's try to do that. And one thing I just forgot is basically in Docker I added this copy thing, but I did not add that file to which one to copy, right? So this the content of this. Yeah, just access token and username and all those things. Fine. And let's go back to this here. The comment that we just added, this GitHub app repository token injection and all those things, we need to add this thing. So I'll just quickly add those things. Should be straightforward. So in here now, yeah, and then let's now we are using this variable. Let's change this one to resources. Okay, so we are trying to get that selection, and then running the scoped sandbox preparation for GitHub app repository resources. So we are trying to create an app installation token, and once we have that thing, that's what we're trying to attach it to auth header, and then the token and all those things. Now it basically, the idea is to just injecting the token into our sandbox, so that it can when we run like the selects GitHub repos, it means that's scope token, and injects it as gh token or GitHub token into that, and so that it can just do like normally what we used to do and all. So that's the thing, and now we should be able to restart and then check once. Like I'll try to drive how to connect in UI and all that now once. Okay, after our changes, just restart this, because that sandbox docker file has to be rebuilt. And after that, let's see in the UI, and yeah, it's just loading. So now here it's ready. Let's try to click on this install button, and now basically it is asking me should I give access to all repositories or select repositories. I'll just give access to only few, and here basically I have the sample thing called blackout thing. That is what I'll be using here just clone this into a sandbox and see if it's able to meet the ask that I do, and that's what I'm just giving the permission for. And now once I click on install, and now it was installed on this account is what we see, and it's pretty much there. So now if I go back in here, and I should see now this is the repositories that we have installed, and now I can just select that, and this is what it's selected. We see so what is it that I wanted to conclude is basically setting up the GitHub app and then installing GitHub app on our personal account or organization account, and then giving repositories access to that app, so that now we can clone it into our sandbox and do whatever the tasks that we wanted to do on it, commits, PRs, or whatever it is, and all those things we can do. So that's the tying it up, all the GitHub related feature that we have. We are there, and I'll try to demonstrate everything of how can we clone this into our sandbox and ask it to perform tasks, and how tool callings and all those things will happen eventually. But before that, we have like a few other things that we need to add first, like schedule task related feature. So we'll try to again start working on that all the way, try to define contracts for it and all, like we just did for GitHub feature. So schedule task related things, I'll just collapse this terminal first, and let's just collapse all of this, open contracts, get into this index.ts, and let's see what and all we need. So I need first the enums for statuses related stuff, so let's add it. So first thing is basically the task status, and it's active or passed, and then run status, is it queued, dispatched, or failed, and the run mode, new session per run, or is it a reusable session and all, and then the overlap policy, so should it allow concurrent or skip or buffer one, and then trigger type, is it a scheduled or manual. Okay, that's the thing. And now the basically the spec kind of like for scheduled union of all the kinds that I'm just going to add in here. It is having the type, is it once, run at, and time zone, and then if it's an interval every seconds, or start at or end at, and if it's a calendar, able to pick the hour, minute, and days of the week and all. So that's like schedule task, the specifications providing all the options that we can normally allow user to configure, and then the agent configuration for the schedule task. So here of course this is going to be having prompt, resources, tools, metadata, model, reasoning effort, and sandbox backend. So just like what agent options is needed, and then the finally the schedule task, this object, so which will have basically above the types or schemas that we define. So this is the persisted schedule task entity actually, including its temporal scheduled ID that we have, and then reusable session ID, session link that we'll be trying to add. So all just standard ID, name, status, schedule ID, or run mode, and all those things. And then that was the schedule task, and if we have run that schedule task, we need to have that related record as well. So this is for that. So it will have the status, trigger type, and the links to the session and trigger event and all those things. This just the persist run record stuff. And now for the CRUD related stuff, like if we wanted to create a scheduled task request, so what should be the fields for that? So it should the create request with defaults per run mode, and the overlap policy, the status, and this metadata, pretty standard for thing. And similar way to update the scheduled task request. So I'm just
adding the same stuff, and these are all the optional things. Any one of the value can be updated or all can be updated, something on those lines. So these are the, like, simple the schemas or the types that we need for our scheduled task related thing. And now once we have this, let's add our tables and the drizzle ORM tables. So let's go to our db package, and in here let's try to update our SQL first, and then the schemas that we'll just try to add. I think, yeah, just pretty standard. This fields that we just added in our the schema, it should be just converted into columns in this table. The first thing is the scheduled tasks table. So this is where each task lives. It's like basically it's a schedule, specifications and agent config are all stored as like the JSON b and with an nullable foreign key to sessions that we will, so that sets null on delete. So deleted reusable session doesn't really destroy the task and all. So that's the thing. And now we need now one more table for scheduled task runs. So let's add that. So this again records every individual firing that we are doing, and its task ID is basically referring to the scheduled tasks ID above table, and sets null, basically cascades this on deleting thing on, so run history survives even after session is gone. So that's the thing. And now we need to create an indexes on these tables on the specific fields that we will be trying to frequently query. So unique index on the temporal schedule ID, so that it lets Postgres catch duplicate temporal schedules before they ever hit actual temporal. So the status index speeds up filtering active versus the past task, and those are the two indexes. And also the couple more indexes on the schedule task runs table, or the task ID and created at, just like we are frequently reading that. So per task run listing ordered by creation, and looking up runs by the session they produced and all. So that's the simple tables. And now we have this. Let's go to our schemas, and here we need to now actually define our the tables, just the drizzle vocabulary stuff. So the schedule tasks, yeah, same ID, name, status, schedule, workflow, schedule ID, run mode, policy, and all those things, metadata, and then indexes that we have. And let me add the scheduled task runs as well, just quickly. So ID, task ID, yeah, and just whatever we just added in the tables, SQL script and all. Okay, fine. These are the just the schemas, and the scripts that we have. And now basically we need to add queries now in our index.ts. So let's open here, and let's just import what and all I need. So okay, this is a very big file, and here from our contracts we just need to just import all the things that we just added. So I'll just right away add it here, the schedule task and all the types that we just added. Okay, and now let's try to create the types for creating schedule task input, just the mirroring of the job schemas that we have. So here let's go all the way to the bottom, so that clearly we can just keep it at one place. So okay, ID, name, status, same thing, whatever schedule task input that we have, and same way the update part as well. So let's add in here
yeah, partial of any of this fields. And then the mapping, everything we have just to give it in the format that we want for same for schedule task run and schedule task, so that it gives into the actual types that we expect. And this is the pretty standard stuff. And yeah, and now let's focus on actual queries to our db tables. So creating schedule task and updating schedule task, so those are just simple CRUD wrappers. So let's just add quickly. Creating schedule task, just whatever input that we get, values we just insert and then map and then return that format. And updating as well, so we'll just check if any of the value is not defined, just we need to update that thing. That's the simple check that we are doing, and matching to the task id, and then again trying to convert into the format and giving it. And now the just trying to get the schedule task and require checks and all. So this basically just trying to get that and return that, and here we are just making sure that schedule task exists and all. That's the normal the checks queries that we normally need. And then now to list return tasks, and also like deleting the schedule task by id and all. So here I'm just listing this, just querying the schedule task table and limiting how many we want and just returning that. And same deleting by id, just right away deleting that. And now for the task runs table, so for that creating, updating and listing things same way that we did for our schedule task table. These are the three functions. So creating, again input task id, trigger type, schedule that and fire that. And just what are the values that we receive, we are just setting it out these things. And status where initially it will be queued, and then return the mapped schedule task run thing. And update also same thing, if it's not defined we just update that and then return that thing. And listing, just trying to filter by that id and limit and return those values. Okay, so yeah, and now basically we have created the tables. We just need to just rerun the bun run dev, and our migration command and script and all should take care of creating these tables and all. So that's the simple queries that we have. And now this queries is something we need to start basically adding schedule task routes and use it in our API app and all those things. Yeah, so I think here, yep, schedule task runs and all. This it'll create for you if it's already not there, and if it's there it's just going to skip that, saying that it's already exists. Okay, so that's the thing, adding at the db layer. And now at the API layer, basically now just trying to use all the things that we added and all. Let's go back to the app thing. So I'm just going to collapse this API, and in here let's open this dependencies first. Okay, so here we need to first import the contracts that we have from the contracts package. And here I need to import this schedule the task, and we need to extend this session workflow client that we have. So let's just go back here, signal interrupt. And here basically I need to add now the functions related to our schedule task. So syncing schedule task, taking this input and returning just nothing, promise of void. Same deleting task schedule and triggering schedule task. So this basically extends this session workflow client. So interface with 3 more methods we'll try to implement now. So this routes or domain can depend on them, like through the typed contract and all. Okay, so fine, so we added this thing, and now let's go in here. Of course we are going to see this issue. And Yep, and let's try to import from the contracts, and also basically I'm just trying to import what and all we need related to schedule tasks, which we just added. So these three things, and also yeah, let's see what and all we can add. Okay, and first thing, the temporal months, let's add this lookups when we are trying to basically schedule this. So this is just helpers month lookup using just JS month index into this temporal's calendar month name and all, and so the function to just wrap that, so temporal month, I'm just going to use that above things that we have, and our overlap policy strings to temporal enum, that we need to try to have an helper to map that. So and of course this needs to be imported from temporal client, and yeah, so if the policy is skip, we just call this schedule overlap policy dot skip, and that's basically it's part of the temporal client. And here and if it's a buffer one, so buffer one, and if it's overlap policy, all. So yeah, and now error, we just try to tiny error helper, so just should create again this one. Let's try to import from this temporal client, just a tiny one that decides whether an update failure means schedule doesn't exist yet, or so created is what that is what we're trying to add, tiny predicate for that. And okay, so now the converter is very important to convert into the format of the temporal schedule that it expects. So here again, schedule spec, let's try to import this from temporal client, and now let me walk through this. This is the core converter. So from our 3 arm schedule union that we have, like interval, calendar, and the normal straight away schedule thing. So this interval, now what it happens is becomes the internals entry. So every schedule things and start at, if you have, you need to update in this. And now this calendar becomes calendar's entry with the time zone and along with this hour, minute, and second. And once basically it's append to exact UTC calendar instant, like via the month name helper that we have just created. So this is the core converter for our temporal schedule options and all. And then the other function I need is for our temporal schedule options. So here this also, let's try to import the schedule options. Okay, so this basically, it's the one which assembles the full create payload. So basically the spec, the fire workflow action, overlap policy, is it passed, or resuming renaming action state, and a memo, and all those things. So you can just, I think by now you should be able to see this start workflow and policies and state and memo and all those things. Okay, and then the helper to update the schedule as well. So this is the one which yeah, again I'm just going to import from temporal client, and it reshapes those same options into temporal's update shape for like schedule dot update call and all. So same spec, action, state, and just this is the shape for updating and all. And yep, so now we have all of the things that we need. And now in this thing we need to start implementing these 3 things that we have defined. So let's just add those things here in the client thing. I'm just adding the sync schedule task. So now we are just trying to get the handle task.temporal schedule id and options, the above temporal schedule options pass in this temporal task queue. And you're just trying to call schedule.update and pass in this update options. And if it's error, we are just, if the schedule doesn't exist, we are going to create that. Okay. So yeah, simple three new workflow client methods. So tries update first, this is the thing, and if not, falls back to create if temporal says the schedule is missing. That's the graceful resync. And delete thing is basically it's the best effort, like we are trying to clean up, so trying to get the handle of the temporal schedule id and call this delete and all. And trigger a schedule task is just starts one of fire workflow with the trigger type manual. That's what we are doing. So workflow dot start schedule task fire workflow. In task queue, I'm going to attach in this workflow id. Will give it this in this way, so that it will be deterministic and all. And arguments task id and trigger type manual. Okay, so that's the thing. And now this schedule task fire workflow is something we need to create a thing. And for that, first let's add some domain logic. So here let's create schedule task dot ts. Okay, so here just let's try to import these contract types and the db query functions and then http exception types and all those things. Yeah, the contracts db from Hono, http exceptions and dependencies, resource and all that stuff. Now the for schedule task id, the single source of truth, I just wanted to always have this in this way. So for task temporal schedule id, so it will be always derived deterministically from that task id. So that's the intent. So we need to make sure that workflows are always deterministic and activities are idempotent, so that we can retry any times and it still gives us the same result and all those things. And let's add us two small guards that helps us be very safer. So this is the validating schedule task schedule. So it must have basically start at and end at and the task name must be non-empty after trimming and all those things. That's the simple check. And yeah, this is the trimmed schedule task name and all. So okay, and the same way we need to have a functions to validate agent config stuff and all for the schedule task whatever we have. So here what we are doing is basically trying to normalize resources and validate tool refs, all those helpers that we have. And then the GitHub repo selection, and it requires basically non-empty prompt and ensures this object storage exists when file resources are actually referenced, and then it returns every like clean config after doing all this validation. So it's always best to do all of this validation. And now the path to create the entry into our actual tables in our db. So first thing for our schedule task thing, so this creating validated schedule task, it's simple. This whatever the create path that we have, we try to first validate the agent config and schedule, the above alpha function that we just created. And after we have validated and they're fine, so then we are just trying to create an entry into our schedule task table which inserts the row. So the db has now fully validated task before we touch the temporal and all that thing. So okay, and the same for our updating as well. So we need to do the same thing. Let's add this thing here. Okay, so this basically it helps first builds a partial update object and not doing anything, so containing only the fields that the caller actually supplied, so that we'll try to skip other things. So we are just trying to validate the name, status, schedule, run mode, overlap policy, metadata, and after all of this we're trying to construct the final the update object that needs to be updated. Okay, and yep, and then other helpers just ensure that we have scheduled task present before we are actually doing something on that. So here require the schedule task for API. Basically we are just making sure that we have an entry in DB, and so that if we don't have any row in our DB, so it turns into proper 404, so handling all of these cases. And restoring scheduled task is basically rewriting a full snapshot of the task, so the rollback used whenever temporal update fails and all those things. So that is this function. And yeah, and now we need to have a compensation pattern, very very important. So if pushing the schedule to temporal somehow goes haywire, then we need to have a functions which can undo those things. So very important in multi-step processes of having this compensation actors. So here first compensation actor is basically syncing created scheduled task. So what this does is basically it just deletes the just inserted row, and that's what we are trying to do. So input dot workflow client dot sync scheduled task and so if there is any error, so we're just trying to delete that scheduled task in the DB, so that we are taking care of this compensation pattern. Same thing, syncing updated scheduled task, it restores the previous one, so the DB and temporal never disagree, so they're all on the same page all the time. So that's this thing. And now the actual route, once we have all the things that we needed in the domain logic. So in this route, let's create a new file called scheduled tasks.ts. okay, so in here, as usual, let's try to add the imports that I need all at once, or auto completion should help you those things. So from contracts, from DB, and from the domain things that we just added. And let's try to now create a function to register our scheduled task routes. Okay, so in here, let's okay, first thing, trying to get the dependencies as usual, settings, DB, workflow client, object storage, and the endpoint. The first thing to create a the scheduled task entry, that's what we are trying to do. So basically first we do job validation always, so that payload is respected what we expect, and then writes the validated task to our DB, and via the domain helper that we just created, then syncs that schedule to temporal. So, and compensating on failure, which we have that compensation pattern, very important. So creating an entry into DB first, and then syncing it to our temporal, that's the pattern. Okay, fine. And now the read routes, so we need to just able to read the scheduled tasks and get that scheduled task by ID and all. So this is the thing, so trying to list the scheduled task, and this is trying to get the details of that specific scheduled task thing by ID. Okay, that was for reading thing. And now the patch related stuff. So here this is basically to update thing. Just fetch, first thing is just trying to fetch the existing the row, and then we try to validate the partial payload, and then we are trying to persist it, and then again we are just trying to sync updated scheduled task, which rolls back to the previous row if temporal rejects the change. If something is wrong, if it's something it's not expected by temporal, we just roll back, and both DB and temporal again will be aligned on the same thing. Okay, and now for the pass and resume thing endpoints. So here this pass and resume are just status flips, nothing else. So we are just trying to update to passed or active, then resync the temporal schedule thing. So that's what we are doing. So existing, and update the status, and then sync updated schedule task, syncing with the temporal. Same thing here as well. That's the thing. And now the actual endpoints to trigger and get the so here let's add in the endpoint first to trigger. So this trigger, what it does, it fires the workflow immediately and returns 202 as like accepted. So here we take in workflow client and trigger schedule task and task ID, and then return 202. And then this is basically the delete endpoint, which removes the temporal schedule first, and then the DB row. So that's what we are doing. So we're just checking it exists, and then workflow client delete schedule task schedule pass in the schedule, and then delete a row in our DB. Okay, fine. And then the final endpoint to get the runs. So this basically returns a task's firing history, which will be bounded by the limit that will be providing as a query param after confirming that task exists and all. That's the thing. Okay, so now we have this thing. Now let's use this one inside our app.ts, and of course let's try to import this register schedule task routes that we have, and then we need to now add all of the routes we just added into this pattern. So let's add this stuff. Yeah, so schedule task, pass, resume, trigger, runs, and ID, and all those things. And now I just need to register that stuff, call that function here. So register schedule task routes and all. Okay, fine. This is the just creating schedule task routes and temporal schedule sync and all between our persistence DB thing and temporal workflow engine and all those things. So yep. And now the actual thing, which is scheduled task dispatch activity, and then the fire workflow is something. Now we need to add it in our worker stuff. So let's open our let's collapse this API and this worker. So this is what makes the schedule task actually run when it's that schedule fires. So turning a temporal trigger into a live agent session and all. So that's what we need to do it now. So let's open here first the activities. Let's try to define the types here that we need for our so I'm just going to import it from our contracts, which is a scheduled task trigger type. So let's try to import this, and now we need to create a type for our input and the result, what we usually send input. So input, we just send in the task ID and trigger type, and also now the activity result should give me the action, so, and session ID, trigger, event ID, workflow ID, so whether to start or a signal. So that's this thing, and plus the session or trigger workflow IDs, the fire workflow needs, and all those things. Okay, so now let's try to create a new activity. So inside this thing, I'm going to name this file name as scheduled tasks.ts. Okay, so here let's open here, and now all the things that we need from our DB layer and events thing and common section and the types, let's just import, which we just added. So yeah, DB functions and the common section and all those things. Okay, fine. All right, so now this is the we need to create activity factory. So factory looks something like this. Let's try to understand. Yeah, this is the just activity factory and an entry point. So what we do is basically trying to load the tasks here, and immediately writes a queued run record, and then resolves that model reasoning or sandbox settings. So that's what we are just trying to do here. And falling back to global defaults when the task didn't pin them. Okay, and now here, if run mode is new session per run, and it's not reusable thing, so this is that branch. That's where, like, now first we need to create a fresh session, and that's the entry thing. And once we have that, we need to assign its a temporal workflow ID. So first, after getting this workflow ID, setting that thing for that session ID, and once we assign that, we need to backfill a reusable session ID if needed, and then it appends the session created, then the user message, and then session status changed events to our NATS. Then the user dot message event is the trigger we hand to the turn. Okay, so that's the thing we are trying to do here, and all those things. And after that, this is what finishes this new session branch. So it enqueues this scheduled task like source to turn, and then appends the turn.queued and marks the run as dispatched with its session or trigger IDs, and returns the action as start. So the workflow knows to spawn a brand new session workflow. So that's the thing here that we are trying to do. And then this is about now the reusable session branch. So here first we need to log the existing session row and append the fresh user dot message while trying to merge the tasks, resources, tools or into the session. And then we basically enqueue so the user message, and after that we are just now trying to enqueue a turn and mark that session as dispatched, and then we return this action as signal. So the workflow wakes the already running session workflow instead of like starting to create a new one and all. And of course, yeah, that's what we are doing. And we have here the issue. Let's try to import from our contracts, and here as well. Okay, now there's no error. So that's this reusable session branch that we have. And just after that, just the error handling, failure path. If anything about rows, we try to mark that run as failed with the error text based effort, and then rethrow, so the record always reflects what's happening and all. So this is the simple activity factory that we have. And now let's create the workflows. Let's trying to collapse this, and in this workflow we need to create this new scheduled the tasks.ts, and inside this basically again let's try to import what we need. So I'm just trying to import our workflow related things that we need from Temporal, and then activities thing, and queue changed stuff. And this let's try to export our type that we need for our scheduled task fire workflow input. So task ID and trigger type, so just the scheduled or manual. And then the I wanted like the shared child start helper. So here something like that, so start session child. So this basically uses the abandon parent close policy. So the session workflow keeps running even after this tiny fire workflow completes or is cancelled. That's the thing, just the helper to start a child session workflow. And now the firing workflow thing. So let's add in here the scheduled task fire workflow. And this basically what it does, it calls this dispatch activity. We'll add this dispatch scheduled task run, and then it either starts a new session child if it's a start, or signals the existing session workflow with a queue changed action signal, falling back to the starting a child if the event signal fails because the target workflow already ended or something like that. So that's the thing. And now in the main activities .ts, here I need to basically add this dispatch stuff, the one that we were trying to call. So here, yep. So default activities dot dispatch tasks run, and of course here we now need to add in here create a schedule task activities, just importing from our schedule task activities that we have created. And here I'll just try to export the input and the result, and yeah, in okay, so already we have this exports here, so we can just try to unionize anywhere, it's fine. So that's the thing. And now just going back to the thing, and we should not see any error. Yeah, so that's the like trying to expose the dispatch schedule task run has a name export, so the now workflows activity proxy can reference it and all. And yep, and finally going back to our workflows.ts, and all I need to do is basically export our schedule task fire workflow, and then the type from that schedule task. So this is like all the way wiring up the contracts and the DB layer and then API layer and the worker and creating activities and workflows and all. So backend side and all that stuff, whatever we need, it's patched up. So it's just now we need to wire it up into our UI thing like we did for our GitHub app and other stuffs and all. So let's try to add the types and the APIs inside our web app. So opening this web app, and inside this the types is something that we need to first add what we need for our the schedule related stuff. Now this first is specifications, just once interval and calendar, those three types that we have, right? So that I need types here. So once it needs run at and time zone, and interval, start at end date and every seconds and all those things. Calendar, we need hour, minute and days of the week, and time zone and all those things. Okay, that's the first thing, a specification. And then for our agent config, basically whatever we had it in our contracts, same thing for our UI, we need here schedule task agent config, and it needs prompt, resources, tools, metadata, model, reasoning effort, and sandbox backend, Docker, Modal, or local or none. Okay, fine. And then the scheduled task, just the full task type, matching the response of the API, just the ID, name, status, and all the other fields that we have. And similar way for our the task run. So let's add that here. Yep, same, matching the API response of that for task run as well. So these are the types that we need. And now the API.ts. So let's let's try to import the types that we just created, the four types that I'm just going to import here from this types. And once we have this, it should be simple API wrappers now to our the endpoints that we have just exposed. So let's try to add for the read sections. So first and here fetching the schedule tasks, just straight away call to schedule task, and same thing for schedule task runs, that's the endpoint. And now the post related stuff, so maybe creating a schedule task endpoint, so function that we'll try to consume here. And yep, so name, schedule, run mode, overlap, policy, agent config, and we'll just send in that body as then for this post endpoint that we have. And now for the patching stuff, just to update the schedule task, so let's add the thing here, updating that again, a task ID and any of this can be sent to update, and that's what we are just passing in. And then the action wrappers, basically passing, resuming, triggering and deleting and all those things. So let's quickly add. So here to pass thing, we just make that to pass and resume, same thing for triggering and then deleting that stuff.
and these are the API stuff. And now the schedules dot feature that we have, which is the placeholder now for anything. So here it's a giant UI stuff and all, because we're trying to keep everything in one file. I'll just right away add like we did for other features, and just give you a brief walkthrough. So let's go all the way to the top, and here simple, we need imports for the icons and all. I think those should be straightforward. And then the important thing is basically from the API, whatever we just added, we have trying to wrap under the hooks and all those things and the types. And then scheduled task form state. So this is basically the local form model. Just that's what like that the form will try to bind before trying to serialize back to the contract thing. And yep, so and this is just trying to create a new scheduled task form state, just the helper for us. And this form state scheduled task, so this what it does is basically okay, so this basically just iterates the form from an existing task here that we have, and converting the contract the schedule back into the form fields like seconds to minutes, hours or minute into a time strings, and for the edit part path and all those things. That's this form state schedule task. And yeah, and then the schedule from form state, it's just the one that just serializes a form back to the contract by delegating to the schedule builder that we have just created above. And then the agent config form from the form state, just it serializes the whatever the agent config and merges the prompt and groundwork related tool toggle, while like trying to preserve the existing model or reasoning or sandbox or metadata. So an edit never resets them, so that's the only thing. So all tool handlings and all those things, and trying to return in that thing. So just the helpers and all those things. And now the we schedule tasks panel. This is the actual the stuff. So let's just try to collapse all of them, so that now I can just give you brief what each does quickly. Okay, so now we are at this tasks panel. Okay, so this let me just open this. Yeah, so this is basically simple panel component and props. You see it has config, resources, and GitHub repos, callbacks, and it's a local state. Basically we have tasks, per task runs, and open or editing or busy flags and all. And then they refresh here, basically which loads tasks on mount and pulls recent runs from the first 8 and all those things that we have here. And then this create task, basically these are the panel's handlers. It validates the prompt and tries to serialize the form, defaulting the name to the prompt slice. That's what here we're trying to add it here, and posts with a panel level model or reasoning defaults. And then we are just trying to create the schedule task. And yeah, that's the thing that we are doing. And here the save task is basically patches an existing task that we are trying to do it in this section. And this now this task action, that's the dispatchers basically pass, resume, or trigger or delete each, trying to refreshing and surfacing errors as the toes and all those things in that stuff. And now this is the panel's JSX. So the header basically will have the refresh or new, like where new toggle basically tries to this create the form. And the create form basically here we have and so we'll talk about this. So just the form intake and all those fields that we need basically to
create an entry into our scheduled task and all. And here trying to showcase the list of tasks that we have. So if empty state, this is the thing, and then the card per tasks, where we'll try to show name, and then the schedule label, and the button to edit, and then we have the pass and resume buttons as well. And then we have this the inline edit form with the run or run now or delete, and then recent runs strip, like trying to link to each produced session. So this is like buttons run now and delete, and the buttons basically yeah. So this is the just a rough the things that I'm just trying to give you an eye level overview of what this does. And yeah, pretty much. And then the schedule task form and all these are basically uh, the reusable component which we were trying to use above. So this is simple, shared by creating and editing stuff. It's all just holds all the form state and generic update, setter keyed by field name and all those things. So label input name, schedule intake, and then text area for a prompt, and then the run at and like start at and end at that stuff, and selecting this new session or reusable session, and then allow this concurrent or buffering one. And do we need to attach Groundwork MCP tool, and then repository picker and all. So this repository picker, it's also like similar, where we added so just same thing. It's just what it does at a high level. It tries to split resource into repository versus file. So if I just expand this one, versus file, and tracks like manually added repos not in the current list, and the single installation ID, all selections must share, and all those things. So that's what we are just trying to do here. And then trying to showcase that repository thing, and trying to refresh and show it same way like normally that we had, like kind of like same as what we had in our GitHub's the stuff that we are trying to showcase. So that's why I'm giving you high level things, and these are all the helpers that we just used in our repository picker and all those things. So local date and the schedule task and schedule label and all. So you get the intent. So that's the, like, high level intent. So basically the thing. And mostly now if we try to open UI, so let's wait for this. Okay, let me just try to restart this a bit. Okay, expanding. Let's try to run this again. And mostly now we should see scheduled thing. And let's see, like we'll try to test and showcase how it's going to create a schedule in Temporal. And then like we'll see simple small example, like let's say hello or good morning summary and stop and something like that. But we will see it's starting up. Okay, UI we can access. Okay, API started. Let's open this UI. Okay, so here we have, okay, these are the scheduled tasks that we just added thing. And here now let's try clicking on this new. So once we click on this new, so we will say let's say hello, good morning or something like this. And it's a let's say it's a once. Okay, I'm going to say something like write a one sentence, good morning, and one good quote of the day and stop, something like that. Okay, and right now, so this one, let's try to schedule it. I'll just schedule maybe, yeah. So I'm just scheduling this, and okay, and let's see. Okay, I just scheduled this, and mostly now if I open this and see in here, we should see the scheduled task created here, and so it should run in a minute or so. So basically this is how it's going to look like. The schedule input we have, and the specifications, minute, start, end, at that step is thing, hour, day of the month, and all those things, basically the things that it needs, the stuff. And you can just see this, and if you want, you can just try to trigger immediately here itself in the temporal. Basically that's for more or less for our developers, if something we wanted to do it on our end, kind of like admin level functionality and all those things. But let's see, so I'll just go back here, and this workflows, yeah, it ran. See, it did complete. Now going here, so you can see here the scheduled tasks. So it did run, so dispatched schedule run, and the input was this, and action was start, session ID, and this is the thing. And now yeah, so if I just go in here, so we can see this has been scheduled and dispatched, and this is what we see now. So I asked it to write a one sentence good morning and good quote of the day, and now once we deploy it somewhere, now we know it has run at this thing. So good morning, may your day begin with hope and purpose, the future depends on what you do today, and all. So that is the code, and that's exactly what we specified to do it and all. So this is a simple thing, but never we are going to use it this way, but it's something like heavy work on our GitHub repo particular project. Then let's say we want to do brainstorm and try to research, and then if you're curious to build and understand prototypes and all, multiple repos and all like this, that's what like scheduled task does. Then, and like this I just showcased you for once, and even the loops concept in the Cloud Code, what they launched is all, it's something on this lines. So we're trying to create a cron job or the scheduled task once, instead of once, intervals of like one every 1 hour or so, something like that. Very good example is basically, let's say we are like running pilot sessions with all of our customers, and every couple of days or so we schedule product feedback runs, and then we take in, ask them to run through product, try them, and then give us the feedback and all. So all of this call recordings and all, that's a good use case. Like for example, let's say every few hours or so, pick up these recordings, transcripts, or something like that, you by attaching these MCP tools, like whatever the meeting platform they are using, and take that, and then give me the create a linear tickets, or post it in a Slack channel or something like that, so that a particular dev can pick up and then try to implement that features or iterate on those developments, something on those lines. So this is the simple the schedule task thing. Like that you can just edit or pass if it's a recurring thing and all those things, and you'll see whatever the schedules that we do inside this and all. So anyhow, that's the once thing, and we can just do other schedules as well. So now let's focus on the MCP stuff. So that's we want agents to manage Groundwork itself. We need some consolidated MCP server that exposes files, the repos, and then schedule tasks as callback tools and all those things. So exciting, right? So that's the thing. We need to add our MCP server. So for that, I'm just switching back to our code that we have, and let's open the API thing. So that's where in the source folder, let me we have already MCP, and here let's create this server, server.ts. okay, fine. And let me just collapse that sidebar and also minimize this terminal. Let's focus on what and all these things we need to do here. So as usual, I need all the core imports to expose our functionalities as a tools, so that it can access files or repos or schedule tasks and all those things. So these are simple the contracts, job contracts that we have, and then the DB calls for listing the scheduled tasks and all those things, and then the GitHub things, and the MCP server, which is important from our MCP SDK that we have, and the domain schedule tasks and all. So you will see this thing now. And before we actually adding all of those things, let's quickly add the helpers that I need, just right away, how we added in other API domain logic and all those things. So this is just normalized repository URL, you should understand, and then repository mount path, just trying to construct in the repos. That's where we try to store in. So we try to give that repos path, and this is the repository URL. All right, so now one function at a time, what and all I need for to construct our MCP server. And so this the repositories with the scheduled task resource. So what it does, basically it tries to augment the GitHub repo with ready-made resource ref. Here this is the thing, we have this normalized URI, default branch, mount path, and so what this can help is agent can paste it straight into tasks agent config.resources. That is the helper. So the more the work that we do, the better the agent functions thing. So now let's try to instantiate our MCP server. Let's see. Okay, so I'm just adding and let's just try to close this. Okay, so here let's first trying to build Groundwork MCP server. So yeah, this is the function which tries to instantiate our MCP server from the same API route depths that whatever the REST APIs are using it. So we just creating MCP server, and then here the JSON helper that wraps any value in an MCP text content block that we have, and then we try to now register first tool, which is a files get download URL tool. So what it does is basically it checks if the file is ready, and then once it's ready, it gives me a short signed URL, and then it gives me all this file metadata plus the URL and its expiry. That's the first tool, the file get download URL. And now second tool basically trying to list down all the repositories that we have. So let me add here. So this is the GitHub repository list. Simple. It just tries to list installed repositories and augments each with ready to use resource ref, and so an agent can attach one to a task without constructing the URI or mount path by n. So, and any missing GitHub app config becomes a clear error here, and that's will be very informative for the agent. And then the read tools, just to read our scheduled task list and the scheduled tasks get. So here straightforward, just the wrappers around the domain logic that we have, and trying to register as a tool under our Groundwork MCP server. So that's the thing. And now the to create a scheduled task, so let's expose here. This is the write action. So this I think it just accepts the input schema that and all we need, and the payload, yeah, just trying to revalidate the contract that we have before using that same domain create plus compensating temporal sync as the same as the rest route and all. Okay, and now that was the create, and now the patching thing, same schedule tasks update. So let's add it here, schedule task update. So it's just the same thing, separates the ID from the rest of the orgs that we have here and revalidates the patch, reuses the same domain update plus sync update schedule tasks, which rollbacks on temporal failure, identical to the same patch route which we have in our REST API. Okay, and now the actions thing, schedule tasks pass, resume, and all those things. So here let's add in this stuff, just the same, reusing same domain functions logic that we have just created. So I'm not going to talk much about it, and by now it should be clear. Same the other two actions that we have for triggering and deleting stuff. So let's try to add it here. Okay, so this is trigger and delete stuff, and now trying to list down the task runs and then finally return our MCP server. So this is the thing. So that's the MCP server, and I think it should be pretty clear. So we're just trying to create a new MCP server and attach the all tools that you can access. So I'm just trying to register tool and all those things. So now we have this an MCP server.ts and all. We should try to import into our app.ts. So let's inside this, let's close this first and import the MCP server that we just created, and also this protocol HTTP server transport from that MCP SDK. So let's add in here this import. These are the two things that we need, and now basically I just need to add in v1 slash MCP and expose that route. Okay, so maybe just let's go all the way to the where we were trying to register routes. Yep, somewhere I'll just add in this route. So v1 slash MCP. So here the transport, now we will just use this create this transport object, and trying to pass the route dependency for our MCP, and then call this connect via this transport, and handle all the requests that is going to be hit to this endpoint. So now basically the MCP and MCP docs, we can expose this cleanly. Okay, so these routes I just need to add it here. Let me add at the bottom. Okay, fine. So this is the MCP and it's ready too. So now basically if I just let's try, okay, and open here. So it's connected. So let's see now. Okay, let's try to ask, can you list down the repositories that we have connected? And let's see. Okay, so mostly MCP is connected, and yeah, it's working. Run active agent segment and all. So now you can see agent activity 1 tools, and this is what exactly we connected. And you see here it used Groundwork GitHub repository list, the one which we just exposed via our MCP. Before, when we had enabled this one and trying to ask, it was throwing it could not find the MCP server and all. So this way, so now the reasoning as well. So reasoning summary, it says that I'm trying to list the connected thing, and after that it knows now it has one MCP server, and trying to see the tools and trying to pick the one which really makes sense. So Groundwork GitHub repository list, that's the tool name that we gave as well, and it got this list, and then it just gave us in formatted way and all those things. So that's the like integration of the MCP and the tools and all. I'm just trying to be non-destructive here, just the read only, and other things I'll just try to showcase how it's going to look like. But mostly what we want and all, now we can start even attaching our this blackout migrate, and I'll show that how the sandbox will clone it and then do that migration and then commit and create a PR and all those things in just a while. But before even that, so most important things is we know at least how to create a decent infra backend layer, and then temporal workflow engine and the other stuffs, and agent harness that run active agent segment. So if you see now, basically the workflow that I just called, this is the one the one which has been just called. So run active run agent segment, so that's the agent harness that we have added way back, and this all this agent harness and all that stuff is done. So now we need to maybe add a very detailed way and option to deploy this whole as a solution. So either it's an AWS or GCP or any other things. So kind of like we need to add the infra as a code, and also something dedicated deployment package, so that we know it needs this environment variables and all those six. So that is the thing now we need to focus a bit on, and before we try to test end to end with one clear example, and see what is this really meant to be. Right, now let's create the deployment package. So new folder called deployment, and inside that let's first add package.json, tsconfig .json, and yeah, usual source folder and index.ts inside that. So this deployment package, we are trying to establish this as like single source of truth for how like a Groundwork can be deployed as a typed validated contract package. So in this package, first simple, we need just the jod as the dependency and TypeScript as the dev dependency. So I'm just going to add in here this thing, and tsconfig. We just need to extend our base thing like we did in our other packages. So let me just add them straightforward. Yep, so fine. And now just let's try to run burn install thing, and here let me just run burn install. Yep, fine. And now let's get into this. Okay, so in here let's see what all I need, and let's try to add all the profiles that we will be trying to support. So yep, so here we are trying to pull in the jod and lay down the first dimension enums that we need. So basically the deployment profile ID, all 12 supported shapes. So local compose, local Kubernetes external, Azure managed, and Azure existing services. Same for AWS, GCP thing, and then a preview PR, preview branch, and then self-contained Kubernetes. And these are like trying to preview the PRs output and all those things, and preview branch and self-contained Kubernetes. So these are the profiles that we'll try to support, and just the deployment profile ID, and now the cloud provider, local generic, Azure, AWS, or GCP stuff, and then runtime platform, is it a Docker Compose or Kubernetes, and that's the thing. Dependency mode, is it managed, external, in cluster, or disabled, and storage API, is it S3 compatible, that we are min.io or something like that, or using S3 or Azure Blob or GCS, those things. So that's the these are the vocabulary, like basically every spec needs them. And now the let's add the related to sandbox stuff after this. So I'm just adding here the sandbox backend, is it Docker, Modal, or local, or none. we'll try to use Docker and C, and this is just the type. And now secret delivery mode. So how are we taking the secrets from? Is it env file or Kubernetes secret or external secret, or we are using Vault or Terraform's organization HashiCorp's ones, or else Azure Key Vault or AWS one or GCP one. So that's the thing, secret delivery mode. And observability backend, is it just straight away using OpenTelemetry or any others like Grafana, Azure Monitor, AWS managed, GCP thing, Prometheus, Grafana, or Datadog, Honeycomb, like any other customer provider thing. Okay, so that's the observability thing. And access mode, is it the disabled one, shared key, or external gateway? And these things something we need. And now the basically the references things, so I'll just add and then walk you through those things. So all the references for our secrets, so here, so the secret references and the external service references, and then the managed service references. So they basically describe like how a subsystem points to an external secret or endpoint, or a managed the cloud resource, and the runtime spec. Basically it helps us to capture the platform, cloud, the namespace, region, registry, and release name, and all those things. So that's the this types are for. And now per subsystem specs for the core things, database, temporal, NATS, and object storage, and secrets, and all that stuff. So let's add the same way like we added for the above things. So here the database spec, same thing, straightforward. What is the mode, engine, pgvector required, external or managed, and temporal, it's a mode, namespace, task queue, external, managed, and all those things. And add specifications, managed or disabled, object storage specifications again, all those things, and secrets specifications things. So yeah, it's all valid dependency modes and carries like optional, external, or managed references, and the rest of the subsystem specs also I'll just try to add. So, like dealing with ingress and all those things. So let me just add in. So here it is. So in this ingress, basically with server send events timeout, that's the thing. And observability requirements, backend require traces or metrics and other external things. And access mode, allow unauthenticated health and for metrics and external. Then sandbox backend stuff, preparation profiles, is it Azure, GitHub, and env allow list, and sandbox backend trying to attach the other job schema. Backup spec, is Postgres required, object storage required, and restore drill required, and all those things, backup policy stuff and all. Okay, and now this required mode reference stuff. So this basically is the kind of shared like super refined helper, what that adds like validation issue whenever, let's say, external mode, let's say, lacks an external reference, or a managed mode lacks a managed reference. So it's defined first, so that now the below the contract like super refine and all can use it. You'll just see and all. And yep, so let me add overall the deployment contract now, then you'll understand this custom and all those things. Okay, fine. So here this is very important, the deployment contract. Okay, so this composes now every subsystem spec that we added above into this final deployment contract. The profile, runtime, database, temporal, NATS, object storage, secrets, ingress, access, observability, sandbox, and backups policy and all. So this now it enforces the cross field rules that makes impossible deployments like unrepresentable and all. So, and for example here this Kubernetes needs a namespace, and here this Docker compose must be local, and now each cloud or preview profile must match its runtime. and ingress. So and yeah, and this ingress needs a real access boundary and all those things, and every external managed dependency must carry its references via this required mode reference helper that we just created, and that's what we are doing. So database and temporal object storage, and these all the things now you should understand what I was talking about. And yep, and the each storage API is restricted to the clouds where it's valid and all those things. You can see that validation and all extra layer of super defined validation. And then the now finally I'll have one parser to just whatever the input value that we get will run through our contract schema, and then single validate entry point. Every profile and every CLI users will try to use this pass deployment contract. Okay, so now we have, so let's try to create a deployment profiles. So this is interesting. So now we have a lot of deployment profiles. So first let's add in local compose and local Kubernetes stuff. So here let's try to okay, so let's add in here deployment profiles. So profile ID and contract. So first the local compose. So parse deployment contract, profile local compose, runtime we need Docker compose, cloud is local, release name is this, database will have in cluster engine Postgres, and pgvector required true, temporal mode is in cluster, again namespace default, task queue will have this groundwork runs and all, NATS again in cluster, object storage in cluster S3 compatible, groundwork files, bucket name, secrets will use env file, and ingress enabled false and all those things, access is disabled, it's all unauthenticated true because it's local, observability none, and sandbox is a Docker. And now the Kubernetes same thing, platform is Kubernetes, namespace local, release name and other things pretty much it's going to be same, in NATS in cluster, API S3 compatible for object storage, groundwork files and secrets is not in file. We'll use Kubernetes secret and all. Yep, so like this for each profile we need to set in here. So let's now add for Kubernetes external. So similar to what we have for local Kubernetes, so I'm just going to add it here. So this basically again generic Kubernetes deployment pointing every dependency at external secret references. So namespace groundwork and external mode external Postgres, and we need secret key references, something like this. Groundwork database URL is needed, same for the temporal and NATS as well, object storage, external secrets, observability sticking to open telemetry thing, sandbox none, and like that. So let's add now the same thing for the Azure managed profile. So here also pretty much Azure managed runtime, Kubernetes, database managed, and all those things. Temporal external host we need to provide, NATS if he chooses this profile, it's external again, secret is needed, NATS URL, object storage Azure blob, provider is Azure itself, and the Azure key vault has a secrets, ingress it's enabled true, access is shared key, and allow unauthenticated health true, and metrics false, observability Azure monitor is what will be used, and all these things. So now Azure existing services profile I need to add it here. Let's add. Okay, so this again Azure Kubernetes reusing the customer provided Postgres, temporal, NATS and blob storage. That's the thing, existing services, so they will provide their own database URL and also the temporal stuff, and groundwork NATS URL, object storage as well, the Azure blob, key vault, access, monitor and all those things pretty same. And now the same for Azure AWS existing services,
and manage the stuff. So let's add this managed thing for AWS. So this basically it will be ideally EKS with managed RDS and S3 and external temporal NATS, so secret manager and AWS managed observability. That's the thing. So Kubernetes EKS, and it will be managed database. Temporal is external, provide the host URL. NATS again, external NATS URL is needed. Object is managed AWS S3. Secrets, AWS secrets manager. Ingress, access is shared key. Observability AWS managed, and backend sandbox none. Okay, and now for the existing services, so this just minor difference is basically AWS Kubernetes trying to reuse existing Postgres, Temporal, NATS, and S3. So it's a straight thing. So I'm just going quick now. And now the same for GCP as well. So let's add in the GCP stuff. Okay, so here it's a profile is GKE Google Kubernetes engine with managed cloud SQL and GCS for storage, and then external temporal NATS, secret manager again managed stuff, and GCP managed observability there again. So that's the thing. Postgres is managed and temporal is external, provide the host. NATS is also external. It's a managed GCS, and same thing, Ingress is enabled, GCP managed, and sandbox is none. Okay, fine. The existing is just using existing services instead of relying on managed stuff. So here I'm just adding this existing services. GCP Kubernetes, again reusing existing Postgres, Temporal, NATS, and GCS. Everything will be external here, so that's the only difference. And the GCP managed secrets and observability and all main core things. Okay, and then the remaining profiles, let's try to add let's see the preview PR. So I'm just adding. So here the preview PR and preview branch. So preview PR, preview branch, self-contained Kubernetes are all basically they're isolated in cluster Kubernetes environments. So and so I'm just pretty much the same in cluster and all, and everything remains the same. So that's why I'm just going to rush here a bit. Self-contained Kubernetes and all those things. So those are the all the profiles and how we manage these things. And now the overall deployment stack plan and all. So like doing pre-flight checks and all, so that we have not missed anything and all. So let's see this what and all we need. So the pre-flight types, like pre-flight check ID. So what it does, like it tries to enumerate every pre-flight check. And so the shape is basically all this Postgres connectivity, pgvector, migrations, temporal connectivity, worker task queue, Kubernetes context, container registry, NATS pubsub, secret delivery, and all of this. And this pre-flight check is the shape basically each returns. And now this platform dependency plan, so it describes one official platform chart, for example NATS or temporal and those things. So lifecycle chart, repo name, values, and all those things and all. And then this deployment stack plan, it just references it, and then is the full plan type that we basically now wrap, profile, Terraform root, Helm's value file, and all those things. So okay, and now the things related to Terraform stuff. So let's quickly add the interfaces for them too. Okay, so here the Terraform output value or record the types that we have, and then deployment run at artifacts. This is just the result of merging Terraform outputs and env into Helm values, and runtime env file, and then the summary.
So which basically describes one generated env variable, its key and value, whether it's required, whether it came from sensitive Terraform output, and all those things. So that is this runtime env entry and these things stuff. And then the functions, for example, to construct a pre-flight check. So just this is how just try to construct and return in this format, and same secret like runtime environment stuff. So that function, it looks something like this. Includes key, token, secret, password, connection string. So just the flag CNV names that should be treated as secrets, not like basic values, and we cannot show it those values and all that thing. And other helpers, just for the env thing. So I'm just going to add the non-empty check and required env and the value env things. This non-empty basically you see it just trims a value with when blank, and to undefined when blank, and this required env and value env just runtime env entries on top of it. That's the thing. Okay. And then the deduping stuff, and also Terraform output string helpers also I'm just going to add. So this deduping, by saying this itself, should be understandable. It duplicates keys, preferring entries that actually have a value, and sorts by key. That's what we are just trying to do it here. And this Terraform output string just safely reads a string Terraform output and returns that value. Okay. And then to that was a string, and if you wanted in the output object format, so this is that reads the string value object output, and returns that. And then add generated image values. Basically what it does, it tries to inject the generated image tag, and empty basically digest for each component into the Helm set values map. So that is the thing, tag and digest as empty, that stuff. And then helper to basically parse Helm path while trying to honor the escaped dots and all those things. So we need that helper. So that's this thing, just trying to split Helm's set path and all. And just these are all the helpers I'm just trying to add, instead of adding all at once, and home well-being these things. So this setting nested value, it basically what it does, it walks or creates the nested object. So walks through this path whatever we have, and to assign a value to at a dotted path and all those things. So that's the thing, just trying to set nested value and all those things. Fine. And similar way, this nested object from Helm set values, so it turns this dotted Helm set values paths into nested object. So using the two above helpers which we just created now, set nested value and split Helm's path and all those things. So that is why we needed those things. We created above, just trying to split it into multiple functions instead of adding it in the same function, so that it doesn't clutter the thing. And now AML value formatting helpers that we need. Here this AML value, just formatting scalars, JSON coding strings and all, and this render AML just recursively renders a value as a sorted YAML thing. And the final piece of this generated Helm values output is what we are just returning here. Okay. Fine. And the lot of this is very important, that's why we need to be very extra careful here. And this basically Helm values file for and Terraform root for. So basically this returns the per cloud Terraform directory. If it's AWS, it's in that directory. If it's Azure, that directory, and GCP and all those things. And this Helm values for again maps each managed profile to its example values file. So if it's a local Kubernetes, we'll try to keep it in this managed, we'll try to keep it in this all this stuff and all. Okay. Fine. And now we need to provide an example stuff, the platform dependency plans, kind of like that. So let me add and just give you a walkthrough so you will understand the intention of that. Yeah, this is platform dependency plans. So what this does, basically it emits the official NATS and temporal chart plans for managed or self-managed self-contained Kubernetes profiles. Basically the repos, values, runtime, env required secrets and install, like including AWS RDS TLS preparations and temporal namespace registration job, verify and destroy commands, it's and everything. Okay, so if it's basically it's not Azure managed, AWS managed, or GCP or self-contained, just right away return empty. And if it's not Kubernetes, also return empty namespace groundwork platform. And now we need to try to return this platform dependency plan everything. So first we are checking if the mode is external. So we are pushing NATS official chart, and release name is this NATS, and chart name is NATS Elms1, and chart repo URL is this, and chart name is NATS. Okay, and values file we will try to have in this official NATS thing, and runtime environment thing. This is what it's going to be required. And env secrets empty, and install commands is basically we need to add using this Helm command and update this NATS, and then try to now create a namespace which is Groundwork platform, and apply that whatever the YAMLs that we have, and upgrade these things and apply these tags, values, network policies, and all those things. So then these are the install commands, and these are the verify commands. Make sure whatever we have installed, they're all present or not. And this is the destroy commands to uninstall Groundwork NATS in the namespace of the Groundwork platform and all those things. And so this is basically nodes and all. So official NATS chart is like, you get the intent. So trying to give everything that they need. So, and if temporal is external, again temporal values, so if it's AWS Postgres TLS enabled, we are just going to set this to true, and all this basically whatever they recommend in that specific images usages based on the cloud, and all we are just trying to set exactly where the permissions, TLS related details, and those config. And then we will try to add this scripts trying to run this deployment temporal values, and generate all of this stuff. And if it's not AWS, just try to run, and this is what it's going to be. And temporal TLS prep commands, same again, trying to install this based on its documentation recommendation, and try to set this up in that k8s. Okay, so pushing here official chart, again same thing, temporal, go.temporal.io, Helm charts, deploy values we'll be finding in here, and runtime environments, required environment variables is Postgres host and Postgres password for our history database, and secret keys, password, Helm commands, adding temporal, updating temporal, and then creating a applying those, and trying to create this profile, TLS prep commands, value commands, and then do all of this just to apply all of this. And this is verify commands, destroy and nodes. So I'm just going at a high level. Okay, so this is for NATS and temporal, that stuff. And now let's add the functions basically to use official platform chart. So now this basically reports whether a given platform dependency ID is lifecycle managed as an official chart for this contract, and also. And this platform runtime env, basically what it does, it tries to looks up runtime env value like contributed by that platform dependency, example in the cluster NATS or temporal endpoints and all. So that's this thing. And yeah, like this, we need to add a lot of stuff. So let's add. I'm just adding now creating this created resource classes. So this basically lists what a profile provisions. So for example, the common Kubernetes or Helm or secret resources, like plus like cloud specific substrate, in cluster fixtures and platform charts. That's the thing. So you can see if it's cloud is Azure and profile is Azure managed. So Azure resource group, AKS cluster, all of this resource classes is something is needed. If it's AWS, EKS cluster, ECR repositories, S3 secret managers, IAM roles and all, GCP, GKE clusters and all those things. If it's unclustered, just disposable in cluster and all, Postgres, NATS, MinI fixtures, same thing, using official things and all. Just we're trying to push in that way. And here the external dependencies basically lists what the operator must supply out of the band. So for example, if it's an external, Postgres with the pgvector should be reachable through this URL. And if it's an external and it's not using official platform chart, then temporal cloud or existing temporal or anything temporal mchart endpoint is something needs to be provided. And same for other checks for ingress and object storage and all those things. These are the helpers. And now image build push commands, important. So let's add here. So here I'm just adding, let's walk you through here image build push commands. So this it returns basically the cloud specific registry login and per component like docker build push commands. For Azure it's ACR, AWS it's ECR, and GCP it's artifact registry and all. So here we are just trying to login server, get that login ACR login server, and access token, get the AZ CLI and try to get that access token, and now log in to this Docker and all those things. So same way for AWS and GCP and all that stuff thing. I'm just trying to give commands for image build and push stuff. So nothing fancy, just trying to build API worker and all, basically the local changes that we have. Okay, and that was like image build push commands. And now we need to provide similar way the deploy commands. So here this is that function deploy commands. So this basically renders full order deploy recipe per profile. So for local compose it straight away run dev, it's what we are doing currently now. And for local Kubernetes thing, it should first build image thing and load and then Helm, those are the things. So we're just trying to build and then load this Docker image and all those things, and then create namespace, and then yeah, or the cloud path of like Terraform apply or whatever it is. So okay, fine. And so here creating this namespace, and then Terraform applies based on the cloud and all, and that should create instances and all. Anyhow, we don't have Terraform scripts and all, we will add, but these are the just an example here. Okay, so image or build or push we are doing via this image build push commands, the above function that we just created. And now this deploying thing and all we are doing using this thing, this function that we have. So fine. And yeah, next is verify commands. Exactly. So after we deploy and all, we need to have a way to verify it has been. So this basically more or less it's a trying to chain the platform charts verify steps, like the pre-flight env check and the confirmation session run with the access key when like shared key auth is on, something like that. So this is a base URL, and then trying to this script will add, and this is what we'll try to just return this. Okay, and now the destroy commands as well, and let's say if we have tested and all it's cool and all, so we want to destroy that stuff.
So this is that if it's a local, we're just going to compose, call the docker compose down and remove orphans and all those things. And for Helm, uninstall and pass in this namespace and those things, and kubectl delete that namespace completely, and those things. So simple local, tear down the docker compose down locally, and the Helm uninstall plus namespace delete, and then platforms, the charts destroy steps in reverse, the platforms namespace, and finally the Terraform destroy. So that's what we are just doing here. Okay, fine. And then the plan nodes, the Terraform plan nodes basically here. So this produces operator guidance, basically keep generated credentials or state private, and kind of like something like use destroy commands for cleanup, plus remind us about access key handling and temporal NATS living like outside this app chart and all those things, just so that helpful notes and all those things. Okay, fine. And now the required env values at runtime. So let's create that function. This is the thing. Okay, so required runtime env variables, just it computes exact env variables that running app needs. So temporal or sandbox, those are the basics. Okay, plus now the database, temporal, NATS, object storage, API, access variables only like when those dependencies like aren't in cluster, kind of external and deduped and sorted and all those things. We're just trying to do those simple checks and written that things. Okay, and once we have, so let's try to create a function which gives the environment values. So here I'm just creating this function. Yeah, runtime env values. So this is the function which is responsible to build the runtime env, like access key, database URL, auth flags, temporal coordinates, NATS URL, API, host or post, host or port, or sandbox backend. And then per API object storage branch, like for Azure blob, tracking the sensitive connection string, and the AWS S3, GCS or generic S3 compatible storage and everything. So trying to get all those environment variables that we need, and just trying to dedupe this entries if you have any duplicates and all that stuff. Okay, fine, we're almost there. And now the pre-flight checks important. So that also may be in one function. So let's add inside this here. Okay, so fine. So this basically returns the ordered profile specific checklist. For example, for Kubernetes, we need to verify Kubernetes context, namespace, service accounts, and API access, and container registry. Then after that, connectivity stuff. After that, storage stuff, and after that, secrets that we have, and then access boundaries, ingress, SSE like open telemetry stuff, and then sandbox readiness, and backup policy, and then confirmation session and all. So each flagged, required or optional like will be built with check helper and those things. So, and if anything is missing environment variables, we need to filter that stuff and by required thing. So it just filters the required list against the current whatever we have or we have been supplied, and returning the ones with the app center blank, and let them know like we need these values and all. Fine. Now the final plan is something we need to assemble, and this is the stack plan for the function.
It is responsible to assemble the complete full plan. So the Terraform root, Helm's values file, platforms dependencies, then the union of the secret like env variables and the deploy or verify or destroy command sets that we have. So all of these functions that we just defined above, and this is like basically the top level orchestrator that is every helper that we have just defined above. And that's the thing. um, Fine. And almost there except one thing. Now I'm just going to add to generate runtime artifacts. So let's add in this thing. So this basically it merges terraforms like Helm's set values and generated image tags into that Helm values. So it computes like and also the runtime env entries and tracks like missing or required or sensitive values here. And then renders that values YAML and runtime env file with provenance headers and all those things. So that's like just trying to generate runtime artifacts for Helm and all those things helper. Fine. So this is like main what and all we need, and all the checking for all the profiles and everything that we need. Just kind of like if we wanted to serve it as like the infra out of the box deployment profiles and all those things. And we're almost there. And now if you want, we can just write test files and all to just cross verify and all. I'll attach in the commit. If you need, you can just take a look at it. Okay, so now we have the deployments contract and all. So now we need to turn that into the operator facing CLIs that basically can check readiness, plan a stack, and assemble runtime config and all those things. So let's maybe for now I'll just add the scripts commands and all, though we don't have any scripts and all, but you will get the intention of that, and we'll add those scripts right after we add these commands. So here let's basically let's add at the bottom. Okay, so for deployment profiles, we'll create this pre-flight deployment thing script. Same for stack, runtime artifacts, temporal values, and confirmation thing. And here dev dependency, we need to add this deployment package and now run through. Okay, so this I'll explain those scripts just now, but these are the commands that we will try to run. So let's now just try to run burn install so that we'll have this package deployment package installed. Okay, it's done. Fine. And now let's try to start adding one script at a time, and then let's see like how that script also looks like. All right, now the scripts. So let's open sidebar, and in this we should start adding the scripts one at a time. So first let's add deployment the pre-flight. Okay, fine. And in this again I'll just try to drive it quickly. So first let's import the things that we need from the deployment package and the child process spawn sync and the net to basically for the live probes and running the commands. And then the arguments that we'll be trying to pass for the CLI, so profile, JSON, list, and check, env, and live things. So those are the CLI flags that we'll be trying to pass in, and a few helpers on the interface, for the results and all. Just I'll add it. So live probe result is this shape, like each live probe returns like a check ID, and then the status is a pass, fail, or skipped, and detailed string and all. And then few just the ones which will pass the probe result and all. So for the same for failed and skipped as well, I'll just try to add this functions. Okay, let me for the skipped. And now the error message, just trying to normalize the error to a string. So this is the helper, and then the helpers to the like trim and tail multi-line commands output to single bounded string for clean reporting and all once we run that this script. And similarly, let's add for a function to redact URL, so just to so that before it's printed it's redacted. That's a additional caution that we can take. And then trying to parse the host port. So here what we are doing is just passing either URL or a plain host dot port with the default port and returning a null or invalid input and all. So that's the thing. And then the function to do TCP probe. So here we'll use that net which I just created. So all we are doing is just trying to open a socket like with 5 seconds timeout, and results passed on connect or failed on timeout or error. So this way like we'll try to test if Postgres connected or like NATS connected, Temporal connected, and all those things. We'll just try to use this the TCP connector probe helper. And the same for TCP URL probe. So just calling that above helper, and here we are just passing a URL and delegating host port to that raw TCP connect probe, the one that we just created above. And same for the host port probe. And here just same thing, parsing string with the default port and delegates to TCP connect probe and all. And the HTTP reachability probe now. So before it was the TCP, and here what we do is we are trying to do a timed get and treats any like or like 200 or 400 as reachables and redacting credentials in the reported URL. So that's the helper that we are just trying to use. And now let's add an helpers to run our Kubernetes commands. So here running kubectl namespace probe. So this what it does, it runs the kubectl get namespace or client version check and maps the result to passed or failed and all. So if you know this kubectl commands and the way to deal manually, this is the way. And yep, and now finally trying to run the live probes for all. So adding here this run live probes. So what it does, first gets the data first. If it's a Kubernetes, we will run through our kubectl the namespace probe and check with commands. And then the TCP probes for Postgres here, and for Temporal, and for NATS, and then the HTTP probes for object storage and the API health endpoint, and skipping any whose env variables is unset. So that's the thing. And then to parse the arguments, let's have the helper function. So we'll be trying to receive in the form of JSON and all those things, list and all. Let's see here. So it's basically the parse arg, so just trying to default to every flag. And now we're trying to loop arguments handling. Then if it's a JSON flag value, we need to set that to true, list or check env live profile, and both profile value and forms that we have, and then rejecting unknown args. So just the simple helper to parse that. And now let's try to, so we are just now trying to get the arguments, parse this, and if we have this list, and iterating through this deployment profile ID options, and then trying to log that and trying to exit. So fine, so we're almost there. And now let's try to get resolve this contract for the chosen profile, and just trying to compute its checks. So required env variables, optional missing env variables, and optional live probe results, and all those things. So we are trying to get in here. So after that, so if it's a JSON mode, we need to console in the particular format. So this, if it's a JSON thing, we need to stringify profile, runtime, modes in this way, and required env variables, and then live thing, and try to exit and all those things. Fine. And then plain text header. So straight away we'll just add a proper console stuff, groundwork deployment pre-flight and runtime on all the values, just trying to print in the plain text format. That's the thing. And okay, and we need to add the env checks and all. So the optional env variable differences, and setting the exit code as 2, so if any are missing, so, and followed by the required checks with optional or required markers and all. That's the thing. And now when it's live, so we need to add that check too. So if it's a live, so we need to print each live probe status and detail sets and then we are trying to set exit code as 1 if anything has failed. So that's the the deployment pre-flight thing. And we can run this thing. So for example, let me just open here, let's run. Okay, what was the profiles? Okay, so we can see here, we are just trying to get the list, local compose, and all things, basically whatever we define in our package and all. And a similar way, if I try to define this pre-flight, run this pre-flight, so we can see for this local compose, we are checking it's a docker compose local, and dependency modes, it just gives all of this, and what is the required runtime environment and all those things, and required checks and all. So it's going to give us like what we need to do, checking pre-flight and make sure everything is running or not. So that's the script, simple. I think you can just refer to that and understand. And now let's create a new script for deployment stack check. So deployment stack. Okay, and I'm just going to collapse this. So here as well, let's just try to import the profiles and just the stack plan from the contract package. So this is just the thin renderer over the plan, nothing much in here. And the arguments, profile JSON on list, supported flags, and as usual the parsing JSON parsing arguments helper, if what they have passed, and we need to just set that true or not. Okay, and then a few more helpers to print the list. Yeah, just trying to iterate through values and trying to print. And now trying to handle the args, so parsing that, and if it's a list, again same thing we were doing there, and then trying to resolve the values, profile ID and plan from this profiles that we just imported. And we need to now print the platform dependencies. So let's create one helper function. So for that, so I think, yeah, we are just trying to iterate through the platform dependencies and just printing out that namespace, release, chat values, and all those values. Okay, fine. And now if it's a JSON, we need to stringify that, or else a plain text, we need to console that. This is just the pretty standard stuff. Yeah, that is the simple deployment stack check. You can run that and check, because I already ran pre-flight and checked the same way. We need to just run deployment stack, and then this deployment runtime artifact. Let's name this as artifacts. Okay, so this is again, let's import profiles, the profiles parser, and generate runtime artifacts, and then the Terraform's output types, and then nodes mk directory to create the directory, and put the values for Helm thing, and then the as usual the args profile Terraform output where to an output directory JSON and allow missing and all. So basically Terraform output path, output directory JSON and allow missing this, and the required argument check. It just reads the next CLI value for a flag or throws if it's a missing and all. So that's the thing. And yep, so pretty standard. Let's add the parse arguments function. Just now trying to handle profile, allow missing, JSON, and Terraform output and output directory and all those things, because this is required. So that's why we added that above helper, because that's where we need to create a new files and all those things. Okay, fine. And after that, let's add a function to read standard input. So it just collects the full standard input stream and decodes it to a string. So that's the thing. And now we need to read the Terraform outputs. So here this basically whatever it reads the Terraform JSON from a file or via the standard input and validates it's an object or not. And then now let's try to parse arguments and resolve the contract stuff. So arguments, and then trying to resolve profile ID, contract, Terraform outputs and artifacts. And now we need to, after this, yep, exactly, I need to create this output directory. So we need to first ensure that output directory exists, and then we need to write the Helm values YAML, and then the runtime env and a summary JSON and all those things. And that's what we are just trying to do. Pretty standard of creating a file and ensuring the directory exists, and then creating a file inside that directory. Fine. And then we just need to now console based on the profile. So if it's a JSON, it just lists the produced files. This Helm value is generated, and runtime env and summary JSON, and plain mode also prints the file paths and any missing env variables. So yeah, that's the pretty much thing. And here just we are trying to exit with code 2 when required env variables were missing and all those things. So fine, and you can just run this as well, these scripts. Okay, and now we're almost there, and we need to add a couple more scripts for conformance and temporal values CLI. So basically those are scripts like adding the post deploy verification and temporal config CLIs that finish the deployment toolkit and all. So let's maybe in the same folder itself I'll just add the deployment conformance, and in here let's try to add the imports that we need. We need one to spawn this. So just to we'll use this to shell out to curl for the object storage probes that need like connect to and all. And now the arguments interface. Okay, so this basically this collects every CLI flag and env derived option, base URL, timeout, agent prompt, optional sandbox, or connect to, access key overrides, the 4 skipped toggles and JSON output and all those things. Okay, fine, that was the arguments. And now for the result to check. So
this is the simple. Each check reports one structured record having an ID and status and detail, pretty standard. And then to run the next thing, require next, so just enforces that value flag is actually followed by value. And then the parse args, like, because we'll try to lean on it for every flag value form. So now let me just add the function to parse the arguments that we expect. So here I'm just trying to add same way like we just added. It'll just see the options from env variables, and then we just do arguments, applying the boolean flags and space separated and hyphen flag, so in the format that we need and all. So that's the thing. Mostly we'll try to provide it from env, but if you wanted to provide in the CLI script command, you can just add it here. Okay, so fine. And yeah, and now we need to just call that function and try to now store the results into the results. And then before that, just the standard skipped, sleep and error message helpers, and then the running the check. So here just we had a wrapper that turns any throwing async function into pass or fail result, and so single failing check never aborts the rest of the suite that we'll be trying to do. So okay, and requesting headers helpers also maybe I'll just add in. So just attaching the barrier access key when one is configured, and merging any extra headers that caller passes to us. Okay, fine. And just the helpers for me to deal with the JSON stuff. So here just the CRUD stuff, getting JSON, the getting text, just the standard HTTP verb helpers, like, so that we can use it across every check. So authenticated get stuff, and yeah, getting as a text for metrics, and post for session or task creation, and then delete for cleanup and all that stuff. Okay, so yeah, and fine. And then we need some safe JSON extractors. So this is that. So trying to use this, basically it just pulls the required non-empty string, and this record field, it just coerces the required object, the uploads required headers into a string map. So that's what we are just doing it. Okay, fine. And now finally we're almost there, and the function to wait for just, this is a shared polling helper that waits for the session to reach a terminal status within the timeout, and it'll be used by MCP tool check. So that's a thing. We are just trying to pull that, and now the just trying to turn header map into repeated -h key value and all in the format this thing flag that curl usually expects. Okay, yep. And then this we have this run curl and run like read stream until abort. So this basically what it does, it just drains the SSE body until the expected events arrive or the abort deadline fires, just swallowing the abort induced read error. And yeah, that's then including the events that it needs and aborting those things. Yeah, so text based then decode, and then the run curl just shells out to curl and throws a on non-zero exit and all, just pretty standard stuff. Trying to run the curl commands, okay, using span sync and all. All right, now we need to add a function to get object from the for S3 stuff. So here we're trying to download the object from pre-signed get URL, again with the optional curl connect to path, so the round trip can compare bytes and all. So that's the thing. And then the pre-flight fetching. So here
this normal pre-flight transport. So a plain options fetch returning the status, headers, and the body, like basically that pre-flight object put really assets on. So that's the thing. And yep, and then the curl pre-flight function. So this parses the curl hyphen I output back into a status, headers, object, and a body. So that's what we are just trying to do, and written that here with this function. And yeah, okay, so now that was about getting. So then the functions to put things. So here put object, so just uploads to a pre-signed put URL, and then falling back to the curls connect to when an override is set, so that probe can reach an internal endpoint while signing for the public host. And yeah, so that's what we are just trying to do here. And here a pre-flight object put just simulates the browser's CORS pre-flight thing, and asserts the bucket allows the origin and put, which makes in browser uploads actually work. So that's the thing that we are just trying to do it in this pre-flight object put function. And then the function to extract the latest turn dot failed, this turn dot failure suffix from an event list. So a failed MCP tool session like produces actual readable message and all. That's this thing. And now let's try to run a check for our API health. So it's one hit to our /health's endpoint and asserts like, okay, true, the cheapest signal that the service is up or not, just checking for that. That's the thing. And now access boundary stuff. Let's run the check. Okay, so this basically it checks two things. First, it reads the client config and confirm the auth required matches whether a key is configured, and then we are trying to fire an unauthenticated post and asserts like 4 of 1 is what we get, and catching any holes in the shared key access boundary and all. So that's the checks that we are doing. And fine, and then check 3 is basically for our metrics. So let's add in here. So we are trying to verify the Prometheus /metrics endpoint here, and exposes the request counter and the duration histogram. So actually a broken scrape wiring fails here instead of on a blank dashboard later. So that's the check 3. Okay, and now let's try to do a check for our session run, and that basically we need to rely on the let's try to let me just add all the checks that I need to do. Okay, for SSE events and then SSE replay and all, I'll just walk through a bit. Fine, and then MCP or tool session, and then the skipping schedule task or so. So then I'll just walk you through each of the checks that we are trying to do. Okay, let's come from the top. Okay, so the thing that we are trying here after this access boundary, so we are trying to declare the session ID, so that all the successive checks can reuse now. So first we are checking if the skip agent is set or not, so and record the 5 agent dependent checks as a skipped. Otherwise we try to run this 4 checks that we have. Yeah, and here what we are doing session run. So we are just trying to create a the real session, and then trying to poll until it reaches idle. So that's what we are doing, this first session run check, and then this event replay. This check is basically trying to replay the sessions persisted events over rest and assert the full life cycle. The session created through turn dot completed is present, proving that event store wrote everything and all. So that's the thing that we are just trying to do. And same for SSE replay. So we are trying to stream the same events over SSE for up to the 5 seconds, and then the abort controller deadline, and then aside that stream carries the session and turn events, proving that live streaming works and all. So this is like extreme check at every layer. And then the MCP tool session. So we are trying to create a session with the MCP tool selected and wait for the idle, and then we are just confirming that MCP tool wiring works end to end. And on failure, we're just trying to append the turn error for a readable report and all those things. So here and then schedule task check. This is again we are trying to create a past only task for in the future somewhere. Okay, so that's what this inputs and all for that endpoint, and then trigger it immediately, and we're trying to poll for that dispatched the runs a session. So, and we are trying to wait for the idle, and then always trying to delete the task in finally, so it never basically laters the database and all. So this again check if event schedule task is working or not and all those things stuff. Okay, and now related to storage is something we need to check. So let me add the storage again, trying to check if the storage is skipped, or and if so, we are just going to go to the if section. Else we need to run the check for full pre-signed URL round trip, like course, pre-flight, port, complete, download URL, get like with a unique payload. Yeah, so and then aside that bytes match, and proving that object storage signing is correctly wired and all those things. So pre-flight object put object post thing, download stuff and all, and then we're just trying to check here. So complete round trip is what we are checking for this storage as well. And then finally just trying to console if it's a JSON in JSON format, or else just trying to iterate through the results list, and then consoling in the plain text manner, result ID, status and detail, and all those things. And if any of the checks fail, we wanted to exit. So here is the thing, if any of the status is failed, we're just trying to say that as a build failure and all. Okay, this is the conformance check, like making sure that every part of the system works on all those things. And now the one final script that we need is basically the temporal values thing. So deployment temporal values .ts. Okay, and I think this should be pretty quick one. So first let's just define the arguments. It's going to be just output that we will try to and then an helper for YAML scalar values. So just leaves integers bare, and but just trying to quotes strings. So every value like interpolated into generated YAML stays valid. So it's the just check for thing. And now few helpers to render. So this basically the config map back to CA volume and mount injected when TLS is enabled. So just we are trying to return additional volumes, and then name config map and volume mounts and all. and other helpers to check the positive integer and then boolean env values stuff. So just simple env parses, so it validates the shard count here, integer thing, and this boolean env parses the tls toggle accepting common, truthy or false spellings and all those things. So fine, and now let's I am just going to add in a function. So basically we need to render temporal values. So here we need to get the host, port, connect address and users secret name and all those things, tls enabled, config map name, config map key and all those things. And then I just need to return this generated it is generated by this script, and do not commit and all those things. And then now we need to properly return the format it expects. So let me just add that proper YAML format that we need to pass on. So let's add it here. So I'm just going to so here the server, okay, yeah, all the details, servers block, and then the both SQL data stores default and visibility like pointed at the same Postgres with the schema management on, and the Prometheus metric annotations, and disabled web UI. If you want, you can just enable that so that you can see temporal UI. I prefer enabling, but that's the default thing, but you can just change that. Okay, fine. And then the function to parse the arguments as usual. Let's try to add here, just we need to just parse the only flag, that is hyphen out, and yeah, and reject anything else. That's what we are doing. Okay, and now just call that above function, and then get the values by passing this env thing. And finally, yep, if we have this arguments out, we're just going to write the values into that, else we are just going to, so basically we're just trying to write the rendered YAML to the output path when given, otherwise we're just going to stream it to in the terminal. So that's the thing. So these are the scripts that we need for getting the temporal values, doing the confirmation check, and then pre-flight checks, and then deployment plans and all those things. Yeah, you can run this later, but pre-flight is something you can just check it out now. And now we need to add actual Helm charts and like per cloud values, what and all we need. So basically we need to actually now add actual Kubernetes Helm chart that deploys our Groundwork onto a cluster. And so that's very important. So we need to let's see, like, how what values we need and the format for each of the per cloud values we need and all. So let's add the Helm charts. So here I'm going to create node in the scripts at root location, say the deploy folder, and create Helm folder, and inside that our Groundwork. Okay, so here by default you can just use Helm create and all, and name of that as Groundwork, and it's just going to give us the chart dot aml and the templates folder and helpers.dpl, just the boilerplate and all. You can do it that way, or also you can just add it in this way, anyhow, whatever works for you. Okay, first let's add the main thing, the chart dot yaml, and here basically just the standard things that we need to specify, the API version and the name of our chart and all those things. So it's a Groundwork So Groundwork API, web worker and migration workloads. This is a type application and the version of our chart and app version. Okay, so that's the first chart thing, and now we need to add the values dot YAML, and here basically we'll try to add all the default values that we will need, and I'll just add and give you a walkthrough here. So yeah, so this basically the control plane, the whole chart basically references. Okay, so it is default images and replica counts, resources, and the config values, stuff, and secret, external secret, enabled or not, API, replica counts and strategy, image, Groundwork API and all those things, and requests, then security context, node selectors, readiness, liveness check, startup, the auto scaling, and then same thing for worker stuff, doing it in the same lines, and then for our web stuff, and yeah, and then migration stuff, Groundwork API, so trying to run DB migrations, and then Postgres, spinning up infra related things, pgvector, and database username and password, and the temporal auto setup stuff, service port, gRPC thing, and Postgres for that history database, and resources, request, min.io for our object storage and all those things, and then ingress to allow the for our web API and health checks, and the NATS again for our live stream event streamings, okay, and observability Prometheus stuff and all. So these are the basically secret names. So every template now will try to define, will read this values from here. So it's defined like before anything that uses it. So that's why like we are creating all the default values and that stuff if we have not created exclusive values.yaml, and so that it can fall back to this file. Okay, and now let's define the templates, and here let's define helpers, partial templates that we will be using by calling include this the defined name that we do. So here again this we will try to basically add all the helpers that we need and add it here. Yeah, so basically we need like, let's say now if I define a groundwork.name, then I can just call in my templates include groundwork.names, and then it will default to this chart.name, and it will truncate to 63 things and trim the suffix and all those things like that. So same for this groundwork full name, and just trying to end in, and groundwork labels, groundwork selector labels, and all those things. So this is the shared named templates, like we have full name, common labels, and selector labels, and image references that every manifest now calls with like include and all. It's like I just mentioned, so they can reuse it and all. So that's this just trying to define all the things that I need instead of duplicate adding it into our files. So now the templates, we have a lot of stuff to add. See, service account first. Let's this basically I think should be quick. I'm just trying to add okay, service account thing. So let's just add the one. Okay, and ignore this error, whatever you're seeing this, fine. And this is basically the pod identity. So deployment basically will run as like service account for role-based access control, and then cloud IAM like for the workflow identity. So it exists before that can use it and all. So okay, so that's the service account stuff, and then the config map.
Okay, so this basically all non-secret stuff and all will usually try to configure in this config map stuff. So here that what will be injected into every pod as env, and usually it will be used by our API or web or worker deployments via this env from. So that's for like whatever we need, mcp url, nats url, and then open telemetry endpoint and observability related stuff and all. So yeah, we'll try to define all the values inside our these things. If not, try to get this from the partial templates that we just defined, full name, and again from the values. So this is the config map. Okay, and then the secrets thing now, secret.yaml, and here basically the in cluster secrets and all that we need, we'll try to store it here. So yeah, and again they will try to mount it deployments via env from. So this the format basically that we'll try to pass in their reusable things like key and value, and then accordingly it'll set that secret that we need and all. Okay, this extension is you can just install for Helm and all, and then you should, so you can search for so yeah, you can just install this. And even this Kubernetes stuff and all, so that for the YAML help and all those things, it will help you and all. But I'm least bothered, but I'm just letting you know so that the syntax and also now you see it is gone and all fine. So yeah, and that's the secret stuff. And now the external secret, the template. So let's add external secret.yaml, and in here basically it's an alternative to secret.yaml. So external secret, they prefer to use vault or other secret managers and all those things. So that syncs values from a like that cloud secret manager. It can be AWS secret manager or GCP equivalent and Azure, so into our K8 secret. So we either choose one path or the other. So that's the thing, we'll configure that in our values, and then we'll try to extract here and trying to do the same thing here, just the external secret stuff. And now the Postgres related secret. So let's create that YAML file, and here basically for our in cluster Postgres. So this is the like the secrets for our Postgres password stuff that we need for our database. Okay, and then the stateful set for our Postgres. So stateful set YAML file. So this basically let's add and then give you an idea about what this does. Okay, this is basically the optional bundle database. So stateful set, not deployment, because it needs stable identity and the persistent volume, and it will be basically gated by this values.postgres enabled when we basically that will be off, or when we
pointed at like managed RDS or Cloud SQL and all those things. So that's this the stateful set, and just trying to provide values that it needs, and then readiness probe, liveness probe, and all just standard checks. And the volume claim templates here, if it's enabled, we'll just bundle that in our in cluster itself and attach that. So that's this stateful set. And then the for our Postgres service now, so let's add the service ML thing. And this basically this is just in cluster DNS for Postgres, so the app now can connect by name or not pod IP and all. So that's the thing. So type cluster IP and name is Postgres, and then port and target port is Postgres, and the selector for this ports and all. So and you should be clear about the ABCD of the Kubernetes and the format, like kind, API version, and those things. What is pods, nodes, deployment services, and stateful cells, and all those things, ingress and all those stuff, network types and all those things. Okay, fine. And that's the simple Postgres service. And now let's add next infra stuff, which is NATS stuff. So NATS deployment.yaml, and here so this it should help us to deploy the NATS in our K8 cluster. So adding in here this thing again, this is a bundled event bus, so stateless. So deployment will be again gated by this NATS enabled or not. Same deployment replicas will take it from our values, selector, template, and containers image will just again pull it from our values, and image pull policy, ports, readiness probe, liveness probe, and pretty much if it's enabled or not. So gated by that value for NAS deployment. And once we have deployment, so the service, so let's create NAT service YAML file. And here again same thing, stable address for NATS, the type is cluster IP, and same is we can just call it by name and connect the ports. Okay, fine. And then the network policy for NATS. Okay, so this is just a firewall for NATS, so that only we wanted to restrict that only app tires can reach it. So that's the thing. So it basically tries to live next to the service it protects. So this network policy, and if network policy enabled and NATS enabled, only then this applies. So network policy and pod selector, and this ingress from this APIs and workers, only app types like API, worker, and web, and all those things. So we'll be able to reach it and all. Okay, fine. And now for our storage related thing, the min.io secret YAML, again here just the access key and secret key for our optional bundled min.io defined like so that stateful set and bucket job needs these values, and we'll try to refer it from this min.io secret, the name that we will try to define from our template helpers that we are defined, and this access key and secret access key can be referred from it. So now let's create a stateful set. So stateful set, so this is the optional again object storage in cluster itself. Okay, so this is basically stateful set will have the persistent volume claim, and just again gated by if this is enabled, and it'll be off by default if we prefer S3 or GCS or Azure Blob and all those things. So same, just standard template metadata container attaching that ports, environment variables, readiness probe, liveness, and volume clean templates, attaching that read write ones, and then attaching to the volume for persistence and all. Okay, fine. And only if you're using local min.io, so that in cluster storage is something volume that will try to provide. And now the min.io service. Okay, again this table address for min.io for pods to directly use by the name. Yeah, I'm just leaving here. Yeah, that's the min.io thing. And then we need a bucket job. So min.io bucket job ml file. So basically this file kind of like what it does, it's like one shot job that creates the bucket basically after min.io is set up, like infra is up, so that we know that storage will not be usable until that bucket exists, right? So this helps us to create that bucket once that is up. So this bucket job batch v1 kind, it's a job, and then back off limit, and then the containers, pretty much the standard image pull policies and all those things. And after that we are just trying to create this bucket that we want and try it in this loop. Okay, fine. So that's this thing. And if you want details explanation of everything, you can just use AI that we have and learn more in depth about that. And okay, fine, storage is done. Now let's add about this temporal. So temporal deployment stuff. So basically we need to first add all the infra related stuff and then come to our app tier. So here this temporal deployment related things, this again optional bundled temporal server here, that's enabled. So this is a durable workflow backend. The worker will be usually polling it. So and this pretty, you can refer to its temporal official docs and all, or the YAML structure and all for the container of that. So what it needs, the ports and env values and db postgres password seeds and bind and ip, readiness probe and liveness probe and all those things. So this is if we are preferring in-house rather than relying on temporal cloud or something else. Okay, then the temporal service, let's create here. Okay, so this is again stable address for temporal's front end, just grpc 7233. So the worker can usually reach it with the name and all. So cluster ip again, name grpc, port just exposing that, selector labels just taking help of the template helpers that we have. Okay, fine. And now I need an helper for migration job. So migration job, let's create. So this basically the file which helps us to run our db migrations. So let's add here. So again, if migrations enabled and API is enabled, so it's a Helm job basically that runs the DB migration around rollout usually, and then defaults the value.yaml annotates it to this to helm.sh hook. So yeah, okay. here annotations, fine, and then post install, pre upgrade, and hook wait, like so on upgrades it runs and completes before the new app pods usually roll. So it uses the config or secret via this env from, and so it's placed after these config maps and secret maps are created and all those things. So yeah, so we are just again using extensive the help of the reusable templates that we have, and yeah, that's the job. And resources, migration resources will try to provide from our values. You'll see this, okay. Fine, and now let's switch to our app tires. So first is this API deployment stuff. So the API deployment basically pretty first of our the app tire that we need. So that's the where all our REST APIs and MCP server and all will be try to host it. So just Hono server parts like pulls config and secret from via the env from stuff. Here this container trying to use our groundwork image, the name that we'll provide, and again all these checks and those things, and runs as a service account. Then the core workload, everything that external talks to, and all those things. So yeah, I'm just leaving it to you, just you can check the same. And now once we have that, the standard is API service stable in cluster address for API ports. So let's create API service thing. So I'm just adding this template format that we need. Kind service, metadata, labels, annotations, just attach in here the spec, type, service type, and ports, and then select under. Yeah, fine. And then we need API horizontal pod autoscaler. So let's add API HPA ML file just to autoscale on CPU or memory usages and all those things. So let's add in this thing. So autoscaling v2, okay, enabled, and kind is HPA, and name and labels. So yeah, target ref is deployment of this APIs. So min replicas will just provide in our values, and metrics is basically the CPU utilization. So if average utilization reaches this percentage, which will again will try to specify in values, then it will add more pods for us, so that easily we can scale as traffic grows and all those things. Okay, fine. And the networking policy for API thing. So network policy, so again this is firewall for the API type, and defines like who can reach it, ingress, and where it might go. Basically DB, NATS, min-io, temporal, that's infra stuff that we have. So that's the thing. I'm just trying to define here ingress and egress. Pretty standard network policy, name labels and ignore the port selector, match labels, policy types, ingress, and the from which port it can reach, basically yeah, and where it might go, which is egress here that we have. Okay, fine. That those all will define in values. I'll provide an example for that. And now the main thing, ingress thing, the main entry point into our cluster. So ingress.ml, I'm just defining here this. Let's add the kind, this ingress stuff. So this is very important because that's the actual entry point in the cluster, which routes external HTTPS traffic into like to the API service. that's one door from the like outside world to access that stuff. So here we are just trying to add this host paths and how which part and all it can reach and all those things, the service and all, just hyphen that service which will provide the values and all those things. So you get this intent, right? So that's an ingress. And now we're done with API. Let's add web related stuff. So web deployment now. So let's create that file, web deployment. So this basically that is what the React SPA will be exposed to the browser, and we can start using it. So that's the thing. So I'll just add all the things that it needs. So basically just the standard metadata name, and here is the specification, service account name, then auto mount service account token, and then containers or groundwork image attaching with the image name, and then this node selector, affinity and tolerations and all. So just pretty standard thing. And we have this deployment and now the service. So let's create web service thing, and this is again stable address for our web ports. So just simple standard thing. And now same thing, we need to add HPA for our web. So like we added for API, so let's add HPA for our web. And inside this, simple based on same resource utilization, it's just for now the web thing. Yeah, I'm just okay, fine. And the network policy as well for this, so pretty standard like we added for API. So I'll just quickly add web network policy, and that is again, yeah, kind of firewall like already explained in API for our web tier. That was for our API tier. And just ingress and egress from home and all those things, this the that we have. Okay, so API is done, web is done, and now it's a worker. So let's add a worker deployment YAML, and here as well same thing. Let's add the temporal worker that helps us to pull that task queue. Okay, so basically the one that runs the session workflow plus activities and all. So here, yeah, just same replicas count strategy selector template, yep, and the containers, yeah, pretty much image pull policy, env from liveness probe and those things, and topology spread constraints, node selector, affinity and tolerations. Just no service, it just pulls temporal outbound and nothing dials in. So there's no service or ingress for it. So that's the this worker deployment. Now just HPA, very important to scale our workers. So worker HPA YAML file, and this one just the autoscaler for worker tier. So again, it scales on basically the concurrent sessions that will be running. So we will specify CPU utilization percentage, pretty same for all API HPA, web HPA, and this worker HPA that we have. And just now the network policy for this worker. So let's add the worker network policy stuff. And so this again firewall for the worker. Basically what we should do is just egress to our temporal or DB or NATS or sandbox. That is the thing. And ingress, there's nothing, so I'm just adding it as an empty array. Fine. So that's the network policy for our worker. And then the we need to add the network policy for all of our dependencies thing. So like for Postgres, NATS, MinIO, and Temporal. So let me add that. So dependency network policy. Okay, so this basically it's like consolidated firewall for the dependency tier. Like I said, all this infra that we have. So that basically what it helps us is just logs them so that only the app tiers, API, web, and worker that we have can reach them. And so that's the only intent of this network policy. So here port selector and ingress from this port selector, API, worker, migration, and temporal, only they can reach this infra related stuff. And again yeah, for the temporal and for MinIO. So for all of those things separately as part of this thing, so multiple can be added in this way. So that's the this dependency network policy. And then the open telemetry collector pipeline config we need to add. So let's add inside this open telemetry collector config map thing. So this basically all the like receivers and then processors and exporters and all, we wanted to define everything inside this file. So let's try to add in here. Okay, so yeah, so name and labels as usual, and collector, then the receivers, protocols, Prometheus, and then processors, and those things. Okay, and then the finally the exporters that we have here. So that now the deployment can use it to mount it. So now let's create that deployment file, collector deployment YAML file. And here basically this just the collector pods that we will use. Basically this will be used by every service basically that ship traces, metrics, logs, and everything will be here, and it fans them out to our backend. So that's the this deploy open telemetry collector. And here the containers open telemetry connector, and then image will specify in our values thing, and pull policy and the ports and mounting of that and volumes and all that is thing. Okay, and we have this deployment same. Now we need to add the service. So open telemetry collector service YAML file. Okay, same again, standard stable open telemetry endpoint. The app pods usually send a telemetry to, so that's just the cluster IP and all those things like we added for our app types as well. And yep, okay, yeah. And now I need to add service monitor, kind of like helping the Prometheus and operator glue. So let's add this service monitor. Okay, so this basically like I said, it's just a glue between Prometheus operator. So it basically tells Prometheus to scrape the apps slash metrics endpoint, and then optional just needs the operator CRDs and all. So that's what this does ideally. And just labels name, and then endpoints metrics path will define that and the values. Then you will see. Okay. Yeah, and let's add rules for alerting, so when to give us alerts and all those things. So again, that's part of the Prometheus rule YAML things. So here basically what we will try to define is just the alerting rules. Just error rate, latency, saturations like will be evaluated by Prometheus, and operator CRD gated. So if it's enabled, so monitoring CoreOS v1. So here name and things, and here rules, Groundwork API error rate like for 10 minutes. Then we need to like throw this alert, and same thing for latency stuff. If it's above 5 seconds, then we need to know what's happening and all. So that's like a couple of rules, and we can add later what if any other critical things that we find. Okay, and the important thing now, pod disruption budgets thing. So here let's add the pod disruption budgets. Basically this helps us to keep a minimum number of pods alive during node drains or upgrades. So a rolling cluster op can't take the whole our app tier down and all. So that is the thing that we are trying to add here. Our types basically app, web app, API and worker. So this is the web thing and worker and the API stuff. So just the policy one pod disruption budget. So making sure that minimum available will specify in the values, and it'll so that our system will never go down. Okay, fine. So those are all the templates and all that we need. And now let's try to add a simple local Kubernetes example values file that I was talking about, so that we can at least try to see Helm in it, and then try to run in local. How basically this values helps us to generate Kubernetes objects, that is the resources, to by populating these values that will have into those templates that we have. Okay, so I'm just going to add the simple example. So let's maybe close this templates folder, and in here add maybe values dot local Kubernetes example dot YAML file. And here basically just you can the whole stack on local K, it can be minikube or kind with all in cluster dependencies enabled, and just like so API replica count, image strategy, and same for worker, and web migrations, secret config what it needs, Postgres, temporal, NATS, MinIO, ingress, and observability and all. So like this, I'll just add for other clouds as an examples quickly. So for AWS, let's add AWS managed dot example YAML file. So pretty similar, just some of the managed services. So here we'll just disable the bundle dependencies and point out basically managed RDS, S3, MSK, and secrets via the external secret like AWS secret manager. Just cloud native backends, that's it. Okay, so image registry is something, account ID, like we need to log into our AWS thing and get that account ID and secret access key, and then we can later use that to deploy. But I'll just showcase local Kubernetes and Docker, so that should be fine. Anyhow, other thing is just you need to log into those account cloud specific and get those credentials. Okay, this API image details and worker image migrations, image and service account secret, it's a false because we are using the secret managers thing, and external secret yes, and this is what we'll use. Network policy enabled yes, Postgres false, we'll use RDS.
temporal false, and here we are assuming temporal cloud or somewhere we are trying to host and get that. And here this same for NATS not enabled. So basically all in thing is disabled. So config all the details that we need, and ingress it's enabled, and the paths just trying to direct it to web, and v1 is API, health API, observability stuff and all. Okay, so that's for the AWS, and just these are all example things, placeholders. Okay, so now for GCP stuff, let's add in, yeah. So for GCP also similar format, it's just its own native alternatives. Okay, so here also pretty standard stuff. Just instead of using RDS and all those things, it'll have managed Cloud SQL and pub sub or NATS, whatever, whichever we prefer, or GCS equivalent. So I'll just leave it to you so you can just check it out, this stuff. And the same for Azure. Let's add in values. Azure managed example YAML file. Okay, so these are all just whatever the stack you cloud is adopted, that's just an example here. Yeah, pretty much it's just Azure fully managed services. So now Azure blob storage, Azure related compatible Postgres stuff and other things, and here I'm just trying to leave it to you. Okay, so that's one thing. And and maybe for Azure, let's say existing services, let's say we have, and we wanted to bring wire it to services that we already have, like for example DB or bus or store, then our chart can still adapt to that same things. So for that also I'll just try to add an example. So Azure existing services YAML. So let's try to showcase here just this example so that you will get an outlet stuff. Okay, so then you can see here NATS, it's enabled false, and then other stuff. So you can just check, just trying to use our own things instead of configure thing. Okay, so that's the thing, and we're almost there, the Helms that whatever we need. So now we can just try to run Helm in it, and first let's check the lint thing. So let's check if the format and all that we have, it's all sorted out. So just specify the Helm that we have. So you can see one chart linted, so what and all we have, it's been, and so everything is fine, so nothing is failed and all. So now basically I can try to render the full example things. So it's just let's try to see how do we populate the values into a template so that it generates Kubernetes resources or objects. Okay, so Helm template, and use our groundwork, and then point it to our local where we have that chat. So groundwork, and here the values, basically let's point it to our local Kubernetes stuff. So file, I'm just trying to give the files path. So values local Kubernetes example YAML file. Okay, so now you can see basically it populates all the values that we have for each of the things that it just prints out here. So it's a Minayo bucket job, and this is I think should be migration job, and all these things. So just to see if it's populating the values that we specified in that file, is it getting populated correctly or not, and just try to debug and just thing. Okay, so we have this Helm charts and all properly wired up and all. Now we can use it to check if it's templates and all those things are fine. All right, so now we have that things. So now we need to work on the Terraform stacks. Now basically that's what will help us actually to provision the cloud infrastructure that Groundwork will ultimately run on. So here also again we need to add cloud agnostic. So for AWS, Azure, and GCP, so let's try to add for them. So same in the so let's just try to collapse this terminal, and in this deploy folder I'm going to create a new folder called this Terraform related things now. So let's yeah, so in this basically and also like in the git ignore, once we like push it to our GitHub, make sure that Terraform state and .terraform, whatever the Terraform plan or Terraform init or Terraform validate or Terraform apply produces doesn't get committed the sensitive related details, you can just add it. So I'm just FYI. Okay, so fine. So the Terraform. Okay, now let's focus on one thing. First provider, AWS. Okay, so we'll just try to group it by provider, AWS, GCP, and Azure later. First this AWS, so versions Terraform. Okay, so this basically now I think should be fine in, easily understandable if you know already Terraform's at least ABCD of that. So it just declares the Terraform required version, so we need at least this, and provider sources or versions for AWS stack. And basically when we try to run and of course this throws an error because I don't have variable set. So this, when we try to run Terraform init, it reads this first to know what to download. So its foundation will be strong that every other file now needs. Okay, so okay, fine, I need to add now variables. So let's add this variables this Terraform. Okay, so here we need quite a few for our overall all the infra that we'll be trying to configure on our AWS. So let's add here. Okay, so this basically input variables, the name test prefix used for AWS resources created by this root, and that's the thing. And then the standard, the region, which one defaulting to US East 1, and then the tags, anything to created AWS resources, and deployment phase. Just because this bootstrap creates this yeah, you can see the description that should explain what this thing. And this network for VPC settings, we'll see virtual private cloud, and this is for our EKS Kubernetes cluster and node group settings. And this boolean to force delete or not, ECR container registries, that's where Docker images that we'll try to store. And this is for Kubernetes workload identity, service account, like allow to assume the IAM role through this IRSA. Okay, and then Postgres mode, so like trying to use for the RDS Postgres SQL. Okay, and yeah, validations stuff and all. And then temporal endpoint settings stuff, again validations thing, object storage related stuff and all. Okay, so this is the things like now the main.df and output.df will reference this via this variables dot that names that whatever we define. And I think by now in versions we were referring to region and also like that. So we'll use all of this. So that's why like all the inputs that are needed we'll just try to define in these variables. Okay, and now this main file, so let's add in this main.tf. Okay,
this is the entire stack. I'm not trying to divide it by modules and all those things. I'm not trying to complicate that anything. So just trying to add it in a single main.tf, just to keep it simple. But that's not recommended. Always try to group it by module, so that if let's say we have the staging, the production and all, it'll be easier to reuse them. Okay, so here I'm just trying to define all the things that I need for our AWS. Just the I'm not talking much about this jargon. Everything is detailed already there in its documentation. Just how to use it is something. So AWS stack, so basically networking stuff, the VPC, plus all the subnets that we need to create and all those things, and then the just the route tables and all those things, and then role stuff, and then EKS cluster, and then we need to have this managed node groups, plus this EKS node groups that I'm just taking, and the all these things are needed, and then again EBS volume stuff related resources, and then the ECR registry, that's where we'll try to store our Docker images and all those things, and S3 bucket files and all those things related stuff, and then secret manager for our storing secrets, DB subnet group and security group for Postgres, and then Postgres from VPC, and DB instance for our Progress. So this basically assume like these are all the entry point, and just in a standard thing, and you can just see what each resource variables it's needed as input and all those things. It's detailedly documented in its Terraform documentation. You can just refer that, but the intent is just to give an eye level things, so just to how do when we try to work on infra or backend or providing reliable services, how Helm charts and then this Terraform configurations and all needs to be provided. Okay, so that's the main thing, and then the outputs, the Terraform. Okay, so here basically this is the thing, once we run this Terraform applier, whatever it is, what and all values we need after resources are configured in our AWS also. This file gives us all the values that we expect out of it. So the cluster endpoint, and the registry, so the EKS cluster name, repository URLs, runtime secret name, and then Postgres host, temporal host, and then object storage backend, bucket, and then the values, this thing, whatever we have defined in our main.tf local variables, so repository names, API worker, and then temporal host and all those things. These are the values that we need. So once this is done, configured, this outputs gives us all of this resources created in that main.tf, and basically this is what will be used by actually runtime artifacts, CLI, which we created the deployment screens to render that Helm values and all. Okay, so that's the thing, and just maybe an example values for inputs variables I can just create in here, placeholder. So Terraform tf variables, let's add in example. Okay, so here we need to just whatever the variables that we have, let's just try to add in the examples here. Name prefix, region, deployment phase, CCR first delete, and tags, and Postgres mode, temporal, and object storage, and all those things. So whatever we have, just think this is what we need to copy into actual terraforms.tf variables, and then we need to fill in our actual values. And all, ideally that will be getting node, so you just need to configure that because those are all secrets and all. So this is the example that gives you at least the layout, the template that needs to be followed for terraform.tf vars. Okay, mostly
that's the thing. And we can basically now try it out. So for AWS, I know we need account ID and all, but still we can test it out without no backend and all. So let's see this. Okay, let's see. So this Terraform, and here the directory, I need to change this to deploy Terraform AWS and try to initialize this backend false. So you can see, so it's initializing provider plugins and then AWS version, and then installing this Azure AWS things that we need, all the versions that we mentioned. So this will help us initialize. After that we can just validate the format and things and all, and the main commands is basically terraform plan, terraform apply. That's what will help us to know what resources will be created in our cloud, and then apply will basically implement that plan. But those needs actual account ID and access secret key and all. I'm leaving it to you just now. So let's now try to check the format if it's correct or not. So this basically gives you confidence that they are all correct and working scripts. We need to configure these respective credentials for that cloud, AWS account ID and secret access key, and then we can actually create these resources in our cloud. So now let's see this format. Outputs, it's throwing me an error. Okay, let's check on this thing. Outputs. Let me try to run this again. Okay. Then let's try to run now, validate, so that we know what's the issue. Okay, configuration is valid. This format, I'll just check on that. But the intent you get, so this is the thing. And then after that, if we have creds, we just need to run the plan and apply commands and provide the variable file, attach terraform.tf where's whatever it is, and create infra in the cloud. Now let's try to do the same for our Azure and the GCP stuff. And formatting, just ignore that, because just the formatting styling in our code, validation is important. Okay, fine. Let's collapse this completely. Okay, and here now inside this I'm creating a new folder called Azure, and inside that let's add the first thing, the versions.tf, pretty similar that we added for AWS. So first thing, just pinning the Terraform core version to 1.13, and we are just trying to declare one provider this stack needs, which is Azure RM. So basically when we try to run Terraform init, reads this first to download the matching provider 4 and allows updates, but not a breaking 5x or whatever it is. Okay, and yep, so just getting started. And now add our provider Azure.
So just we are configuring the Azure provider is features is required by Azure RM even when empty. So it's a block where provider wide behaviors like how to handle resource group deletion and all those things would be toggled here. Okay, fine. Now after that, variable stuff. So let's add in variables thing. First thing, as usual, the name prefix. So I'm just adding this variable. Yeah, just naming of every Azure resource, this module whatever we will be creating, so that so a single value, like for example keeps AKS, ACR, key vault and storage names consistent, traceable. So that's why like it's always important to add a prefix so that we'll know these are all resources created by Terraform and all. Like let's say we have a lot of stuffs in our cloud and all, so this just like, and this regex validation is basically enforces like DNS Azure safe naming lowercase start 3 to 31 characters, because several resources like ACR and storage accounts reject uppercase or leading digits or hyphens. That's why like we are trying to be extra cautious. And then the location, so it was region in AWS, and here it is going to be a location. So just the straightforward region, and then the variable for our the create resource group that just toggles whether Terraform provisions the resource group or attaches to pre-existing one. That's the thing. And then if you're creating or attaching to the particular resource group, the name of that resource group, and then the tags, just going to, yeah, they just on to created resources, just trying to add for those resources. And then the deployment phase, we need variable for that. So this basically splits the deploy into two phase, like two pass workflow, like stands up the substrate like AKS, ACR key value storage that has basically no runtime endpoint dependency set, right? So while then complete additionality then enforces that external dependency endpoints or credentials are supplied. So that this gating is why the Postgres, temporal, object storage or validations only fire when set to like complete. So avoiding this everything is waiting for other thing. So it's classic there, you get the intent, right? Okay, fine. And now for AKS stuff, so here we are just trying to configure AKS cluster that runs the Groundwork agent workloads with sensible defaults here. So we have like 2 nodes and standard D4DS v5 instance VM size and optional Kubernetes version, DNS prefix, and just differing to Azure defaults whenever we omit those things. Yep. And then node pool, surge and drain or soak knobs, like default 0 means no soak, so, and then rolling upgrade disruption and all. So these are all just we're trying to configure these things. And then the key vault, so here just controls the key vault that actually stores our Groundwork secrets, DB password, storage keys, API credentials and all those things. And then ACR pull role assignment here decides whether Terraform grants AKS the kubelet identity, the ACR pull role, so nodes can pull Groundwork images from created ACR and disable it if it's like default is true. Okay, fine. And after that it's our storage layer, which is the Postgres. So let's add the variable for that. Okay, so this basically it selects between module managed Azure database for PostgreSQL, that flexible server, or an existing external server for Groundwork's primary data store. So that's the thing. This what it does. And the validations basically enforce like mode in managed and external stuff, and it requires the password to be of this at least 16 characters and all those standard validations and all. Okay,
fine. And instances, b standard b2 SKUs, 32 GB storage. Just trying to set that default values. You can see that. And then PG version 16 and all those things. Okay. Yeah, that's the Postgres related stuff. And now just related to Temporal. So this basically pointing our groundwork at its temporal workflow backend. So either an Excel cluster or the bundled official chart upstream Helm deployment that we'll be doing. So then the task queue is basically default groundwork runs TS and namespace must just, yeah, that's the simple the temporal variable stuff. And then now related to object storage, where we'll just try to use Azure blob storage, and again, or these self-managed or something like that. So here this is where we store all our file artifacts, like defaulting to basically Azure blob account or an external Azure blob or S3 compatible target. So that's the thing. And others you can just see others defaults things. We are just trying to set this thing, and just normal validation, it should be the Azure blob S3 compatible, the API value and all those things. Okay, fine. Those are all the things that we need. And now let's go to main.tf. So that's where we need to actually add the snippets to create resources, the all we need. The first, the local variables I wanted to declare here, the things that will be, so these are just the computer names plus common tags that will be reused everywhere now in the resource that we'll be using. So that's what, like, we know because they have strict naming rules. And for example, ACR key vault or storage account like must be alphanumeric and short and all their internal validations. So we're just making sure that taking care of all of those things, and we are just stripping dashes and truncates to like 24 characters and all those things. Okay, so that's a tags, ACR name, AKS name and all those things. Fine. And now let's try to add the data block. So first okay, so this read only just lookup, not a created resource of like of whom we have authenticated as. And that's the just the thing. And now the resources group, let's add all the things that we need. So this resource group, the container, basically every other resources usually tries to live in. So and here the count basically makes it optional, so we can deploy into an existing resource group also. Okay, so that's the thing. And then the container registry, let me try here. So this is just the private Docker registry that our workload images push to, and admin enabled is basically false, basically forces our back auth instead of the shared admin password and all. Okay, fine. And then Azure Kubernetes cluster resource, let me just add this thing. So this is the basically actual AKS cluster spin up that runs our groundwork. And here we have the OIDC issuer plus workflow identity or on. So basically so on so pods get Azure identities with no secrets, and then the system node pulls is sized from the variables which we will try to configure. And then Defender is basically wired in optionally just via dynamic block and all. Okay, so that's the standard AKS thing. And now add a role assignment resource. So this basically grants the AKS kubelet identity, the ACR pull role on this registry. So without this, the cluster literally can't pull our images. So that's the thing, we're just trying to give that permission. And now related to key vault to store our secrets and all that stuff. So this the secret store, and this is our back authorized, so tenant taken from the like client config lookup, and this is what the actual Helm chart's external secret path reads from. And that is this key vault for. And if you're using Azure Postgres SQL thing, flexible server we need to configure. So this is managed Postgres server, and this will be only configured if basically mode is managed. Otherwise we just point at our own DB and all, and other things, the standard default things we're just configuring. And so the next is basically this is the actual Groundwork database that will be created in the above server that will be configuring. So that's the this thing stuff, and we need to add some firewall rule and all those things. So let's add this, just opening the range allow Azure internal services. That's how like AKS will try to reach the DB and all. And and then let's add the custom firewall as well. Okay, so this is extra caller defined firewall rules, like for each or a map. So for example, let's say we have our home Wi-Fi IP or like office IP for admin access and all those things. Fine, and now we need to enable the Postgres extensions that our Groundwork needs. So here we need the pgvector, the RAG embeddings, and pgcrypto, and then btregen. So then that's why like document search now works on managed Azure Postgres. So configure that specific Postgres flexible server with pgvector, and then name Azure extensions, and then what and all we need to specify here, so that extensions that will be installed on that managed server. Okay, now the storage account thing. So let's add in this resource stuff. So this the storage account basically backing object storage, that's a blob. So and yeah, the others just count, name, account tyre, and blob properties, retention policy, and container delete things, and course rules, and all those things that we are just trying to manage. And then the we need to create the container. So this is the private container, the bucket basically inside the account where uploaded files actually will land in. So that is this bucket creation inside the container, and mostly yeah, this is it that we need. And now the other final thing is basically outputs thing. So here every output we need, I'll just try to add quickly, and they should be self-explanatory: resource group name, and then the AKS name. So and then the AKS issuer URL we need for workload identity, and then the container registries login server, and then that ACR's pull role assignment is enabled or not. Okay, and then AKS kubelet object ID just exposes that kubelet's identity principal ID as an exact grantee for our manual ACR pull assignment. Okay, and after that key vault name for secrets and the stuff, and then the Postgres host important, we need that. So this, and then the temporal host, temporal namespace, and temporal task queue, and all those things that we need. So temporal host, I've just added namespace and the task queue. Okay, and then the object storage related stuff, like object storage endpoint that we need to use. Then this backend like Azure Blob or S3 compatible and all. So this, and then the bucket of that name, so object storage bucket, fine. And then this object storage Azure account name, so this is conditional. So and same Azure connection string, let's just output this object storage thing. And finally the Helm set values, the things that we need to actually use the values here. So this is a pre-assembled map of only the non-secret Helm overrides, like image registry, temporal wiring, object storage, backend, bucket region provider. So letting the CLI like splat one object into Helm like -f set instead of like hand mapping outputs, like, and all those things. Okay, so fine, so that's the thing. And finally I'll just add the Terraform examples tf variables. Okay, so here let's add in this example. Okay, so here I'll just be straightforward. I think you can just refer what and all variables we need. I'm just configure those sample examples and all. You can just take a look at it. Okay, fine. And yeah, that's the thing. And now we can just run those commands to do init check and all those things, like we did for AWS, and it works pretty fine. So I'm just leaving that to you. And so now we need to just create a new GCP folder. So let's create here, and here as usual let's try to add this versions stuff. Same thing, trying to pin the Terraform core version, and then the provider version, and then the provider Google. Just add a project region and zone that it needs. And yeah, now once we have this, I just need to define now variables. So inside this I'll just be quick project ID. Yeah, I think if you create GCP project, it'll by default grouped by project, so we need to get that project ID, and then the name prefix for all the resources that we'll be creating through this Terraform state management, and then the resources region where this resources will be created. Okay, and then the zone in that specific region. So I'm just adding that variables, and the labels, additional labels, like we had the tags in other provider. And then the deployment phase, like I'm specified, first intra related stuff needs to be up, and then that URLs or something can be used by our app tires or something like that. Okay, and then the network related variable that we need. So just controls like whether Terraform creates a dedicated VPC subnet or uses an existing one via the create network false. So yeah, production setups you typically prefer their own network for peering and firewall control, while just yeah, we can just choose that. And now the config for our GKE Kubernetes engine, Google Kubernetes engine, yeah, bundles all this GKE cluster, node pool tuning, and all those things. So node count, max, min, and other size, machine type, and all those things. We can just have a look at that. Okay, and then registry writer number. So this just grants the writer push access on the artifact registry repo to the listed IAM principal. So like now, for example, CI pipelines or RDev or engineers can publish Groundwork container images and all those things. So this is the thing. And then GKE admin members. Let's just the IAM members given like cluster admin level access to the Kubernetes API of this GKE cluster. So basically used to get who can run kubectl or deploy workloads and all those things. Okay, fine. And now the Kubernetes workload
identity, this declares the Kubernetes namespaces or services account pair that is bound by a workload identity to basically impersonate the GCP runtime service account, letting Groundwork pods like call GCS or secret manager or cloud SQL like without static keys and all. Okay, fine. And then after that, the Postgres related details, and then temporal and all. So let's add the Postgres. Okay, so this basically selects and configures the database backend. Managed provisions our cloud SQL Postgres 16 instance, and here it's a regional HA or DB custom to 8192 and all those. Just you can just check this. And validation, the standard for deployment phase if it's not complete, and checking the mode, and checking the length of the password and all those things, host and all, just making sure that it doesn't conflict with the internal validations in that specific resources and all. Okay, so now the temporal related details variable. So here this chooses basically how Groundwork reaches its temporal workflow backend. So it's external for an existing cluster endpoint or official chart to let the stack wrapper like deploy the substream Terraform Helm chart that will have, and then default task queue and all. I think it's pretty standard across 3 cloud providers. And after that, the object storage, so by default we'll use GCS and all. You can just check this stuff. These are all the variables, and now let's open this main thing, main.tf. okay, and here as usual let's first declare the local variable so that it can be used across all resources that will be needing. Just the label, cluster name, artifact repo id, runtime, subnet name, and all those things. Okay, first the VPC, which is pretty optional. Means like we define our own subnets explicitly instead of like Google Auto creating one per region and all those things. And and after that just the subnet inside that VPC where GKE nodes actually live, and that's this resource. And then the service networking just enables the service networking API required to basically to peer our VPC with the Google managed services, for example Cloud SQL. So only created when private IP is on, so that's the thing. And then the private services, so let's this reserves an internal IP range for that VPC peering, so Cloud SQL can get a private address and all those things. Okay, and now to establish actual private peering connection, so I need this private this is what lets our Postgres be reached privately with no public IP and all. And then the runtime GCP service account, so let's create that resource. The identity like Groundwork parts assume like via this workload identity like keyless out and all. Alright, so that now the main the cluster container cluster. So let's create this resource, the container cluster. So this is the GKE cluster. The default node pool is removed, managed like separately by we'll add below. Okay, and then the workload identity pool is basically set, and private nodes are optional via this dynamic block. Okay, so now the node pool, let's add container node pool. Okay, so this is the real node pool. So auto scaling min or max, auto repair plus auto upgrade, so running as the like runtime SA like with a GKE metadata, so workload identity works on those nodes and all. Okay, so this is the cluster and this is the node pool, and this is where actual nodes will be configured. Then the resources related to artifact registry, where we'll try to push our images, just where all this workload images will be stored, and the image rights permissions and all. So let's add that, just granting writer to whoever pushes images for each or members, like typically our CI or that stuff. Okay, fine. And now granting our service account the reader, so that cluster can pull the images in our nodes. Okay, and the now storage bucket files. So this is the GCS bucket actually, like for our object storage. The public access by default is enforced off, so an uniform bucket level access, and then optional we have cores plus versioning and optional managed mode and all. So yeah, just the bucket that we need. And then the secret manager to store our env values for our runtime config auto replicator. So the this is basically an equivalent of Azure Key Vault or AWS secret manager and all. Okay, fine. And then the giving access now to our runtime service account, read from the secret access secret manager and all. So that's this thing. And the same thing, now we need to give an admin to, like, container admin, like need to grant this container.admin to named members, like for each, so that basically the ones who manage the cluster, like DevOps guys or whoever it is. Okay, and then this runtime workload identity. So this is this keyless hot link. So it tries to bind the Kubernetes service account to GCP SA, which is workload identity user. So pods basically authenticate as the SA with the no key files needed and all. Yep, so that is this resource for. And then this is runtime token creator. So it basically lets the runtime service account mint tokens for itself, like service account token creator. So basically they are needed for our signed URLs or impersonation. So that's why we are adding this resource, runtime token creator. And runtime storage admin, just granting object admin role on this files bucket, so the app can read or write objects and all. And now Google Postgres related instance, so we need to add that resource. So let's add in here. Okay, so this is managed Cloud SQL Postgres instance. And then the backups, point in time recovery on an optional private IP and all those things, pretty default things and all. And then now we need to create the Groundwork database on that instance. So this is that Groundwork database creating in for on that instance. And then the database user and password, the Groundwork connects as. So let's add in here SQL user, name and password and all. So this is the, like, the actual things, all resources that we need in GCP. So fine. And now let's create this outputs .tf. Okay, and here I think, yeah, just the project ID, region and all the stuff. So I'm just project ID. Okay, then the region, then GKE cluster name. Okay, and then artifact registry repository. I think these are self-explanatory. These are all values that we need. And runtime service account email. Okay, and runtime secret ID, Postgres host. And after that our temporal engine host. Okay, description as detailed elaboration why we need and all this temporal host. Okay, and then the object storage backend, then object storage bucket. Yeah, okay. This the bucket, and then finally the Helm set values. Yeah, so this is the outpost.tf, and yeah, that's it. And Terraform scripts that we need for all of our clouds is done, and I'm just going to add now example variables. So here this Terraform tf as example, and yeah, so I'm not showing you exactly by creating actual credentials and then trying to run Terraform plan and validate, apply and all, because that is very minimal task, and you can just configure that and then run this script. The intent is basically how to come up with the scripts and the infra stuff, like how do we deal with infra or backend heavy projects and all those things. Okay, fine. So that's this example. So I'm just writer members, GK admin members, and these things, examples I'm just added. We can just have a look at that. Okay, fine. And you can now we can just try to run the validate and all those things. So maybe let's just run quick validate command, and then, but before that we need to initialize, but I'll just try to run that. Okay, so here it's just the directory should be GCB now, so that it'll just install that provider related dependencies and all. Okay, so now I'm just going to, yeah, it is there present, and let's also initialize for Azure so that it's like we have checked for all and everything looks good. Okay, and now just try to validate. Yeah, so they're all good and all pretty much sorted, the Terraform scripts and then the Helm charts that we need and all. So now we are almost trying to like have all the code that we need for our infra configuration and all. And now yep, the things that are still pending is now like we need to maybe package the third-party infrastructure and the runnable container image that is like self-hosted Groundwork basically needs, like NATS and Temporal and all those things. I'll just try to basically the third-party stack values and workload image, and then we can just see what and all is left, and then try to wrap it up. Okay, so just let's add the Docker image, kind of like all three sharing the same Docker file. So let's open and collapse this thing, and here I'll just add Groundwork Docker file, and in this we'll just add the Docker. So this is kind of like shared foundation for all three services. So basically we're trying to copy every workspace package.json, so APIs, workers and web, and then running burn install frozen the log file. And after that, so though I have not on record added testing package and all, but I'll be committing that. You can just take a reference from there. Okay, so then trying to install the dependencies, and after that we're just copying those and then now setting this node env to production, and also drops to the non-root bun user for security purposes and all. And after that the API target, so here the API image, so it just reuses the base above as thing and exposes the 8000, and then we run the Hono API. So this is exactly what the charts API deployment will use it to run in production. Okay, same for the worker now. Same thing again. The worker basically pulls temporal outbound, so nothing dials in, so it needs no port and all. It just launches the worker process and all. Fine. And now the web build. So here all we are doing is basically, this is the intermediate build stage that compiles basically React single page application. And after that the target now, so let's, after build stage, so we are just now trying to run this command start, and this is the Docker file. Okay, and now these tags for our official NATS and Temporal and all those things needed. Basically when we try to run Helm install, these values will be picked by that. So I'll just quickly add first thing official NATS values. So just it will be available in NATS Helm charts values. You can just browse that and check it out. And here let's maybe just create the same file. So official NATS values YAML thing, and here I'm just going to, yeah, so just give you, so you can just refer to this URL and you'll see that. So configuring cluster enabled false, jetstream false, merge and service ports, NATS monitor and container resources request and limits, and then pod disruption budget and NAT spokes and all those things. Okay, so that's the NATS thing. And then for official the temporal Postgres values, so values dot example YAML thing. So for this let me just add in values that we need. Okay, so here I have just added the commands as well. So this is go.temporal, I will get that. And here basically this is for upstream temporal chart, just wired to an external Postgres, like no bundle DB and all. So that's like it defines basically two data stores. The temporal requires basically default, which is history 1, and the visibility, both pointing at our like managed Postgres file and existing secret and all. So this is the SQL thing, and then visibility thing, like with 128 history shards, and schema managed through Helm books, and temporal web UI by default is disabled. If you want, you can just enable that and all. Yeah, this is the for temporal Postgres that we need. And okay, and then I need to add in a temporal namespace job. So let's add that. So official temporal namespace job YAML file. Okay, and this is basically temporal basically doesn't accept workflows until a namespace like exists. So for that we need to create a namespace ourselves, like the default one at least. So that is the job that we needed, this one. So I'm just trying to add this YAML.
Okay, fine. So that's what. So this idempotent job, what it does basically, it just runs temporal operator, namespace describe default, uh, and or like basically create default, so against the front end or describe a state. So basically rerunning the install is safe. So it uses official admin tools image and then auto cleans 24 hours after finishing this TTL seconds after finished. Okay, so just making sure that the namespace is created, and that's what this job is for. uh, and then the network policies is something that we need to add for our Groundwork platform. So let's add that. So Groundwork platform network policies. Okay, and so let me add network policy for our temporal front end ingress, and then our NATS thing. So I'm just adding for NATS and temporal here. So just I think should be straightforward. So basically it first thing is NATS. It locks NATS down to like default deny posture. Basically only pods labeled with like component in API and worker in the Groundwork namespace will be able to reach it on like 422 and 8 222, sorry, 422 and 8 222 thing. So nothing else in the cluster can touch this message bus. That's this networking policy for our NATS. And the same for our the temporal ingress, the same lockdown again for temporal front end. Only API or the worker can reach it on 7233, and every other workload is denied. So that's this policy. And now basically what we can do, it's let's try to run. So let me expand the terminal, and let's just try to first let's run this lint. So deploy yeah, so there's no issue. And then let me just try to run command. Okay, so basically I'm trying to run template Groundwork, and then attaching the namespace Groundwork, NATS enable true, secret create true, and secret dot string data database URL I'm attaching here. Just this placeholder, and then temporal host and OpenAI key. So let's see now. So you see now it's okay. So basically this proves that they are working fine, and we can use them to deploy to production into whichever cloud we have. And so we're almost done, and wrapping up everything that we need, code for our infra deployment, and then basic all the packages that we need and all. And just the couple of fixes before we try to see the actual end-to-end from UI. So because I was testing before I know, so the fixes I identified while I was trying to test. So in the runtime package, so let's try. So let's go to our this runtime source. I just need to basically create a tool here needing approval for irreversible change. Okay, so that I need to create a tool. Let me just maybe add in this thing, and yeah. So I'll just add maybe somewhere. Okay, anywhere should be fine. So let's add, yeah, I'll just add here. Okay, so this is
the request irreversible change approval, that's a tool. And now I need to import this. Basically, let's go all the way to the bottom top, and here I need to import this tool from this agents stuff. Yeah, let's add it here. So tool, and the type for that. Okay, and then we need to update this prompt, the one that where we have this build groundwork agent prompt here. Here I just need to basically add exclusively that before any irreversible or destructive action, or like for example, let's say dropping table or truncating or deleting or data or infrastructure, something that you need to call this tool or specific like that. So let me just add in this. Yeah, I'm just adding that you must call this tool, the one which we're just trying to add, and then I need to attach this tools for this one. So yes, and we can just be specific and typecast this one. So this is the tool addition, and then when I'm trying to migrate and all, I'll showcase this UI, this tool call from this agent and all, and this will be working. Okay, and also now I want to scope event producer ID per execution. So basically, so approval resume does not collide and all those things. So that basically I need to change it in agent segment thing that we have. So here let's producer ID. Yep, so here let's add this more scoping, which is the input. I'll add additionally input dot trigger event ID. Okay, fine. And now when we are trying to call this publish, yeah, here what I'm going to do is basically I'll just create the start events instead of just trying to send it to publish and then pass on that thing. Okay, all right. So here I'm just going to add this start events, and do a check of like if the trigger type is not equals to basically user approval decision, then we are going to push an event specifically conditionally. We are just trying to push that turn the started, and then I just need to now pass on that start events to this publish. Okay, I think you get this now, right? So if it's approved, we know that it's already existing session and all, so we don't have to turn say that it started and all things. Okay, fine. That's the minor fix, just to make sure that it does not collide for approval resume and all thing. And also, like, now in the app.tsx, basically we need to clear approval prompt once the approval has been decided. So that how do we decide is that thing. So let's navigate to that, and here we should have something called approvals. Again, let's do a search. Yeah, okay. So this again, I'm just going to remove that by, so let's add this condition. Okay, so what I'm doing is decided approval IDs, trying to check for user.approval decision and get that, and then now we are just trying to filter which doesn't have this that approval ID, and then clear that approval prompt, like basically once that approval has been decided. Okay, that's the thing. So just trying to correct. And also, like, in the runtime section, let's say if it's a heavy task and something we need excessive tool calls and for the task and all, I have just limited this one to 40 and all, but you can just exceed this or else make this as dynamic configuring and all those things. So for example, you can change it to 120 or 150 or whatever it is. So I just kept it as low so that the billing on our APIs of OpenAI or Claude doesn't soar high. Okay, so that's it. That's the code, everything and all, and I'll be cleanly pushing it. I know I might not have properly conveyed what I want to do, but at least the intention is to give you the direction and how to think, and then take a reference from here and then try to navigate and all. Hope you got something, and we'll catch you in the next one.